I couldn't take it anymore because I was like sketching notebooks and planning these experiments and exercises.
You had big ideas in your mind. You were planning big experiments.
Yeah.
And that was difficult to work with on a small scale for like a postdoc type of situation where you have to, publish basic papers, deliver on some basic deadlines for a project, all that,
and support your advisor. And so one day I came in, and it actually involved another friend of mine, an astronomer named Jill Carter, with a Kite Massetti science business of detecting extraterrestrials, which I assume you'd never like to talk about aliens, so I'm sure we'll get to aliens. But Jill was visiting Stanford, and I was like, I really want to meet her. Can you introduce me? And she said, no, in fact, you're fired. my boss. So I was like, this is possibly the best thing. I didn't know where it would lead or what would happen to it, but getting fired from this ultra prestigious university turned out to be the path. I mean, literally, it brings me here today. In that, because of that, I ended up working for another person at Caltech, which is in Pasadena. And she, my original boss there at church, she got me a job with her former advisor named Andrew Lang. And Andrew was like, he was like this. He's like like Steve Jobs or charismatic, handsome, persuasive, ideal man. Not the guy always in the lab and everything, but understood where things are going. Yeah, and he had been involved in an experiment that measured the universe was flat, very close to flat, along with a preceding experiment done at Princeton by Lyman Page and collaborators.
So the shape of the universe is flat.
The geometry of the universe is flat.
How did he do that?
So he used the cosmic microwave background. And so what I said is you have to look for triangles in the universe. So you can measure triangles on Earth, and actually it's hard to show how the Earth is curved, but you can show the Earth is curved using triangle mountaintops, etc. If you have an accurate enough protractor. Yeah. God, you're like auto canceling. This is great. My ratings are going to go up.
If you want actual science, go listen to Brian. He want all of these conspiracy theories, or AKA the truth about flat Earth.
So what he used was the following triangle. There are proto-galaxy-sized objects in the CMB. The cosmic microwave background has these patches, and so you can make a triangle out of the diameter of one of these blobs of primordial plasma, the soup that constitutes the early universe. It's just hydrogen. It's a very simple material. Understand hydrogen, electrons, and radiation. Very simple. Plasma physicists understand it. The diameter is one base of the triangle, and then the distance of the Earth is the other two lengths. So he measured, along with his colleagues at Caltech and the University of Rome and this other group at Princeton, measured the angle, interior angle, effectively, very, very accurately, and showed that it added up to 180 degrees.
Can you localize accurately the patches in the CMB? Can you know where they could trace them back location-wise?
You can know where they are, but more than that, there's so many of these patches. They're about 1 square degree on the sky. The sky, you may know, a sphere has about 44,000 square degrees in a sphere. So there's literally 44,000 of these size patches over which he could do these kind of measurements, build up very good statistics. That's not exactly how they do it, or how they did it in this experiment called Boomerang, but they did measure very accurately what was called the first Doppler peak or acoustic peak in the plasma of the plasma.
That's that. So the sphere has approximately 44,000 degrees. If you cover a sphere, that's a very kind of important data collection thing when you're sitting on a sphere and you're looking out into the observable universe. So there's a lot of patches to work with.
Yeah. And in fact, a lot of the fast kind of algorithmic decomposition of spheres and machine learning in the early 2000s, still used today, was created out of this field by data analysts using this thing called hierarchical equal area triangles called heel picks is what it's called.
And so just stitch all of this stuff together, and that's and stitch it together very accurately.
Yeah. Get high statistical significance in order to reduce these statistical errors. Very clean signal and measurement device to reduce the systematic errors. Those are the two predominant sources of error in any measurement. Those that can be improved by more and more measurement. Take more and more measurements in this table, you'll get slightly better each time, but you only win as the number of the square root of the measurements. But the square root of 44,000 is pretty big. So they were able to get a very accurate measurement. Again, it's not exactly how they did it. They also have to do a Fourier analysis, decompose that through a power spectrum, filtration, windows. There's a lot of work that goes into it. Image analysis, and then comparing that with cosmological parameters. Very simple model, just 6 different numbers that go into a model that make a prediction. And one of those is the geometry of the universe pops out. And that is the universe has 0 spatially curvature. And that was called boomerang. So he had just come off with this. Now, let me remind you, who was the first person, to measure the curvature of the Earth? It's a guy named Aristophanes, whatever, around Aristotle's time. His name is in the history books. This guy, Andrew Lang, I was like, he's like the next Aristotle. I just wanted to work for this guy. He was clearly had this brand. He was about 40 at the time. California Scientist of the Year. I was sure he was going to win the Nobel Prize. And I knew that he, so I went down to Caltech to give my job talk, and he said, I love it, you got a job. And before he finished the sentence, I said, I'll take it. It was too good to be true. And I started working there at Caltech, and slowly but surely, because Caltech's a rich private university, at that time run by a Nobel Prize winner by the name of Baltimore, he just wrote us a check. Baltimore wrote us a check and said, get started on this idea. And so we started coming up with the idea for what I later named BICEP, by background imaging, cosmic extragalactic polarization, which is kind of ironic because we ended up measuring galactic polarization. We'll get to that in a minute. But along the way, the idea was very simple. We're going to make the simplest telescope it could possibly be, which is a refracting telescope. Your eyes, you have 2 refracting telescopes in your head. Only way, forward is making things more complex, right? When you make things complex in science, you introduce the possibility for systematic. So we wanted to build the cleanest instrument. It turns out the cleanest instrument we could build in astronomy is a refractive telescope. We also had to, unlike that telescope or Galileo's, we had to use very sensitive detectors that were cooled less than 1/20th of the temperature of the cosmic background itself, which is the coolest temperature in the whole universe. So we had to cool these down to about 0.1 or 0.2 degrees Kelvin above absolute zero. To do that, we need to put it inside of a huge vacuum chamber and suck out all the air molecules and water molecules and take it to a very, very special place called the South Pole, Antarctica, from which I retrieved from a patch there that's clear. So when you go there, you get these bright red jackets.
Right? Oh, yeah. Somebody was born in the Soviet Union, but I just like to call it red. United States Antarctic Program, the National Science Foundation.
The base is called the Amundsen-Scott South Polar Station. So it's a little known fact of geopolitics that whatever country occupies a region has ownership over it. Now, there is a treaty in Antarctica. You can't use it for military purposes, for mining, et cetera, et cetera. But I don't know if you know, but about 12 years ago, Putin sent a submarine to the North Pole. Now, there's no land at the North Pole, right? So what did he do? He stuck it on the ocean underneath. But the South Pole is on a continent called Antarctica, which was first reached about 110 years ago. First time in human history. Antarctica means the opposite of the bear. That means like no bears there. Basically, the opposite of what polar bears are. Arctic is polar bear. That's where in Greek. Yeah. So Antarctica means the opposite place. So humans never even saw it, let alone went to the South Pole, which is kind of in the middle of that continent. We wanted to take this telescope somewhere extremely dry. It turns out the Sahara Desert, San Diego, there's no place like the South Pole or Chile. Those are the 2 premier places on Earth. Of course, you'd like to go into space. There's no water in space.
So it's not about cold, it's about dry.
Exactly. So that's why, for example, you can take this blood cup and you can put it in this cup, right? And we can take it over to a microwave somewhere and heat it up. After 2 minutes, the water, 3 minutes, the water, you can't touch it. Take it from the mug. But you can touch the mug and take it out if you want to, right? Why? Because the mug is totally bone dry. But the microwaves get absorbed by the water molecule. The water molecules resonate exactly at these microwave frequencies. So we don't want these precious photons, 420 of them, traveling per cubic centimeter from the Big Bang itself to get absorbed in some water molecule in the Earth's atmosphere. So you take it to a place with the fewest number of water molecules per square centimeter of surface area. And that happens to be either Chile or my other part of the surface area, or you take it to the South Pole. We took it to the South Pole and spent a couple of months of my life down there. And it's like being on Hoth. It's like it's a completely otherworldly environment. Ice, planar, flat as a pancake. You like, and the buildings are built up on stilts. They're built up because the snow will otherwise cover them over. The nearest medical facilities are 4,000 miles away. If you have any issues with your wisdom teeth, they yank them before you go down there. If you have any issues with your appendix, they cut it out of you before you go down there. The Russians at Rothschild base, not too far away, that's 600 miles away. The doctors there, there's a famous picture of one of them operating on himself, taking out his own appendix in the middle of winter by himself.
A harsh condition. Science in the harshest condition.
And we go to those great lengths because it's the pristine environment to observe these precious photons. And we built this telescope, and it weighs tens of thousands of pounds. And it had to scan the sky almost like it's a robot. I mean, it's scanning the sky almost unattended. It needed, we have a guy who spends a year of his life down there, a girl who spends a year of their life down there. They're called winter overs. They arrive in sometimes as early as November, and they don't leave until the following December. And we always joke, $75,000, you just have to work for one night a year. It's a long night. And what bicep is, and I couldn't bring my polarized sunglasses here, so I brought these extra polarizers. So if you take this and put it in front of your telescope, you have now made a polarizer. You've made a polarization sensitive telescope. Now, you may not be able to immediately know how you use such a thing, but one way to think about it, now take this guy and look at a light, look at a light source, put one up to your eye, and now put the other one in front of it, anywhere, and now rotate them. What happens to the light source?
It was brighter and dimmer and brighter.
Yeah, so it's called a quadrupolar pattern, right? So it's repeating. It goes bright, dim, but it rotates twice in intensity for every single physical rotation. And that's because of the property of the photon. The photon is a spin-point field, but the polarization of light is it's the axis in which its electric field is oscillating. So the electric field is marching straight up and straight down. So therefore, vertical polarization is the same as negative vertical polarization. And so you get the same pattern as you rotate 2 times for every one physical rotation. It's just like a spin 2 object. So now if you put that in front of the telescope, you can do one of 2 things. Now you're polarizing all the light that's going in because you have one of the polarizers. And then you can analyze it as you rotate the other one. You can analyze it and change the amount of polarization. Or you can put this kind of very special crystal. There's a crystal called calcite. This is from Lex Luthor, not Lex. This crystal, put it on top of the printed text there, and tell me, what does it look like?
There's like I can see everything twice.
It's a double image.
A double image.
That is a special crystal that has 2 different indices of refraction. So light emerging, which is unpolarized from that black ink, comes out, and it splits into 2 different directions. It could split even more if I made the crystal, maybe my more expensive crystal. That's all I have.
What is the crystal that is kind of
It's called calcite. This crystal is called birefringent crystal. Bi means 2, refringent means refracting. So this is a special type of material that separates light based on its polarization.
pretty clean bi signal.
Yeah.
It's cleanly 2.
Yeah.
I'm seeing 2 very cleanly.
It's very crisp, right? So that's yours to keep with every time you press it. Now, take the polarizer underneath your left hand. Put it on top of the crystal. And
wow. This is incredible. You can switch as you rotate. You switch from one signal to the other. So it's one of the refractions to the other.
Whoa. So that is now you are analyzing the polarization. You are confirming the light comes out of the crystal, 2 different types of polarization. And effectively what we do is we have those 2 things, if you like, but working in the microwave. So our detector, that's where the cosmic photons are brightest in the microwave regime, the electromagnetic spectrum. And we're coupling that to a refracting telescope. But your eyes are refracting telescopes. So you are a polar. The human eye can actually slightly detect polarization, but otherwise it mainly detects the intensity of light and the color. That's what we call color, intensity, brightness.
So you're devising an instrument that's very precise in measuring that.
Exactly. And doing so in the microwave region, with detectors not made of biological human eye retina cells, but of superconductors and things called bolometers. And this has to be done at temperatures close to absolute 0 under vacuum conditions, 1/1000th of the pressure you feel here in the sea level.
So why is it that this kind of device can win a Nobel Prize?
So when the CMB was discovered, it was discovered serendipitously. There were two radio astronomers working at the time at Bell Laboratories. Now, why would Bell Laboratories be employing radio astronomers? Bell Laboratories is kind of like Apple, or it was like a think tank, or it was Google. Let's say it was like Google Access. Right? So they were working there, but imagine if Google was employing radio astronomers, like they were actively recruiting them. Why would they do that? Well, it turns out that was the beginning of the 1960s. Was the first commercial satellite launch for communication. And so Bell Labs, which would later become the telephone, part of AT&T, the telephone company, later invent the first cell phone. And they would take that, and they would take that telescope technology that radio astronomers had developed, and they would use that to see if they could improve the signal to noise of the satellites that they were seeing. And they found they couldn't. They found that they could not improve the signal noise ratio of the first telecommunications satellite. It was like the equivalent to 1 kilobit per second mock-up. And they were bouncing signals from the West Coast up to the satellite, bouncing it down, landing it in New Jersey, of all places, in northern New Jersey, Homeville, New Jersey. And these radio astronomers couldn't get rid of the signal. So they said, well, New Jersey's not far from New York. Let's see if the signal's coming from New York. Nope, not coming from New York. Let's see if it changes with the year. Maybe it's coming from the galaxy, which was also discovered there by Janssen.
So in the not being able to reduce the signal or increase the signal noise ratio, the noise.
They knew the signal was right. They couldn't get rid of the noise. And there was excess noise over the model that had not only been predicted by them, but had been measured by a previous guy, right? Edward Hall. He measured the same signal, found that there was this hiss of static, of radio static that he could not get rid of, that had a value of about 3 Kelvin. So you can translate. Remember I said, if you take a radio telescope and you have pointed at an object that's hot, the radio telescope's detector gets to the same temperature as the object. It's a principle of radio thermodynamics. So it's a really interesting thing. It's a thermometer, you can stick it into Jupiter from here on Earth. It's amazing. So we in radio astronomy characterize our signal not by its intensity, but by its temperature. So he found, this guy, Edward Hall, there's this 3 Kelvin signal, I can't get rid of it. It must be I did my error analysis wrong, and I would give him an F if he was doing my first year students. But he just attributed it to lack of understanding. These other guys, Penzias and Wilson, who are also radio astronomers, they said, no, let's build another experiment, put that inside of our telescope, and do what's called calibration. Inject a known source of signal every second that has a temperature about 4 Kelvin, because the signal they're trying to get rid of is about 3 Kelvin, and you want to have it as close as possible to the pernicious signal as possible. They did that once a second, so they got millions of measurements over the course of several months, years, even, by the end of millions of measurements for sure. And they found they couldn't get rid of it either, but they measured it was exactly 2.7265 degrees Kelvin.
So how does having a 4 Kelvin source, how does the calibration work?
It could be larger. Imagine like you're trying to calibrate the microphone. Like you could do it with like a really loud sound, but the gain is such a compress. So there are amplifiers downstream from the detector in every experiment that I've ever worked on. And they only have a linear region of a very small region. And you want to keep it as linear as possible. That means if you're trying to get rid of, you're trying to compare like a voice, and you're trying to compare that to a jet engine. It's not going to be as easy on the amplifiers as getting a slightly loud gong or something.
So the idea is the noise is present in both.
There's noise present in both, and you measure. What they did is they made a separate measurement just of the calibration system, which they measured exactly very well. 4 Kelvin is the temperature of helium. That's a temperature that's not going to change, and it's certainly not going to change over a time span of 1 second. And so they can compare unknown signal, known signal, unknown signal, known signal, like a scale, like a balance. So another way to think about it is like this. You've seen these Libra kind of balances where you put 2 weights in a pan, right? What happens if you put like a 1 ounce weight on one side and a 20 kilogram weight? You don't get any measurement, right? But you do get kind of a measurement if they're close enough. That's why we use formula.
Got it. But just to linger on the fact that there's a romantic element to the fact that you're arriving at the same temperature. That's kind of fascinating. And you're measuring stuff in terms of signal in terms of temperature at the source.
Yeah.
So you get there's something about temperature that's intimate.
Yeah.
It's cool.
Yeah, especially since all life is basically conversion of energy and trying to control entropy, which is then related to thermodynamics. Exactly. And this is very crucial kind of thing to do in science because they weren't looking for the signal. They found it accidentally. These two scientists, Patsy cells. And I like to think that those kind of discoveries are the paras in science. Like when you see something, Isaac Asimov said, like the most important reaction to scientists is not eureka, which means eureka. I have found it. No, he said no. He said, like, that's weird. Like that's a much better reaction, or that's freaking cool. Like, that's a scientist, not like I found it because
Surprise.
Yeah, because if you find what you're going to find, that's what leads us susceptible to confirmation bias, which is deadly. It's close to deadly as possible.
So how does that take us to something that's potentially worthy of a Nobel Prize?
So Penzias and Wilson weren't looking for a signal. They ended up discovering the heat left over from the fusion of helium from hydrogen, etc. And that was a serendipitous discovery. They won the Nobel Prize in 1978. It's the first one ever awarded in cosmology. My reasoning is, what if you could explain not only how the elements got formed, but how the whole universe worked, and kill off every other model of science? So if that weren't enough, every scientist, worth his or her salt, had told me, Andrew Lang, and our colleagues, this is a slam dunk Nobel Prize if you could do it, because it was really explaining again the stakes of this science is different than like superfluidity, plasma physics. When you talk about the origin of the universe, it ties into everything. It ties into philosophy, theology. You realize if Paul Steinhardt is correct, that the Bible can't be correct. In other words, if the Bible is correct now, is it falsified if you like, if you believe it? I never use the Bible as a science book, obviously. But the Bible speaks of a singular beginning. What if you knew for sure the universe was not singular? It would be more like the cosmology of Akhenaten and Egyptians than the biblical Torah, Old Testament, if you will. So, in my mind, the stakes could not be higher. And again, it's not an offense because we need plasma physics. We need every type of physics except maybe biophysics. Like we literally use every branch of physics, thermodynamics, superconductivity, quantum mechanics, all of that goes into our understanding of the instrument. And even further, if you want to understand that theory that predicts the signal that we were able to measure. So I rationalized that if Penzias and Wilson won the Nobel Prize for this, if Halson-Taylor won the Nobel Prize for indirectly detecting gravitational waves, this is decades before LIGO, by me detecting gravitational waves indirectly, detecting how the universe began, detecting the origin of the initial conditions for the Big Bang nucleosynthesis, which won the Nobel Prize in 1983. These are like 5 Nobel Prizes, potentially. For that reason, it seemed as close as you could possibly get to being a slam dunk to outdo what my father did. Really this impossible. And at that time, blacks, again, it sounds weird because people are like, oh, you would, you don't really, you still want the Nobel Prize. You're still like, look, you wrote another book. And I was joking, like, well, if you want to see if I'm a hypocrite, just get them to give me the Nobel Prize of Literature. Yeah. And if I accept it, then I'm a hypocrite. But
wait, well, we'll get to your current field of Nobel Prize and so on. But so there's this ambition. Let's say this device, this kind of signal could unlock many of the mysteries about the early universe. So there's excitement there. So let's take it further. I mean, there's a human story here of a bit of heartbreak. Not only was this possibly worth the Nobel Prize, if the Nobel Prize was given, you were excluded from the list of 3 that would get the Nobel Prize. So why were you excluded? Maybe that's a place to tell the story of Bicep 2.
Yeah, so Bicep 2, like, iPhones or Android, every year they get a little bit better. They get more megapixels, they get more optics, triple X zoom, whatever. Okay, right? We upgraded our detectors as well. The initial detectors were based on what are called semiconductors. They have certain properties that make them pretty difficult to replicate at scale. And we wanted to make them into superconductors, which have a virtue that you could then mass produce. Why superconductors? Well, again, we're measuring heat. So one thing about a superconductor is that it transitions from some finite resistance to 0 resistance over a very short span of temperature range. That that means you can use that very short span dependency as an accurate, sensitive, and precise thermometer. And so my brilliant colleagues around the world, in this case Jamie Hawk and now Skaggs at Princeton, they are just exquisitely making these sensors, tens of thousands of them. The initial Bicep 1 instrument, which is called Bicep, that only had 98 detectors. Simon's Observatory is going to have 100 times more just in one of our 4 telescopes. We're going to have 60,000 detectors operating full time at 0.1 degree above absolute zero in the Atacama Desert. We'll get there. But in the case of getting back to what Bicep did, we upgraded in Bicep 2. In January 2010, we had just installed in the exact same location at the South Pole, in the same building, which is ominously called the Dark Sector Laboratory, DSL, still operating to this very day. We installed a new receiver on the same platform as before, with very similar, identical optics, cryogenics, vacuum, everything, except it went from 98 detectors to 512 detectors. So almost an order of magnitude. Very substantial upgrade. And it had certain other features that made it even more powerful, but then just a factor of 5. And then we started observing with that. And we knew we'd have years to go, and maybe we'd never see anything. Again, we're looking for these tiny little reverberations in the fabric of space-time, which is close to the origin of the universe as we can ever get. So I was playing a role in that. Obviously, I had upgraded my a version of the original idea that I had for Bicep along with Andrew Lang. And in January of 2010, I was at a meeting at UC Berkeley, and I got a call from Andrew Lang's, or I was at a meeting with Andrew Lang's thesis advisor, Paul Richards at UC Berkeley. And he said that Andrew was dead. He had taken his life by suicide. And this is a man, and I already lost my father at this point in 2010, but he was like a father figure to me. Andrew. He would give me advice on marriage, on how I should be with my kids, and what was the most important way to move through the academic ladder. Again, he was preternaturally suited to win the Nobel Prize. Everyone always thought he would win it. Still, if he were alive, he still could win it. In fact, his wife, his ex-wife, won it. That's Arnold in 2018. And it was this power couple, and it destroyed me for a long time because he was just this magical person. I mean, I couldn't conceive of my career, my life. Even these aspects of raising kids and being married without him. And to do it in that way, it felt like, again, I'm not going to get kids. I feel terrible for them, obviously. But it did feel like betrayal. I mean, I'm just being honest. I felt like, why the F did you not reach out? I thought we were close. And I couldn't, I told him everything. And I felt like he had told me everything. And now he was gone, and then inevitably we had to keep running the instrument. I mean, there's millions of dollars invested, careers at stake, young people working tremendously hard. And then here we were, and who's going to take over the lead? He was the lead of the project at Caltech. And then it turned out that the other collaborators with whom I've been working for years and shared a lot of as well, they had decided to form a collaboration in which I was no longer the principal investigator. I was no longer the co-principal investigator as I was on Bicep 1. So I continued on Bicep 1 for the 12 year of it, but not on Bicep 2. And, obviously that was pretty painful.
This is all happening at the same time as you lose this father figure. Now this kind of just one betrayal in a way, and then there's another or something that feels like a betrayal.
Yeah, and he had, kind of been the only one looking out for my interest in the new experiment. I had moved from Caltech to UC San Diego, and there were other postdocs in the mix, all of whom would come there to work with him to get the approbation that would then lead to their careers taking off as it did for mine. And so there was a competition. Science is not free from egos and competition and desires, rightfully or wrongfully, for credit and attribution.
Was he the source of strength and confidence for you as a scientist, as a man? I mean, we're kind of alone in this world. As when we take on difficult things, we often kind of grasp at a few folks that give us strength. Was he basically your only source of strength in this whole journey? Like primarily in terms of this close knit?
As a scientist, there were really two. There's one, this Russian cosmologist Alexander Polnareff, who thankfully is very much alive. He was at Queen Mary University, he's retired. And he was kind of a theoretical, cosmological father to me. And then Andrew was this counterpoint that was teaching me you need to have a brand as a scientist. Every scientist has a brand, and some of them don't protect it, some of them don't burnish it. But some of the skills about being a scientist we don't teach our students involve how do you cultivate a scientific persona. And he was the exemplar for that, in addition to being the avuncular, father figure type character that really, was the person I would talk to. I had issues with when I had issues with my own students. He would tell me how those were. And he would tell me, his misgivings about about people that he worked with or things that was personal. And it was devastating. But again, like who the hell am I? I'm a kid. His kids lost father. So I feel guilty talking about it in that sense, but it's just a reality.
Well, there is something that's not often talked about is people who collaborate on scientific efforts. I mean, don't want to compare, but it's sometimes when the collaborations are truly great, it sounds similar as when veterans talk about their time serving together. There's a bond that's formed. So like comparing family and this kind of thing is it is not productive, but the depth of the bond is nevertheless real because you're taking on something. You're taking on the impossible. You're trying to achieve something. Sort of like there's this darkness, this fog of mystery that we're all surrounded by, which is what the human condition is, and you are like grasping at hope through the tools of science, and you're doing that together with like the confidence and progress you're about to have.
Yeah,
you boldly pushing through it. For him to take his own life, it can ask you about this kind of moment that combined, I don't want to say betrayal, but perhaps the feeling of betrayal that Bicep 2 kind of goes on without you, even though you're part of it, you're not part of the leadership group. Can you describe those low points? Was there depression, or was there a crumbling of confidence?
No, it was so wrapped up with my identity as a person. Like there's only a few different ways to have identity. Unless you're unhealthy psychologically. One of them for scientists is often that they're scientists, and that sometimes is their primary identity. Now I've got a husband, father, but at that time that was my identity. So to have that kind of taken away, it reminded me of being kind of adopted in the sense like the one who created me and that I had played a role in my own, that he abandoned me in a sense. I felt like these people are abandoning me. And the only thing I correct about the analogy that you use is like in the war, they're all working for a common good. It's not like I want to be and get the most kills. I compare it more to like a band. Like think about the Beatles, and what they did. And then they they ripped apart because of egos, credit. They had solo careers. They had, the relations, their intimates and so forth. And there it's not only for the common good. There is more of a zero-sum aspect. Like I would say, science is an infinite game. You can't win science. You never get to we won science, and even the Nobel Prize, they don't feel like, oh, we're done. They feel like a lot of times it's impossible to even get that good. However, science is made up of a lot of finite games, but there is only one winner for Canada. There is only three winners for the Nobel Prize. And because of that, I think it's heterodox and it's very confusing, especially there's no guide. I never got a guide how to be a professor, how to teach, how to lead a research group, how to deal with the death of an advisor, how to deal with an early graduate student. So we're all like reinventing it, which is kind of ironic and insane. Because the academic system that I am a part of, that you are a part of, is 1,000 years old. Dates back to Bologna, northern Italy, 1088 or so. First universities were established. And, very little's changed. Some guy or gal scratching a rock on another piece of rock. And, like one better aspect nowadays is that back then, the students could go on strike if they didn't like the professor. He or she wouldn't get paid. Nowadays, that barbaric process is replaced by 10%. But no, it was a definite kind of feeling of the rug getting pulled out from underneath because, you know, he was like my consigliere. He was the guy saw counseled me, and he's dead. And I felt like there is no one who's going to honor the agreements that we had. And he was a very soulful person. He was so much better at being a scientist than I could ever be. And just the loss for the cosmos, it just really hurt. And, I thought, it's so sad because he could have won a Nobel Prize. I don't think like that. First, I think I was kidding. So at first, now there goes my chance of winning a Nobel Prize, and hence the title of the book. It's like I knew I would not win the Nobel Prize. It also means that there's parts of the Nobel Prize that have to be done away with. It's a double entendre. Like we need to lose aspects of the Nobel Prize to help with science out. We can talk about that at a different time. But in the context of like now thinking back on it, that was such an innocent part of it because let's say he did win the Nobel Prize, or I did win it, or any of us did. Would that have changed anything? Would that have brought anything back? It's so it's like that. It's futility. And I just for me, the Nobel Prize is like I don't want to say it's like insignificant because obviously it has a lot of power and it has influence. And I went back. I had Neil deGrasse Tyson, and he prepares. He prepares like a surgeon before doing surgery when he goes on the talk show. So you see him going on Colbert Report. You think, oh, they just have a banter. He's just naturally gifted. No, you say that, you're undermining what he does. What he does, he goes back. He watches the last month of Colbert Report. He says, how long does he pause between fights? How long in the news cycle does he go back? What topics has he talked about with people similar to me? So I can nail it. And I do that for you. And I look back, how many times Lex mentioned the words Nobel and Prize? And I put it into Google Anywhere, and out came exactly the same number of times as show episodes. He said the words Nobel Prize over 240 times.
Yeah, I mean, it's so strange as a symbol that kind of unites this whole scientific journey, right? Like, it's both sad and beautiful. A little prize, a little award, a medal, a little plaque that would be most likely forgotten by history completely. It's some silly list. It's somehow a catalyst of greatness. It resulted in you doing your life's work. Yeah. The dream of it.
Would I have done it without the Nobel Prize? I necessarily can't actually that would have happened. No, it definitely has a place. And for me, it is valuable to think about it. But the level of obsession that academics have about it is really, I think it is almost unbalanced. And again, I make no truck with the winners of the Nobel Prize. Obviously, now I've had 11 on the show. And to think about, like the one rule. So by the way, right after the denouement of the story, which I'll get to in a bit, how our dreams went down to dust and ashes. I was asked by the Royal Swedish Academy of Sciences to nominate the winners of the 2015 Nobel Prize in Physics. So, like the one that I theoretically could have been eligible to win in 2016. They asked me to nominate. Now, imagine if I asked you say, Brian, instead of me inviting myself, if you say, Brian, would you like to come on the Lex podcast? I say, you know what, Lex? I've had Rogan. Can you introduce him to me? Like, you imagine how that would feel if you could have that, So I was asked to nominate the winners, and the one rule that they say, of all the rules that Alfred Nobel stipulated, there's only one rule that they maintain. In other words, he said one person can win it for something they discovered in the preceding year that had the greatest benefit to mankind, made the world better. None of that was mentioned in the letter. It said many people can win it for the work done long ago. They didn't mention anything in the letter to me, signed by the Secretary General. Nothing about benefiting mankind. I said, just one thing, you can't nominate yourself. So none of these guys nominated themselves.
Actually, a little known fact, they sent that exact letter just to you. That rule was created just for you.
That's called the Keating correlate. Yes, exactly.
Just to
Good for them.
just rub it in. It's in this particular case, of course, there's like some other technicality or whatever. But in this particular case, it's kind of a powerful reminder
No
that
way.
the Nobel Prize leaves a lot of people behind.
Yeah.
And then there's stories behind all of that.
Yeah, I mean, here's a good example. Again, this is my friend, Barry Barris. He's become like a mentor and a friend. He wrote the full he won the Nobel Prize because a different guy died. And he admits it. And he said it. And actually, it's funny with him because I've heard you talk, very rhapsodically and lovely and romantically about with Harry Cliff and wonderful podcast with him about the LHC and how wonderful and how in that, we were about to build the super collider right here in Texas, and it didn't get built and got canceled by Congress. And I'd say with Barry, that was the best thing that ever happened. And he's like, "What the hell are you talking about?" I'm like, if that didn't get canceled, first of all, they even though it did get canceled, the Europeans went on to build it themselves, saved the American taxpayers billions of dollars, and we wouldn't have learned anything really substantially new, as proven by the fact that, as you and Harry talked about, nothing besides the Higgs particle of great note has come. And actually, he's had a recent paper that's been an upper limit along with his collaborators, HCP experiment that we talked about. But the bottom line is, it was really built to detect the Higgs. And SSC, much money, would have sucked up Barry's career. He would have been working on that, maybe not. And then he would never have worked on LIGO. And then he wouldn't have won the Nobel Prize, right? So you look at counterfactual history. That's not actually a big stretch, right? If the SSC had still gone on, he would have worked on it because he was one of the primary leaders of that experiment. Second thing, if, imagine the following thing happened. They won the Nobel Prize because in September 2015, they detected unequivocal evidence for the in-spiral collision of two massive black holes, each about 30 times the mass of the sun, leaving behind an object that had just less than 60 solar masses behind. So one solar mass worth of matter got converted to gravitational energy. No light, so by them. This particular date, September 14th, 2015. Okay? That explosion, because of the miracle of time travel the telescopes afford us, that actually took place 1.2 billion years ago in a galaxy far, far away. They actually don't know what galaxy is close, but still, they never will. Okay, if that collision between these two things, which have probably been orbiting each other for maybe a million years or more, if that had occurred 15 days earlier, Barry wouldn't have won the Nobel Prize. Because
it's hilarious to think that there's one you and the one Nobel Prize because two giant things collided.
a billion, 200 million years ago. And if it had happened 18 days, 20 days, 30, because that was the deadline for the Nobel Prize to be announced, they announced the findings in February, but you have to nominate the winners in January. So I could have nominated them up until January 30th, but they didn't announce anything, and there was just rumors. So he didn't. But the reason that he wouldn't have won it is there was another guy who was still alive, considered to be the founder, father, the three fathers, Ray Weiss, who did win it, Kip Thorne, who did win it, and the third gentleman at Caltech, named Reaver, who passed away. Again, he was alive in 2016. He died in 2017.
And here we are, several billion of hairless apes that strangely wear clothing. Celebrated 3 other clothed hairless apes with a medal, with one particular element, and then they made speeches in a particular language that evolved.
And get those medals in front of another guy who wears even fancier clothes, who was the king of Sweden.
And they got some free food afterwards.
Reindeer meat, that's right.
Okay, excellent. Since you mentioned Joe Rogan, that little example, what happened to you in terms of bicep too? I want to kind of speak at a high level about a particular thing I observed. So I was a fan of Joe Rogan since he started the podcast. I just listened to the podcast. I'm a huge fan of podcasts in general. And it also coincided with my entry into grad school and this whole journey that I became in. So grad school, getting my PhD, going to MIT and then Google, and just looking at this whole world of research. What I really love about how Joe Rogan approaches the world is that he celebrates others. Like he promotes them. He gets like genuinely, and I now know this from just being a friend privately, he genuinely gets excited by the success of others. And the contrast of that to how folks in academia often behave was always really disappointing because the natural, just on a basic human level, there is an excitement. The nature of that excitement is more like I'm happy for my friend, but I'm really jealous and I want to even outdo them. I want to celebrate them, but I want to do even better. So that's even for friends. So there's not a genuine, pure excitement for others. And then couple that with just you now as a host of a popular podcast know this feeling, which is like there's not even a willingness to celebrate publicly the awesomeness of others. People in academia are often best equipped, technically, in terms of language, to celebrate others. They understand the beauty, like the full richness of why the cool idea is as cool as it is. They're in the best position to celebrate it, and yet there's a feeling that if I celebrate others, they might end up on the cover of Nature, whatever, and it's not me. They turn it into zero sum game. The reason why I think Rogan has been an inspiration to me and many others is that it doesn't have to be. And forget money and all those kinds of things. I think there's a narrative told that academics are this way because there's a limited amount of money, so they're fighting for this. I don't think that's the reason it's happening this way. I think you can have a limited amount of money. The battle for money happens in the space of proposal. There's networking. There's private stuff. Public celebration of others, and just how you feel in the privacy of your. It's not have to maybe with money. It has to do with you having a big ego, not humbling yourself for the beauty of the journey that we're all on. And there's folks like Joe Rogan, who in the comedian circles is also rare, but he inspired all these other comedians to realize, you know what? It's great to celebrate each other. We're promoting each other, and therefore the pie grows. Yeah, because everybody else gets excited about this whole thing, and the pie grows. Right now, scientists by fighting, by not celebrating each other, are not growing the pie, and now because of that, so science becomes less and less positive.
And exactly. No, and I want to point out one is that I remember you went on Joe's show like a couple of years ago, and then he gave you a watch. He gave you like a Rolex, right? And I tweeted to you, and I think Omega. Sorry. Okay. The watch that went to the moon, which we'll get to now. But I don't think he can give you what I can. We'll get to what that final gift package is.
And by the way, I also wanted to mention, because when you said Joe Rogan, I would not be upset, and you should definitely go on Joe Rogan. And we had this conversation with him, because I was like, so moving to Austin, and had a conversation like, don't you think it's weird, like we have the same guests at the same time or whatever? It's like, fuck that. I want you to be more successful than me. He truly wants everybody, like especially people close to him, to be more successful. Like there's not even a thought like,
but you don't know why. And this is what I tweeted to you. I've retweeted that I said, I said someday you're going to give it to somebody. Today, that's me. No, no, but the point is, he sees in you that same, curiosity, that same genuine spirit of graciousness. I think that's true. I mean, you do something very rare. I don't want to listen to too much about this, but I do want to say, even back to Andrew, who I've almost been hate graphic about, just treating him the same. He said to me the same thing, like in a moment of peak. He said, like I have to train these guys and women that work for me so that they can be better than me, so that they can go out and compete with me for the same limited amount of funding that they have in NSF. And that wasn't who he was. That was just an expression, like I'm doing something which is fundamental. But you know what? When you have kids, hopefully, these guys listen to it, because I think, and I hope we can get to talk about that later. But part of investing and part of doing something with when you have a kid, like you can get married. You can marry someone because she's rich, he's rich. You can marry someone because they're good looking, he's good. You can marry for all these different reasons that are ultimately selfish. There's no way you can have a kid. Nobody says like, oh, you know what? I really want this thing that's 3 feet tall that doesn't speak English, that craps on my floor, that wakes me up all hours of the night, that interferes with my love life. Nobody says that. This doesn't benefit you for months and months. A friend of mine who actually does videos for me, like solo videos, he's having his first kid. He's like, because he always gets stupid about, catch up on sleep now. Yeah, I'm going to store sleep in my sleep bank. Like, I don't think Huberman and you talked about that, right? You can't do that. That's stupid. What you can do, give the kid a bath. Feed the baby, let the mother relax. Like, in other words, do the things, and this really relates back to what Aristotle said. He said, why do parents love kids more than kids love parents? As much as you love your dad, they still love you more. And because you love that which you sacrifice for. Here's a proof. I know a lot of families that have kids with special needs. Some with severe, like our uncles, the Keen side had this, they call it retardation. That's a different name. That out of the 9 other brothers and sisters, he was their favorite because they had to sacrifice so much for him. And I think of that, in a small case, like Joe's kind of mentoring you, whatever, you're going to mentor someone. You love that which you sacrifice for. Sacrifice is reduction of entropy, it's storing and investing, and you want to protect that. That to me really speaks to me. So I don't hold it against. But it is true. Like scientists are, when they're described again, they're often said to be like children, right? You've heard this description. They're inquisitive, they're curious, they're passionate. They love that. I'm like, yeah, they don't play well with others. They're jealous, they're petty, they're selfish. They won't share their ball and go home. There's no such thing as a single-edged sword. I wish there were, because we need someone like that because you guys blow it up. But in this case, he, I think when you have this kind of investment in science, it's going to be natural. But that doesn't mean we have to feed the flames of competition. Really benefit. If you go to the homepage of the NSF or the Department of Energy or the recently released National Academy of Sciences Future of Science for the astronomical sciences for the next 25 years or more, they talk about how many Nobel Prizes these different science things can bring. Exoplanets, life, the discovery of the CMB B-mode polarization that I said, that's figure 2 in this thing. And I'm like, what message is that sent to kids? Like, to young people? Like, that's what you should be doing. So you win this small, this prize given out by one hairless ape to another wearing a fancier costume. Even though he has the Nobel Prize is only currently given to 3 people, which was never one of his. He actually said one. You can only give it to one person. So they changed it. Why did they change it? And I talked about it. By the way, the book's only 3 chapters out of 11 about the Nobel Prize, and it's a fact. But one of the things that's been so interesting, like speaking, actually, this is coming up in December, is the Nobel Prize is given out on the day of Alfred Nobel's death. There's a lot of, and they bring in flowers, not from his birthplace, but from his mausoleum, which is in San Marino in Italy. It's a lot of that fascination. Denial of death features heavily in the Nobel Prize because it's like, what outlives a person? Well, science can outlive a person. My father has a theorem named after him. It's still engraved in many places around the world. You or I, we can go to different places around the world. People know who we are based on our publications. We engrave things, we now store things, we compress things. And I think there's something beautiful about that. There is a notion of denial of death. Like, there is a notion of what will outlast you. Especially if you're among the many, 90-something% of members of the National Academy don't believe in an active faith, in a creator, in a God. And science can substitute for that, but it's not ultimately as fulfilling. I don't believe it can fulfill a person in a way, even practicing but not believing in a religion can fulfill a person.
So, which is interesting because you do bring up on the background of denial of death in the Nobel Prize book, and there is a sense in which that's probably in part at the core of this, especially the later dream of the Nobel Prize or prize or recognition. I've interacted with a few, or a large number of scientists that are getting up in age, and there is the feeling of real pride, of happiness, that of winning awards, getting certain recognitions. And probably at the core of that is a kind of immortality, or a kind of desire for immortality. And that was always off-putting to me, as opposed to, I know it sounds weird to say it's off-putting, but it just, rather than celebrating the pure joy of solving puzzles or the mysteries all around us. Just the actual exploration of the mysterious
for its own sake.
for its own sake.
Well, that's what I said. It's like a scientist should. Okay, you have to be careful and not have any physical. It has to be platonic, but you can think of scientists and mentors. I have a chart in the book and a plaque made by one of my graduate students, former graduate students. She's now a professor in New Mexico, Darcy Brown. And she made this plaque, and it has 17 generations. So here I am, 17 levels down. There's a guy, Leibniz, not the famous Leibniz, 1596 he was born, and I'm in this chain. And I don't know if you know this, but in the Russian language, the word scientist means someone who was taught. I'll say it there's one who was taught, right?
Uchone.
So the probably a guy who's taught, right?
No,
a kid just
no, it's literally someone
who was taught, right? So what does that mean? To me, it has a dual kind of meaning, at least. One is that you have to be a good student to be a scientist, because you have to learn from somebody else. Two, you have to be a teacher. You have to pay it forward. If you don't, I claim you're really not a scientist in the truest sense. And I feel like with the work that I do in outreach and stuff like that, I'm doing it at scale. I'm influencing more than 24 kids I might have in my graduate class or undergraduate class. And they potentially could reach thousands of people around the world and make them into scientists themselves. Because that's the flywheel that is only beneficial. There is no competition. There's no zero-sum fixed mindset versus growth mindset. Because it is an infinite game. Imagine a culture that had none of the trappings of the negativity of the Soviet Union or pre-World War I Germany or Imperial Japan. Science celebrated. And we're just making like a nation of scientists. And like, we're not doing it to become multi-billionaires or necessarily, for any military purpose whatsoever. But if we had that, sometimes I'm flying, home at night. You fly into LA, you literally, it's very, very, you can see like the number 10 million. Like, it's very hard to like visualize things. You see a brick wall, you ask how many bricks are there? There might be 1,000, 2,000. 10 million lights. There's 10 million souls. And you can see, they're discrete. They're not like the Milky Way all blended together.
Each lost in her own busy lives,
right.
Excited, fall in love, afraid of losing their job, all that. Other people should know that you're a pilot. Yeah. So you're literally being fly.
Yeah, sometimes I get to do it.
You get to look at the eye of God perspective on these 10 million, on these millions of.
And I don't mistake, they're like constellations, but upside down. It's like a constellation. Hopefully, I'll stay and keep the flame right there. But when you think about it, like, imagine they're all working together, and imagine like you always talk about love, but like you don't know that they're not worthy of love. Like, so you're looking down at them, and it's just amazing because you think like, what amazing creation is man and humans, and what can we do? What's new? Did you watch any more videos? Dude, it's phenomenal. It's so exciting. And then I get to do it, it's a job I say don't tell Gavin Newsom about, do it for free. I love what I do. But to think about like, oh, if my student succeeds, no, it's unfortunate that you have experienced it. I've certainly experienced it, and I think there are ways around it. I think it is a vexing problem because people want to, it's very tempting to keep your own kind of garden immortalized. One thing that's interesting is like, people are like, why are you doing this thing and podcast? And you're supposed to be a serious scientist leading this huge project and collaborators. And I'm like, well, most of what I do, as I said before, for you it's Velcro. For me, it's like, what is the deal with the safety standards on the truck that we're driving up to deliver the diesel fuel that will power the generator that will power the concrete truck? It has nothing to do with the Big Bang, inflation, the multiverse, God's existence. It has nothing to do with that, right? So those are people I say I have to talk to. The people that come on the show, those are people I want to talk to. And that's super fun. I mean, it's a real honor that I get to do it. I have some unfair advantages, right? I'm at top university. We have people, it's affiliated with the Arthur C. Clarke Foundation, brilliant scientists coming through. But I felt like it would be kind of a shame if I didn't, allow them to teach at scale because they're better teachers than I am.
Let me ask you a interesting, maybe difficult question. Have you ever considered talking on your podcast with the people who would get the Nobel Prize for BICEP2 if it turned out to be detecting what it is?
Yeah, I mean, I'm still friends with them, and they have still gone on to. So we should say like why we didn't win the Nobel Prize, and then what happened with the group that is now leading it. That I'm completely divorced from, and secular. We're friends. We see each other, we send each other emails and stuff like that.
I would love to get their sense of like what the natural heartbeat built into the whole process of the Nobel Prize, what their sense is. I would love to hear an honest, real conversation. I understand your friends.
Yeah.
There's some hard truth that even friends will talk
they
about.
were happy about the book. I mean, I remember one of them, was like, well, what's this I hear about a book? And I mean, a lot of people told me not to write the book. They said it's going to give, too much attention to the Nobel Prize, going to look like sour grapes. Again, I say you can prove I have sour grapes or not, just give me the next prize. No.
So you would defeat the Nobel Prize for literature.
It's funny because Sabina Hassenfelder, who's a fellow kind of YouTube sensation,
She's shooing for the Nobel Peace Prize.
You're right. She's so gracious and so good. She has that German, just gentleness.
She's a little too nice for my taste. I would say.
I wish she could really say what she thinks, and be snarky on occasion. So she wrote a review of my book when it came out 3 or 4 years ago, and she said, well, Brian Keating, she said, well, it's good. Yeah, it's interesting. He talks a lot about cosmology, but they can do whatever the hell they want, and he, presumably has this, problems with it, but it's none of his business. Basically, it's private. And at the end, she said, but if you want one good thing, he's a really good writer, and who knows, he could win the Nobel Prize. I said, and then she allowed me to publish a rebuttal on her blog, which is kind of funny. But anyway, so getting back to the guys that we were, kind of frenemies. We don't wish each other active ill. I've visited them. They're welcome to visit me. They have visited me. The thing I have to say is that I just wonder about introspection. Like for me, literally, I don't care about the Nobel Prize other than what it could do to benefit science. But I did. But by the way, I did seriously care about how it benefited Brian Keating early on in my career. I'm just totally honest. I'm not proud of it. It's kind of embarrassing. But now I would hope that people would say, like, okay, the guy is like, it's not that he's obsessed with it. My next book is not about this. It's about something totally different. And, I do feel like people lack introspection a lot of times in science. Like, we don't think about why we're doing what we're doing. And I think it comes down to curiosity. One thing about Joe, and again, I've only listened to like I have to confess. Father Friedman. I haven't listened to like that many of your episodes, start to finish. Okay, I'm with our friend, mutual friend Eric. I've listened to a bunch of recent ones. Weinstein.
I get them confused with the brother.
The brothers, and a few others. I haven't ever listened to a Joe Rogan episode, but from what I've seen with him, he has a preternatural curiosity. He doesn't have passion. There are a lot of podcasts that have passion. Like I've been on their show. He has curiosity. Like he's not going to stop talking about something until he pops it, until he understands it, until he gets it viscerally. And I respect that because, as I say in this more recent book, passion's like kind of like the dopamine hit that gets you started. Like, oh, I'm going to be great. Maybe I can win a Nobel Prize. Like that's not going to sustain you. The sustenance comes from the passion converting to curiosity. And what I want to do is convert, as many things as possible to things that I can then, because actually I've had on, people that discuss addiction. And there's an addictive quality to, doing podcasts, whatever. There's an addictive quality to being a scientist. And you get to do things that are very specialized in specialized locations with special people, paid for by other people, have no freaking idea what you do. I mean, imagine you worked in some job, and Feynman said all these contradictory things. Like when he was once said, like, he said, if you can't explain it to your grandmother, you don't understand it yourself. And the day he won the Nobel Prize, a reporter asked, "What'd you win it for?" I said, "If I could explain it to you, bud, it wouldn't be worth it." So let's leave aside. But in reality, there is that kind of like dopamine rush that we get. But what is ultimately going to be the sustenance of it? So yeah, I do feel like we have to find a way to nucleate that. I don't know if it's like can you turn someone into a scientist? I used to ask this question all the time. Can you make someone creative? Like, can you teach someone to be creative? I don't know. Can you teach someone to be curious? I don't know. I do know that kids are naturally curious. As they get older, they get less curious. Just like I heard from the other forward authors, James Altucher, he said once he did a study, kids smile 300 times a day or smile a lot. Adults 5 or 6. 5 or 6. No. But anyway, no, it's true. So somewhere you lose 30, to 50%.
I'm not entertaining. That's because I'm an adult. No, but and then I do remember there's some distribution on those studies with the happier adults smile a little more, but still the kids go a lot of the
depression. So in other words, should we invest our energy in getting the half-life decay constant stretched out more for curiosity for kids? Or should we try to reset the dopamine hit and I don't know. It's an open question.
Well, I think it goes to David Foster Wallace to keep in mind to be unborable. I think you could train this kind of thing, which is in every single situation. So like, which I think is at the core, at least this core of curiosity. In every situation, try to find the exciting, the fascinating. Like in every situation, you sitting at the, I don't know, waiting for something like a D&D or something like that. Find something that excites you, like a thought, like watch people or start to think about, well, I wonder how many people have to go to the D&D every day. And they try to go into the pothead mode of thinking like, wow, isn't this weird that there's a bunch of people that are having to get a stamp of approval from the community to drive their cars and really car driving.
Like, how can I do this better? Maybe there's some blockchain and I can like VIN transfer. Yeah, exactly. Yeah. No, that is a good thing.
And then at every situation, I think if you rigorously like just practice that at a young age, I think you can learn that because like sometimes people like ask me for advice on do this thing or that thing. I think you at the core really have to have this muscle of finding the awesomeness in everything. Because if you're able to find the awesomeness in everything, like whatever journey you take, whatever weird that you take through life is going to be productive. It's going to end up in a good place. So like that muscle is at the core of it. And I guess curiosity is central to that. But you didn't win the Nobel Prize. The team of bicep that led the bicep which one is the moon? Which one is
that one's dust?
What are we looking at? So why is space dust the villain of this whole story?
Well, it's funny, I wrote these books, and I don't know about you, but when you get all these books, I'm sure you get most people saying, they always come in these dust jackets. What the hell's a dust jacket? Like, how much dust is raining down at any moment? I mean, this is immaculate. This is Russian tidiness galore. But in a normal household, how much dust is raining down? It's not really hard until I wrote a book. And I realized, I'm writing a story about the origin of the universe, the prologue, to the cosmos. And dust is going to cover this story. It's actually more a story about astrophysics and cosmology than dust. And this is the link between the cosmological and the astrophysical. So what does that mean? So astrophysics is, broadly speaking, the study of physical phenomena manifested in the heavens. astronomical phenomenon. Cosmology is concerned with the origin, evolution of the universe as a whole, but not really concerned with stars, galaxies, and planets per se, other than how they might help us measure the Hubble constant, the density of the universe, the neutrino constant. So we have a tendency to kind of look a little bit, they're like, not all astronomers and astrophysicists are equal. They're all equal, but some are more equal. So we have kind of a prejudice, a little swagger, right? And cosmologists are studying, we're using Einstein, we're not using Boltzmann. We're thinking of the biggest possible picture. In so doing, you can actually become blinded to otherwise obvious effects that people, would have not overlooked. In our case, when we sought out the signal, we were using the photons that make up this primordial heat bath that surrounds the universe, luckily only at 3 degrees Kelvin approximately. We're using those as a type of film onto which gravitational waves will reverberate it, make them oscillate preferentially in a polarized way, and then we can use our polarized sunglasses, but in the microwave format, to detect the characteristic twofold symmetry pattern of the rotation. That's the technical way that we undergo it. But there's more than one thing that can mimic exactly that signal. First of all, when you look at the signal, if inflation took place, big if, but if it took place, the signal would be about 1 or 2 parts per billion of the CMB temperature itself. So a few nanokelvin. The CMB is a few Kelvin. The signal from these B nodes would be a few nanokelvin. It's astonishing to think. Penzias and Wilson, 1965, measured something that's a billion times brighter. And that was what, 60 years ago? It's called 60 years ago since they discovered it. Moore's Law, it's called every 2 years. So you're talking about like 2 to the 30th power, and doubling or something. It's called 2 to the 20th or something like that. That's like only 2 to the 10th is a thousand, right? Correct my math, I'm wrong. 2 to the 20th is a million, right? 2 to the 30th is a billion. So we're outpacing Moore's Law in terms of the sensitivity of our instruments to detect these feeble signals from the cosmos. And they didn't have to deal with, in the semiconductor factory in Santa Clara, California, they don't have to deal with meteorites and things like coming into the laboratory. It's a clean room, it's pristine, they can control everything about it. We can't control the cosmos. And the cosmos is literally littered with particles of schmutz and failed planets, asteroids, meteoroids, things that didn't coalesce to make Earth, the moon, the planet Jupiter, or its moons, or get sucked into them and make craters on them, etc., etc. The rest of it is the power spectrum. There's very few, thank God, Chicxulub-sized impact or progenitors that will take out life on Earth. But there's an extremely large number of tiny dust particles and microscopic grains, and then there's a fair number of intermediate-sized particles. It turns out this little guy here is the end product of a collapsing star that explodes in what's called a supernova. So stars spend most of their life using helium nuclei, protons, into and neutrons into helium nuclei, and then from there it can make other things like beryllium, carbon, nitrogen, oxygen, all the way up until it tries to make iron and nickel. Now, iron and nickel are endothermic. It takes more energy that gets liberated to make an atom of iron. When that happens, there's no longer enough heat supplying pressure to resist the gravitational collapse of the material that was produced earlier. So the star forms and goes inside out. That's how scientists discovered helium was discovered on the sun. That's why it's called helium. Yeah, they went there at night. And they went there at night. No, helium means Helios is the god of the sun. It was discovered in its spectrum from observations of the telescope like 150 years ago. It wasn't discovered like when oxygen and iron was discovered. So it's only relatively recent coming to appear.
So helium came after oxygen.
Oh no, first hydrogen forms into helium. So that's the first thing that forms.
No, in terms of discoveries.
Oh yeah, after oxygen. Yeah, I think Priestley, Dalton discovered it in the 1700s. No, helium was really only discovered from the spectrum of looking at the sun and seeing the weird atomic absorption that we call Fraunhofer lines in the solar spectrum. So, but when it tries to make iron, there's no longer any leftover heat. In other words, there's heat left over from fusing, as you know, the sun and the plasma. So if you fuse hydrogen nuclei, you get excess energy, plus you get helium. So that's why fusion energy could be the energy source of the future. Always will be. Hopefully, much sooner than that. And so trying to make iron, it takes more energy, doesn't give off enough energy. The star collapses, explodes, and what does it spray out into the cosmic interstellar medium? It sprays out the last thing it made, which is that stuff. Luckily for us, because some of that coalesced and made the core of the Earth, onto which the lighter like silica and carbon and the dirt and the crust of the Earth was formed. And some of that made its way to the crust, the iron made its way to the crust. Some of that your mother ate and synthesized hemoglobin molecules. And hemoglobin has iron particles in it. It's quite amazing substance. Without it, we wouldn't have a red blood. We wouldn't exist as we are.
Is this a very long, complicated mom joke?
I've done enough dad jokes. So taking this object, seriously, there's not all of it gets bound up in plants. In fact, forming plants is very beneficial. And so there's a lot of what's left over, some of which gets in the way of our telescopes looking back to the beginning of time. Molecules like iron is used in compass needles, right? They're magnetized. And magnetic fields in our galaxy can align them and make the exact polarization pattern that we're looking for. As if the compass needles get all aligned, that's like the polarization of the dust grain. It's like that filter, polarizing filter. That means light polarized like this will get absorbed, and light polarized like this will go through. So it's absorbing, it's making 100% polarized light out of an initially unpolarized light source. And that's what happened. And what we ended up claiming March 17th, and I'm sure you were there, you might remember this, at the Harvard Center for Astrophysics, there was an announcement. There would be 3 or 4 Nobel Prize winners in the audience, and the BICEP 2 team, which I was no longer leading, was still a member of it. In fact, in the announcement, the first person they mentioned, besides, thank you all for being here, is me and my team at UC San Diego, although I wasn't invited to go to the press conference because the Harvard, yes, exactly. It's a little screen up there. And so they ended up making this announcement that we discovered the aftershocks of inflation. We detected the gravitational wave, shaking up the CME. And on that day, Lex Friedman podcast, back when it was called Artificial Intelligence, Max Tegmark said, "Goodbye, universe, hello, multiverse, and hello, Nobel Prize." See, he saw that as confirmatory evidence, not only of inflation, not only gravitational, but of the multiverse. Goodbye, universe, hello,
Multiverse is a natural consequence.
According to
and of course, leave the poetry to Max, which he does masterfully. Okay, so that the excitement was there. I mean, maybe the initial heartbreak for you is there too.
Yep.
That's some of the darker moments you're going through, but broadly for the space of science, there's
and I often note that this is a problem in what I call, the science media complex, because oftentimes you'll see things like past guest Sarah Seeger, Venus life, exists, and that will be really, it's fascinating, right? Look at the work that she's doing, our colleagues are doing, Clara, who's on the show, and that will be on front page, New York Times, Boston Globe, San Diego Union Tribune. It'll be above the fold, make headlines around the world, and then 6 months, 12 months later, as a case for us, retraction. Page C17 of the Saturday edition that nobody reads, underneath the personal. So we have a problem with that. If it explodes at leads, and we get this huge fanfare. Not unique to my experiment. This happened with the earlier discovery of the so-called Martian life discovered in Antarctica, which was announced after peer review. We weren't peer reviewed at the point when we made the announcement at a press conference and other reasons that the team leaders felt it was important to do that, so that we had been scooped by a referee who's unethical. We thought we had done everything right, but that's confirmation bias.
There's like levels to this.
And there were people, reading warning about how to be interpreted and wanting to also make sure that we cut all the data out, including the maps, which we still haven't released. And so there were a lot of reasons to be skeptical, but the public never knows this. I think it's so. I've made a rule that if I am ever in charge of doling out large amounts of science funding, that when you should keep kind of an option. In other words, you should have money for publicity, fine. Have money for your press, but hold in reserve in a bond to be used. Hopefully never, but if it's to be used, an equal fund for the retraction. If it should.
So you would like to see, because that's a big part of transparency. To me, in the space of science, at least, that's as beautiful because it reveals the it tells a great story. There's an excitement. There's a climax to the triumph, but there's also a climax to the disappointment at the end, because that also eventually leads to triumph again. That sets up. That's the drama that sets up the triumph. Like with Andrew Wiles' movie From Us theorem. I think it's not last name, whatever. Is like the ups and downs of that, the roller coaster, the whole thing she went down.
That is science. And when we don't do that, then we cultivate this aura that excludes other scientists, often from minorities, or that you have to be Einstein. Like Einstein came out of the world and he was just like this guy with like her. No, he wasn't. He wasn't bad at math. That's all nonsense. But he said that you know what he said he attributed his success to was? He said, I never asked my dad what happened when I ran alongside the light as a kid. And thank God I did, because he would have told me the best answer of the day, which, by the way, he would create 20 years later as a 26-year-old in the Pathfinder. And in so doing, by delaying when he asked these questions, he said, I approached it with the intellect of a mature scientist, not a little kid. And I wouldn't have accepted the same explanation. So sometimes assuming that scientists are infallible, inevitable, omniscient, I think that really does a disservice. Jim Gates said, it's like Einstein was a good study. And we cultivate this mystery and allure at our peril because we're until we have artificial Einstein, which I don't think will ever exist.
You've launched the assay or project. We hope to assess theories of everything with experiments. You have a YouTube video where you announce that. That looks super cool. Can you describe this project? And you also mentioned give a shout out to a little known fellow by the name of Galileo Galilei and inspiration to this project.
Yeah, so Galileo is kind of my avatar, my hero, kind of all-around scientist that I would love to approach the logarithm of Galileo. He was not only a phenomenal scientist, he was an incredible artist, a writer, a poet, a philosopher. And back then they didn't have distinctions. A scientist, like a physician was like a physicist. And he would indulge, kind of these really intellectual flights of fancy, thinking about phenomena such as the Earth's tides or the composition of the Milky Way. And what's interesting about Galileo is that he was almost as wrong often as he was right. And Galileo was not alone like this. I always think Einstein had at least 7 Nobel Prizes that he could have won for discoveries that later became true. But he also had 7, huge, impossible to believe wonders in some sense. That's too bad because he could have had a good career. Galileo was like that too. In other words, he would fall victim to, I think, this confirmation bias that all scientists have to guard their lives against, their careers, their brands, their reputations against, which is the exclusion of evidence that doesn't conform to what you're trying to prove for one reason or another, or the radical acceptance of things that do comport with it in order to bolster your confidence. Both are equally intoxicating. Your confirmation bias is a hell of a drug because it really reinforces this notion, which is partially some cost. You put so much time, effort, money, reputation into it. You don't want to be wrong to go back on it. With Galileo, he would be incredibly perceptive about things such as the Earth being not located at the center of the solar system and the sun being the center, so-called Copernican hypothesis. And he would use as evidence very, very interesting ideas, that all of which were wrong. And in fact, we weren't able to prove that the Earth orbited around the sun. And I asked you, can you prove the Earth is not flat? No, you're a flat Earth. But I asked my graduates.
With Flat Earth Society member, T-shirts coming out soon. Livestreamer.com merch.
But it's actually not trivial to do that. But most of my graduate students, can prove that the Earth is round. Explain how the Earth.
It is actually not trivial.
It's not.
Yeah.
And much harder is to prove that the Earth goes around the sun. In fact, that's extremely hard to prove. And almost none of my students, even after they get their PhD on the final exam, kind of like to just give them a little bit of humility. Because I think to be a good scientist, You need to be humble. You need to have a little humility, and you need to have swagger. You need to feel like a little cocky, like I can do this. I can do this thing that Einstein, by definition, couldn't do. I'm going to attempt it. I'm going to attempt to do what was impossible just a generation ago.
How do you that the Earth goes around the sun? Is it by the motion around the planet?
So there are many ways to do it. I mean, obviously, you can take a spaceship, park it at the north celestial pole of our solar system, and just watch what happened. But obviously, that was how it was discovered in the late 1700s. So it's called aberration. So if you look at stars as the Earth orbits around the sun, the position of the stars will shift slightly because of the tilt of the Earth and because the Earth is in motion around the Earth and around the sun, and because the Earth has a trivial amount of velocity compared to the speed of light in its orbit around the sun. The stars will trace out little tiny ellipses, and those will correspond to the fact that they're moving around if they're at infinite distance, which we assume that they are not really. But for all intents and purposes, in the scale of the solar system, infinitely. So that's called stellar aberration. And that was the first way it was discovered. And actually, we still use that. We have to correct for that effect when we measure the cosmic microwave background. Because imagine you're inside of an oven. It has a temperature 3 Kelvin, 1,000 Kelvin, whatever. If you're moving towards you, the photons that are coming to me in that direction will be blue shifted hotter, and the ones behind you will be red shifted. I'll artificially impute a greater or lesser amount of matter or energy where you are, and that's the extent of Doppler. So we actually make use of that and construct what's called local standard. Anyway, so you can do it. But Galileo said, no, I'm not going to wait for that. I have other proofs for it. One of which is that the Earth has tides. And the tides come in and out twice a day, high tide and low tide. And he made the analogy of because the Earth is moving around the sun, say this is the sun here, and it's moving around the sun, but it's also rotating on its axis. See how the water sloshing inside the as that happens, he said that's what the tides is. Totally wrong.
Most people listen to this podcast. Just so you know, if you're listening, he actually has a bottle of vodka in his hand, and we're both drunk and whatever else is possible.
So as it sloshed around, he claimed that has nothing to do with that. The moon over there, the moon pulls differentially on the Earth and the Earth's ocean. That causes the oceans to bulge slightly towards and away from where the moon is. The moon is actually the source of the Earth's tides. It has nothing to do with Copernicus, the orbit of the sun. So he was totally wrong. He also thought that the Milky Way was comprised only of stars, gas, dust, nebulae, things like that. So he had a fair share of work. Now, one thing I always kind of make note of, and I'm actually producing along with Jim Gates, Fabiola Giannati, Frank Wilczek, and Oliver Belli, and the first ever audiobook of one of Galileo's dialogue, the one where he claimed to find evidence for the orbit of the Earth around the sun. That it was an error.
So you're reading parts of this text.
Yeah, it's
just incredible.
Brilliant book. So this book was written in 1632. It was written, and it's the one that caused him to go into house arrest and almost threatened to be tortured. And that book laid out his arguments for what was called the Copernican, or the non-peripatetic, Aristotelian notion of the planetary dynamic. And eventually he was forced to recant that he believed in it, and eventually he said these different moves. Anyway, so we're making that. It's written in the form of a trialogue. It's actually called a dialogue. There's 3 people. There's one named Salviati, who's espousing Galileo's notions about how the heavens were orchestrated. Salviati means like the salvation, a savior. Then there's a middleman, Segredo. So Carlo Rovelli is playing Salviati. I am playing Segredo, who's like an intelligent interlocutor. I can appreciate Aristotle, I can appreciate Copernicus. Then there's this guy, Simplicio, the simpleton. And he espouses the words of the poet. So you can imagine, like, you're working in the Putin's government or working in whatever, and all of a sudden you're kind of putting the words of like the fool, literally calling the fool, but you're using the words of the all supreme powerful being on earth at that time. So that makes sure, especially for the Italian. So he wasn't as brilliant, politically as he was astrophysically.
Who's Simplicio?
Simplicio is a friend of mine at University of Manchester. He's an Irish guy, but he's full-blooded Italian. Well, they all speak English and Italian. I only speak. And the forwards are written by, so one forward, and this place has 3 forwards, which is like a 12 word. Okay. The forwards are written
that joke
for me. Yeah, that was good. The forward, 3 forwards. One of them is written by Albert Einstein, in which he says Galileo was not only one of the greatest scientists in history. This is Einstein telling Galileo, but he was one of the greatest writers and minds of all of human history. That forward is read by Frank Wilczek. Jim Gates, who you also had, he reads the translation, the translator, Stillman Drake, who's a renowned scientific translator. And then Fabiola Giannati, she reads the introduction and dedication from Galileo to the Duke of Tuscany and some of the different introductions that Galileo himself had. It's such a thrill to be able to do it. I only randomly found out because I wanted to study it, and it's like 500 pages long. I was like, let me get the audio book because an audio medium coming up didn't exist. So I said, let's do it ourselves. And so we did it, and hopefully it'll be out on Galileo's birthday, which is February 15th, 2022. It'll be a ripe 457. But that's not the only one of his books. Galileo wrote many books, one of which is called The Military Compass. And this is an interesting book for my blockchain and your blockchain efficient course. In this book, he talks about a compass, which is not a magnetic compass, but an actual slide rule. It's basically a slide rule. And it's a manual. It's like, imagine if your phone came with a manual. Nowadays they don't, right? But this was a manual for how to use this slide rule, which is like enormously important. And he gives a whole bunch of working examples. It's brilliant. One of the examples is how do you convert money? So he does a money conversion, currency conversion between Ducati and Florentine Ducati, and Scuti, and whatever, lira, whatever. He does all these currency conversions. One copy of this book, maybe 2 exist. First printed in 1600 still exists. If Galileo had just kept those in his family, they're worth $100 million. Nowadays, you can't get a Scuti. The Scutis were nothing. Like a Ducati's worth nothing. Maybe some collector wants a piece of paper, right? So it's a lesson. Like there are value in physical, non-fungible tokens. It's original non-fungible tokens. So, but then a third book is called the Assayer. So what is an Assayer? So assayers were kind of like these alchemists, physicists, chemists that would be around a court, and every so often for the treasurer, they would want to accept pieces of gold from the citizens and convert that to script or paper money. And to do that, they needed someone to verify was the standard of gold that they knew to be gold, and do some kind of semi-non-destructive evaluation of the hoarded object, the metal that was supposed to be gold. So they would take these pieces of gold, theoretically gold, and they would rub it on something called a touchstone. Touchstone was a special piece of rock, granite, whatever. It has no intrinsic value. It's just a piece of rock. But with that rock, you could assay and determine the content of this thing that could be worth, billions of lira or whatever. Right? So it's an incredibly important job. And so this person would take this piece of inanimate rock and use it to do something valuable. What I want to do in the Assayer project is take this plethora of physical theories of everything. I said recently, we should give a Nobel Prize to someone who doesn't come up with a theory of everything. Because there's just it's just rotten. And I think it's great. I often say that theory is kind of like software, and I'm not denigrating software at all, but like you can create a lot of software. You can make a coin, and it'll make its own coin. And you can make infinite amounts of software.
Look it up, kids.
And you can replicate. You can't make a telescope that makes a telescope that makes a telescope. In other words, hardware is kind of like the non-fungible token that's ultimate minted, limited edition, the compass book. And so it's very expensive. That means you have to be very careful before you invest decades, billions of humans into pursuing one of these theories of everything. You have to have good intuition for it. And lately what I've seen is not predictions, but retrodictions. So you see that the Large Hadron Collider will come out with a measurement. And then so-and-so will say, this is compatible with string theory. Or G-2 of the muon. It has these bizarre properties. Fifth force, string theory predicts this. String theory solves this. Neutrinos, sterile neutrinos. Large Hadron Collider bottom B experiment. blah, blah, blah. They'll say that it's compatible after the fact. And it's not so bad, right? Because look, what did Einstein do with general relativity? The first thing he did was not predict something new. He looked at the anomalous behavior of the planet Mercury. And he saw it was behaving strangely. And people had said, oh, that's because there's another planet hiding behind the sun that we can't see that perturbs the orbit of the planet Mercury. It's always called Vulcan. That was one approach. That's kind of like the dark matter approach, where it's like there's a clump of matter that we can't see that's influencing the planet that we can't see, and we use that to divine intuit the existence of the other planet. That's actually how Neptune was discovered. Neptune was discovered because of the anomalous behavior of the planet Uranus. So Neptune was dark; we couldn't see it. It was tugging on Uranus in a certain way, and that led to Leverrier discovering the planet, predicting where this planet should be found. So it had a good heritage in physics, right, to predict this planet that you couldn't see. That worked. But Einstein said, no, it's caused by the warping, big and bending of space-time due to the presence of matter, that would later become known as the Einstein equation. But he explained why Mercury did that. And it was known since the time he knew that Mercury was behaving in this really freaky way. So he didn't predict it. He retropredicted it. That's fine. But at some point, you should come up with something new that's uniquely predictive of your theory, as I just said. The theory of dark matter in the context of Neptune is actually a valid theory. It just happens not to make sense in the context of Vulcan. And so, if he had kept doing that, maybe perhaps he wouldn't have come up with these other predictions that he would later reject. Like he rejected the existence of gravitational waves. He would never talk about that. He didn't actually believe it. It's the one peer-reviewed paper that he had. He used to send back in those days. Send a letter to Nature, Physical Review, publish this. I'll let them know how much it costs me. And they got it rejected because he said you can't detect gravitational action, or they're not real. And the guy showed that they're real because he corrected the math error, and Einstein wrote this paper. So it's fascinating. What should be asked there to do? You should look at these things, look what things they explain that already exist, and look at what new predictions they can claim to explain if we can do experiments to test them.
Yeah, so kind of challenge yourself to think about what kind of predictions can they make such that we can construct experiments. So that's like ultimately back home to the signal, to the experimenter's theorist, essentially. That's right. So like very experiment-centric exploration of the fundamental theory of everything.
That's right. And the best scientists, the best physicists, were both experimentalists and theorists. Or at least that if they were experimentalists, they understood the theory well enough to make predictions or explore the predictions and the consequences of those predictions. Or if they were theorists, they were like Galileo. Like Einstein has patents for things that he invented. And then, some of his work with the laser and amazing. So he didn't have practical, it wasn't just pure airy-fairy, quantum reality and expanding universe. So in this case, what I want to do is look at, there's 10 different theories of everything, or cosmological models. They make predictions, they have advantages and disadvantages. And I'm just asking the question, why aren't we applying Bayesian reasoning with confidence intervals? Why don't we have updates? Every time an experiment comes out, we can update our credulity in that experiment, or that theory rather, based on the results of the experiment. And we shouldn't do it after the fact, or as Mr. Kaku has said, well, you have to tell me what the initial conditions are. That's not my job. You're supposed to tell me if string theory is correct. What should it predict if it's true? There's one big part, which I should say, that to be a good asset, I think you have to be worldly in the sense of worldly and curious, like we were talking about before with you, with Joe. You can't only talk your own book. You can't only understand your own pet theory of everything. You can't only say, well, I only understand string theory, and I don't have time for these other theories, or as if it's beneath me to even go into Garrett Lisi or Eric Weinstein or Stephen Wolfram or aspects of M theory, et cetera, et cetera. And there are some that say, like, why do we give string theory so much of an advanced pass when there are actually predictions it's made that are completely anathema to what we observe in physics. Like the dark energy should be negative. We see it as positive. Like that's a huge start. If you told somebody, here's my 10-year application, if it wasn't done by Aldacena and Witten and folks like that, I don't know if it would have had the traction, the endurance, the resiliency that's had. And that worries me because all these men and some women are making these fantastic, brilliant, beautiful ideas. They're not even looking at what their neighbors do.
There's the thing that I really enjoy seeing and I don't see often enough in these theories, which is others who are also experts, kind of studying them sufficiently well to steal man the theory, to show the beautiful aspects of the theory. And I see that with Stephen Wolfram. He has a very different sort of formulation of physics with his physics project. Now it's, physics is a foreign land for me, but his formulation, especially in the context of the automata or hypographs, just as objects, as mathematical objects themselves are familiar. And so I'm able to see the real beauty there, and it saddens me that others in the physics community can't also see the beauty. Like, give it a chance. Give it a chance to see the beauty. And then,
so there is one person who does take time and is what I consider to be a great scientist in terms of what he thinks. He obviously has an invested interest in his own theory. It's Eric. Eric's got a truly encyclopedic knowledge of the history of physics, and he has a great warmth and graciousness when it comes to giving other. And I've witnessed this. I've had. Look, first of all, I think debate is pointless. Like, I don't know about you, but if you've ever voted, like, oh, I saw this debate, and because Trump did so badly, now I'm going to vote for Biden. No, it never happens. You almost never change anybody's mind unless you debate with love. Unless you have almost like we're going to win together, like the red team approach of the military. They're trying to win a war, so they may disagree on the tactics day to day, but the strategy, we have to win this war. I love you, and I want to protect you. I don't see that very many of these businesses from Kaku. I almost see it. It's embarrassing in some ways because they'll almost mock, with the exception of Eric. And Garrett's interesting. His theory is, people have a lot of issues, very technical. But Eric has taken the time to try to understand it. Eric has taken the time to understand Peter Wood's theory. And I don't see the same graciousness extended from them. I'm sorry.
Yes, you're right. Maybe with Eric, he wants to, but he hasn't the same for Stephen Wolfram because I think.
No, he did. No, actually, no, he did. I had a debate with them live on my show.
No, I did. I listened to it, but I just think it's outside the true kit of the Eric is comfortable with. So it's not that he's not. But you're right. The main thing that's often absent that Eric does have is like the willingness and like not just like dismissing or mocking that he's reaching out. But okay.
I mean, what if it's not? Joking around, it was like, how many theories? Highlander, there can be one. I don't know.
But he, of course, also like the other folks who propose a theory, has an ego. He rides a dragon. The dragon represents an ego. Well, let me ask you about your friend Eric Einstein. So he proposed initial sketches of geometric unity, which is his theory of everything. Maybe you can elucidate some aspect of it that you find interesting. But what do you think about the response he got from the site?
Well, some of the response came from people, academicians, professors. Some came from a lay audience, and some came from trained scientists who are no longer maybe practicing in university. I thought there was a lot of vitriol, which surprised me because I look at what he's trying to do, and it was always the vitriol would always come with some element of ad hominem, and maybe that's his personality, maybe that engenders this or whatever. Maybe there is kind of just a natural tendency. I always get these emails, Professor Keating. I have a new theory. Einstein was wrong. I'm going to prove it. I'm not good at math, but if you help me, I will share my Nobel Prize with you. Well, have you read my book? In other words, it's always taking down the dragon. It's always taking down the Kung Fu master, right? That you get the hit points from D&D. You get their hit points. You take their cards. You get their risk tokens from Chaka. And thinking about it with Eric, it's like, because what he's doing is so aspirational, it is grandiose in a good sense. What he's trying to do is construct a geometric theory of everything that has aspects of supersymmetry and stuff embedded in it. He's trying to meld that. It has very unusual features, and that it features not only multiple spatial dimensions, but multiple time dimensions. It uses new mathematical objects that he's invented. And look, I had had him on my show. I talked with him. We've had consultations with other physicists, where he'll come down, and I have the visitor's office, and he comes down to San Diego sometimes and spends time there. And we talk with eminent mathematicians and physicists. Eric's been out of the academic world for a long time. And there is, as I said before, an aspect of persuasion that must take place in order to get anything through. And I think there was a slight amount of good nature, not ignorance, naivete, but just the sense that if this is right, everyone will recognize it. If you build a better mousetrap, the world will be a path to your door, as the expression goes. That's completely untrue. That doesn't even happen with mousetraps. I mean, you know how many freaking mousetrap types there are? It's like, no, they don't beat a path to your door. You have to sell that freaking thing. You have to sell it like Steve Jobs or Elon. I've had one paper, I have 200 papers I've published in peer-reviewed journals. I've only had 1.5% published with no reference comments. In other words, published like dream, submitted it, published it, happened to be in a prestigious journal. I was pretty psyched about that. But you almost have to crave the response, getting it back from a journal. And I think he does. First of all, he doesn't subscribe to the peer review process. He thinks that is a anathema to the way science is, and best interest in public in journals, et cetera, et cetera. I think you can have elements of peer review that are substantive and valuable. I think you have to learn from your critics. One of my conversations with John Mather, he talks about loving your critics in this book, but not being so open to their criticism that their criticism goes to your heart, and not being so open to their compliments that their compliments go to your head. It's a very tough Scylla and Charybdis to walk.
Well, there's something, I want to be careful here because I'd like to talk to Eric about this directly, but I'll just, from the perspective of a friend, want to ask about the drug of fame. So there's also the public perception of the battles of physics. And so there's a very narrow community, but then there's the way that's perceived, the exploration of ideas is perceived by the public. And so there is a certain drug to the excitement that the public can show when they sense that you have something big. And that in itself might become the thing that gives you pleasure. And I think that with theories of everything, or with any kind of super ambitious project, this is taking us back to when you were ambitious about trying to understand the origins of the universe. If you convince yourself that you have an intuition about the origins of the universe, and you have a platform like you do now, where you start to communicate your intuition, it's hazy, like all the science is still unsure. But you have a sense, perhaps you don't have that as a mentalist, because you always kind of start going, okay, how can I build a device to see through the fog? But if you're more like a theoretician who kind of works in the realm of ideas and the realm of intuitions, it is also a source of pleasure. You mentioned dopamine, a source of dopamine that you can communicate to others that you're really excited by the possibility of solving the deepest mysteries of the universe. So there's some aspect to which you want to be a Grigori Ganesha Perlman and go into the hole and get the work done and shut the hell up about speak about myself, about, talking about the dream and planning and exploring how great it will be if my intuition turns out to be correct. If the sketches I have turn out to actually build the bridge it takes to go a whole new place. As a friend, or a friend of, or my friend, what kind of advice do you give? What is your role? Is it to be a supporter, given that he has many critics? Or is it to be in private, a critic, like a lot of my friends will say, hey, shut the hell up. Just get it done.
Well, first of all, I want to ask you a question I've asked him. it comes from Animal Farm. But,
Probably my favorite book. Yeah.
so you remember Benjamin the Donkey, and he's talking about pig. Anyway, the pig system, you've got this long, lustrous, beautiful tail. You're so lucky. I got this short, curly, little squiggly thing that's Jack's claw. Tell me, how does it feel to have such a lustrous tail? Benjamin says, well, the good Lord, he gave me a tail to swat away the flies. But you know what? I'd rather not have the tail if I didn't have the flies. So I ask you, as I've asked Eric, is it worth it? You know, you've got these beautiful tails, but there are flies. I'm not saying in a negative way. I'm just saying you get unwanted distractions, dopamine. You know, kind of the highlight, the spotlight effect. It's obviously allowing you to do things that you could never do alone. And I think, well, first of all, I'd love to know how you answer that, because that's something I don't feel I can relate to myself.
Well, this has to do with more like platform stuff.
Yeah.
Scale. Oh, that has very little effect on me. I enjoy it. I enjoy meeting new people, but that has nothing to do with platform. Yeah, no, that has no effect on me. I'm somebody that enjoys the act itself. And so this conversation, the reason I'm doing this podcast with you today, it is because it allows me to trick you into talking to me for a long period of time. I don't care about platform. I assume nobody listens. It really doesn't matter.
Yeah, if you got it right. My whole task of it is good podcast. How do you know? Like, podcasts been around, 12 years? How do we know as podcasters we're doing a good job? Like, sometimes someone say, that was the best we've ever had. That doesn't happen. But if you realize that you forgot to put the SD card in the guy and the Zoom didn't work, would you do it again? And I think if you say yes to that, that's good.
Yeah, exactly. That's exactly it. So in that space, yeah, all of it is worth it.
Yeah.
But the dream, the I'm more referring to the psychological effects. Forget the platform, forget all of that. You know, I maybe shouldn't even brought up the platform, because it really has to do even in your own private mind, which is what I'm struggling with. I enjoy the planning, the dreaming, the stages, so that I often don't take projects to completion. This is psychological effect that I'm sure basically every engineer, everybody that does anything goes through. I just, in this case in particular, I think it also applies. And I wonder, as a friend,
so yeah, and that effect is to document everything from planning telescopes to diet. So there's a tiny bit of dopamine that you get visualizing how you're going to feel. But losing 5 pounds. I said, I'm going to lose 5 pounds, and I'm going to be able to run a minute faster. So there's a part of me when I'm planning the diet and the meals and the exercise that I get a little bit of that thrill, and that actually saps a little bit of my willpower to actually complete the task that will take me to that goal. So that's a documented effect, and that happens in project planning and project management. It's a very, very important thing to guard against as a manager in a big project. With Eric, it's interesting because with him, first of all, we relate extremely well, in friendship level, and very close. He does remind me a lot of my father, and I called him that, just as a mathematician, as a big thinker, as in his case, as a father, the father kind of figure that I didn't have in a sense, but that he is a true lover of life. He knows he's got a huge platform. He knows he gets a lot of attention for what he does. And I jokingly say, well, it's one thing. Like, how do you know, Lex, that someone's an expert? Experts say. There's a good rule Ray Dalio writes about in Principles. He says an expert is someone who's done something 3 times successfully. Like, you can do something correctly once, you can do something correctly. It's very hard to pull off like 3 projects, 3 telescopes, 3 whatever, right? So look for that. It's arbitrary. It could be 4, it could be 2, right? But the point is, look at Eric. So how many things has he contributed to and made, pretty substantive kind of paradigm shifts for different people? I would say he's been right many times. Does that mean he's fallible, that he's ineffable? No, of course not. For me, so what I'm saying is I get a little bit of the joy of kind of learning something purely as a scientist, something completely completely outside of what I do, mathematics, gauge theory, the kind of very advanced geometry, topology that he's interested in. But every now and then, I will sneak in that I want, I told him, I'm going to turn your son into an experimentalist. Despite, like, he's not going to be a therapist. Zeb is not going to be a therapist. He is working with me. He is learning from me. We're trying to get him into, he wants to bypass all of the, the kind of nonsense of undergraduate, go straight to graduate school. And I've tried to encourage him that maybe he can do it, maybe he can't, but there's no other way than to try. And so I prepared a whole curriculum for Zeb to basically bypass all of undergraduate. And to his credit, he's done tons of credit. He's learned it to a level that matches my name.
Okay, hold on a second. I have to push back and sweet saying it. I'm sure I'll come to Eric about this. But to say, you said Eric's done was right on multiple things. I think Eric has a great, deep insight about human nature and how societies work. And he says a lot of wise words from that work. But I think if we're talking about experts, you kind of have to prove, it's like Michael Jordan playing baseball. Like, he's proved it many times that he can play basketball. But he's also got to prove that he can play baseball. And I would say the whole point of radical ideas is you're not, it's very hard to be sitting at a track record. When you're swinging for the fences always, there's not a track record to sit on. And like Max Tegmark is an example of somebody who has a huge track record of more like acceptable stuff, but he also keeps swinging for the fences in every other one. So he has that track record. Yeah. With Eric, if you look at the number of publications, all this stuff, he chose not to travel the academic process. There's no proof of expertise except sort of an obvious linguistic demonstration. That's not how physics works, right?
There's a polite way to damn somebody as a scientist and say he or she they really know the history. like this is always something like Sean Carroll always jokes about. Like this you should never talk about history of physics. But it's more than that. So Eric has certainly contributed in finance specifically, in gauge theory and economics, and in inflation dynamics and non-technological products.
That's yet to be proven. He has a lot of powerful
theories. He has a gauge model for currency exchanges between different nations that is explanatory. It's not. Is it something? In other words, it's a model and it's used for pedagogical purposes.
It might be.
Okay. It's unique to him and Pia.
Yes. Yeah. It might be a powerful model. It might be one that actually deserves huge amount of applause, celebration, but does not yet receive that. And that's one of the things that Eric talks about. It has not received the attention it deserves. But it has not yet received the attention it deserves. And so, like, the no proven expertise thing, there's a lot of people that go to their grave without the recognition they deserve. And it's a tragedy. But the fact is, like, you have to fight for that recognition. The tragedy happens for a reason. You can't just say this person is obviously brilliant and therefore they deserve the credit in every single domain. It doesn't like transfer. There's nobody that's, well, at least I would argue, Eric is one of the special minds in our generation. But you still have to fight the fight of physics and prove it within the community. And I think the same applies in economics. You can't. If somebody that falter the academic journey, just like you said, the peer review, all of those things, flawed as they are, that's the part of the process. You have to convince your peers, the people that are as obsessed for whatever the hell reason about that particular thing that you're working on. Yes, there's egos. Yes, there's politics. It's a giant mess. I think it's a beautiful mess through which you have to go through in order to reveal the power of your idea to yourself and to the world.
Let me use an example. So you know James Clerk Maxwell, and he invented the laws of electromagnetism, which is the first example of a unification principle ever displayed by the human mind in history. Purely mathematics, unifying really disparate phenomena. In one case, electricity, charges, static electricity, lightning, and the other magnets, bar magnets, currents, etc. Unified. You know what he did? I like to do a thought experiment. So imagine Twitter exists 1864. Maxwell's working away, and he goes, I have this wonderful idea with fluxions and inductive virtue and blah, blah, and it revolves on this thing called ether. And by the way, there are these little vortices and gears, and the gears have these planetary things, and they suck up vortices, and the vortices determine the density of the electromagnetic. And what would you do? Come on, honestly, you would say everything this guy does is wrong. I mean, he's got this idiotic idea. And it would be proven falsified a couple of decades later by Michelson and Warren. And in so doing, you would have thrown out a very beautiful baby with bathwater. Imagine a tweet storm, Clerk Maxwell, at Clerk Maxwell one would get. It would be brutal, right? And to the detriment. And that might even set back history. Imagine Yang Mills doing the same thing. Churn signs. A lot of these things are very fantastic. But why, Lex? Why does Ed Witt? Why does Ron the same? Ron, yes, brilliant guy, I love him. He is the reason that Stephen Hawking conceded his black hole information paradox. What did he concede? He conceded based upon now the same as calculation in ADS-CFT and five-dimensional wormholes. But is any of that? First of all, we don't live in an ADS universe. Second of all, we don't know if wormholes are traversable, if they exist even. These are devices that Kip Thorne has popularized for movies. Like, to say that this is something on which I would concede a bet. Now, obviously, Hawking's different. What is not the same guy? What is that? He's got a pretty high H index, pretty well-respected guy at IAS. Love talking to him, brilliant guy. By the way, also had made use of Eric and Pia's work on gauge theory and economics. Originally, and won, I believe, the breakthrough prize. I can't remember exactly what, but partially, credit some of the work that he did, which appears there's a footnote to Pia Maloney's thesis and some conversation with Erica in it. Anyway, getting back to that, why is there not the same skepticism? Is it because Navicena, who's an eminent physicist, obviously, has published realistic work and done and stuff? What about Whitney? Whitney gets a pass. I mean, if
Whitney gets a pass on the chest, but it's a string theory.
Well, yeah, the M theory is correct. I mean, let me just say Hawking got so. Hawking would say things like M theory. There's zero evidence for it. I mean, there's the famous meme that went around this weekend. What is string theory predicted? It's not. And by the way, that's actually wrong. You talked to Cameron. Cameron says that string theory does make predictions. It predicts the mass of the electron lies between 10 to the minus 1 Planck mass and 10 to the minus 50. Whatever. Electron. It's a huge range. Imagine Cameron comes up, and again, he's just some nobody, but he actually, he doesn't have a profile. He's not at Harvard. Has zero H index, or whatever Eric said. Why do we not in other words, why are we more harsh on people that are trying?
You know the answer to that. So I get a million emails, just like you said, you yourself, where they humanize in my world of artificial intelligence. The equivalence of that is I figured out how to build consciousness, how to engineer intelligence, how to
you should send your emails to me. I'll send my emails.
Will reply to. I mean, I don't want to sort of mock this. Because I think it's very possible that there is either kernels of interesting ideas or there is geniuses out there that are unheard, but because there's so much noise, you do have to weigh higher the Ed Whittens of the world when they make statements, and that's why you build up a track record. As you said with Ray Dalio, you have to show that you can, if you're Pollock and you show us a painting of a bunch of, you have to. This is an example of because he probably never showed this, but he could, right? Yeah. It's much more comforting to see that they can paint a good, accurate picture of still life of an apple on a field. So there's
you're right,
because then there's something about the scientific community that they have perhaps an oversensitive bullshit sense to where they're not going to give the full effort of their attention if you don't have a track record. Now you could say that's a kind of club that only you have to have 10, you have to have this, yes, that exists, but there's some aspect in which you have to play the game a little bit to get the machine of science going. Otherwise, if you're always saying, "Well, I have my ball, and I don't want to play your game. Your game sucks," then nobody's going to play with you.
That's true. And look, inherent in all this is an underlying bias. Look, how could you talk about doing what Kaku said on here and elsewhere? We're looking for the umbilical cord that connects our universe to another universe that will then reveal in a 1-inch equation that will surely revolutionize the mind of God.
That's like a prerequisite, I guess, to tackle these questions.
I think it's detrimental. I think doing that, first of all, I think there's an element of almost snarkiness because none of these scientists are believing, Gnostics. They're not theists, right? So they're using it as kind of a stand-in. And they always talk about Einstein that he was like a Spinozan and he wasn't a theist.
God doesn't play that.
God doesn't play
yeah, Einstein's mentions of God. Yeah.
Yeah, and then Stephen Hawking says that when we come get M theory understood, we'll know the mind of God. That's the title of Kaku's book, The God Particle, The God Equation. Do any of them really believe in God? No. Is that a prerequisite? No, I'm not saying. But the point being, you're talking about something that has to do with God, right? I mean, where else do you go from there? I mean, I think God for now enjoys a little bit more, kind of PR than Elon or Joe or whatever, right? So like, it's, God's got a pretty good H index of some.
He has, by the way, a Twitter account, just so you know. It's pretty good. He tweets a good one. Yeah.
So if you look at that, you have to go in there. Again, you have to go in some surrender. You have to have a little bit of arrogance, but you should, I agree, mix with a little bit of humor. So he's doing something, he comes from outside of academia. Now, if he rails against if he's just railing, the system, and I'm not going to publish because F that, and that's only created by greedy journals, I don't think he's doing himself a favor. On the other hand, if he's shopping it, if he's talking it, if he's willing to expose it to criticism and to even embrace people who may not have the purest intentions, perhaps, but in the sense of like they're not arguing solely to get to the truth with a capital T. What they're trying to do is take down air. Hopefully, those aren't the people who are out there. But on the other hand, looking at what Eric does for other people, looking at the fact that he has courtesy, he will look at Wolfram. He will look at Lisi, who's one of his closest friends. I mean, he calls him his
nemesis.
Nemesis, right. I think that's interesting that they're loving friends.
I really enjoyed that portal conversation between Gary and Lisi. Eric is torn about that conversation because, I guess, because of the nemesis of the beautiful dance of minds playing his ideas like years ago.
And some of these things, so fundamentally, now I might disagree with him, Eric, on a different aspect, which is the only one I'm capable of. But let me say one thing, which is experimental. But let me say one thing. I understand probably a third of my other stuff. I understand, GR, I understand mathematics, I understand some group theory, fiber bond. I can get a little of it, H theory. But I also understand what I don't understand. And I understand that there are people like Whitney, Nima, other people that can understand it. And they're not trying to understand. Sabina, she can understand. She makes all these, I don't understand it, I don't want to understand. I don't have time. And then she makes a music video, kind of mocking Eric and Steven and Garrett. I'm like, oh, yeah, and I love Sabina. And I've actually promoted my show on her. And I love her. We're doing a wonderful job. But you have a video that you said yourself takes 8 weeks to produce from start to finish. You couldn't spend, 30 minutes, 2 hours. Brian Keating, of that as an experimental cosmologist. And I have enough to say, like, this is interesting. It's part of the Ask Air project. And actually, I shouldn't say that there are no people. They're very serious. Louis Alvarez Gomez, it's the Stony Brook Science Center for Physics. So he and I are running this seminar. Hopefully this summer, we're going to reenact the famous Shelter Island conferences in 1900. Where Feynman got together and they talked about the Lamb shift. But what did that feature? The harmony, the resonant minds behind the best experimentalists in cosmology, particle physics. Condensed matter physics is now teaching us tremendous things about lower dimensional systems that can be applied. Theorists and experimentalists, observers, cosmologists, we all will get together, and we're just going to do it out of a spirit of love. But if it's just like, this guy's like, I don't have time for that. I really don't. I don't think it's interesting way to spend it.
There's an aspect that I hope to see. It goes back to our sort of discussion about Joe Rogan. I do hope to see sort of love and humility in the presentation. Like, let go of this kind of fear of your ideas being stolen and the ego that's inherent to the scientific pursuit. And now that everybody's established and known entities, we'll go with that a little bit so we can explore and celebrate ideas. I would love to see more of that. Just because you're saying, especially with these big ideas and theories of everything.
I mean, this isn't talking tales out of school, but I mean, he has made claims that I fundamentally disagree with. You know, in terms of like, he's had this Twitter baiting, loving trolling of Elon. Why are you spending all this money to get to Mars? We should be spending money on interdimensional travel, and we can unlock it. And I said to him, like, and he makes the point, that the atomic theory, that unleashed the nuclear age, and that could lead to planetary destruction. But I make the point pushing back with love on him. I think, look, nobody looked at the equations, like Fermi didn't look into all these equations of unification, which still doesn't exist, by the way. We spent all this time, Lex, and I don't know why it is. It's a phenomenon purely and theoretical. People are looking for the toe, and they're overlooking the gut. In other words, they're spending all this time on the theory of everything, the God equation, and there's this gut that unifies the three stronger forces. We don't have a theory for that, and people like lash out. They tried and failed at it.
Yeah, for people who don't know, there's four forces. Gut, grand unification theories that unifies the three forces. Still up and down, trying to get a shortcut to the theory of everything, which unifies the four. And then there's this whole thing that maybe quantum gravity is not even a thing. So, so we're trying to solve. We're trying to solve the puzzle of everything at the physics level, and then already before solving it, already saying once we solve it, here's going to be all the beautiful.
Or just like level jumping again.
Yeah.
Going to level 56.
Next thing. Yeah. I mean, I suppose you need that kind of ego, that confidence, that ambition.
The only two people in this book of 9 Nobel laureates who told me they don't have the imposter syndrome were two theorists, Frank Rothschild and Sheldon Glashow. And Frank is pretty interesting. I mean, I know eventually we'll cover the meaning of life, but you talk about Frank. Frank invented this theory along with his advisor and another person in the early 1970s, which from 1974 through when he was at Princeton, all the way up until 2004 when he won the Nobel Prize. Every day of his life, imagine this. You're going to have this startup. Sometimes you're going to win a lottery. You're going to win a lottery for 4 years. What becomes your singular focus in your life from now until the next 40 years?
Well, I'm not sure. I mean, would it be winning a lottery, or if I'm
So it's like
confident?
you're guaranteed to win a lottery.
Yeah.
Here's this wallet, Bitcoin wallet. It's going to guarantee to have this much money, stable coin, whatever. You're going to win it 40, but you have to wait 40 years. To me, it would be surviving for the next 40 years. You wouldn't leave your house. You would go out in a bubble wrap hat. You wouldn't go out without 20 masks on, right? Your whole life would be consumed with. Now imagine everyone's telling you you're going to win the Nobel Prize, which is bigger than the lottery. I mean, many prizes are worth more than the Nobel Prize, and every person who wins a prize that's worth 3 times the money, like Nobel saying that, he would trade the breakthrough prize for a Nobel Prize in a heartbeat. So these guys had to wait 40 years. Imagine the excruciating pain. What got him through it? He didn't feel like he didn't deserve it. He felt like, hell yeah, I earned it. He has that swagger. And what I'm looking for in this asset is to try to find ways that we can test stuff now, because I don't know if I'm going to be here for a year, but can we bypass? Can we have shortcuts with stuff like cold energy machine? And to me, that's what's interesting. Like, what can we do now? I don't care. Like Isaac Newton came up with color theory. And he did something really interesting. Next time I come, I'll bring you some prisms. So what did he do? He took a white light and took a prism from the sun, actually. Put it through a slit, put it through a prism, and it made a beautiful rainbow, like you see. And then he took another prism and he put it upside down, like, dark side of the moon. And the light went through the first prism, turned into a rainbow, and then the rainbow went into a prism and came out a white light. That's pretty cool. Then he took a popsicle stick or whatever it is, pipe of tobacco, and he put it in the beam, like blocked out the orange, and it didn't make white light. He showed like colors of synthesis. It's a comment. He didn't use like the Large Hadron Collider to do that. He used a very low energy experiment to prove a unification. It's color physics, different kind of color physics, chromodynamics. But nevertheless, can we find things like that? Are we spending way too much time and energy thinking about the future circular collider, which even if it gets built will cost $30 billion just to build? By the way, anytime from now on, if I didn't use anything, anytime an experimental physicist tells you a number, always double it, maybe triple it.
How much it's going to cost
to operate it? So, like, do we build an aircraft carrier? To build an aircraft carrier, we build a nuclear reactor, a semiconductor facility? And the rule of thumb that works pretty well in project management is it costs about 10% per year to operate a given object of sufficient complexity. And in this case, so in 10 years, it'll cost double the cost. So never believe a number, whether it's from our mutual friend Harry or whoever. Don't believe in it. Double it, and then say, is it worth it? And so building a solar system size accelerator, even if it were possible, do we have to do that? Or can we use these two 30 solar mass objects colliding together to test the number of large extra spatial dimensions? Can we do that? People are working on it. I think it's fascinating.
So focused on building detectors that, like, where the cosmos is part of the experiment, I suppose. It's doing the hard work. Because when you're saying low energy regime, because for some of these, especially big questions like theories of everything, you need some high energy events. And so somehow figure out how the high energy events that are already happening out there, how to leverage them here and there.
One of the alternative theories of cosmology that is not a singular quantum gravitation requiring as the Big Bang inflation are these bouncy models. Some of them feature a similar kind of entity called the quantum field. And that quantum field, in the initial stages of the universe of occurring after the bounce, which is not a singularity, it compresses to a classical kind of rebound, and the universe starts expanding. During that process, the expansion is governed by what's called the scalar field, of which we only know one that exists. That's called the scalar fundamental particle field. That field then later does double duty, and it becomes dark energy. So it solves two problems. And I'm not saying it's correct, we don't know. But are there observations of, and so dark energy is manifest today. It's manifest in properties we see in supernova explosions, et cetera, et cetera. We see the effects of the accelerated universe caused by presumably dark energy. Is dark energy a constant, or does it vary? That has to vary in order for this theory to be true, because that energy has to decay so that the universe can not support itself and collapse again classically. So we could use low energy phenomena. It's hard to think of supernova as being a low energy phenomenon, but we use that as a tracer of the cosmic expansion field and see, does it change or is it constant? That's an example of a low energy limit to prove a high energy phenomenon like this collapsing universe in a single moment.
Speaking of things that cost a lot but are super exciting,
Page 2.
no, we'll wrap it up. There's more than page 2. What do you think this is? This is
Louis de Broglie's thesis.
So, size matters in different dimensions in life. I think the lessons I've learned about life is the shorter the paper or the shorter the thesis. Actually, the shorter the paper, like the papers have to write for short. I feel like some of the best ideas in this world, not to sound like a contradiction or finding a contradiction on top of a contradiction, but it could be written on a napkin, honestly. Which is kind of what tells you something about ideas. What are your thoughts about the James Webb Space Telescope? Is this somebody who likes telescopes? And this is one of the, I think it says, it took 20 years to build, $9.7 billion. Is that way too much, too little? Are you excited about this thing?
It's sufficiently different from what I do in my field that it's incredibly interesting to me, because it's I have no horse in that race, and so I'm not competing with them for time or money or resources or people or whatever. Really be an advocate and an aficionado of something. It is in some successor to Hubble. It will do things that Hubble can't do. It will also may or may not have the impact on a visceral kind of artistic level that Hubble had. What are some of the most iconic things that Hubble did? The Hubble Ultra Deep Field, the pillars of creation, storms and imaging of these twisted deep sky galaxies. Those resonate with the public.
These visual, beautiful.
Visually, yeah. When you look at these images, the Hubble Ultra Deep Field, you'll put that in, you'll show every speck of light except for one. 4,000 blobs of light of this one star in our galaxy, the rest are galaxies. Now, that image is less than 1/10 of of your fingernail held out at arm's length. That contains 4,000 galaxies. And they can figure out how many galaxies there are in the whole sky just by seeing how long does it take you to move your fingernail over the whole sky. So it comes out to be, that's how we get 500 billion or more galaxies. It's not that exact to the galaxy, but it's a good order of magnitude estimate, maybe better. Hubble produced that. And it was basically serendipitous. They pointed to some dark, blank piece of sky, what they thought was blank, and they saw it. Same thing that happened with the CMB, looking for something they didn't find. Same thing they found when they were looking for the deceleration of the universe and found it was accelerating. So what I sometimes hear is that we don't know what we're going to discover. I never think that's a good idea to spend billions of dollars on something. Like, you should have some guaranteed low-hanging fruit, and then there should be swinging for the fences. And I think in this case, it was really everything that's swinging for the fences because it's kind of a single-point failure. That telescope, which is this origami construction of 22 hexagonal panels that have to unfold properly and then orient themselves a million miles from Earth beyond the Earth-Moon distance by a factor of 4, and still transmit telecommunication back to the Earth, get solar energy, keep it away from the sun. You don't want to the telescope the sun with the waning eye, and you do that, and you cover. It's going to be phenomenal. For science, for sure, if it works. There are a lot of people think, it's so risky. It's NASA sunk so much of their budget. It ate up, and what if it does fail? I mean, there's no guarantee. Yes, it's insured, but so what? You're not going to get back those 20 years of people. Well, let's start building it again. Like, they didn't build 2 copies of it.
Then if it fails, it kind of has a dampening effect on the prospects and the inspiration of the public for what science can do, what science engineering can do out in space.
It will make a huge impact scientifically. Let's hope for the best. Let's assume it does its launch in a couple of weeks. And when it does, it will transform our understanding of, we just discovered not only like extrasolar planets that have moons on them, an asteroid belt. We discovered an extrasolar planet in another galaxy. This will be able to see crazy stuff like that, spectroscopy, imaging. But it'll be able to go back farther in time, such that we will be doing cosmology. Like Hubble did some cosmology. It measured the Hubble constant. That was its key project. It was designed a lot. But because it is an optical telescope, it's sensitive to more close-in redshifts, so shorter distances. Now, James Webb is much higher redshift. It can probe the darker, deeper, distant universe.
Okay, let's talk about not the distant universe, but our neighboring planets. First, I got to ask you about the moon. So there's a piece of the moon on this table that you gave me that we didn't have to pick up, that arrived here. So how did a piece of the moon arrive here on Earth?
This chunk of the moon were delivered by the Apollo and NASA missions. You and I would be guilty of that. It's illegal. The moon collected by the Apollo astronauts. So don't even joke about that when you go over to Houston. This piece of moon rock was delivered via the old-fashioned way by gravity. So this was a chunk of the moon, which is blasted off because the moon gets bombarded by asteroids and meteoroids. Some of them eject material from the surface of the moon into space. And it will then orbit the common moon-Earth system, and it will then eventually enter our atmosphere. And if the piece is large enough and the trajectory is proper, it can land intact. And this one landed a few 100 grams worth, and they sliced it up, and then it was delivered via U.S. Postal Service to my house. So you can buy these pieces, and actually you can buy a piece of Mars. You can buy a piece of Mars delivered by the same guy. Now, what's so interesting about it? Well, if a piece of Mars can get here, a piece of Earth can get there, a piece of Earth has some life forms on it, it can get there, and if that can happen in our solar system, it can happen throughout the galaxy. So I'm actually not of the opinion that there is life elsewhere in the universe, at least technological life that we can see. I see this little horror difference. I view it, I am personally extremely pessimistic, would be extremely surprised.
I'm curious by the transition, because you just said that life could have arrived from Mars, or like from planet to planet, but because of meteorites striking it and so on.
Yeah.
And then you went to, you don't think that there might be life out there in the universe, technological life, advanced intelligent civilizations. Okay. Okay. So go on.
Yeah. So that's a generalization of what this astronomer Fred Hoyle called, I know this is a PG-13 project, it's called panspermia. Panspermia. And
Beat that out.
yeah, exactly. And that's the exchange of genetic life form material from other reaches on Earth, which explains the origin of life on Earth, but not the origin of life itself, which I think is a much grander mystery and much more interesting. How did life get here? And we've talked about that much, but just thinking about the reverse process. Let's say life started on Earth somehow, and then made its way out into the universe. Is there enough time for the whatever material went from Earth via panspermic direction, spraying the love gun? Did that then have enough time to incubate on it that could support it? Certainly not within our solar system, which traveling at the meteorite speeds require hundreds of millions of years. Then looking at the evolutionary history from bacteria to Bach, from rocks to Rachmaninoff.
Oh wow, that's pretty good.
How do you get from those very simple inanimate objects to life? I just simply think there's enough time for Earth to seed life, technological life.
But so you really think that the origin of life on Earth is a really special event?
Yeah, if it did originate on Earth. My question for those that search for life outside the Earth is, what if you had a letter from God? And you understand life didn't originate on Earth. Like, would you choose a different profession? Like, it would seem hopeless. Like, in other words, we only have a sample of one. In fact, we only know of one conscious life form that has life on it. What if you knew for sure it didn't start here? That means that there's almost nothing about Earth that is originated. It didn't originate the life process. So study purely the origin of life, not life itself. But how can we learn about the origin of remember, you have to go from inanimate object to living object, whatever that definition of life is. I'm an expert in many definitions, Max, Sarah, many definitions. But how do you actually go from inanimate to animate? It's a huge question.
Yeah, but then you don't have to be the place where life originated to replicate the origin or that's one way to understand something is to build it, but another way is to just observe it. You don't have to truly re-engineer from scratch. So but then yes, if it didn't originate on Earth, then your intuitions about the basic prerequisites of life are off.
What's the governing principle?
Right. Like, what is? You could have just an arbitrary number of possible. Like, if life didn't start on Earth, to me that's exciting because it's like we know even less than we thought. The thing is, it can prosper on Earth, though.
Yeah.
So maybe the origin of life is fundamentally different from the maintenance of life.
Right. And maybe the existence of Earth-life symbiosis is critical. I think Sarah, you talked about Sarah Walker, that it's a planetary phenomenon, et cetera, et cetera. So doesn't that make it less like? In other words, not only do you need special life conditions to create life, but then it's the sustenance of life, as you say, that also has to be maintained under very specific circumstances by very specific planets, with very specific tectonic activity at the moon. And by the way, you need a Jupiter nearby, you need an Earth and a moon system so that you don't get bombarded too early. And I always think like this, technological life. I haven't said this before, so I'm just speaking. I usually like to write down before I say it. One of the things I thought about.
Somebody hosts a podcast. You should probably accept the fact that you're going to say stupid things every once in a while.
Not every once in a while. Everyone. I claim that, to get to sending, people to the moon, our planet needed whales and dinosaurs, right? Like, you don't make a solar panel from another solar panel. You made a solar panel from a factory that melted down glass, silica, aluminum, extruded that using fossil fuels. Where do those fossil fuels come from? So any civilization that's going to get Dyson, Kardashev, did they have dinosaurs? Did they have prebiotic life? Did they have a great oxygenation event? Did they have a dimorphism between prokaryotic and eukaryotic? All those hurdles, let's say give each one, let's say there's 8 hurdles. And each one of those has a probability of 1 in 1,000 to go from, eukaryotic, prokaryotic, whatever. Let's say there's a 1 in 1,000 chance. I think it's like a 1 in 10 or 40 or whatever. whatever. But let's say it's first generous nature, 1 in 10 to the 3. Let's say there's 8 of those hurdles. Let's give 10 to the 24th power, different possibility, and not just with 8. Like the moon has to be there, Jupiter has to be there, dinosaurs have to be there, all the different things that we have to get the technological. There's only 10 to the 12. There's 10 to the 22nd. We think planets in the observable universe, not the galaxy. So that's 100 times fewer than the probability to get 100% clearing these 8 very low hurdles of 1.
That's fascinating. Now I really need to listen to your conversation with Chrome and probably again, because he believes the opposite.
Yes, I know. Yeah, I want to have a debate with him.
He believes that the way biology evolved on Earth could have evolved almost an infinite number of other ways. So, like, if you ran Earth over and over and over, you would keep getting life, and it would be very different. So, the fact that our particular life seems unique is just like, well, because every freaking life is going to seem unique, but it'll be different. It's not like we shouldn't be asking the question of what's the likelihood of getting a human-like thing, because that seems to be super special. It's more like how easy is it to make anything that has the skills of a human, and I don't mean like something with thumbs, but achieving basically a technological civilization. And according to the media, it's like it's trivial.
I know we fought. I fought a little bit. I'd love to debate him. I think it'd be a lot of fun because we debate with love. When I fought with Leon, I think. But let me ask you a question. And I asked this of him and Sarah. So, what do you think would happen the next day? Let's say we discovered life. Proxima Centauri B. It's looks just like slime mold, like you get in Greek cheese or whatever. We discovered it. What would happen the next day? And they were like, "Oh, it's transformative." And I'm not trying to be like total Cassandra, but I said I don't think anything. What are you talking about? Transformation. I'm like, I stipulate that life exists. Go down to like the river, I'm in San Diego. Go down to the Pacific Ocean, scoop up a glass, we're gonna find life in there. And what are we doing? What are we doing to our Earth? We're destroying it, callously. We're like pumping crap into there. Like we had this toxic waste spill a couple months ago in San Diego. I couldn't go to the beach. Let me take it a step further. You know how many people? I'm sorry, you do know, but how many people died in the 20th century? These are advanced civils. This isn't slime mold. We kill, we maim, we harm, we hurt, we hate. I don't think anything would happen the next day. We go back to what we had. And I said, if that weren't proof enough, life has been discovered at least 2 or 3 times just in my professional career. Once in 1996, these Allen Hills meteorites in Antarctica, that's the microbial respiration processes. Still, we don't know. It was a press conference held by Bill Clinton on the White House lawn that's featured in the movie Contact, repurposed for that movie. And then there's this this phosphorus life, this toxic life in the pools of Mono Lake, and you get extremophile. We continue to. So why are we thinking that like our salvation, from whence will our salvation come? As the Bible says, like it's not going to change how we are. It's not going to magnify how I treat you or you treat me. And we're pretty knowledgeable people compared to many people.
Okay, that's interesting. That's a really interesting argument. I wonder if you're right, but my intuition is I can maybe present a different argument that you can think about in the realm of things you care about even deeper, which is like what happens once we figure out that we're just in the universe. Like, how would that change your life? I would say there are certain discoveries that even in their very idea would change the fabric of society. I tend to see if there's definitive proof that there's life more complex and more powerful that the idea is elsewhere. I'm not exactly sure how it would change society, because it's such a slap in the face. It's such a humbling force. Or maybe not. Or maybe it's a motivator to say, I don't know which force will take over. Maybe it'll be governments, military, start to think like, well, how do we kill it? If there's a lot of life out there, how do we create the defenses?
How do we extract it? Or
mine it for benefits?
I mean, I just see like there's a 100 million little counterexamples of that. I mean, right now there's like 700 million kids in poverty. Like, how do we go about our life? Just not do it. I mean, I put it aside. I eat hamburgers. In the 100 years I'll be camped for being, carnivore or whatever. But so obviously to get through life, you have to make certain compromises. You're not going to think about certain things. But I just think there is a sort of wish fulfillment. Like every time there's water, why are we going to Mars and digging and flying this cool ass helicopter? We're looking for water. Like stipulate that water was there. Like I believe there was water. I think we should investigate and see what the geology was like.
But don't you think? So you're saying?
I don't think you're going to get meaning from it. That's all I'm saying. I'm not saying it's not worth doing. I'm just saying there's a wish fulfillment aspect that people will find meaning for life from science.
Okay, but there's a complicated line here. What if it's this intelligent civilization living, obviously, probably not on Mars, but somewhere like in a neighboring galaxy that in a neighboring star system that we discover? Don't you think that profound change?
I mean, I guess again, I assume that because of this panspermia process or whatever, that the probability is much greater than zero. I mean, it's not 100%, but it's much likelier than not that at least some living material from Earth has ejaculated itself into the solar system, into the universe. Right? That's where I
Beats that as well.
That's right. So I like the fact that could happen, and that you're holding a piece, from a planetary body and one that couldn't support life, as far as you know. But I can keep next time if you play nice and you come to my podcast someday, I will give you a tiny chunk of Mars. So Mars theoretically could support stuff, right? So I believe that there could be remnants of Earth in this. So that means there could be evolution. I don't think there's any chance that there's like people using iPhones and having podcasts and stuff.
No, there's some chance though, right? So
yeah,
it's.
I think the simple safe thing to say it's much higher probability that life exists than technology. Right? I don't think we can argue that. It doesn't mean it's forbidden. Again, I'm not saying any of this is forbidden. I'm not studying, interesting.
So likely,
yeah. And to answer I think you're wise to push back. And what does it matter what I'm doing? And I like to think about that, because it's like, what is the value of what you're doing? Like, you have to answer that question, or else at the end of your life you'll have these existential, kind of crises, right? So when I think about like who I am, part of my identity is answering and asking scientific questions. For me, though, there is a religious kind of undercurrent that does undergird, in some sense, this quest. Again, I'm not like a practicing, like I'm not like full on into my birth religion, Judaism. But at the same token, I think one of the things Einstein did say is that religion without science is blind, or it's lame, and science without religion is lame. It's blind and lame. Anyway, like you can't get meaning, from just knowing facts. Like Wikipedia knows more than all of us will ever know, right? It has no wisdom. Wisdom, it means sapient. Wisdom in Latin is sapient. We are wise. And by the way, what our real name is Homo sapiens sapiens. So it's man who knows that he knows. You know what he knows? You know what the known thing is? It's that he's going to die. We're the only creatures that know that we are going to die. We don't know when we're going to die. But I have a cat. A fierce cat. It's beautiful. She doesn't know she's going to die. Doesn't mean I'm valuable.
The survival instinct is fundamentally different from like the knowledge of death, and that's where the spectre comes in with the terror of death. Okay? That's a creative force that seems to be more feature than bug about the human condition. Is that it means a gift of knowing our mortality. To me, that's why. I agree with you in some sense in terms of the aliens not being a thing that solves all mysteries. That's why my love has always been human minds, or understanding who we are, what the hell are we, and I think your love has been an echo of that, which is where did we come from? Or basically, as cheesy as it sounds, eat your cocktails. If you could just like enjoy the,
he's like Sam Harris of Cosmo. He speaks in complete paragraphs.
But like also unapologetically, he says, we will know God, or we will know the mind of God, or whatever the cult, those kinds of things. That's exciting. That physics might be able to find equations that unlock our origins at the very core, like the fabric of it all, too, not just our origins. What's up? What's at the beginning. Something tells me we're too dumb to truly understand what's at the beginning. But
I think we should be humble in that way. I mean, again, another thing is, you ever hear the saying, like, we share 90 of our DNA with chimps or bonobos or whatever? I share, like, probably more than that. Sometimes I wish we shared 100%. Like, that would be so much more interesting. Like, there's 50% of a fruit fly or banana. Like, no. There's something, but that should make us feel more precious. And I almost feel like discovering life on another planet, whatever solar system, would cause a diminution of humanity. Like, the one thing I do hold fast to from religion, I don't know where I am with God. Like, do I believe in God? I think that's an unanswerable question. But I have some thoughts about it. But by the same token, I think the one thing I do get from religion is that every human has infinite worth, because we are, in religious capacity, considered to be equal to God. In other words, we are gods, not to be like, but we can contemplate what God did. We have aspects of God. We have free will. God had free will. If it exists, I can't prove that God exists. Otherwise, you wouldn't have any training to believe in.
This is interesting. I mean, it's like I'm talking to Einstein here, but let me ask him anyway.
Can you clip that for my clips, Jeff?
For somebody who's looking at the young universe, at the early universe, and are talking about God and are agnostic, who do you think is God?
So I thought you had just like one of the best podcasts with Sam Harris this past summer. And one of the things I liked about that conversation is he talked a lot about happiness and meditation. And he said something that's really resonated with me, and I'm working around it, trying to work on it. He said, like, you can never be happy. You can only become happy. And I'm trying to take it a little bit further than that, because I think it's interesting. Like, meditation is like, you're not like, oh, I'm happy, and now, like, oh, my kid came in, now I'm not happy. Like, no, like, you can be satisfied. Kurt Vonnegut said, like, so you ever catch this sometimes, like, so you're like walking around, you're like, life is freaking amazing. Like, I'm happy. And Kurt Vonnegut said, you should say to yourself every time that happens, like a little mantra, like, if this isn't goodness, if this isn't happiness, nothing is. Just remind yourself how awesome it is every breath, everything that you do when you make an impact, even some of the bad stuff that happens. Good. It's good. So Sam said that, and it made me think, because I was like, well, what does it really mean to be happy? Because, like, I can think about 2 or 3 ways that right now I could double my happiness. Like with the lottery or whatever, like I could double my happiness. There's only a few ways, right? Like, I had this kind of thought, like, how many boats can you water ski behind? Like, you had twice as many followers, now you got 2 million followers, 5 million, whatever. It doesn't do anything. It's called the hedonic treadmill. Like, once you get to a certain level, it takes a lot more, change, followers, money, impact, whatever you want, to make you have one more quanta of happiness. On the other hand, this is a concept from entropy. I can make your life miserable in an infinite number of ways. In other words, there's more space to make your life unhappy than happy. And so I thought about that in the context of what Sam said about happiness. It's an expression of entropy. And that what you should be doing is doing that which will cause you devastation if it goes away. Because those are the things that, like, are where you're reducing entropy. Like a kid, like anyone who's a parent knows instantly what I'm talking about. Like how to make your life a billion times worse. But there's no way to make your life a billion times better. And so thinking about that, now turning to the question of God's existence, I feel like there's no way that you can believe in God, to misquote Sam, but there's ways that you can become a believer in God. In other words, you can increase the Bayesian confidence level that there is some, and let's not call it God because it's a afraid term. Let's just call it some infinite source of goodness or beautiful power, right? Simple things can do that. You can increase your credulity in the goodness of life. And we have this bias as humans towards negativity. Negativity bias, well known that. So what I want to do is it's called God good, right? That's where it comes from. God good. Same words in German. And when we think about what is good, let's do those things that would devastate us. And a lot of that could be relationships. And there's a powerful concept from network theory, which is that, the number of connections in a network, I'm just saying, it grows as the square of the elements of the matrix. Right? So you think of a matrix with 10 people, person 1, 2, 3, 4, and then there's 4 other people. There's 16 different pairs, but half of them overlap. The diagonals where you know each other, you know yourself. But that still grows as n squared. So those connections increase and decrease, right? You ever have 2 friends that are fighting, and you're kind of upset, even though you're not fighting with either one of them? So a network grows like that. So you want to increase your network as much as possible, but only the kind of high quality interspecies people. And I think in doing so, you make yourself fragile, not anti-fragile. And I think that is where purpose and maybe approaching some measure of God.
That is a source of meaning, maximizing goodness in life. And the way you know it's good is if it's taken away, you're devastated.
That's one thing. Think about your brand, your business, your spouse, your kids. I mean, parents can't comfort. I've known parents that have watched. Jim Simons, here's a perfect example. He's one of my oldest friends and mentors. He is one of the richest people. Gulfstream, mega yacht. This is all documented. He lost 2 sons as adults. And here people feel, I'm so jealous of his son. Would you take everything? I don't know where he has that strength. And his wife now, his first wife broken. I'm not like that. Some people there are angels that are among them. And there's this famous prayer. It's like, God, there's an old saying about one of the hardest tests there are in life is to be given a lot of money. And you see it happens with lawyers, people in the lottery or whatever, NFL football players after their career's over, they're broke. God, please test me with money. But in reality, you should never say I want what X person has, unless you really take everything, and you'll find you won't want
to take everything. Yeah, I think a lot about the altering effects of fame, of money, of power, and it blinds people, and I wonder about that for myself because it seems like in themselves these are definitely not the goals. I'm pretty much afraid. I'm not desirous, and I'm definitely afraid of each of those things: money, fame, and power. But it seems the dreams I have as consequences can often have these things. And I'm really afraid of becoming something that would disappoint me when I was younger. That I wouldn't recognize. Because change happens gradually.
But are you using yourself as the touchstone to use the essay? What is your rubric to apprise if you have lived up to that 12-year-old, whatever-year-old flex? How will you know or not know if you've let yourself down? Or, I always think, live to impress yourself. I don't care if I have fun already. It's nice or whatever, but it's hedonic and it's just never ending because you'll always see the next level. But I think it's pretty damn cool that I've gotten to go to these places, the South Pole, and I've done these things, and I've made a family, and I'm able to teleport my values into the future through my children, and I've had ideological children so by what metric, have you not already A, impressed yourself, and B, could you let yourself down? I don't want to turn to the therapist.
I should think some of it is psychology. For me, I'm very much just never highly self-critical. I'm never happy with what I've done, but I'm always happy in the way that you described, which is that the Vonnegut thing, where you just often during the day will feel, I don't know, I just remember just eating beef jerky and being truly happy. That was just last night, and I have that all the time, and that to me is why. I mean, that feels to me like a healthy way to live life, and at least for me, it's the way I really enjoy. A lot of people tell me that maybe being so self-critical, so hard on yourself, is not a good way to go. But more and more as I get older, I realize this is just who I am. I get to a certain point, accept this is how I'm always going to be this self-critical.
So you're welcome, right? You know thyself. But I want to leave you with one last thing, which is to say, just on this topic, it could be different, right? We could go down to the ocean and get some krill instead of the 7-Eleven. It could be that we have no other taste buds. And Eric's talking the 4 dimensions of the vibration of your tongue, right? It could be like there's one, and it's just like not Memphis barbecue, whatever you like in your Slim Jim. It could be something. It could be very boring, similar. What if that's a clue? What if that's giving us evidence? Here's another clue. There are many animals. Most animals have single monocolor vision. They only see in black and white intensity. They only have rods and no colors. We could be like that. No. Why is that not a clue? God's not gonna hit you over the head and say here I am, because then everybody would believe it. And there's very simplistic. I've had debates even with famous atheists like Lawrence Krauss. He's self-declared militant atheist. And I was like, well, I don't believe in the same God you don't believe in. Some guy in a white beard in a chair. That's infantile. I gave that away a long time ago. But what if there are clues? What if Yang Mills theory, Maxwell's equation, what if those are beautiful? Have you ever seen, expressed in tensor notation, Einstein's equations, or Maxwell's equations, and then Maxwell's equations riding on Einstein's, it's unbelievably beautiful. It doesn't have to be that way. And we can comprehend it. That's a crack. Maybe that's where the light gets in. And the light is what reveals what's beautiful. So I don't believe in God. I think that's a stupid notion. Do I believe in God? Sometimes I wonder if God believes in me. More than if I believe in he needs Brian Keaton. What would it's one of my friends is Rabbi. He's what would I be doing if I were God? Exactly what God's doing right now. I know more than God.
We're believing he blues of beauty or these hairless apes. And to see what they do with this and then marvel at the both the tragedy of what those apes do to each other and the rare moments of fun when they understand deeply about how the world works. Ryan, you're an incredible human being. I'm a big fan, and I'm really honored. First of all, shower me with rocks from the moon, from space, and
crystals, magical crystals, healing crystals.
Yeah,
that you can use for good.
And tell me your story. It's been valuable time today. This was amazing.
It's a great pleasure for me, Lex. Thank you so much.
Thanks for listening to this conversation with Brian Keating. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Galileo Galilei. In questions of science, the authority of 1,000 is not worth the humble reasoning of a single individual. Thank you for listening, and hope to see you next time. The following is a conversation with Cal McCoon, his second time on the podcast. He is the chief AI scientist at Meta, formerly Facebook, professor at NYU, Turing Award winner, one of the seminal figures in the history of machine learning and artificial intelligence, and someone who's brilliant and opinionated in the best kind of way. And so it's always fun to talk to him. This is a Lex Friedman podcast. To support it, please check out our sponsors in the description. And now, leave my conversation with Jan LeCun. You co-wrote the article, Self-Supervised Learning, the Dark Matter of Intelligence. Great title, by the way. With Isha and Israel. So let me ask, what is self-supervised learning and why is it the dark matter of intelligence?
I'll start by the dark matter part. There is obviously a kind of learning that humans and animals are doing that we currently are not reproducing properly with machines, with AI, right? So the most popular approaches to machine learning today are, or paradigms, I should say, are supervised learning and reinforcement learning. And they're extremely efficient. Supervised learning requires many samples for learning anything. And reinforcement learning requires a ridiculously large number of trial and errors for the system to learn anything. And that's why we don't have self-driving cars.
That's a big leap for one together. Okay, so that to solve difficult problems, you have to have a lot of human annotation for supervised learning to work. And to solve those difficult problems with reinforcement learning, you have to have some way to maybe simulate that problem so that you can do that large scale kind of learning that reinforcement learning requires.
Right. So how is it that most teenagers can learn to drive a car in about 20 hours of practice, whereas even with millions of hours of simulated practice, a self-driving car can actually learn to drive itself properly. And so obviously we're missing something, right? And it's quite obvious for a lot of people that the immediate response you get from many people is, well, humans use their background knowledge to learn faster. And they're right. Now, how was that background knowledge acquired? And that's the big question. So now you have to ask, how do babies in the first few months of life learn how the world works? Mostly by observation, because they can hardly act in the world. And they learn an enormous amount of background knowledge about the world. That may be the basis of what we call common sense. This type of learning is not learning a task. It's not being reinforced for anything. It's just observing the world and figuring out how it works. Building world models, learning world models. How do we do this? And how do we reproduce this in machines? So self-supervised learning is, one instance or one attempt at trying to reproduce this kind of learning.
Okay, so you're looking at just observation, so not even the interacting part of a child. It's just sitting there watching mom and dad walk around, pick up stuff, all of that. That's what you mean by background knowledge.
Yeah, it's not even watching mom and dad, just watching the world go by.
Just having eyes open or having eyes closed, or the very act of opening and closing eyes, that the world appears and disappears, all of that basic information. And you're saying in order to learn to drive, like the reason humans are able to learn to drive quickly, some faster than others, is because of the background knowledge. They were able to watch cars operate in the world in the many years leading up to it, the physics of basic objects, all of that.
That's right. I mean, the basic physics of objects, you don't even know, you don't even need to know how a car works, right? Because that you can learn very quickly. I mean, the example I use very often is you're driving next to a cliff. And you know in advance, because of your understanding of intuitive physics, that if you turn the wheel to the right, the car will veer to the right, it will run off the cliff, fall off the cliff, and nothing good will come out of this. But if you are a sort of tabula rasa reinforcement learning system that doesn't have a model of the world, you have to repeat falling off this cliff thousands of times before you figure out it's a bad idea, and then a few more thousand times before you figure out how to not do it. And then a few more million times before you figure out how to not do it in every situation you ever encounter.
So self-supervised learning still has to have some source of truth being told to it by somebody.
And
so you have to figure out a way without human assistance or without significant amount of human assistance to get that truth from the world. So the mystery there is how much signal is there, how much truth is there that the world gives you, whether it's the human world, like you watch YouTube or something like that, or it's the more natural world. So how much signal is there?
So here's the trick. There is way more signal in sort of a self-supervised setting than there is in either a supervised or reinforcement setting. And this is going to my, analogy of the cake.
Yes.
The cake, as someone has called it, where when you trying to figure out how much information you ask the machine to predict and how much feedback you give the machine at every trial. In reinforcement learning, you give the machine a single scalar, you tell the machine to do good and do bad, and you only tell this to the machine once in a while. When I say you, it could be the universe telling the machine, right? But it's just one scalar. So as a consequence of this, you cannot possibly learn something very complicated without many trials to get many feedbacks of this type. Supervised learning, you give a few bits to the machine at every sample. Let's say you're training a system of recognizing images on the ImageNet with 1,000 categories. That's a little less than 10 bits of information per sample. But that's only in the setting. Ideally, you don't know how to do this yet, but ideally you would show a machine a segment of a video and then start the video and ask the machine to predict what's going to happen next. So you let the machine predict, and then you let time go by and show the machine what actually happened, and hope the machine will, learn to do a better job at predicting next time around. There's a huge amount of information in the machine because it's an entire video clip of the future after the video clip in the first place.
So both for language and for vision, there's a subtle, seemingly trivial construction, but maybe that's representative of what is required to create intelligence, which is filling the gap. So it sounds dumb, but it is possible you can solve all of intelligence in this way, just for both language, just give a sentence and continue it, or give a sentence and there's a gap in it, some words blanked out and you fill in the words go there. For vision, you give a sequence of images and predict what's going to happen next, or you fill in what happened in between. It's possible that function alone, as a signal for self-supervised learning, can solve intelligence for vision and language.
I think that's always shot at the moment. So whether this will take us all the way to human level intelligence or something, or just cat level intelligence, is not clear. But among all the possible approaches that people propose, I think it's a shot. So I think this idea of an intelligent system filling in the blanks, either predicting the future, inferring the past, filling in missing information. I'm currently filling the blank of what is behind your head and what your head looks like, and from the back, because I have basic knowledge about arguments I made. And I don't know if you're gonna what you're gonna say, at which point you're gonna speak, whether you're gonna move your head this way or that way, which way you're gonna look. But I know you're not gonna just dematerialize and reappear 3 meters down a hole. Because I know what's possible and what's impossible according to intuitive physics. So
we do have a model of what's possible. It's possible, and you'd be very surprised if it happens, and then you'll have to reconstruct your model.
Right. So that's the model of the world. It's what tells you, what fills in the blanks. So given your partial information about the state of the world, given by your perception, your model of the world fills in the missing information, and that includes predicting the future, predicting the past, filling in things you don't immediately see.
And that doesn't have to be purely generic vision or visual information or generic language. You can go to specifics like predicting what control decision you make when you're driving in a lane. You have a sequence of images from a vehicle, and then you have information, if you record it on video, where the car ended up going, so you can go back in time and predict where the car went based on the visual information. That's very specific, domain specific.
Right, but the question is whether we can come up with sort of a generic method for training machines to do this kind of prediction of lines. So right now, this type of approach has been unbelievably successful in the context of natural language processing. Every modern natural language processing is pre-trained in self-supervised manner to fill in the blanks. So you show it a sequence of words, you remove 10% of them, and then you train some gigantic neural net to predict the words that are missing. And once you pre-train that network, you can use the internal representation learned by it as input to, as something that you train supervised or whatever. That's been incredibly successful. Not so successful in images, although it's making progress. And it's based on sort of manual data augmentation. We can go into this later. But what has not been successful yet is training from video. So getting a machine to learn to represent the visual world, for example, by just watching video. It's really succeeding with this.
Okay, well, let's kind of give a high-level overview. What's the difference in kind and difficulty between vision and language? So you said people haven't been able to really kind of crack the problem of vision open in terms of self-supervised learning, but that may not be necessarily because it's fundamentally more difficult. Maybe like when we're talking about achieving, like passing the Turing test in a full spirit, the Turing test in language might be harder than vision. That's not obvious. So, in your view, which is harder, or perhaps are they just the same problem? When the farther we get to solving each, the more we realize it's all the same thing. It's all the same cake.
I think we're looking for our methods that make them look essentially like the same cake, but currently they're not. And the main issue with learning world models or learning predictive models is that the prediction is never a single thing because the world is not entirely predictable. It may be deterministic or stochastic. We can get into the philosophical discussion about it, but even if it's deterministic, it's not entirely predictable. And so, if I play a short video clip and then I ask you to predict what's going to happen next, there's many plausible continuations for that video clip, and the number of continuations grows with the interval of time that you're asking the system to make a prediction for. And so, one big question with self-supervised learning is how you represent this uncertainty, how you represent multiple discrete outcomes, how you represent this sort of continuum of possible outcomes, etc. And if you are a sort of a classical machine learning person, you say, "Oh, you just represent a distribution," right? And that we know how to do when we're predicting words, missing words in the text, because you can have a neural net give a score for every word in the dictionary. It's big, it's a big list of numbers, 100,000 or so. It can turn that into a probability distribution that tells you when I say a sentence, the cat is chasing the blank in the kitchen. There are only a few words that make sense there. It could be a mouse, it could be a laser spot, something like that, right? And if I say the blank is chasing the blank in the savannah, you also have a bunch of plausible options for those two words, right? That because you have kind of underlying reality that can refer to sort of filling those blanks. So you cannot say for sure in the savannah if it's a lion or a cheetah or whatever. You cannot know if it's a zebra or a gnu or whatever wildebeest. But you can represent the uncertainty by just numbers. Now, if I take you a video and I ask you to print a video clip, it's not a discrete set of potential frames. You have to have somewhere representing a sort of infinite number of plausible continuations of multiple frames in a high-dimensional continuous space. And we just have no idea how to do this properly.
Finite high-dimensional. So like
it's finite high-dimensional, yes.
Just like the words, like trying to get it to down to a small finite set of like under a million, something like that. I mean, it's kind of ridiculous that we're doing a distribution over every single possible word for language, and it works. It feels like that's a really dumb way to do it. Like it seems to be like there should be some more compressed representation of the distribution of the words.
You're right about that.
And so, do you have any interesting ideas about how to represent all of the reality in a compressed way such that you can form a distribution over it?
That's one of the big questions. How do you do that? Right? I mean, what's kind of another thing that really is stupid about I shouldn't say stupid, but like simplistic about current approaches to self-supervised learning in NLP in text is that not only do you represent a giant distribution of the words, but for multiple words that are missing, those distributions are essentially independent of each other. And you don't pay too much of a price for this, so you can't. So the system, in the sentence that I gave earlier, if it is a certain probability for a lion and cheetah, and then a certain probability for gazelle, wildebeest, and zebra, those two probabilities are independent from each other. And it's not the case that those things are independent. Lions actually attack bigger animals than cheetahs. So, there's a huge independence hypothesis in this process, which is not actually true. The reason for this is that we don't know how to represent properly distributions over combinatorial sequences of symbols, essentially, because the number of rows exponentially the length of the symbols. And so we have to use trees for this, but those techniques can get around. Don't even deal with it. So the big question is, would there be some sort of abstract latent representation of text that would say that when I switch lion for gazelle, lion for cheetah, I also have to switch zebra for
Yeah, so this independence assumption, let me throw some criticism at you that I often hear and see how you respond. So this kind of filling in the blanks is just statistics. You're not learning anything like the deep underlying concepts. You're just mimicking stuff from the past. You're not learning anything new such that you can use it to generalize about the world. Okay, let me just say the crude version, which is it's just statistics. It's not intelligence. What do you have to say to that? What do you usually say to that if you kind of hear this kind of thing?
I don't get into the discussions because they're kind of pointless. So first of all, it's quite possible that intelligence is just statistics. It's just statistics of a particular kind.
Yes.
Where
this is the philosophical question. It's kind of is intelligence? Is it possible that intelligence is just statistics?
Yeah. But what kind of statistics? So if you're asking the question, are the models of the world that we learn, do they have some? Yes. So if the criticism comes from people who say, current machine learning systems don't care about causality, which by the way is wrong, I agree with them. That you should, your model of the world should have your actions as one of the inputs, and that will drive you to learn causal models of the world where what intervention in the world will cause what results. And you can do this by observation of other agents acting in the world and observing the effect. Or humans, for example. So I think, at some level of description, intelligence is just statistics. But that doesn't mean you won't have models that have deep mechanistic explanation for what goes on. The question is, how do you learn them? That's the question I'm interested in. Because a lot of people who actually voice their criticism say that those mechanistic models have to come from someplace else. They have to come from design engineers. They have to come from I don't know what. And obviously, we learn them. Or if we don't learn them as an individual, nature learned them for us using evolution. So regardless of what you think, those processes have been learned somehow.
So if you look at the human brain, just like when we humans introspect about how the brain works, it seems like when we think about what is intelligence, I think about the high level stuff, like the models we've constructed, concepts like cognitive science, like concepts of memory and reasoning module, almost like these high level modules. Is this serve as a good analogy? Like, are we ignoring the dark matter, the basic low level mechanisms, just like we ignore the way the operating system works? We're just using the high level software, ignoring that at the low level, the neural network might be doing something like statistics, like meaning, sorry to use this word probably incorrectly and crudely, but doing this kind of fill in the gap kind of learning and just kind of updating the model constantly to be able to support the raw sensory information to predict it and adjust to the prediction when it's wrong. But like when we look at our brain at the high level, it feels like we're playing chess. Like we're like playing with high level concepts and we're stitching them together. We're putting them into the long term memory. But really, what's going on underneath is something we're not able to introspect, which is this kind of simple large neural network that's just filling in the gaps.
Right. Well, okay. So there's a lot of questions about answers there. Okay. So first of all, there's a whole school of thought in neuroscience, computational neuroscience in particular, that likes the idea of predictive coding, which is really related to the idea I was talking about in self-supervised learning. So everything is about prediction. The essence of intelligence is the ability to predict, and everything the brain does is trying to predict everything from everything else. Okay, and that's really sort of the underlying principle, if you want, that self-supervised learning is trying to kind of reproduce this idea of prediction as kind of an essential mechanism of task-independent learning. The next step is, what kind of intelligence are you interested in reproducing? And of course, we all think about, trying to reproduce high-level cognitive processes in humans. But like with machines, we're not even at the level of even reproducing the learning processes in a cat brain. Most intelligent or intelligent systems don't have as much common sense as a house cat. So how is it that cats learn? And cats don't do a whole lot of reasoning. They certainly have causal models. They certainly have because many cats can figure out like how they can act on the world to get what they want. They certainly have a fantastic model of intuitive physics, certainly of the dynamics of their own bodies, but also of praise and things like that, right? So they're pretty smart. They only do this with about 800 million neurons. We are not anywhere close to reproducing this kind of thing. So to some extent, I could say, let's not even worry about like the high level of cognition and kind of long-term planning and reasoning that humans can do until we figure out like can we even reproduce what cats do. Now that said, this ability to learn world models, I think, is the key to the possibility of learning machines that can also reason. So whenever I give a talk, I say there are three challenges, three main challenges in machine learning. The first one is machines to learn to represent the world and using self-supervised learning. The second is getting machines to reason in ways that are compatible with essentially gradient-based learning, because this is what economy is all about, really. And the third one is something we have no idea how to solve, at least I have no idea how to solve, is can we get machines to learn hierarchical representations of action plans? We know how to train them to learn hierarchical representations of perception, with convolutional nets and things like that, and transformers. But what about action plans? Can we get them to spontaneously learn good hierarchical representations of actions?
Also gradient based.
Yeah, and all of that needs to be somewhat differentiable so that you can apply sort of gradient based learning, which is really what economy is about.
So it's background knowledge, ability to reason in a way that's differentiable, that is somehow connected to integrate with that background knowledge or builds on top of that background knowledge. And then given that background knowledge, be able to make hierarchical plans
right.
in the world.
So if you take classical optimal control, there's something in classical optimal control called model predictive control. And it's been around since the early 60s. NASA uses that to compute trajectories of rockets. And the basic idea is that you have a predictive model of the rocket, let's say, or whatever system you intend to control, which, given the state of the system at time t, and given an action that you're taking in the system, so for a rocket it would be thrust and all controls you can have, it gives you the state of the system at time t plus delta t, right? So basically a differential equation, something like that. And if you have this model, and you have this model in the form of some sort of neural net or some sort of set of formula that you can backpropagate gradients, you can do what's called model predictive control, or gradient-based model predictive control. So you have you can unroll that model in time. You feed it a hypothesized sequence of actions, and then you have some objective function that measures how well at the end of the trajectory the system has succeeded or matched what you wanted to do. Is it a robot arm? Have you grasped the object you want to grasp? If it's a rocket, are you the right place near the space station, things like that. And by backpropagation through time, and again, this was invented in the 1960s by optimal control theorists, you can figure out what is the optimal sequence of actions that will get my system to the best final state. So that's a form of reasoning. It's basically planning, and a lot of planning systems in robotics are actually based on this. And you can think of this as a form of reasoning. So, to take the example of the teenager driving a car again, you have a pretty good dynamical model of the car. It doesn't need to be very accurate, but again, that if you turn the wheel to the right and there's a cliff, you're going to run off the cliff, right? You don't need to have a very accurate model to predict that. And you can run this in your mind and decide not to do it for that reason, because you can predict in advance that the result is going to be bad. So you can sort of imagine different scenarios and then employ or take the first step in a scenario that is most favorable, and then repeat the process of planning. That's called receiving horizon, predictive control. So even all those things have made instead of going back decades. And so if you're not the classical optimal control, the model of the world is not generally learned. There's sometimes a few parameters you have to identify. That's called systems identification. But generally, the model is mostly deterministic and mostly built by hand. So the big question of AI, I think the big challenge of AI for the next decade is how do we get machines to run predictive models in the world that deal with uncertainty and deal with the real world in all this complexity. So it's not just trajectory of a rocket, which you can reduce to first principles. It's not even just trajectory of a robot arm, which again you can model by careful mathematics. But it's everything else, everything we observe in the world. People behavior, physical systems that involve collective phenomena like water or trees, branches in a tree or something, or that complex things that humans have no trouble developing abstract representations and predictive model for, but we still don't know how to do with machines.
Where do you put it in these three, maybe in the planning stages, the game theoretic nature of this world, where your actions not only respond to the dynamic nature of the world, the environment, but also affect it? So if there's other humans involved, is this point number 4, or is it somehow integrated into the hierarchical representation of action in your view?
I think it's integrated. It's just that now your model of the world has to deal with, it just makes it more complicated. Like the fact that humans are complicated and not easily predictable, that makes the model of the world much more complicated. That much more.
But there's a chess. I suppose chess is an analogy. So Monte Carlo tree search. If there's a I go, you go, I go, you go. Like Ajay Kapatha recently gave a talk at MIT about car doors. I think there's some machine learning too, but mostly car doors. And there's a dynamic nature to the car, like the person opening the door checking. And he wasn't talking about that. He was talking about the perception problem of what the ontology, what defines a car door, this big philosophical question. But to me, it was interesting because it's obvious that the person opening the car door, if they're trying to get out, like here in New York, trying to get out of the car, you slowing down is going to signal something. You speeding up is going to signal something. And that's a dance. It's a asynchronous chess game. I don't know. So it feels like it's not just. I guess you can integrate all of them into one giant model, like the entirety of these little interactions. Because it's not as complicated as chess. It's just like a little dance. We do like a little dance together, and then figure it out.
Well, in some ways, it's way more complicated than chess because it's continuous. It's uncertain in a continuous manner.
It doesn't feel more complicated.
But it doesn't feel more complicated because that's what we've evolved to solve. It's the kind of problem we've evolved to solve, and so we're good at it because nature has made us good at it. Nature has not made us good at chess. We completely suck at chess.
Yeah.
In fact, that's why I designed it as a game, to be challenging. And if there is something that recent progress in chess and Go has made us realize, is that humans are really terrible at those things, like really bad. There was a story right before AlphaGo that the best Go players thought they were maybe 2 or 3 stones behind an ideal player that we called God. In fact, no, they were like 9 or 10. stories behind it. It's just bad. So we're not good at. It's because we have limited working memory. We're not very good at doing this tree exploration. Computers are much better at doing than we are. But we are much better at running differentiable models as well. I mean, I say differentiable in a kind of, I should say, not differentiable in the sense that we run backprop through it, but in the sense that our brain has some mechanism for estimating gradients of some kind, and that's what makes it efficient. So if you have an agent that consists of a model of the world, which in the human brain is basically the entire front half of your brain, an objective function, which in humans is a combination of two things. There is your sort of intrinsic motivation module, which is in the that's the thing that measures pain, hunger, things like that, like immediate feelings and emotions. And then there is the equivalent of what people in reinforcement learning call critic, which is a sort of module that predicts ahead what the outcome of a situation will be. And so it's not a cost function, but it's sort of not an objective function, but it's sort of a trained predictor of the ultimate objective function. And that also is differentiable. And so if all of this is differentiable, your cost function, your critic, your work model, then you can use gradient-based type methods to do planning, to do reasoning, to do learning, to do all the things that we'd like an intelligent agent to do.
And the gradient-based learning, like what's your intuition? That's probably at the core of what can solve intelligence. So you don't need like a logic-based reasoning in your view.
I don't know how to make logic-based reasoning compatible with efficient learning.
Yeah.
And okay, I mean, there's a big question, perhaps a philosophical question, and it's not that philosophical, but that we can ask is that all the learning algorithms we know from engineering and computer science proceed by optimizing some objective function, right? So one question we may ask is does learning in the brain minimize an objective function? I mean, it could be a composite of multiple objective functions, but it's still an objective function. Second, if it does optimize an objective function, does it do it by some sort of gradient estimation? It doesn't need to be backprop, but some way of estimating the gradient in an efficient manner, whose complexity is on the same order of magnitude as actually running the inference. Because you can't afford to do things like perturbing a weight in your brain to figure out what the effect is, and then sort of you can do sort of estimating gradient by perturbation. To me, it seems very implausible that the brain uses some sort of zeroth order black box gradient-free optimization, because it's so much less efficient than gradient optimization. So it has to have a way of estimating gradients.
Is it possible that some kind of logic-based reasoning emerges in pockets as a useful, like you said, if the brain is an objective function, maybe it's a mechanism for creating objective functions. It's a mechanism for creating knowledge bases, for example, that can then be queried. Like maybe it's like an efficient representation of knowledge that's learned in a gradient-based way or something like that.
Well, so I think there is a lot of different types of intelligence. So first of all, I think the type of logical reasoning that we think about, that we are, maybe stemming from, sort of classical AI in the 1970s and 80s. I think humans use that relatively rarely and are not particularly good at it.
But we judge each other based on our ability to solve those rare problems. It's called an IQ test.
I think so. Like, I'm not very good at chess.
Yes, I'm judging you this whole time because we actually
with your heritage, I'm sure you're good at chess.
So stereotypes. Not all stereotypes are true.
Well, I'm terrible at chess. So but I think perhaps another type of intelligence that I have is this ability of sort of building models of the world from reasoning, obviously, but also data. And those models generally are more kind of analogical, right? So it's reasoning by simulation, And but by analogy, where you use one model to apply to a new situation, even though you've never seen that situation, you can sort of connect it to a situation you encountered before. And the reasoning is more, akin to some sort of internal simulation. So you're kind of simulating what's happening when you're building, I don't know, a box out of wood or something, right? You can imagine in advance, like what would be the result of cutting the wood in this particular way. They can use screws or nails or whatever. When you are interacting with someone, you also have a model of that person and sort of interact with that person. Having this model in mind to kind of tell the person what you think is useful to them. So I think this ability to construct models of the world is basically the essence of intelligence, and the ability to use it then to plan actions that will fulfill a particular criterion, of course, is necessary as well.
So I'm going to ask you a series of possible questions to keep asking, as I've been doing. So if that's the fundamentals of dark matter of intelligence, this ability to form a background model, what's your intuition about how much knowledge is required? I think dark matter, you put a percentage on it of composition. So how much of it is dark matter, how much of it is dark energy, how much information do you think is required to be a house cat? So you have to be able to, when you see a box, go in it. When you see a human compute the most evil action, if there's a thing that's near an edge, you knock it off. All of that, and plus the extra stuff you mentioned, which is a great self-awareness of the physics of your own body and the world. How much knowledge is required, do you think, to solve it? I don't even know how to measure an answer to that question.
I'm not sure how to measure it, but whatever it is, it fits in about 800,000 neurons, 800 million neurons. Sorry,
The representation does.
everything, all knowledge, everything, right? It's less than a billion. A dog is 2 billion, but a cat is less than 1 billion. And so multiply that by 1,000, you get synapses. And I think almost all of it is learned through this, a sort of self-supervised learning. Although, I think a tiny sliver is learned through reinforcement learning, and certainly very little through classical supervised learning. Although it's not even clear how supervised learning actually works in the biological world. So I think almost all of it is self-supervised learning, but it's driven by the sort of ingrained objective functions that a cat or a human have at the base of their brain, which kind of drives their behavior. So, nature tells us you're hungry. It doesn't tell us how to feed ourselves. That's something that the rest of our brain has to figure out, right?
Well, it's interesting because there might be more deeper objective functions underlying the whole thing. So hunger may be some kind of, now you go to like neurobiology, it might be just the brain trying to maintain homeostasis. So hunger is just one of the human perceivable symptoms of the brain being unhappy with the way things are currently. Right. It could be just like one really dumb objective function at the core.
But that's how behavior is driven. The fact that the basal ganglia drive us to do things that are different from, say, an orangutan or certainly a cat is what makes human nature versus orangutan nature versus cat nature. So, for example, our basal ganglia drives us to seek the company of other humans. That's because nature has that we need to be social animals for our species to survive, and it's true of many primates. It's not true of orangutans. Orangutans are solitary animals. They don't seek the company of others. In fact, they avoid them. In fact, they scream at them when they come too close because they're territorial. Because for their survival, evolution has figured out that's the best thing. I mean, there are occasionally social for us for reproduction and stuff like that, but they're mostly solitary. So all of those behaviors are not part of intelligence. People say, "Oh, you're never going to have intelligent machines because human intelligence is social." But then you look at orangutans, you look at octopus. Octopus never know their parents. they barely interact with any other, and they get to be really smart in less than a year, in like half a year. In a year they're adults, in 2 years they're dead. So um, there are things that we think as humans are intimately linked with intelligence, like social interaction, like language. I think we give way too much importance to language as a substrate of intelligence as humans, because we think our reasoning is so linked with language.
So to solve the house cat intelligence problem, you think you could do it on a desert island? You could have
Pretty much.
you could have a cat sitting there, looking at the waves that the ocean weighs, and figure a lot of it out.
It needs to have sort of the right set of drives to kind of get it to do the thing and learn the appropriate things, right? But for example, maybe humans are driven to want to stand up and walk. Okay, so that's kind of this desire is hardwired. How to do it precisely is not. That's right. The desire to
walk,
move around and stand up. That's sort of. It's very simple to hardwire this kind of stuff.
Oh, like the desire to. Well, that's interesting. You're hardwired to want to walk. That's not a. There's got to be a deeper need for walking. I think it was probably socially imposed by society that you need to walk, while the other bipedal.
No, like a lot of simple animals that probably walk without ever watching any other members of the species.
It seems like a scary thing to have to do because you suck at bipedal walking at first. It seems crawling is much safer, much more like, why are you in a hurry?
Well, because you have the thing that drives you, which is sort of part of the sort of human development.
Is that understood actually? What?
Not entirely. No.
What's the reason you get on 2 feet? It's really hard. Like most animals don't get on 2 feet.
Well, they get on 4 feet. Many mammals get on 4 feet.
Yeah, they
very quickly. Some of them extremely quickly.
But I don't, like from the last time I've interacted with a table, that's much more stable than a thing that has 2 legs. It's just a really hard problem.
Yeah, how many birds have figured it out? 2 feet.
Well, technically, we can go into ecology. They have 4. I guess they have 2 feet.
2 feet.
Chickens.
Dinosaurs have 2 feet. Many of them.
Allegedly. I'm just now learning that T-Rex was eating grass, not other animals. T-Rex might have been a friendly pet. What do you think about? I don't know if you looked at the test for general intelligence that Francois Chalet put together. I don't know if you got a chance to look at that kind of thing. Like, what's your intuition about how to solve like an IQ type of test?
I don't know. I think it's so outside of my radar screen that it's not really relevant. I think in the short term.
Well, I guess one way to ask, another way, perhaps more closer to what to your work, is like, how do you solve MNIST with very little example data?
That's right, and that's the answer to this probably is self-supervised learning. Just run through rapid pages, and then not even to recognize how many pages on top of this will only require a few samples. So we observe this in humans, right? You show a young child a picture book with a couple of pictures of an elephant, and that's it. The child knows what an elephant is. And we see this today with practical systems that we train image recognition systems with enormous amounts of images, either completely self-supervised or very weakly supervised. For example, you can train a neural net to predict whatever hashtag people type on Instagram, right? This with billions of images, because it's billions per day that are showing up. So the amount of training data there is essentially unlimited. And then you take the output representation, a couple layers down from the output of what the system learned, and feed this as input to a test fire for any object in the world that you want, and it works pretty well. So that's transfer learning, okay, or weakly supervised transfer learning. People are making very, very fast progress using self-supervised learning for this kind of scenario as well. And my guess is that's going to be the future.
For self-supervised learning, how much cleaning do you think is needed for filtering the malicious signal, or what's a better term? But like, a lot of people use hashtags on Instagram to get like good SEO
Mm-hmm.
that doesn't fully represent the contents of the image. Like they'll put a picture of a cat and hashtag like science, awesome, fun. I don't know, all the type that. Why would you put science?
Well, so
That's not very good SEO.
the way my colleagues who work on this project at Facebook now, Meta AI, a few years ago, dealt with this is that they only selected something like 17,000 tags that correspond to kind of physical things or situations, like that has some visual content. So you wouldn't have like HTTP or anything like that.
Also, they keep a very select set of hashtags. Is what you're saying?
Yeah.
Okay.
But it's still on the order of 10 to 20,000. So it's pretty large.
Okay. Can you tell me about data augmentation? What the heck is data augmentation, and how is it used? Maybe contrasted learning for video. What are simple ideas here?
Right. So data augmentation. I mean, first, data augmentation, is the idea of artificially increasing the size of your training set by distorting the images that you have in ways that don't change the nature of the image. Right? So you do NLIS, you can data augmentation on NLIS, and people have done this since the 1990s. Right? You take a NLIS digit and you shift it a little bit, or you change the size, or rotate it, skew it, etc. Add noise, etc. And it works better. If you train a supervised classifier with augmented data, you're going to get better results. Now, it's become really interesting over the last couple of years because a lot of self-supervised learning techniques to pre-train vision systems are based on data augmentation. And the basic techniques is originally inspired by techniques that I worked on in the early 90s and Jeff Hinton worked on also in the early 90s. They were sort of parallel work. I used to call this Siamese network. So basically you take two identical copies of the same network, they share the same weights, and you show two different views of the same object. Either those two different views may have been obtained in imitation, or maybe it's two different views of the same scene from a camera that you moved, or at different times, or something like that, right? Or two pictures of the same person, things like that. And then you train this neural net, those two identical copies of this neural net, to produce an output representation, a vector, in such a way that the representation for those two images are as close to each other as possible, as identical to each other as possible, right? Because you want the system to basically learn a function that will be invariant, that will not change, whose output will not change when you transform these inputs in those particular ways, right? So that's easy to do. What's complicated is how do you make sure that when you show two images are different, the system will produce different things? Because if you don't have a specific provision for this, the system will just ignore the inputs. When you train it, it will end up ignoring the input and just produce a constant vector that is the same for every input. Right? That's called a collapse. Now, how do you avoid collapse? So there's two ideas. One idea that I proposed in the early 90s, my colleagues at Bell Labs, Jim Bromley and a couple other people, which we now call contrastive learning, which is to have negative examples, right? So you have pairs of images that you know are different, and you show them to the network, and there's two copies, and then you push the two output vectors away from each other. And that will eventually guarantee that things that are semantically similar produce similar representations, and things that are different produce different representations. We actually came up with this idea for a project of doing signature verification. So we would collect signatures from like multiple signatures of the same person, and then train a neural net to produce the same representation, and then force the system to produce different representation from different signatures. This was actually the problem was proposed by people from what was a subsidiary of AT&T at the time called NCR, and they were interested in storing representation of the signature on the 80 bytes of the magnetic strip of a credit card. So we came up with this idea of having a neural net with 80 outputs that would be quantized in bytes, so that you could encode the
And that encoding was then used to compare whether the signature matches or not.
That's right. So then you sign would run the neural net, and then you compare the output vector to whatever is stored on the card.
It actually worked.
It worked, but they ended up not using it. Because nobody cares actually. I mean, the American financial payment system is incredibly lax your
with the signatures. What's the purpose of signatures anyway? This is very.
Nobody looks at them, nobody cares.
And it's
No. So that's contrastive learning, right? So you need positive and negative pairs. And the problem with that is that, even though I had the original paper on this, I'm actually not very positive about it because it doesn't work in high dimension. If your representation is high dimensional, there's just too many ways for two things to be different. And so you would need lots and lots and lots of negative pairs. And so there is a particular implementation of this, which is relatively recent, from actually the Google Toronto group. Jeff Hinton is the senior member there. It's called SimClear, SIMCLR. And basically a particular way of implementing this idea of contrastive learning, the particular objective function. Now, what I'm much more enthusiastic about these days is non-contrasting methods. So other ways to guarantee that the representations will be different for different inputs. And it's actually based on an idea that Jeff Hinton proposed in the early 90s with his student at the time, Becker. And it's based on the idea of maximizing the visual information between the outputs of the two systems. You only show positive pairs, you only show pairs of images that you know are somewhat similar. And you train the two networks to be informative, but also to be as informative of each other as possible. So basically, one representation has to be predictable from the other, essentially. And he proposed that idea, had a couple of papers in the early 90s, and then nothing was done about it for decades. But I kind of revived this idea together with my postdocs at FAIR, particularly a postdoc called Stefan Denis, who's now a junior professor in Finland at the University of Aalto. Came up with something called that we call Barlow twins, and it's a particular way of maximizing the information content of a vector, using some hypotheses. And we have kind of another version of it that's more recent now called VICREG, VICREG. That means variance, invariance, covariance, regularization. And then it's the thing I'm the most excited about in machine learning in the last 15 years. I mean, I'm really excited.
What kind of data augmentation is useful for that non-contrasting learning method? Are we talking about, does that not matter that much? Or it seems like a very important part of the step.
Yeah.
How you generate the images that are similar but sufficiently different.
Yeah, that's right. It's an important step, and it's also an annoying step because you need to have that knowledge of what data augmentation you can do that do not change the nature of the object. Yeah. And so the standard scenario, which a lot of people in this area are using, is you use the type of distortion. So basically you do geometric distortion. So one basically just shifts the image a little bit. It's called cropping. Another one kind of changes the scale a little bit. Another one kind of rotates it. Another one changes the colors. You can shift in color balance or something like that. Saturation. Another one sort of blurs it. Another one adds noise. So you have like a catalog of kind of standard things that people try to use once for different algorithms so that you can compare. But some algorithms, some subsequent algorithm actually can deal with much bigger, like more aggressive data augmentation, and some don't. So that kind of makes the whole thing difficult. But that's the kind of distortions we're talking about. And so you train with those distortions, and then you chop off the last layer, a couple layers of the network, and you use the representation as input to a classifier. You train the classifier on ImageNet, let's say, or whatever, and measure the performance. And interestingly enough, the methods that are really good at eliminating the information that is irrelevant, which is the distortions between the images, do a good job at eliminating it. And as a consequence, you cannot use the representations in those systems for things like object detection and localization, because that information is gone. So the type of data augmentation you need to do depends on the task you want eventually the system to solve, and the type of data augmentation and standard data augmentation we use today are only appropriate for object recognition or image classification. They're not appropriate for things like.
Can you help me out understand what line localization is? So you're saying it's just not good at the negative, like at classifying the negative, so that's why it can't be used for the localization?
No, it's just that you train the system you give it an image, and then you give it the same image shifted and scaled, and you tell it that's the same image. So the system basically is trying to eliminate the information about position and size. So now you want to use that to
like
figure out where an object is on what side.
got it. It's like a bounding box that they'd be able to actually. Okay, it can still find the object in the image. It's just not very good at finding the exact boundaries of that object. Interesting. Which, that's an interesting sort of philosophical question. How important is object localization anyway? We're like obsessed by measuring, like image segmentation, obsessed by measuring perfectly, knowing the boundaries of objects, when arguably that's not that essential to understanding what are the contents of the scene.
On the other hand, I think evolutionarily, the first vision systems in animals were basically all about localization, very little about recognition. And in the human brain, you have two separate pathways for recognizing the nature of an object and localizing objects. So you use the first pathway, the ventral pathway, for telling what you're looking at. The other pathway, the dorsal pathway, is used for navigation, for grasping, for everything else. And basically, a lot of the things you need for survival are localization and detection.
Is similarity learning or contrastive learning, or these not contrastive methods, the same as understanding something? Just because a distorted cat is the same as a non-distorted cat, does that mean you understand what it means to be a cat?
To some extent, I mean, it's a superficial understanding, obviously.
But what is the ceiling of this method, do you think? Is this just one trick on the path to doing self-supervised learning? Can we go really, really far?
I think we can go really far. So if we figure out how to use techniques of that type, perhaps very different, but the same nature, to train a system from video to do video prediction, essentially, I think we'll have a path, towards, say unlimited, but a path towards some level of, physical common sense in machines. And I also think that that ability to learn how the world works from a sort of high throughput channel like vision is a necessary step towards artificial intelligence. In other words, I believe in grounded intelligence. I don't think we can train a machine to be intelligent purely from text, because I think the amount of information about the world that's contained in text is tiny compared to what we need to know. So, for example, let's people have attempted to do this for 30 years, right? The SAC project and things like that, right? Of basically kind of writing down all the facts that are known, hoping that some sort of common sense will emerge. I think it's basically hopeless. Let me take an example. You take an object. I describe the situation to you. I take an object, I put it on the table, and I push the table. It's completely obvious to you that the object would be pushed with the table, right? Because it's sitting on it. There's no text in the world, I believe, that explains this. And so if you train a machine as powerful as it could be, your GPT 5000, or whatever it is, it's never going to learn about this. That information is just not present in any text.
Well, the question, with the psych project, the dream, I think, is to have like 10 million, say, facts like that give you a head start, like a parent guiding you. Now, we humans don't need a parent to tell us that the table will move. The smartphone will move with the table, but we'll get a lot of guidance in other ways. So it's possible that we can give it a quick shortcut.
What about a cat? The cat knows that.
No, but they evolved. So
they learn like us.
The physics of stuff.
Yeah.
Well, yeah. So you're saying it's so you're putting a lot of intelligence onto the nurture side, not the nature.
Yeah.
Because we seem to have, there's a very inefficient, arguably, process of evolution that got us from bacteria to who we are today. Started at the bottom, now we're here. So the question is how. Okay, so the question is how fundamental is that the nature of the whole hardware, and then is there any way to shortcut it if it's fundamental? If it's not, if it's most of intelligence, most of the cool stuff we've been talking about is mostly nurture, mostly train, we figure it out by observing the world, can form that big, beautiful, sexy background model that you're talking about just by sitting there. Then okay, then you need to then like maybe it is all supervised learning all the way down. Self-supervised learning, say.
Whatever it is that makes human intelligence different from other animals, which a lot of people think is language and logical reasoning and this kind of stuff. It cannot be that complicated because it only popped up in the last million years.
Yeah.
And
it
only involves less than 1% of a genome, right? Which is the difference between human genome and chimps or whatever. So it can't be that complicated. It can't be that fundamental. I mean, most of the complicated stuff already exists in cats and dogs and certainly primates, non-human primates.
Yeah, that little thing with humans might be just something about social interaction and ability to maintain ideas across like a collective of people. It sounds very dramatic and very impressive, but it probably isn't, like, mechanistically speaking.
It is, but we're not there yet. Like we have. I mean, this is number 634. In the list of problems we have to solve.
So basic physics of the world is number one. What do you? Just a quick tangent on data augmentation. So a lot of it is hard coded versus learned. Do you have any intuition that maybe it could be some weird data augmentation, like generative type of data augmentation, like doing something weird to images, which then improves the similarity learning process? So not just kind of dumb, simple distortions, but by you shaking your head, just saying that even simple distortions are enough.
I think data augmentation is temporary and necessary evil. So what people are working on now is two things. One is the type of self-supervised learning, like trying to translate the type of self-supervised learning people use in language, translating this to images, which is basically a Dino-Zenoto encoder method, right? So you take an image, you block, you mask some parts of it, and then you train some giant neural net to reconstruct the parts that are missing. And until very recently, there was no working methods for that. All the autoencoder type methods for images weren't producing very good representation. And there's a paper now coming out of the FAIR group at Menlo Park that actually works very well. So that doesn't require data augmentation, that requires only masking.
Only masking for images. Okay.
Right, so you mask part of the image and you train the system, which in this case is a transformer because the transformer represents the image. It does non-overlapping patches, so it's easy to mask patches, things like that.
Okay, then my question transfers to that problem, then masking. Like, why should the mask be a square or a rectangle?
So it doesn't matter. Like, I think we're going to come up probably in the future with sort of, ways to mask that are, kind of random, essentially. Well, I mean, they are random already, but
No, but like something that's challenging, like optimally challenging. So, like, I mean, maybe it's a metaphor that doesn't apply, but it seems like there's a data augmentation or masking. There's an interactive element with it. Like, you're almost like playing with an image.
Yeah.
And like, it's like the way we play with an image in our minds.
It's like dropout. It's like also machine training. Every time you see a percept, you also you can perturb it in some way, and then the principle of the training procedure is to minimize the difference of the output of the representation between the clean version and the corrupted version, essentially, right? And you can do this in real time, right? So most of the machines work like this, right? You show a percept, you tell the machine that's a good combination of activities of your input neurons, and then you either let them go their merry way without clamping them to values, or you only do this with a subset. And what you're doing is you're training the system so that the stable state of the entire network is the same regardless of whether it sees the entire input or whether it sees only part of it. The no-zero encoder method is basically the same thing, right? You're training a system to reproduce the input, the complete inputs, and fill in the blanks, regardless of which parts are missing, and that's really the underlying principle. Imagine sort of even in the brain, some sort of neural principle where neurons can oscillate, right? So they take their activity and then temporarily they can shut off to force the rest of the system to basically reconstruct the input without their help, and I mean, you can imagine more or less biologically possible
Something like that. And I guess with this denoising autoencoder and masking and data augmentation, you don't have to worry about being super efficient. You can just do as much as you want,
Yeah.
and you can get better over time. Because I was thinking, like, you might want to be clever about the withdrawals, but that's only it's somehow costly to do every iteration, but it's not really.
maybe. And then there is, data augmentation without explicit data augmentation. Is data augmentation by weighting, which is, the sort of video prediction. You're observing a video clip, observing the continuation of that video clip, and you try to run a representation using those joint embedding architectures in such a way that the representation of the future clip is easily predictable from the representation of the observed clip.
Do you think YouTube has enough raw data from which to learn how to be a cat?
I think so.
So the amount of data is not the constraint.
No, it would require some selection, I think.
Some
selection of, maybe the right type of data. You
go
need
down the rabbit hole of just cat videos you might need to watch some lectures or something.
No,
how meta would that be? If it watches lectures about intelligence and then watches your lectures and learns from that how to be intelligent.
I don't think it would be enough.
What's your do you find multimodal learning interesting? We're talking about visual language, combining those together, maybe audio, all those kinds of things.
There's a lot of things that I find interesting in the short term, but are not addressing the important problems that I think are really kind of the big challenges. So I think things like multitask learning, continual learning, adversarial issues. I mean, those are great practical interests in the relatively short term. Possibly, but I don't think they're fundamental. Active learning, even to some extent, reinforcement learning. I think those things will become either obsolete or useless or easy once we figure out how to do self-supervised representation learning or learning with predictive world models. And so I think that's what the entire community should be focusing on. At least people who are interested in sort of fundamental questions or really kind of pushing the envelope of AI towards the next stage. But of course, there's a huge amount of very interesting work to do in sort of practical questions that have short-term impact.
Well, it's difficult to talk about the temporal scale because all of human civilization will eventually be destroyed because the sun will die out, and even if Elon Musk is successful multiplanetary colonization across the galaxy, eventually the entirety of it would just become a giant black holes, and
it's going to take a while though.
So, but what I'm saying is that logic to say it's all meaningless. I'm saying all that to say that multitask learning might be, you're calling it practical or pragmatic or whatever. That might be the thing that achieves something very akin to intelligence while we're trying to solve a more general problem of self-supervised learning and background knowledge. So the reason I bring that up, maybe one way to ask that question, I've been very impressed by what Tesla Autopilot team is doing. I don't know if you got a chance to glance at this particular one example of multitask learning, where they're literally taking the problem, like, I don't know, Charles Darwin starts studying animals. They're studying the problem of driving and asking, okay, what are all the things you have to perceive? And the way they're solving it is one, there's an ontology where you're bringing that to the table. So you formulate a bunch of different tasks. It's like over 100 tasks or something like that that are involved in driving. And then they're deploying it and then getting data back from people that run into trouble. And they're trying to figure out, do we add tasks? Do we focus on each individual task separately? In fact, I would say I would classify Andre Karpathy's talking to it. So one was about doors, and the other one about how much ImageNet sucks. You go back and forth on those two topics, which ImageNet sucks, meaning you can't just use a single benchmark. There's you have to have like a giant suite of benchmarks to understand how well your system actually works.
I mean, he's very sensible guy. Now, okay, it's very clear that if you're faced with an engineering problem that you need to solve in a relatively short time, particularly if you have Elon Musk breathing down your neck, you're going to have to take shortcuts, right? You might think about the fact that the right thing to do with a long-term solution involves, some fancy self-supervision, but you have, Elon Musk breathing down your neck, and this involves, human lives, and so you have to basically just do the systematic engineering, fine-tuning and refinements and try and error and all that stuff. There's nothing wrong with that. That's called engineering. That's called putting technology out in the world, and you have to kind of unplan it before you do this. So much for grand ideas and principles. But I'm placing myself sort of some upstream of this, quite a bit upstream of this.
You're Plato think about platonic forms. You're
not platonic because eventually I want that stuff to get used, but it's okay if it takes 5 or 10 years for the community to realize this is the right thing to do. I've done this before. It's been the case before that I've made that case. I mean, if you look back in the mid 2000s, for example, and you ask yourself the question, okay, I want to recognize cars or faces or whatever. I can use convolutional nets, or I can use more conventional kind of computer vision techniques, using interest point detectors or dense SIFT features, and sticking an SVM on top. At that time, the data sets were so small that those methods that use more engineering work better than COMNETs. There's just not enough data for COMNETs. The COMNETs were a little slow with the kind of hardware available at the time. And there was a sea change when, basically when data sets became bigger and GPUs became available. That's what, two of the main factors that basically made people change their mind. And you can look at the history of like all sub-branches of AI or pattern recognition. And there's a similar trajectory followed by techniques where people start by, engineering the hell out of it. Be it optical character recognition, speech recognition, computer vision, like image recognition in general, natural language understanding, like translation, things like that, right? You start to engineer the hell out of it. You start to acquire all knowledge, the prior knowledge about image formation, about the shape of characters, about morphological operations, about like feature extraction, Fourier transforms, Wernicke moments, whatever, right? People have come up with thousands of ways of representing images so that they could be easily classified afterwards. Same for speech recognition, right? It took decades for people to figure out a good font end to pre-process speech signals so that the information about what is being said is preserved, but most of the information about the identity of the speaker is gone. Textual coefficients or whatever, right? And same for text, right? In entity recognition, in cars, that you do tagging of parts of speech, and you do this sort of tree representation of clauses and stuff right before you can do anything. So that's how it starts, right? Just engineer the hell out of it, and then you start having data, and maybe you have more powerful computers. Maybe you know something about statistical learning. So you start using machine learning, and it's usually a small sliver on top of your kind of handcrafted system where you extract features by hand. Okay, and now nowadays the standard way of doing this is that we train the entire thing end to end deep learning system. It learns its own features, and speech recognition systems nowadays, or OCR systems, are completely end to end. It's some giant neural net that takes raw waveforms and produces a sequence of characters coming out. And it's just a huge neural net, right? There's no, Markov model, there's no language model that is explicit other than, something that's ingrained in the sort of neural language model. Same for translation, same for all kinds of stuff. So you see this continuous evolution from, less and less handcrafting and more learning. I think it's true in biology as well.
So, I mean, we might disagree about this, maybe not into this one little piece at the end. You mentioned active learning. It feels like active learning, which is the selection of data and also the interactivity, needs to be part of this giant neural network. You cannot just be an observer to do self-supervised learning. You have to, self-supervised learning is just a word, but whatever this giant stack of a neural network that's automatically learning, it feels, my intuition is that you have to have a system, whether it's a physical robot or a digital robot, that's interacting with the world and doing so in a flawed way and improving over time in order to form this self-supervised learning. Well, you can't just give it a giant sea of data.
Okay, I agree and I disagree. I agree in the sense that I think I agree in two ways. The first way I agree is that if you want, and you certainly need a causal model of the world that allows you to predict the consequences of your actions. To train that model, you need to take actions. Right? You need to be able to act in the world and see the effect for you to learn causal models of the world.
So that's not obvious because you can observe others.
You can observe others.
And you can infer that they're similar to you, and then you can learn from that.
Yeah, but then you have to kind of acquire that part, right? Mirror neurons and all that stuff, right? So, and it's not clear to me how you can do this in a machine. So I think the action part would be necessary for having causal models of the world. The second reason it may be necessary, or at least more efficient, is that active learning basically goes for the jugular of what you don't know, right?
Mm-hmm.
Is obvious areas of uncertainty about your world and about how the world behaves, and you can resolve this uncertainty by systematic exploration of that part that you don't know. And if you know that you don't know, then it makes you curious. You kind of look into situations that, and across the animal world, different species have different levels of curiosity, right?
Yeah.
Depending on how they build, right? So, cats and rats are incredibly curious. Dogs not so much. Yes.
Yeah. So it could be useful to have that kind of curiosity.
So it can be useful, but curiosity just makes the process faster. It doesn't make the process exist. So what learning process is it that active learning makes more efficient? And I'm asking that first question. We haven't answered that question yet. So I worry about active learning once this question is.
So it's the more fundamental question to ask. And if active learning or interaction increases the efficiency of the learning, so sometimes it becomes very different if the increase is several orders of magnitude, right? Like,
that's true.
But fundamentally, it's still the same thing. And building up the intuition about how to, in a self-supervised way, to construct background models, efficient or inefficient, is the core problem. What do you think about Yosha Benjo's talk about consciousness and all these kinds of concepts?
Okay, I don't know what consciousness is, but
it's a good opener.
And to some extent, a lot of the things that are said about consciousness remind me of the questions people were asking themselves in the 18th century or 17th century when they discovered that, how the eye works and the fact that the image in the back of the eye was upside down, right? Because you have a lens. And so on your retina, the image that forms is an image of the world, but it's upside down. How is it that you see right side up? And with what we know today in science, we realize this question doesn't make any sense, or is kind of ridiculous in some way, right? So I think a lot of what is said about consciousness is of that nature. Now that said, there's a lot of really smart people that, for whom I have a lot of respect, who are talking about this topic. People like David, who's a colleague of mine. I have kind of an unorthodox folk speculative hypothesis about consciousness. So we're talking about the study of a world model. And I think, our entire prefrontal cortex basically is the engine for a world model. But when we are attending at a particular situation, we're focused on that situation, we basically cannot attend to anything else. And that seems to suggest that we basically have only one world model engine in our prefrontal cortex. That engine is configurable to the situation at hand. So we are building a box out of wood, or we are, we're driving down the highway playing chess. We basically have a single model of the world that we configure into the situation at hand, which is why we can only attend to one task at a time. Now, if there is a task that we do repeatedly, it goes from the sort of deliberate reasoning using model of the world and prediction, and perhaps something like model cognitive control, which I was talking about earlier, to something that is more subconscious, that becomes automatic. So I don't know if you've ever played against a chess grandmaster. I get wiped out in 10 lives, right? And I have to think about my move for like 15 minutes. And the person in front of me, the grandmaster, just like react within seconds, right? He doesn't need to think about it. That's become part of the subconscious because it's basically just pattern recognition at this point. Same, the first few hours you drive a car, you're really attentive. You can't do anything else. I mean, after 20, 30 hours of practice, 50 hours, it's subconscious. You can talk to the person next to you, things like that, right? Unless the situation becomes unpredictable, then you have to stop talking. So that suggests you only have one model in your head. And it might suggest the idea that consciousness basically is the module that configures this world model of yours. You need to have some sort of executive kind of overseer that configures your world model for the situation at hand. And that leads to kind of the really curious concept that consciousness is not a consequence of the power of our mind, but of the limitation of our brains. That because we have only one world model, we have to be conscious. If we had as many world models as there are as situations we encounter, then we could do all of them simultaneously, and we wouldn't need this sort of executive control that we call consciousness.
Yeah, interesting. And somehow maybe that executive controller, the hard problem of consciousness, there's some kind of chemicals in biology that's creating a feeling, like it feels, experience some of these things. That's kind of like the hard question is, what the heck is that, and why is that useful? Maybe the more pragmatic question, why is it useful to feel like this is really you experiencing this versus just like information being processed? It could be just a very nice side effect of the way we evolved. That's just very useful to feel a sense of ownership to the decisions you make, to the perceptions you make, to the model you're trying to maintain. Like you own this thing, and it's the only way you got. And if you lose it, it's gonna really suck. And so you should really bring in some signals about it. What ideas do you believe might be true that most, or at least many people, disagree with you with? Let's say in the space of machine learning.
Well, it depends who you talk about, but I think so. Certainly, there is a bunch of people who are nativists, right? Who think that a lot of the basic things about the world are kind of hardwired in our minds. Things like the world is three-dimensional, for example, is that hardwired? Things like object permanence is something that we learn before the age of 3 months or so, or are we born with it? And there are very wide disagreements among the cognitive scientists for this. I think those things are actually very simple to learn. Is it the case that the oriented edge detectors in V1 are learned, or are they hardwired? I think they're learned. They might be learned before birth because it's really easy to generate signals from the retina that actually will train edge detectors. So, and again, those are things that can be learned within minutes of opening your eyes, right? I mean, since the 1990s, we have algorithms that can learn pointed edge detectors completely unsupervised with the equivalent of a few minutes of real time. So those things have to be learned. And there's also those MIT experiments where you kind of plug the optical nerve on the auditory cortex of a baby ferret, right? And that auditory cortex becomes a visual cortex essentially. So clearly there's learning taking place there. I think a lot of what people think are so basic that they need to be hardwired, I think a lot of those things are learned because they're easy to learn.
So you put a lot of value in the power of learning. What kind of things do you suspect might not be learned? Is there something that could not be learned?
So your intrinsic drives are not learned. They are the things that make humans human, or make cats different from dogs, right? It's the basic drives that are kind of hardwired in our ganglia. There are people who are working on this kind of stuff. It's called intrinsic motivation in the context of reinforcement learning. So these are objective functions where the reward doesn't come from the external world. It's computed by your own brain. Your own brain computes whether you're happy or not, right? It measures your degree of comfort or discomfort. And because it's your brain computing this, presumably it knows also how to estimate gradients of this, right? So it's easier to learn when your objective is intrinsic. So that has to be hardwired. The critic that makes long-term prediction of the outcome, which is the eventual result of this, that's learned. And perception is learned, and the model of the world is learned. But let me take an example of why the critic. An example of how the critic may be learned, right? If I come to you, I reach across the table and I pinch your arm, right? Complete surprise for you. You would not have expected this.
I was expecting that to hold up, but yes, let's say for the sake of the story. Yes.
Okay, your basal ganglia is going to light up because it's going to hurt, right? And now your model of the world includes the fact that I may pinch you if I approach my
don't trust humans.
my hand to your arm. So if I try again, you can think, and that's your critic, your predictive, your predictor of your ultimate pain system that predicts that something bad's going to happen in the future.
Maybe that can be learned.
That is learned, definitely. This is what allows you also to, define some rules, right? So the fact that you're a school child, you wake up in the morning, you go to school, and it's not because you necessarily like waking up early and going to school, but you know that it's a long-term objective you're trying to optimize.
So Ernest Becker, I'm not sure if you're familiar with him, the philosopher who wrote the book The Knowledge of Death, and his idea is that one of the core motivations of human beings are terror of death, our fear of death. That's what makes us unique from cats. Cats are just surviving. They do not have a deep cognizance, introspection that over the horizon is the end. And he says that there's a terror management theory. There's just all these psychological experiments that show that basically this idea that all of human civilization, everything we create, is kind of trying to forget, if even for a brief moment, that we're going to die. When do you think humans understand that they're going to die? Is it learned early on? Also,
I don't know at what point. I mean, it's a question at what point do you realize that what death really is? And I think most people don't actually realize what death is, right? I mean, most people think that you go to heaven or something. Right?
Well, to push back on that, what Ernest Becker says, and Sean Masson and all of those folks, and I find those ideas a little bit compelling, is that there is moments in life, early in life, a lot of this fun happens early in life, when you do deeply experience the terror of this realization. And all the things you think about religion, all those kinds of things that we kind of think about more like teenage years and later. We're talking about way earlier.
No, it was like 7 or 8 years, something like that. Yeah.
You realize, holy crap, this is like the mystery, the terror. Like it's almost like you're a little prey, a little baby deer sitting in the darkness of the jungle of the woods, looking all around you. There's darkness full of terror. I mean, that realization says, okay, I'm going to go back in the comfort of my mind where there is a deep meaning, where there's maybe like pretend I'm immortal, however kind of idea I can construct to help me understand that I'm immortal. Religion helps with that. You can delude yourself in all kinds of ways. Like lose yourself in the busyness of each day, have little goals in mind, all those kinds of things to think it's going to go on forever. And you kind of know you're going to die, yeah, it's going to be sad, but you don't really understand you're going to die. And so that's their idea. And I find that compelling because it does seem to be a core unique aspect of human nature. We're able to think that we're able to really understand that this life is finite. That's important.
There's a bunch of different things there. So first of all, I don't think there is a qualitative difference between us and cats in the term. I think the difference is that we just have a better long-term ability to predict the long term. So we have a better understanding of how the world works. So we have better understanding of finiteness of life and things like that.
So we have a better planning engine than cats.
Yeah.
But what's the motivation for planning that?
Well, I think it's just a side effect of the fact that we have just a better planning engine because it makes us, as I said, the essence of intelligence is the ability to predict. And so because we're smarter, as a side effect, we also have this ability to kind of make predictions about our own future existence or lack thereof. You say religion helps with that. I think religion hurts, actually. It makes people worry about, what's going to happen after their death, etc. If you believe that, we just don't exist after death, like it solves completely the problem. At least
you're saying if you don't believe in God, you don't worry about what happens after death.
Yeah.
I don't know.
You only worry about this life because that's the only one you have.
I think it's I know if I were to say what Ernest Becker says, I actually agree with him more than not. Is you do deeply worry. If you believe there's no God, there's still a deep worry, like of the mystery of it all. Like, how does that make any sense? That it just ends. I don't think we can truly understand this right. I mean, so much of our life, the consciousness, the ego, is invested in this being, and then
science keeps bringing humanity down from its pedestal. And
yeah,
but that's just another example.
That's wonderful, but for us individual humans, we don't like to be brought down from the pedestal.
I'm fine with it.
But see, you're fine with it because, so what Ernest Becker would say is you're fine with it because that's just a more peaceful existence for you, but you're not really fine. You're hiding. In fact, some of the people that experience the deepest trauma earlier in life, they often, before they seek extensive therapy, will say, I'm fine. It's like when you talk to people who are truly angry, how are you doing? I'm fine. The question is, what's going on?
No, I had a near-death experience. I had a very bad motorbike accident when I was 17. So, but that didn't have any impact on my reflection on that topic.
So I'm basically just playing a bit of devil's advocate, pushing back on wondering, is it truly possible to accept that? And the flip side that's more interesting, I think, for AI and robotics is how important is it to have this as one of the suite of motivations is to not just avoid falling off the roof or something like that, but ponder the end of the ride. If you listen to the Stoics, it's a great motivator. It adds a sense of urgency. So maybe to truly fear death, or be cognizant of it, might give a deeper meaning and urgency to the moment to live fully.
Well, maybe I don't disagree with that. I mean, I think what it is here is knowing more about human nature. I mean, I think human nature and human intelligence is a big mystery. It's a scientific mystery, in addition to philosophical, etc. But I'm a true believer in science. So, um, and I do have kind of a belief that for complex systems like the brain and the mind, the way to understand it is to try to reproduce it with artifacts that you build, because you know what's essential to it when you try to build it. The same way I've used this analogy before with you, I believe. The same way we only started to understand aerodynamics when we started building airplanes, and that helped us understand how birds fly. So I think there's kind of a similar process here where we don't have a full theory of intelligence. But building, intelligent artifacts will help us perhaps develop some, underlying theory that encompasses not just artificial implements, but also human biological intelligence in general.
So you're an interesting person to ask this question about sort of all kinds of different other intelligent entities or intelligences. What are your thoughts about kind of like the Turing or the Chinese room question? If we create an AI system that exhibits a lot of properties of intelligence and consciousness, how comfortable are you thinking of that entity as intelligent or conscious? So you're trying to build now systems that have intelligence, and there's metrics about their performance, but that metric is external. Okay, so how are you okay calling a thing intelligent, or are you going to be like most humans and be once again unhappy to be brought down from a pedestal of consciousness / intelligence?
No, I'll be very happy to understand more about human nature, human mind, and human intelligence through the construction of machines that have similar abilities. And if the consequence of this is to bring down humanity one notch down from its already pedestal, I'm just fine with it. That's just your life. So I'm fine with that. Now, you were asking me about things that opinions I have that a lot of people disagree with. I think if we think about the design of an autonomous intelligence system, so assuming that we are somewhat successful at some level of getting machines to learn models of the world, predicting models of the world, we build intrinsic motivation objective functions to drive the behavior of that system. The system also has perception modules that allows it to estimate the state of the world, and then have some way of figuring out a sequence of actions that to optimize a particular objective. If it has a critic of the type that I was describing before, the thing that makes you recoil your arm the second time I try to pinch it, intelligent autonomous machine will have emotions. I think emotions are an integral part of autonomous intelligence. If you have an intelligence system that is driven by intrinsic motivation, by objectives, if it has a critic that allows you to predict in advance whether the outcome of a situation is going to be good or bad, it's going to have emotions, it's going to have fear. When it predicts that the outcome is going to be bad and something to avoid, it's going to have elation when it predicts that it's going to be good. If it has drives to relate with humans, in some ways, the way humans have, it's going to be social, right? And so it's going to have emotions about attachment and things of that type. So I think, the sort of sci-fi thing where, you see commander data like having an emotion sheet that you can turn off, right? I think that's ridiculous.
So, here's the difficult philosophical social question. Do you think there will be a time, like a civil rights movement for robots, where, forget the movement, but a discussion at like the Supreme Court that particular kinds of robots, particular kinds of systems, deserve the same rights as humans because they can suffer just as humans can, all those kinds of things?
Well, perhaps not. Like imagine that humans were that you could die and be restored. Like, you can sort of, be 3D reprinted, and your brain could be reconstructed in its finest details.
Our ideas of rights will change in that case. If you can always just, there's always a backup. You could always restore. Maybe like the importance of murder will go down one notch.
That's right. But also your desire to do dangerous things like skydiving or race car riding, car racing, all that kind of stuff, will probably increase. Or airplane aerobatics or that kind of stuff, right? It'd be fine to do a lot of those things, or explore, dangerous areas and things like that would kind of change your relationship. So now it's very likely that robots will be like that because they'll be based on perhaps technology that is somewhat similar to this technology, and you can always have a backup.
So it's possible. I don't know if you like video games, but there's a game called Diablo, and
My sons are huge fans of this.
yes,
In fact, they made a game that's inspired by.
also like built a game.
My three sons have a game design studio between them. Yeah,
That's awesome.
they came out with a game
Like, just came out.
last year. No, this was last year, about a year ago.
That's awesome. But so in Diablo, there's a hardcore mode, which if you die, you're gone.
Right.
That's it. And so it's possible with AI systems for them to be able to operate successfully, and for us to treat them in a certain way, because they have to be integrated into society, they have to be able to know copies of art. In fact, copying is illegal. It's possible with humans as well, like cloning would be illegal. It's possible.
With cloning is not copying, right? I mean, you don't recognize the mind of the person and like experience, right? It's just intellectually.
But then but we were talking about with computers that you'll be able to copy,
Right?
You'll be able to perfectly safe pickle the mind state, and it's possible that will be illegal because that goes against that will destroy the motivation of the system.
Okay, so let's say you have a domestic robot, okay, sometime in the future.
Yes.
And domestic robot, comes to you kind of somewhat pre-trained, it can do a bunch of things.
Yes.
But it has a particular personality that makes it slightly different from the other robots because that makes them more interesting. And then because it's lived with you for 5 years, you grown some attachment to it, and vice versa, and it's learned a lot about you. Or maybe it's not a household robot. Maybe it's a virtual assistant that lives in your augmented reality glasses or whatever, right?
Yeah.
The her movie type thing, right? And that system, to some extent, the intelligence of that system is a bit like your child or maybe a PhD student, in the sense that there's a lot of you in that machine now, right? And so if it were a living thing, you would do this for free if you want, right? If it's your child can, then live his or her own life. And, the fact that they learn stuff from you doesn't mean that you have any ownership of it, right?
Yeah.
But if it's a robot that you've trained, perhaps you have some intellectual property claim about
Intellectual property. Oh, I thought you meant like permanent value in the sense that's part of use in.
Well, there is permanent value, right? So you would lose a lot if that robot were to be destroyed and you had no backup. You would lose a lot. Right? You would lose a lot of investment. Kind of like a person dying. That a friend of yours dying, or a coworker or something like that.
But also you have like intellectual property rights in the sense that system is fine-tuned to your particular existence. So that's now a very unique instantiation of that original background model, whatever it was that arrived.
And then there are issues of privacy, right? Because now imagine that robot has its own kind of volition and decides to work with someone else, or kind of thinks life with you is untenable or whatever, right? Now all the things that system learned from you, how can you delete all the personal information that system knows about you?
Yeah.
I mean, that would be kind of an ethical question. Like, can you erase the mind of a intelligent robot to protect your privacy?
Yeah.
You can't do this with humans. You can ask that to shut up for that. You don't have complete power over them.
Can't erase humans. Yeah, it's the problem with the relationships. That you break up, you can't erase the other human. The robots, I think it will have to be the same thing with robots. That risk, that there has to be some risk to our interactions to truly experience them deeply. It feels like so you have to be able to lose your robot friend, and that robot friend to go tweeting about how much of an asshole you were.
But then, are you allowed to murder the robot to protect your privacy from it?
Yeah, probably
What
not.
decides to be?
I have the situation that for robots with certain, like it's almost like a regulation. If you declare your robot to be, it's called sentient or something like that. Like this robot is designed for human interaction. Then you're not allowed to murder these robots to sustain this murdering other humans.
Well, but what about you do a backup of the robot you preserve on a hard drive or the equivalent in the future?
That might be illegal. It's like
then,
piracy is illegal.
No, but it's your own robot, right?
But you can't. You don't.
But then you can wipe out. Right. So this robot doesn't know anything about you anymore, but you still have technically you're still in existence because you messed it up.
And then there'll be these great speeches at the Supreme Court by saying, "Oh, sure, you can erase the mind of the robot just like you can erase the mind of a human. We both can suffer." There'll be some epic like Obama type character with a speech that we like the robots and the humans are the same. We can both suffer. We can both hope. We can both all those kinds of things. Raise families, all that kind of stuff. It's interesting for these. Just like you said, emotion seems to be a fascinatingly powerful aspect of human interaction, human robot interaction, and if they're able to exhibit emotions, at the end of the day, that's probably going to have us deeply consider human rights, like what we value in humans, what we value in other animals. That's why robots and AI is great. It makes us ask good questions.
Yeah. But you asked about the Chinese room type argument. Is it real? If it looks real,
Yeah.
I think the Chinese room argument is really good.
So for people who don't know, Chinese room is you can I don't even know how to formulate it well, but basically you can mimic the behavior of an intelligence system by just following a giant algorithm code book that tells you exactly how to respond in exactly each case. But is that really intelligent? It's like a giant lookup table. When this person says this, you answer this. When this person says this, you answer this. And if you understand how that works, this giant infinite lookup table, is that really intelligence? Because intelligence seems to be a mechanism that's much more interesting and complex than this lookup table.
I don't think so. So the real question comes down to: do you think you can mechanize intelligence in some way, even if that involves learning? And the answer is, of course, yes. There's no question. There's a second question then, which is assuming you can reproduce intelligence in sort of different hardware than biological hardware, like computers. Can you match human intelligence in all the domains in which humans are intelligent? Is it possible, right? So it's the hypothesis of strong AI. The answer to this, in my opinion, is an unqualified yes. This will happen at some point. There's no question that machines at some point will become more intelligent than humans in all domains where humans are intelligent. This is not for tomorrow. It's going to take a long time, regardless of what others have claimed or believed. This is a lot harder than many of those guys think it is. Many of those guys who thought it was simpler than that 5 years ago, now think it's hard because it's been 5 years and you realize it's going to take a lot longer. That includes a bunch of people at DeepMind, for example. But
interesting. I haven't actually touched base with the DeepMind folks. If it's some of it Elon or Dennis House, I mean, sometimes your role, you have to kind of create deadlines that are nearer than farther away.
Yeah.
To kind of create an urgency. You have to believe the impossible is possible in order to accomplish it. And there's, of course, the flip side to that coin, but it's a weird. You can't be too cynical if you want to get something done.
Absolutely, I agree with that. But you have to inspire people to work on certain ambitious things. So it's certainly a lot harder than we believe, but there's no question in my mind that this will happen. And now people are kind of worried about what does that mean for humans. They are going to be brought down from their pedestal, a bunch of notches with that, and is that going to be good or bad? I mean, it's just going to give more power, right? It's an amplifier for human intelligence, really.
So speaking of doing cool, ambitious things, FAIR, the Facebook AI research group, has recently celebrated its 8th birthday, or maybe you can correct me on that. Looking back, what has been the successes, the failures, the lessons learned in the 8 years of FAIR? And maybe you can also give context of where does the newly minted Meta AI fit into, how does it relate to FAIR?
Right. So let me tell you a bit about the organization of all this. FAIR was created almost exactly 8 years ago. It wasn't FAIR yet. It took that name a few months later. And at the time I joined Facebook, there was a group called the AI group that had 12 engineers and a few scientists, like 10 engineers and 2 scientists or something like that. I ran it for 3.5 years as a director. Hired the first few scientists and kind of set up the culture and organized it, explain to the Facebook leadership what fundamental research was about and how we can work within industry and how it needs to be open and everything. I think it's been an unqualified success in the sense that FAIR has simultaneously produced top-level research and advanced the science and technology, provided tools, open source tools like PyTorch and many others. But at the same time has had a direct or mostly indirect impact on Facebook at the time, now Meta, in the sense that a lot of systems that Meta is built around now are based on research projects that started at FAIR. So if you were to take out deep learning out of Facebook services now and Meta more generally, the company would literally crumble. It's completely built around AI these days. It's really essential to the operations. So what happened after 3.5 years is that I changed role and became scientist. So I'm not doing day-to-day management of FAIR anymore. I'm more of a kind of think about strategy and things like that. And I conduct my own research. I have my own kind of research group working on self-supervised learning and things like this, which I didn't have time to do when I was director. So now FAIR is run by Joël Pinault and Antoine Bord together, because FAIR is kind of split in two now. There's something called FAIR Labs, which is a bottom-up science-driven research, and FAIR Excel, which is slightly more organized for bigger projects that require a little more engineering support and things like that. So Joël leads FAIR Lab and Antoine Bord leads FAIR Excel.
Where are they located?
It's always delocalized all over. So there's no question that the leadership of the company believes that this was a very worthwhile investment, and what that means is that it's there for the long run, right? So there is, if you want to talk in these terms, which I don't like, is a business model, if you want, where FAIR, despite being a very fundamental research lab, brings a lot of value to the company, either mostly indirectly through other groups. Now, what happened 3.5 years ago when I stepped down was also the creation of Facebook AI, which was basically a larger organization that covers FAIR, so FAIR is included in it, but also has other organizations that are focused on applied research or advanced development of AI technology that is more focused on the products of the company.
So what's emphasis on fundamental research?
Less fundamental, but it's still research. There's a lot of papers coming out of those organizations, and people are awesome, and wonderful to interact with them. But it serves as kind of a way to kind of scale up, if you want, so AI technology, which may be very experimental and sort of lab prototypes into things that are usable.
So FAIR is a subset of Meta AI. Is FAIR like PSC? It'll just keep the F. Nobody cares what the F stands for.
We'll know
Nobody
soon
knows.
enough probably by the end of the 2021.
This is not a giant change, man. Yeah.
Well, maybe doesn't sound too good, but the brand people are kind of deciding on this, and they've been hesitating for a while now, and they tell us they're going to come up with an answer as to whether it's going to change name or whether we're going to change just the meaning of the F.
That's a good call. I would keep fair and change the meaning of the app.
That would be my preference. I would turn the F into fundamental.
Oh, that's
Fundamental
good.
AI research
Oh, that's really good. Yeah, yeah.
within Meta AI. So this would be
Meta fair.
Meta fair.
Yeah.
And, people would call it fair. Right?
Yeah, exactly. I like it.
And now Meta AI is part of the reality lab. So Meta now, the new Facebook, right, is called Meta, and it's kind of divided into Facebook, Instagram, WhatsApp, and Reality Lab. And Reality Lab is about AR, VR, telepresence, communication technology and stuff like that. It's kind of you can think of it as the sort of the combination of sort of new products and technology part of Meta.
Is that where the touch sensing for robots? I saw that you were posting about that.
But touch sensing for robot is quite fair. That's a few.
Oh, it is. Okay.
Yeah. There's also there is the other way, the haptic glove, right?
Yes.
That has
That's more reality lab.
that's Reality Lab research.
Reality lab research. But by the way, the touch sensor is super interesting. Like integrating that modality into the whole sensing suite is very interesting. So, what do you think about the metaverse? What do you think about this whole kind of expansion of the view of the role of Facebook and Meta?
Well, metaverse really should be thought of as the next step in the internet, right? Sort of trying to kind of make the experience more compelling of being connected either with other people or with content. And we are evolved and trained to evolve in 3D environments where we can see other people, we can talk to them when other people are far away can hear us, things like that, right? So there's a lot of social conventions that exist in the real world that we can try to transpose. Now, what is going to be eventually how compelling is it going to be? Is it going to be the case that people are going to be willing to do this if they have to wear a huge pair of goggles all day? Maybe not.
But then again, if the experience is sufficiently compelling, maybe so.
Or if the device that you have to wear is just basically a pair of glasses, and technology makes sufficient progress for that. AR is a much easier concept to grasp. That you're going to have augmented reality glasses that basically contain some sort of virtual assistant that can help you in your daily lives.
But at the same time, with AR, you have to contend with reality. With VR, you can completely detach yourself from reality, so it gives you freedom. It might be easier to design worlds in VR.
Yeah, but you can imagine how the metaverse being a mix, right? Or like you can have objects that exist in the metaverse that pop up on top of the real world, or only exist in virtual reality.
Okay, let me ask the hard question.
Oh, because all of this was easy. So
this was easy. The Facebook, now Meta, the social network, has been painted by the media as net negative for society, even destructive and evil at times. You've pushed back against this, defending Facebook. Can you explain your defense?
Yeah, so the description, the company that is being described in some media is not the company we know when we work inside. And, it could be claimed that a lot of employees are uninformed about what really goes on in the company. But, I'm a vice president. I mean, I have a pretty good vision of what goes on. I don't know everything, obviously. I'm not involved in everything, but certainly not a decision about, content moderation or anything like this. But some decent vision of what goes on. And this evil that is being described, I just don't see it. And then, I think there is an easy story to buy, which is that all the bad things in the world, and the reason your friend believes crazy stuff, there's an easy scapegoat, right? In social media in general, Facebook in particular. We have to look at the data. Like, is it the case that Facebook, for example, polarizes people politically? Are there academic studies that show this? Is it the case that teenagers think of themselves less if they use Instagram more? Is it the case that people get more riled up against opposite sides in a debate or political opinion if they're more on Facebook or if they are less? And study after study show that none of this is true. This is independent studies by academics. They're not funded by Facebook or Meta. Studied by Stanford, by some of my colleagues at NYU, actually, with whom I have a connection. There's a study recently, they paid people, I think it was in former Yugoslavia, I'm not exactly sure in what part, but they paid people to not use Facebook for a while in the period before the anniversary of the Srebrenica massacres, right? So people get riled up, like, should we have a celebration, a memorial kind of celebration for it or not? So they paid a bunch of people to not use Facebook for a few weeks. And it turns out that those people ended up being more polarized than they were at the beginning, and the people who were more on Facebook were less polarized. There's a study, from Stanford of economists at Stanford that trying to identify the causes of increasing polarization in the US. And it's been going on for 40 years before, Mark Zuckerberg was born.
Yeah.
Continuously. And so if there is a cause, it's not Facebook or social media. So you could say social media just accelerated it, but no, it's basically a continuous evolution by some measure of polarization in the US. And then you compare this with other countries like the west half of Germany, because you can go 4 years east side, or Denmark or other countries, and they use Facebook just as much, and they're not getting more polarized; they're getting less polarized. So if you want to look for a causal relationship there, you can find a scapegoat, but you can't find a cause. Now, if you want to fix the problem, you have to find the right cause. And what rises me up is that people now are accusing Facebook of bad deeds that are done by others, and those others we're not doing anything about them. And by the way, those others include the owner of the Wall Street Journal, in which all of those papers were published.
So as you mentioned, I'm talking to Mike Shrep on this podcast, and also Mark Zuckerberg, and probably use the conversation you can have with them, because it's very interesting to me. Even if Facebook has some measurable negative effect, you can't just consider that in isolation. You have to consider about all the positive ways it connects us. So, like, every technology, it's like,
question.
You can't just say there's an increase in division. Yes, probably Google search engine has created an increase in division. We have to consider about how much information is brought to the world. Like, I'm sure Wikipedia created more division. If you just look at the division, we have to look at the full context of the world, and they didn't make a better world.
The printing press has created more division, right?
Exactly.
So when the printing press was invented, the first books that were printed were things like the Bible, and that allowed people to read the Bible by themselves, not get the message from priests in Europe, and that created the Protestant movement and 200 years of religious persecution and wars. So that's a bad side effect of the printing press. Social networks aren't being nearly as bad as the printing press, but nobody would say the printing press was a bad idea.
Yeah, a lot of it is perception, and there's a lot of different incentives operating here. Maybe a quick comment, since you're one of the top leaders at Facebook and at Meta, that's in the tech space. I'm sure Facebook involves a lot of incredible technological challenges that need to be solved. A lot of it probably is in the computer infrastructure, the hardware. It's just a huge amount. Maybe can you give me context about how much of Shrep's life is AI, and how much of it is low-level compute, how much of it is flying all around doing business stuff in the same way Zuckerberg, Mark Zuckerberg?
Didn't you focus on AI? Certainly in the run-up of the creation of FAIR, and for at least a year after that, if not more, Mark was very, very much focused on AI quite a lot of effort on it, and that's his style. When he gets interested in something, he reads everything about it. He read some of my papers, for example, before I joined. Yeah. And so he learns about that. Right. And Shrek was really to it also. And Shrek is really kind of has something I've tried to preserve also despite my not so young age, which is a sense of wonder about science and technology, and he certainly has that. He's also a wonderful person in terms of as a manager, like dealing with people and everything. Mark also actually. So they're very very human people. In the case of Mark, it's shocking, but given his trajectory, the personality of him that is painted in the press is just completely wrong.
Yeah, but you have to know how to play the press. So that's I put some of that responsibility on him too. You have to. It's like like the director, the conductor of an orchestra. You have to play the press and the public in a certain kind of way where you convey your true self to them. If there's a depth and kindness to you,
and it's probably not the best at it. So yeah.
You have to learn, and it's sad to see. I've not talked to him about it, but the Shrek slowly stepping down. It's always sad to see folks sort of be there for a long time and slowly. But I guess time.
I think he's done the thing he set out to do, and he's got family priorities and stuff like that, and I understand after 13 years or something. It's been a good run, which in Silicon Valley is basically a lifetime.
Yeah,
because it's dog years.
So in Europe, the conference just wrapped up. Let me just go back to something else. You posted a paper you co-authored was rejected from Europe, as you said, proudly it was rejected. Can you? Yeah, I know. Can you describe this paper and what was the idea in it? And also, maybe this is a good opportunity to ask what are the pros and cons, what works and what doesn't about the review process.
Yeah, let me talk about the paper first. Talk about the review process afterwards. The paper is called VICREG, so this is, I mentioned that before, variance and variance covariance regularization. And it's a technique, a non-contrastive learning technique for what I call joint embedding architecture. So Siamese nets are an example of joint embedding architecture. A joint embedding architecture is, let me back up a little bit, right? So if you want to do self-supervised learning, you can do it by prediction. So let's say you want to train the system to predict video, right? You show it a video clip, and you train the system to predict the next continuation of that video clip. Because you need to handle uncertainty, because there are many continuations that are plausible. You need to handle this in some way. You need to have a way for the system to be able to produce multiple predictions. And the only way I know to do this is through the data environment. So you have some sort of hidden vector or a variable that you can vary over a set or draw from distribution. And as you vary this vector over a set, the output, the prediction varies over a set of plausible predictions. Okay, so that's called the generative latent variable model.
Got it.
Okay. Now there is an alternative to this to handle uncertainty, and instead of directly predicting the next frames of the clip, you will also run those through another neural net. So you now have two neural nets: one that looks at the initial segment of the video clip, and another one that looks at the continuation when training, right? And what you're trying to do is run a representation of those two video clips that is maximally informative about the video clips themselves, but is such that you can predict the representation of the second video clip from the representation of the first one. Easily. Okay. And you can sort of formalize this in terms of maximizing the information, some stuff like that, but it doesn't matter. What you want is informative representations of the two video clips that are mutually predictable. What that means is that there's a lot of details in the second video code that are irrelevant. Uh, you know, I let's say video clip consists in the camera panning the scene. There's going to be a piece of that room that is going to be revealed, and I can somewhat predict what that room is going to look like, but I may not be able to predict the details of the texture of the ground and where the tiles are ending and stuff like that, right? So those are irrelevant details that perhaps my representation will eliminate. And so what I need is to train this second neural net in such a way that whenever the continuation video clip varies over all the possible continuations, the representation doesn't change.
Got it. So it's got it. Over the space of representations, doing the same kind of thing as you do with similarity learning.
Right. Yeah. So these are two ways to handle multimodality in a prediction, right? In the first way, you parameterize the prediction with a latent variable, where you predict pixels, essentially, right? In the second one, you don't predict pixels, you predict an abstract representation of pixels, and you guarantee that this abstract representation has as much information as possible about the input, but sort of drops all the stuff that you really can't predict, essentially. I used to be a big fan of the first approach, and in fact, in this paper with Chan Mishra, this blog post, the dark matter intelligence, I was kind of advocating for this. And in the last year and a half, I've completely changed my mind. I'm now a big fan of the second one. And it's because of a small collection of algorithms that have been proposed over the last year and a half or so, 2 years, to do this, including VCREG, its predecessor called Barley Twins, which I mentioned, the method from our friends at DeepMind called BYOL, and there's a bunch of others now that can work similarly. So they're all based on this idea of joint embedding. Some of them have an explicit criterion. There is an approximation of visual deformations. Some others at BYOL work, but we don't really know why. And there's been like lots of theoretical papers about why BYOL works. No, it's not that, because we take it out and it still works. And so there's like a big debate, but the important point is that we now have a collection of non-contrastive joint embedding methods, which I think is the best in sliced bread. So I'm super excited about this because I think it's our best shot for techniques that would allow us to kind of build predictive world models, and at the same time learn hierarchical representations of the world, where what matters about the world is preserved and what is irrelevant is eliminated.
By the way, the representations before and after is in the space in a sequence of images, or is it for single images?
It would be either for a single image, for a sequence. It doesn't have to be images. This could be applied to text. This could be applied to just about any signal. I'm looking for methods that are generally applicable that are not specific to one particular modality. It could be audio or whatever.
Got it. So what's the story behind this paper? This paper is what? This is describing one such method?
This is VCREG method. So this is co-authored. The first author is a student called Adrien Barne, who is a resident PhD student at FAIR Paris. He's co-advised by me and Jean Ponce. He's a professor at École Normale Supérieure and so research director at INRIA. So this is a wonderful program in France where PhD students can basically do their PhD in industry, and that's kind of what's happening here. And this paper is a follow-up on this Barlow Twin paper by my former postdoc, Stefan Lee, with Li Jing and Joris Montar and a bunch of other people from FAIR. And one of the main criticisms from reviewers is that VCREG is not different enough from Barlow Twins. But my impression is that it's Barlow Twins with a few bugs fixed essentially, and in the end, this is what people read.
Right. So,
but I'm used to stuff that I still may be rejected for.
So it might be rejected and actually exceptional well cited because people use it.
Or it's already cited like a bunch of times.
So I mean, the question is then to the deeper question about peer review and conferences. I mean, computer science as a field is kind of unique that the conference is highly prized. That's one.
Right.
And it's interesting because the peer review process there is similar as opposed to journals, but it's accelerated significantly. Well, not significantly, but it goes fast. And it's a nice way to get stuff out quickly, to peer review quickly, though, to present it quickly to the community. So not quickly, but quicker.
Yeah.
But nevertheless, it has many of the same flaws of peer review because it's a limited number of people look at it. There's bias. Like that, if you want to do new ideas, you're going to get pushback. There's self-interested people that kind of can then infer who submitted it and kind of be cranky about it, all that kind of stuff.
Yeah, I mean, there's a lot of social phenomena there. There's one social phenomenon which is that because the field has been growing exponentially, the vast majority of people in the field are extremely junior.
Yeah.
So as a consequence, and it's just a consequence of the field growing. Right? So as the size of the field kind of starts saturating, you will have less of that problem of reviewers being very inexperienced. The consequence of this is that young reviewers. I mean, it's a phenomenon which is that reviewers try to make their life easy, and to make their life easy when reviewing a paper is very simple. You just have to find flaw in the paper, right? So basically, they see that task as finding flaws in papers, and most papers have flaws, even the good ones. So it's easy to to do that. Your job is easier as a reviewer if you just focus on this. But what's important is is there a new idea in that paper that is likely to influence? It doesn't matter if the experiments are not that great, if the protocol is things like that. As long as there is a worthy idea in it that will influence the way people think about the problem, even if they make it better, eventually, I think that's really what makes a paper useful. And so this combination of social phenomena creates a disease that has plagued other fields in the past, like speech recognition, where basically people chase numbers on benchmarks, and it's much easier to get a paper accepted if it brings an incremental improvement on a sort of mainstream, well-accepted method or problem. And those are, to me, boring papers. I mean, they're not useless, right? Because industry strives on those kind of progress, but they're not the ones that I'm interested in terms of new concepts. Right? So papers that are really trying to strike new advances generally don't need. Now, thankfully, we have
Archive, exactly. And then there's open review type of situations where Twitter is a kind of open review. I'm a huge believer that review should be done by thousands of people, not 2 people.
I agree.
And so archive, do you see a future where a lot of these strong papers, it's already the present, but a growing future where it'll just be archived and you're presenting an ongoing continuous conference called Twitter / the internet / archive sanity. Andre just released a new version. So just not being so elitist about this particular gating.
It's not a question of being elitist or not. It's a question of being basically recommendation and seal approvals for people who don't see themselves as having the ability to do so by themselves, right? And so it saves time, right? If you rely on other people's opinion and you trust those people or those groups to evaluate a paper for you, that saves you time because you don't have to scrutinize the paper as much. It is brought to your attention, and it's the whole idea of sort of collective recommender system. Right? So I actually thought about this a lot, about 10, 15 years ago, because there were discussions at NIPS, and we were about to create ICLEA with Yoshua Bengio, and so I wrote a document kind of describing a reviewing system, which basically was, you post your paper on some repository, let's say archive, or now it can be open review, and then you can form a reviewing entity, which is equivalent to a reviewing board, a journal or a program committee of a conference, to list the members, and then that group reviewing entity can choose to review a particular paper, spontaneously or not. There is no exclusive relationship anymore between the paper and the venue or reviewing entity. Any reviewing entity can review any paper, or may choose not to. And then give an evaluation. It's not published or published, it's just an evaluation and a comment, which would be public, signed by the reviewing entity. And if it's signed by a reviewing entity, it's one of the members of the reviewing entity. So if the reviewing entity is, Lex Friedman's, preferred papers, right? It's Lex Friedman writing.
Yes. So for me, that's a beautiful system, I think. But what's in addition to that, it feels like there should be a reputation system for the reviewers.
For the reviewing entities, not the reviewers.
The reviewing entities, sure. But even within that, the reviewers too, because there's another thing here. It's not just the reputation; it's an incentive for an individual person to do great. Mm-hmm. Right now, in an academic setting, the incentive is kind of internal, just wanting to do a good job. But honestly, that's not a strong enough incentive to do a really good job at writing a paper and finding the beautiful with the mistakes and the flaws and all that kind of stuff.
Right.
Like if you're the person that first discovered a powerful paper and you get to be proud of that discovery, then that gives a huge incentive to you.
That's a big part of my proposal, actually. I describe that as, if your evaluation of papers is predictive of future success,
yes,
okay, then your reputation should go up as a reviewing entity. So yeah, exactly. I mean, I even had a master's student who's a master's student in library science and computer science actually kind of work out exactly how that should work with formulas and everything. But
so in terms of implementation, do you think that's something that's doable?
I mean, I've been sort of, talking about this to sort of various people like, Andrew McCallum, who started Open Review. And the reason why we picked Open Review for iClear initially, even though it was very early for them, because my hope was that iClear was eventually going to kind of inaugurate this type of system. So iClear kept the idea of open reviews, so where the reviews are published with the paper, which I think is very useful. But in many ways, has kind of reverted to kind of more of a conventional type conferences for everything else, and that I don't run iClear. I'm just the president of the foundation, but people who run it should make decisions about how to run it, and I'm not going to tell them because they're volunteers, and it's thankful that you do that. So, but I'm saddened by the fact that we're not being innovative enough.
Yeah, me too. I hope that changes. Because the communication science broadly, but communication and computer science ideas is how you make those ideas have impact.
Yeah, and I think a lot of this is because people have in their mind kind of an objective, which is fairness for authors and the ability to count points basically and give credits accurately. But that comes at the expense of the progress of science. So to some extent, we're slowing down the progress of science.
And are we actually achieving fairness?
And we're not achieving fairness. We have biases. We do those on review, but the biases are still there. There are different kinds of biases.
You write that the phenomenon of emergence, collective behavior exhibited by a large collection of simple elements in interaction, is one of the things that got you into neural nets in the first place. I love cellular automata. I love simple interacting elements and the things that emerge from them. Do you think we understand how complex systems can emerge from such simple components that interact simply?
No, we don't. It's a big mystery. Also, it's a mystery for physicists. It's a mystery for biologists. How is it that the universe around us seems to be increasing in complexity and not decreasing? I mean, that is a kind of curious property of physics, that despite the second law of thermodynamics, we seem to be, evolution and learning and etc. seems to be kind of, at least locally, to increase complexity, not decrease it. So perhaps the ultimate purpose of the universe is to get more complex.
We have these, small pockets of beautiful complexity. Do cellular automata, these kinds of emergence of complex systems, give you some intuition or guide your understanding of machine learning systems and neural networks and so on? Or are these for you right now different concepts?
Well, it got me into it. I discovered the existence of perceptron when I was a college student. By reading a book, and it was a debate between Chomsky and Piaget. Seymour Papert from MIT was kind of singing the praise of the perceptron. That book, and it's the first time I heard about the running machine. Right, so I started digging the literature, and I found those books, which were basically transcription, workshops or conferences from the 50s and 60s about self-organizing systems. So there was a series of conferences on self-organizing systems in these books, and this. Some of them are you can actually get them at the Internet Archive, in digital version. And there are fascinating articles in there by there's a guy whose name has been largely forgotten, Heinz. He's a German physicist who immigrated to the US and worked on self-organizing systems in the 50s. And in the 60s, he created, at the University of Illinois Champaign, created the Biological Computer Laboratory, ACL, which was all about neural nets. Unfortunately, that was kind of towards the end of the popularity of neural nets, so that lab never kind of tried very much. But he wrote a bunch of papers about self-organization and about the mystery of self-organization. An example he has is imagine you are in space in zero gravity. You have a big box with magnets in it. Okay, kind of rectangular magnets with North Pole on one end, South Pole on the other end. You shake the box gently, and the magnets would kind of stick to themselves and probably form a complex structure, spontaneously. That could be an example of self-organization. But you have lots of examples. Neural nets are an example of self-organization to many respects. And it's a bit of a mystery, how, what is possible with this. Pattern formation in physical systems, in chaotic systems, and things like that. The emergence of life, things like that. So, how does that happen? It's a big puzzle for physicists as well.
It feels like understanding the mathematics of emergence in some constrained situations might help us create intelligence. Help us add a little spice to the systems, because you seem to be able to, in complex systems of emergence, to be able to get a lot from little. And so that seems like a shortcut to get big leaps in performance. But
there's a missing theoretical concept that we don't have.
Yeah.
And it's something also I've been fascinated by since my undergrad days. And it's how you measure complexity. Right. So we don't actually have good ways of measuring, or at least we don't have good ways of interpreting the measures that we have at our disposal. Like, how do you measure the complexity of something? Right? So there's all those things, Kolmogorov-Chaitin Solomon of complexity of, the length of the shortest program that would generate a bitstream can be thought of as the complexity of that bitstream. I've been fascinated by that concept. The problem with that is that that complexity is defined up to a constant, which can be very large. There are similar concepts that are derived from, Bayesian probability theory, where the complexity of something is the negative log of its probability, essentially, right? And you have a complete equivalence between the two things. And then you would think, the probability is something that's well defined mathematically, which means complexity is well defined. But it's not true. You need to have a model of the distribution. You may need to have a prior if you do Bayesian inference. And the prior plays the same role as the choice of the computer with which you measure your complexity. And so every measure of complexity we have has some arbitrariness in it. An additive constant which can be arbitrarily large. And so, how can we come up with a good theory of how things become more complex if we don't have a good measure of complexity?
Which we need for this one way that people study this in basic biology. The people that study the origin of life are trying to recreate life in the laboratory. And the more interesting one is the alien ones. When we go to other planets, how do we recognize this life? Because, complexity, we associate complexity, maybe some level of ability with life. We have to be able to have concrete algorithms for measuring the level of complexity we see.
Sure.
In order to know the difference between life and non-life.
And the problem is that complexity is in the eye of the beholder. So let me give you an example. If I give you an image of the n-list digits, right, and I flip through n-list digits, there is obviously some structure to it because local structure, neighboring pixels are correlated across the entire data set. I imagine that I apply a random permutation to all the pixels, a fixed random permutation. I show you those images. They will look, really disorganized, more complex. In fact, they're not more complex in absolute terms. They're exactly the same as originally, right? If you knew what the permutation was, you could undo the permutation. Now, imagine I give you special glasses that undo that permutation. Now, all of a sudden, what looked complicated becomes simple. Right? So, if you have humans on one end, and then another race of aliens that sees the universe with permutation glasses,
with the permutation glasses.
What we perceive as simple to them is probably complicated. It's probably heat.
Yeah. Heat. Yeah.
Okay. And what they perceive as simple to us is random fluctuation. It's heat.
Yeah. So truly, in the eye of the beholder, depends what kind of glasses you're wearing.
Right.
Depends what kind of algorithm you're running in your perception system.
So I don't think we'll have a theory of intelligence, self-organization, evolution, things like that, until we have a good handle on a notion of complexity, which we know is in the eye of the beholder.
Yeah, it's sad to think that we might not be able to detect or interact with alien species because we're wearing different glasses.
Because the notion of locality might be different from us. This actually connects with fascinating questions in physics at the moment, like modern physics. Quantum physics, like questions about can we recover the information that's lost in a black hole, things like this, right? And that relies on notions of complexity, which I find this fascinating.
Can you describe your personal quest to build an expressive electronic wind instrument, EWI? What is it? What does it take to build it?
Well, I'm a tinkerer. I like building things. I like building things with combinations of electronics and mechanical stuff. I have a bunch of different hobbies, but probably my first one was building model airplanes and stuff like that, and I still do that to some extent. But also electronics. I taught myself electronics before I studied it. And the reason I taught myself electronics is because of music. My cousin was an aspiring electronic musician, and he had an analog synthesizer. I was, basically modifying it for him, and building sequencers and stuff like that. Right, for him. I was in high school when I was doing this.
Hence the interest in progressive rock of the 80s. What's the greatest band of all time according to Gallant Field?
There's too many of them, but it's a combination of National Orchestra, Weather Report, Yes, Genesis,
Genesis,
Peter Gabriel, Gentle Giant, things like that.
Great. Okay, so this love of electronics and this love of music combined together.
Right. So I was actually trained to play the Baroque and Renaissance music, and I played in an orchestra when I was in high school and first years of college. And I played the recorder, crumb horn, the oboe, things like that. So I'm a real instrument player. But I always wanted to play improvised music, even though I don't know anything about it. And the only way I figured, short of learning to play saxophone, was to play electronic wind instruments. So they behave, the fingering is similar to a saxophone, but you have a wide variety of sound because you control the synthesizer with it. So I had a bunch of those, going back to the late 80s, from either Yamaha or Akai. They're both kind of the main manufacturers of those that they were classically, going back over decades. But I've never been completely satisfied with them because of lack of exclusivity. And those things are somewhat expensive. I mean, they measure the breath pressure, they measure the lip pressure, and you have various parameters you can vary with fingers, but they're not really as expressive as an acoustic instrument, right? You hear John Coltrane play two notes, and it's John Coltrane, it's the unique sound, or Miles Davis, right? You can hear it's Miles Davis playing the trumpet because the sound reflects their physiognomy, basically. The shape of the vocal track kind of shapes the sound. So how do you do this with electronic instrument? That was many years ago. I met a guy called David Westphal. He was a professor at Berkeley and created the the center for like the music technology there, and he was interested in that question. And so I kept kind of thinking about this for many years. And finally, because of COVID, I was at home. I was in my workshop. My workshop serves also as my kind of room in home office. And
This is in New Jersey.
New Jersey, and I started really being serious about building my own instrument.
What else is going on in that New Jersey workshop? Is there some crazy stuff you built, like just or like left on the workshop floor, left behind?
A lot of crazy stuff is electronics built with microcontrollers of various kinds, and weird flying contraptions. And
So you still love flying?
it's a family disease. My dad got me into it when I was a kid, and he was building all kinds when he was a kid, and he was a mechanical engineer. He taught himself electronics also, so he built his early radio control systems in the late 60s, early 70s. And so that's what got me into, he got me into kind of engineering, science, and technology.
Do you also have an interest and an appreciation of flight in other forms, like with drones, quadcopters, or do you use it as a model airplane?
Before drones were, kind of a consumer product, I built my own, with also building a microcontroller with gyroscopes and accelerometers for stabilization, writing the firmware for it, And then when it became kind of a standard thing you could buy, it was boring. I stopped doing it. It was fun anymore.
You were doing it before it was cool.
Yeah.
What advice would you give to a young person today in high school and college that dreams of doing something big, like let's talk in the space of intelligence, dreams of having a chance to solve some fundamental problem in the space of intelligence, both for their career and just in life, being somebody who was a part of creating something special?
So try to get interested by big questions. Things like, what is intelligence? What is the universe made of? What's life all about? Things like that. Like even like crazy big questions, like what's time? Like nobody knows what time is. And then learn basic things, like basic methods, either from math, from physics, or from engineering. Things that have a long shelf life. Like if you have a choice between, learning, mobile programming on iPhone or quantum mechanics, take quantum mechanics. Because you're going to learn things that you have no idea exist. You may never be a quantum physicist, but you'll learn about path integrals, and path integrals are used everywhere. It's the same formula that we use for basic integration and stuff like that.
So the ideas, the little ideas within quantum mechanics, within some of these kind of more solidified fields, will have a longer shelf life that you somehow use indirectly in your work.
Learn classical mechanics, like you learn about Lagrangians, for example, which is like a hugely useful concept for all kinds of different things. Learn statistical physics, because all the math that comes out of for machine learning basically comes out of was figured out by statistical physicists in the late 19th, early 20th century. So, and for some of them, actually, more recently, by people like Giorgio Parisi, who just got the Nobel Prize for the replica method, among other things. It's used for different things. Variational difference, that math comes from statistical physics. So a lot of those kind of basic courses, you'll if you do electrical engineering, you take signal processing, you'll learn about Fourier transforms. Again, something super useful. It's at the basis of things like graph neural nets, which is an entirely new sub area of AI machine learning, deep learning, which I think is super promising for all kinds of applications. Something very promising, if you're more interested in applications, is the applications of AI and machine learning to science, or to science that can help solve big problems in the world. I have colleagues at Meta, at FAIR, who started this project called Open Catalyst, and it's an open project collaborative. And the idea is to use deep learning to help design new chemical compounds or materials that would facilitate the separation of hydrogen from oxygen. If you can efficiently separate oxygen from hydrogen with electricity, you solve climate change. It's as simple as that. Because you cover some random desert with solar panels, and you have them work all day, produce hydrogen, and then you feed the hydrogen wherever it's needed. You don't need anything else. You have controllable power that's can be transported anywhere. So if we have a large scale efficient energy storage technology like producing hydrogen, we solve climate change. Here's another way to solve climate change: is figuring out how to make fusion work. Now the problem with fusion is that you make a super hot plasma, and the plasma is unstable and you can't control it. Maybe with deep learning you can find controllers that will stabilize plasma and make practical fusion reactors. I mean, that's very speculative, but it's worth trying because the payoff is huge. There's a group of people working on this path.
So convert as many problems in science and physics, biology and chemistry into a learnable problem and see for machine learning.
Right. I mean, there's properties of complex materials that we don't understand from first principle, for example. Right. So if we could design new materials, we could make more efficient batteries. We could make maybe faster electronics. There's a lot of things we can imagine doing, or lighter materials for cars or airplanes and things like that. Maybe better fuel cells. There's all kinds of stuff we can imagine. If we had good fuel cells, hydrogen fuel cells, we could use them to power airplanes and transportation or cars. We wouldn't have emission problem, CO2 emission problems for air transportation. So there's a lot of those things I think where AI can be used. And this is not even talking about all the sort of medicine, biology, and everything like that, right? Protein folding, figuring out how to design a protein that it sticks to another protein at a site, because that's how you design drugs in the end. So deep learning would be used for all of this. So those are kind of these are enormous progress if we could for that. Here's an example. If you take this is from recent material physics. You take a monoatomic layer of graphene, right? So it's just carbon on an hexagonal mesh, and make this single atom thick. You put another one on top. You twist them by some magic number of degrees, 3 degrees or something. It becomes a superconductor. Nobody has any idea why.
I want to know how that was discovered, but that's the kind of thing that machine learning can actually discover.
Well, maybe not, but there is a hint perhaps that with machine learning you train the system to basically be a phenomenological model of some complex emergent phenomenon, which superconductivity is one of those. Where this collective phenomenon is too difficult to describe from first principles with the current, the usual sort of reductionist type method. But we could have deep learning systems that predict the properties of a system from a description of it after being trained with sufficiently many samples. This guy Pascal Fouat at EPFL, he has a startup company where he basically trained a convolutional net essentially to predict the aerodynamic properties of solids. And you can generate as much data as you want by just running computational fluid dynamics, right? So you give a wing for something shape of some kind, and you run computational fluid dynamics, you get as a result the drag and lift and all that stuff, right? And you can generate lots of data, train a neural net to make those predictions, and now what you have is a differentiable model of, let's say, drag and lift as a function of the shape of that solid. So you can do by gradient descent, you can optimize the shape so you get the properties you want.
Yeah, that's incredible. That's incredible. And on top of all that, probably you should read a little bit of literature and a little bit of history for inspiration and for wisdom. Because after all of these technologies will have to work in the human world.
Yes.
And the human world is complicated.
It is. So,
yeah, and this is an amazing conversation. I'm really honored you to talk with me today. Thank you for all the amazing work you're doing at Fair, Meta, and thank you for being so passionate after all of these years about everything that's going on. You're a beacon of hope for the machine learning community. And thank you so much for spending your valuable time with me today. That was awesome.
Thanks for having me on. It was a pleasure.
Thanks for listening to this conversation with Jan. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Isaac Asimov. Your assumptions are your windows on the world. Scrub them off every once in a while, or the light won't come in. Thank you for listening. Hope to see you next time. The following is a conversation with Thomas Tull, founder of Legendary Entertainment, known for producing blockbusters like Batman's Dark Knight trilogy, the Hangover franchise, Godzilla, Inception, Jurassic World, 300, and many more. He runs Talco, which is an investment company that focuses on how artificial intelligence can revolutionize large industries. He's part owner of the Pittsburgh Steelers. He's the guitarist for the band Ghost Towns that tours with the Rolling Stones. But most importantly, he's humble, down to earth, and someone who has quickly become a mentor and friend. This is the Lex Nichols podcast. To support it, please check out our sponsors in the description. And now, here's my conversation with Thomas Tull. In 2004, he founded Legendary Entertainment, known for producing blockbusters like Batman's Dark Knight trilogy, that includes Batman Begins, Dark Knight, and Dark Knight Rises, the Hangover franchise, Godzilla, Inception, Jurassic World, 300, and the list goes on. It's just some of the biggest movies in history. What does it take to make an epic movie like that? What does it take to make it happen from start to finish?
Well, look, I've been enamored with movies since I was a kid, and I think what you need is to be able to tell a great story. If you're going to tell a great story, you need a great director. You got to start with a fantastic script that is able to take some of these iconic characters that we did and put your own stamp on it while still respecting the mythology. And I had zero experience in movies and television before I started Legendary, so it was a very interesting trip. Total luck that we had the opportunity to make 5 movies at the time with Chris Nolan, who turned out to be one of the greatest filmmakers of all time. But it's each one is its own little startup company. I don't think there's any formula to get there, but I know that if you don't have a great director and a great script, if you don't have that foundation, it's hard to pull off.
Who's the CEO of that little startup company? The director? Who would you say kind of defines success or failure?
Well, when you build a big movie like that, it's an enormous effort, 360 degrees. I mean, from digital effects, certainly actors. I mean, if you have an amazing script, an amazing director, but you don't believe anybody playing parts, that's a problem. So the reason I think it was so difficult to pull off is I always used to say you start with a stack of papers with words on it called a script. Bring that to life, and you're asking an audience to believe in everything that you're trying to put out there, and you've got a cast that, even if they're immensely talented individually, they have to mesh together, they have to have chemistry together. And the director is kind of a general on the battlefield, but you have a strong producer who's very hands-on. It truly, to me, is each one had its own story and its own sort of how it came to be and why it worked or didn't work.
So you said you were new to the industry, but you did a lot of revolutionary things, Legendary. So at that time and now, the good, the bad, and ugly of the business of filmmaking, what are some interesting holes that you were able to, or like problems that you were able to fix? What problems still exist that can still be solved?
Well, look, the business has changed so radically since 2004. When I started Legendary, DVDs were still a cash cow. So, that's how far things have come. But I would say a couple of things. The reason that I started it from a business perspective was at the time it was a $30 billion industry, and there was no institutional capital around the movie business. And I was fascinated by that because almost every other category that you look at that size as institutional capital, private equity, et cetera, is kind of a cottage industry set up around it. And I was perplexed and fascinated that didn't occur. And the way the movie business worked was unlike any business I'd ever looked at before. So after kind of convincing myself that you could actually make money if you were disciplined and had the right approach, went out, raised the money from the capital markets, which was Herculean, still maybe the hardest thing I've ever done in my career, to walk around and say, look, I have no experience. I've never done this before, but, And the second thing, being very fortunate at the time, was able to partner up with Warner Brothers. Warner's at the time was run by a man named Alan Horn, who besides being creative is also a Harvard MBA, so really understood what I wanted to do. And Alan, was just an absolute gentleman, someone that I still look up to this day. After Warner Brothers, he went and ran Disney with their run, between Marvel and Star Wars and everything. And so between Alan being responsible for Harry Potter, the Dark Knight stuff, and then on to all the Disney stuff, he probably had as great a career as anyone I've ever heard of in the movie business. So my first focus was around sort of two concepts: global, worldwide, large tentpole films and franchises, and then the business aspect of bringing long-term institutional capital to bear.
I'm going to ask you dumb questions, which is part of the style, I guess. But just for people who don't know, including me, what is institutional? What is capital? What is institutional capital? What is private equity?
Right. Okay. Well, so if you're starting a company and you go around to a bunch of your successful friends and say, "Hey, you should invest in my company," that's sort of that's great. It's capital, but it's not getting money from Fidelity or T. Rowe or a sovereign wealth fund or an endowment fund from a university that has large pools of organized capital that has a long-term point of view on your business. So if you get money from your neighbor who's a successful dentist, next year the dentist may say, "Hey, times are hard. I need my money back." If you partners with Fidelity or Morgan Stanley or any of these institutions, they have the capital and the wherewithal to say, "Okay, I'm looking at this over the next 5 to 10 years." And I thought there was an opportunity to bring that type of capital to the movie business, to be patient.
And the benefit of that, patient, so it's long term. You have to deal with fewer parties and do much larger investments. So
Yeah.
what are the benefits? What are the sort of the challenges of that kind of investment?
Well, I think the benefits in some ways are the professionals who are largely dispassionate. Right? It's like, look, if you're hitting the numbers you told me and you're hitting your plan, great. And the other thing that always was interesting to me about the movie business is if I'm investing in an artificial intelligence company or a chipset company or something like that, a lot of the institutions don't have the technical expertise to really truly grasp what's being done, so they don't, other than good business practices, they're not offering every little opinion. The movies and television are completely approachable. Everybody has an opinion. So, whether it's, I think you guys chose the wrong actor for that, or why did you do that movie? So it invites a lot more sort of second guessing and things like that. So that was always one of the idiosyncrasies of the business that I thought was interesting. And then when you talk about private equity versus public equity. If you're a public company where the companies can are traded, you want to buy Microsoft shares, you just go to your broker, TD Ameritrade, and buy them. If, on the other hand, we talk about private equity, that's institutions or individuals investing in private companies. So thus, if you have pools of capital that mostly invest in private equity deals, that's how you think about it.
It's difficult to make those happen because it's individuals. You have to sort of have dinners, agree. So it's much less. It's much more human, much less mechanical, I would say.
Yeah, and again, massive difference between large private equity shops who are professionalized and in the same category that I mentioned earlier, versus private individuals who are wealthy or whatever. But again, it's much more individualized when you're going to people who like your idea and just say, I'd like to invest in this.
Is that from all the kinds of investments you've seen? What do you think is the most conducive to creating works of genius? Whether that's in technology, AI space, or whether that's in movies. So creating something special.
I would say a couple of things. Enough money that whatever endeavor that you're going into, that you're not so nervous about the edges, right? If I have $100 to spend and I think I can create a perpetual motion machine or something for $104, I can't do it because they're all over me about the budget. So I would say making sure that you have enough capital, making sure that that capital is patient enough so that it's, if you're going to do things that are extraordinary, it takes some time. And you're going to break stuff, right? You're going to make mistakes. You're going to have a whole bunch of film on the cutting room floor, so to speak, or if you're in the lab, you're going to have a whole bunch of broken stuff. And I also think it's very important at the beginning, and I always try to do this with companies I invest in or buy, is make sure that you have a philosophical and somewhat mechanical alignment with the management team. So that going in, you both understand, hey, this is how we think about this problem or this company. This is what we feel like our culture is. This is what our goal is. And these are the metrics by which we'll agree to measure the problem. Because if you don't have that shared, hey, we're going to take this journey, then I think that's where people get upset, disappointed, etc.
What about this is a weird question, but constraints as opposed to filmmaking and investment? Do you think more money is always better?
No.
So I like constraints a lot. It's like constraints and almost like a desperation, and deadlines are catalysts for creativity, for productivity, for sort of innovation. So can you kind of speak to that? Sure. As an investor, as a creator, like what's the right balance here?
Well, I think if you're focused on a particular problem or a company or a thesis, if you have that focus and you feel like I have unlimited resources or renewable resources, so there's no leverage in the situation. Right? There's no, if I fail at this, I'll just go get more money. Right? I'll just go. I think that's a hard way to be resilient. And to think of new ways to solve problems. So I think capitalizing things just to the nth degree does create some problems. So I think there's that perfect blend of don't starve the oxygen to the point where you make short-term decisions or non-strategic or thoughtful decisions because you got to pay the rent. And on the other hand, you can't have it be like this everlasting gobstopper of whatever you want, just keep flowing the cash, because that doesn't create any friction points that I think do result in works of genius and things that that are transformative. And one of the things that is interesting to me about society sort of writ large is I think that when you go through hard times, you have to do things that are uncomfortable and you don't want to do them because you're tired, that in some ways builds up that you're comfortable being uncomfortable muscle. And I sometimes think we're losing that a little bit. And you can't sort of paint with a wide brush, but that's one of the things that I kind of observe and hope that we don't go that way.
I do think challenge and discomfort are kind of gift. It's like overcoming that. It's like from every perspective, from a human perspective, it's a source of happiness and fulfillment, overcoming challenge. But from a business perspective, I see like if something is really difficult, to me, it's also a sign that most others or many others would fail at this point. So like it's a feature. It's nice that something is difficult. But when people tell you that something is impossible, I love that because it's like, all right, well then that's what a lot of people will believe, and that gives you an opportunity to be the person who shows it's not impossible. And of course, you might be wrong, but if you're not wrong, you have the opportunity to stand out. So going through that hardship, taking those big risks, is going to really pay off. So like discomfort is a feature, not a bug, of both personal life. It's just good for life, but for business, it's like just good business sense. If something is hard, it's probably a good idea. Yeah, most others will fail. Fun question. I don't know if you can answer this, but what's the most expensive movie you were involved with? Make why was it? You don't have to say numbers, but like something stand out as being exceptionally expensive, and why is it expensive?
I think Jurassic World was pretty expensive. Worked out great. And
That's an epic film.
Look, it's one of my favorites. They just did an amazing job. And frankly, the crazy thing about my life is all the stuff that I loved as a kid somehow came full circle back into my adult life. And having the opportunity while I was out there to develop a friendship with Steven Spielberg, and then have my name on the same film as Steven Spielberg. I mean, that's pretty surreal. So that was an expensive film. Dark Knight Rises was an expensive film. But again, to me, there's a difference between expensive and irresponsible, and expensive because the vision warranted, and it turned out financially it certainly did.
Yeah, with Jurassic World, I can't even imagine having those meetings because like you have to create so much, and so much of it is obviously not real. You can't bring dinosaurs in.
Yeah.
Is that where a lot of the cost is in the computer side of things?
Yeah, those are generally pretty massive components of the budget, and especially if you're doing it and inventing things as you go. I mean, Jim Cameron is one of those filmmakers who, is designing the plane as it's flying in such a brilliant way. And I've known him over the years and just in awe of the way his brain works. And so, yeah, it's a big component.
Can you speak a little bit more to him in terms of, because you're such a fascinating person, because you care a lot about technology, you care a lot about the cutting edge of technology. So how does he, a creator, a director, build the plane while it's flying? Like, what's the role of animation in this whole process?
Well, so I never made a film with Jim. I'm just a huge fan and got to know him and John Landau, his producing partner. And one of the things that just fascinates me about Jim is, so he makes Titanic, and there's a bunch of underwater cameras and things that they need that don't exist. So he goes and invents them, and has a good grasp of engineering, and has not only the imagination but the ability to lead a team to build them. I got to go down early when they were shooting Avatar in a warehouse, I think it was, where they were shooting. As they were explaining to me how they were capturing it, and they could go back later because they created the environment, it blew my mind. And I said, okay, this is truly, people talk about a big leap. This certainly is one. So he has continued to push the envelope in terms of the art of the possible. And I just think he is an incredible genius in that part.
Again, another hard question. So you, in the realm of music, care about storytelling. Is there some aspect in which money and beautiful graphics get in the way of story? Filmmakers, if you think about Jurassic World, obviously that's an experience like any other. Like, what do you think about the tension between story, experience, and the visual effects?
Well, look, if you're using big effect shots and all kinds of tricks to cover over the fact that you don't have a very interesting story to tell, that's where I think it gets in the way. Where I think you have these incredible filmmakers, you mentioned Chris Nolan, Jim Cameron, Guillermo del Toro, you could go on and on, folks that just see the world differently and use technology to enhance the storytelling, right? To make you believe differently, rather to make you not just suspend your disbelief, but to feel like they're immersed in it. So I've certainly seen it done expertly, and I've seen it done poorly.
You've talked about this a little bit in the past, but you kind of left the movie making business at an interesting time. Perhaps you saw the changes. There's been a lot of excitement with Netflix and TV, so the role of film in society has changed. So, what do you think is the future of movies versus TV? Like, if you were, as a business person, as a creator, as a consumer, as a technologist, thinking about the next 10, 20 years, what do you think is going to be the godfather, the great pieces that move us as a society in the next 10, 20 years? Is it going to be TV? Is it going to be movie? Is it going to be TikTok clips? What's it?
Well, so I think the other category that I would add to that would be the next great medium is truly immersive virtual reality, in which new storytellers will emerge, especially when you can go into VR and there's enough computing power to sustain it and to allow it to be social and, for you to have different paths to go down. That'll be, I think, the next realm of what storytelling experience will look like.
So do you think video game kind of world, or is it more movies, or is it more social network, or is it all of it kind of blending reality and gaming?
Yeah, I thought if you saw Ready Player One, which I love the book, and the movie was cool too. But that's one version of it, right? Where you go in. I was just talking about the metaverse and all that, but you go into a world that's fully rendered as yourself and you interact with the world. The other side of it is to go in somewhere between being a passive observer and being able to move around your point of view and experiences, which I think is interesting. And then I think another adventure, so to speak, I can think of is a blend of video games. So there's a mission, right? There's obstacles, there's everything, and you move through it, but it's immersive and it tells a story at the same time. And that's why I think you're going to see new, amazing storytellers that we don't know yet that understand how to innovate and how to make you feel something in that environment. And to your earlier point, I saw probably around 2015 when Netflix decided to be bold, put out House of Cards, put out all the episodes, leave you in charge of the pace at which you would view them, which I thought was great.
That was a gutsy move.
Yes, it was, and I can't tell you around Hollywood anybody that says that everybody thought it was a great idea is not being truthful, because everybody I talked to said they're idiots, right? And what do they know about movie making and TV? And what I saw happening was, if you look at what Netflix pulled off, and they realized there isn't really a moat around the studios, you really could make stuff. And really good stuff. And so they started to create their own content. That pulled in Amazon, which pulled in Google through YouTube, and then you had Hulu, and you had Disney deciding that they're going to have Disney Plus. And the next thing you have some of the biggest companies with the largest balance sheets on the planet being in the creative business. That's, if you're an independent, that's bringing a knife to a gunfight, to be sure. And so, I thought that was interesting. The other thing that it used to be that movies were where the big things happened, and television was sort of, small screen, different experience. Then you had something like Game of Thrones come out, which was not only at the same epic level visually and storytelling wise, but had the budget to be able to do it. And now, I think you're seeing all kinds of different storytelling taking place. And I also like that you're not pigeonholed into a time. Like, you got 2 hours to tell the story. You can do a 3-part miniseries, a 5-part miniseries. You can do television that's all kinds of different format. That I think is allows creators to do a lot more interesting things.
It is also interesting to consider the role of companies that enable that, like the capital that enables that. Without Netflix and HBO, you would have some of these epic shows. So if we're thinking about the virtual reality world that you're talking about, it's interesting to consider who will enable that. Now, like you said, Facebook is talking about meta and metaverse, but it's unclear that just having money is enough. Netflix did a lot of really revolutionary stuff. Amazon has money. There's a lot of companies that have money that don't quite do as good of a job yet at enabling creators of creating revolutionary new content that changes the whole industry. And that's probably going to be the case with virtual reality. There is a lot of money needed to enable experiences, but in terms of compute infrastructure, there needs to be a huge amount of money there, but you also need to somehow give freedom to creators to have fun, to do their best work, at the same time, like, provide the perfect amount of constraints, all of that together. Like, however Netflix makes it happen, they do a pretty good job, because it's a very constrained platform. But yet, all the creators I've ever talked to, comedians and so on, that work with Netflix are really happy because they feel free to create their work.
Yeah, and I think a lot of times, companies are a letterhead that boils down to people.
Yeah.
And I think I've known Ted Sarandos a long time, who ran the studio at Netflix and now took over for Reed running the company. But Ted, very smart, talented guy, and understood early how to cultivate talent and relationships with talent, which is important. When you're dealing with creative people, their motivations and their goals are not always the same, right? They're not always capitalistic, right? And so in terms of being able to communicate with creative people that are not always A to B to C is a talent. And so I think they did a great job. Ted did a great job with that early. But I think that you're going to see different formats. I don't think going to a theater to see a massive movie on that screen in that format is a fundamentally different experience. And I think you're going to find movies, my legendary just put out Dune, which I thought was phenomenal. When we secured the rights to Dune years ago, I was over the moon because I love the book. I love the entire world that is Dune, and that's a movie that I think you see on the big screen. I think when Avatar 2 comes out, I'll want to see that on a big screen. But I think you're going to see a ton of content is obviously being produced, and it's not all going to go to a theater-going experience. So you're going to see, I think, different versions of this over the next 5 to 10 years.
In case James Cameron is listening to this, so we officially agreed to talk at the time of on this podcast at the time of Avatar 2 release. Just holding you to that recorded conversation. Also, just super excited both the movie and director. There's something special about movies. You know, they win Oscars. They're historic in nature. There's something about TV shows, even when they're epic like Game of Thrones, that they're forgotten much quicker in history. I don't know. Maybe that's because we haven't had enough of them. But, you know, the De Niro performances, you know, the Scorsese films, all the great films that kind of we think of throughout the generations that define generations are films. Is that just old school thinking? Is that always going to be the case?
I mean, look, to me, going in a darkened theater with a bunch of strangers and the lights go down and you go on this journey, there is something special and magical about that. And I think movies have been a part of our cultural fabric. And for some reason, Hollywood in America was, you know, uniquely positioned to do a great job with it, right? Not that there aren't great foreign movies, but far and away, American movies, you know, are dominate not only the world market, but, you know, and so whatever it is that we do well, or Hollywood does well, you know, there's something in the water apparently. But I agree that I love movies, and I will for the rest of my days. It's interesting how creators can move back and forth now as well. And that used to be a complete no-no. You're either a movie guy, or you're a person, or you know, or you're a TV director, and that's that. But those lines have completely blurred.
And they're also blurring. I mean, they're blurring all kinds of lines. Like they're moving to TikTok and Instagram, and like I know right now it's just ridiculous to consider that these like 1 minute things could be considered even in the same realm creatively as a film, but maybe that changes over time too. Maybe experiences can completely become fluid in terms of their size, as long as they have some deep, lasting impact on you as a human being, as a consumer. Or
to me, the whole thing is about either the moving image or even sometimes a picture will bring out an emotion, a reaction, something. So, you know, short form is harder because you have less time to set things up and all that. But I'm sure there will be short videos and creators that come up with things. And if a moving image can get a reaction out of it and make you feel a certain way and stay with you or inspire you, well, that to me is just the next evolution of whatever it's going to be between humans and cameras, etc.
see, I think that's why I talked offline about this. That's why I love robots. Is I think there's certain things in the short form with robots that immediately can bring out a feeling in people. There's something about our consideration of our own intelligence, of our own consciousness, of all the fears and hopes and the beautiful things about human nature, the dark things about human nature. Somehow, especially Lego robots bring out, because we have both fear and excitement. Towards that, are these going to be our overlords, our gods that overtake humanity? Are these going to be things like horses or something like that, something that empowers humanity? You don't know what to make sense of it. That's why they're super exciting. Yeah. Speaking of robots and film, you've gone into traditional industries and disrupted them quite a few times. Is there a system for deciding which industry is right for disruption? When you look at the world and see what are the big problems you would like to solve? Do you have a system of how you see which problems to solve? How do you look at the world?
Yeah, well, on the business side of that, so I have a holding company called Tolco, very imaginatively named. Part of that is literally every name ever is now taken, registered, and all that stuff. So we're a holding company.
What's a holding company?
So instead of being a fund that has money flowing in and out of it, and there's what's called a vintage year. I raise capital and I agree to invest that capital for so long, and then I give it back to you, which sometimes creates artificial time pressures and things like that. A holding company is more permanent capital. So the idea was behind Tolco was to buy almost always whole companies in majority stakes with great management teams in spaces that do not traditionally have a lot of innovation. And to have our labs group, where data scientists, AI practitioners, engineers, machine learning, etc., and to be able to bring that wherewithal to that company. So to provide them with the right capital and to provide them with access to technology, it would be hard to individually recruit for that company. So I would say that the thesis was to look for industries that were large enough that hadn't traditionally had access to that type of technology or innovation, and to try to look for companies that not only looked that part, but had management that embraced this and wanted to take that kind of thing.
So, yeah, there is quite a few industries like that, but that finding the industries and the management there, because like those industries often have a lot of old school folks who don't. It takes quite a bit of work for them to leave the technology. I work quite a bit with the autonomous vehicles and just the automotive industry. Depending on the company, there's old school folks. It's like Detroit thinking versus like what do you call it? I don't know, California thinking.
Well, I think you have to look at the nexus of two things there. One is just plain old human behavior. If I am uncomfortable and this isn't a comfort zone for me, and it's not something I have as a field of expertise, I'm going to shy away from it. Okay? Especially if I'm successful and I feel good about myself and it's a big successful company or person or whatever it might be. And the second thing is, especially if you're a public company, you're being weighed and measured every quarter. You are rewarding the managers of that company to hit metrics and to be reliable and to say, hey, I'm counting quarter to quarter that you're going to deliver what you say. It's difficult to say, you know what, everybody, in the next 2 years, I wouldn't count on our financial projections at all. Because we're going to reinvent what we're doing. It's going to work in the long run, and you're going to see that this was a really smart investment 5 to 7 years from now. That's not the way capitalism is currently wired, generally, right? And a lot of, so again, if you managers with yearly bonuses and stock options based and tied to stock price and all these other things, and then ask them to go break stuff, that's hard, I think.
So you're saying, the Talco approach, private investment, is the best way, or perhaps the only way, to enable this kind of long-term innovation, investment, taking big risks, and investing in innovation.
Well, but we certainly are not by any means the only one doing it. I'm just saying that when you think about big companies, more successful, that are in old line businesses, and I hear people sort of talk about, well, why can't they just pivot? They recognize they need to be in the technology business. Well, because it's hard. It's hard to steer a ship and turn it that big, and especially if it's not part of your DNA at that company. So, I just think that what we tried to do is to enable management teams that know where they want to go and to be patient with capital, and to also, again, bring innovation to bear that they have access to. There's plenty of capital structures doing interesting things. That's one of the things I love about our country. This country innovates, and this country invents things, and I'm constantly in awe of just the the human ability to innovate and to iterate. I get to hang around some universities, including your old shop, MIT, and it's like
Still there.
yeah,
Still teaching there.
still teaching, but that place is like Hogwarts. I mean, it's just it's inspiring,
Yeah.
right? And certainly the energy in Silicon Valley, which now Austin, Texas, where we're sitting, has its own incredible ecosystem. So that's one of the things I love about America is the ability, and that really is, I think, in the American DNA to create things and invent things. And I think that's invigorating.
And I think that's even bigger than capitalism, sort of the machine of how capitalism works. That's just human nature. Capitalism is just one of the ways to sort of make that human nature shine, I suppose. But it's like you mentioned MIT. There's a drive there to invent, to innovate. That's so purely human. That human spirit to sort of build something new. It's like that hopeful, optimistic spirit, especially in the engineering space. Like if you pay attention to the internet, like Twitter and all that kind of stuff, intellectuals and so on, there's a cynicism to when we talk about stuff, but there's an optimism to when we do stuff. And the doing part, when you actually build things, especially, like you care a lot about manufacturing too. If you actually build physical products, that's where we truly shine.
Yeah, no question about it. And I'm passionate about our country making stuff again, right? Doing our own manufacturing and making sure that we don't lose the ability not just to create things intellectually and do the world's greatest blueprints, but actually make things here.
Actual factories.
Yeah, that's exactly right.
How do we do that? How do we bring more manufacturing to the United States?
There's a company that I have a big personal investment in called Rebuild, with some folks that all went through the MIT school years ago. There's a good friend of mine named Jeff Wilkie who used to be at Amazon, and we all felt the same way that America needed to make sure that it didn't lose its edge in that way. So it's a company that invests in American high-tech manufacturing, and I think the way we do that is provide capital, provide training. To me, this is also fertile ground for good, sustainable, high-paying jobs. And we have to make it economically feasible to do that again here in this country, and not to say to companies again are being weighed and measured quarter by quarter. Hey, this is 3 times as expensive to do it here, but you should do it here. We need to innovate, and we need to create processes and companies and opportunity that balance that equation. And I think as we saw during the pandemic, I don't think in this day and age you can eat solutions. That doesn't make any sense to me. But being self-reliant and self-determinant and making sure that you are never in a position as a nation that we can't do basic things because we're relying on the supply chain in other countries. And whether it's, we're not friends anymore, or a natural disaster or a virus or something pops up, I think those are costs of doing business that we have to put into the calculus of being able to make things.
There's an extremely high cost to making supply chain resilient that we have to consider. And so if you really consider that cost, it makes a lot of sense to invest, especially long term, in building up manufacturing in a way where you're making most of the stuff in one place. Sort of bringing it all, not all, but as much in as possible, and building homes like from scratch here in the United States. And what I guess your thought is with innovation is possible to sort of revolutionize the move to manufacturing, so reduce the amount of supply chain stuff and like build stuff from scratch and do high tech manufacturing. So optimize all aspects of manufacturing, all that kind of stuff.
Yeah, and I think where technology is the most efficient is the human machine interface. Right? It's not let's automate everything and have nobody working. For a long time, that's neither feasible nor desirable. But where we can enhance jobs and make that interface immensely productive with the right training and so forth, I think that's a worthwhile endeavor and something that's going to be important to our country.
Yeah, when you were talking to, I love human robot interaction, human machine interaction, and AI interaction. So, what do you think is the role of robotics in this high tech manufacturing? So, it's like industrial robots, robotic arms, all that kind of stuff, or even more complicated kind of robots. What do you think is the role of robotics? What do you think is the role of AI in this manufacturing future?
Well, robotics to me is an extremely exciting field. I don't have the same expertise that you do. I have an adjacency, but not the depth of knowledge. I've never really delved deeply into it or made investments in it. But I think what's exciting about it is everything from doing jobs that are very dangerous for humans, enhancing the human experience. When you look at really repetitive labor, things that, it might take away a job, but is it a good job for that person who's spending 30 years doing something highly repetitious? Is that a good experience in life? So I think, and then when you think about everything from military applications, rescue, we're already seeing a bunch of those things. And then just lastly, when you talk about that human interaction with robots, when you start to have the combination, so you have some level of intelligence and interaction. I mean, that's why we always love the droids in Star Wars, right? I mean, it's exciting. It captures the imagination. And I think, look, many hours have been spent on debating artificial intelligence and the ramifications if things go sideways and so forth. And I think those are all, those are appropriate conversations to be having. AI is happening. I think it's actually happening slower than most people realize, because there are tasks that humans do every minute of every day, standing up without losing your sense of balance. These are really hard things, but I think there's enough investment, both in private industry as well as nation states now, on artificial intelligence that it is coming.
So both in the software space, in the digital space, and in the physical space. So talking about manufacturing, so industrial robotics is very true that even in the factory, even the tasks you think are pretty basic, the amount of small intuitive decisions that humans make is quite incredible. So we have to be kind of explicit about saying which tasks are actually really hard and humans are just really good at them. And so on the flip side, in the digital space, there's social networks with recommender systems with all kinds of personal assistants in terms of voice or voice-based AI systems. All of that. There's opportunities there to find niches where AI can really have a transformative effect. I think one of the places that really haven't, this is where the word say stupid things, but I believe this very much, that when we have AI systems in the home currently, you have something like Alexa and Google Home and so on, they're kind of very basic servants. They tell you about the weather, they can play some music, they can turn the lights on and off, all that kind of like smart home stuff. I think there's a lot of value in systems that form relationships with us in the way that pets do, dogs and cats. I don't know, cats, just for people who have cats, cats don't care about you. They really don't. They don't form any kind of relationship. I don't know why you have a relationship with them. It's one way. Anyway, sorry, it's also shit. I'm just kidding about that. That's a basic kind of connection you have with another living being. Then there's also just friends. You have different levels of friends, acquaintances, you have lifelong friends, all that friendship you have. I really believe that there is some aspect of the human experience that deeply enriched by interacting with other beings. And for systems, computing systems, artificial intelligence systems in our world, to have the capability to engage in some of that, I think, is not just an opportunity to help people grow, become better people, but it's also just a good business opportunity too. And that hasn't really been explored enough. So that to me is really, that's a whole exciting space that I think will enable better industrial robotics. It will empower a better Facebook or a better social network, a competitor to Facebook that overthrows Facebook. So it'll create better technologies that currently don't have that human robot interaction touch. So I don't know. That's super exciting to me. But that has to deal with the mess of human nature. The reason that most robotics people and AI people stay away from humans, they stay away from the human robot interaction problem, is because humans are complicated. They're messy. They're hard to control. They're hard to predict stuff about. They're hard to make sense of or like test repeatedly because one human can be drastically different from another human. So to deal with that as the robotics problem is super hard. And so one of the questions is which problems can you remove the human from consideration when you're trying to solve the problem? So like Elon Musk is an example of somebody who believes autonomous driving, we can remove the human from consideration, we can solve autonomous driving as a robotics problem. It's stay in the lane, and there's a red light, stop at a red light. If there is humans in the picture like pedestrians, that's a ballistics problem. Just treat them as a moving object that has with like 90% probability keeps moving in the way they were in the past few seconds. Some smaller probability they might stop or turn. Like just do some basic models about them and you'll be able to do just fine. So I tend to believe that even driving has to consider the full messiness of humans. The dance, the game theoretic dance of chicken that we all do when we jaywalk, we look at the car. That driver doesn't have the guts to murder me. So I'm going to walk in front of it and not look at the car. We do that kind of dance, and AI systems need to be able to do that kind of dance. In Telco, there's the labs. So there's a data science component, there's an AI component. So how do they go into a company and help revolutionize that industry?
Well, there's different examples. So one of our companies, Figs, makes healthcare workwear, started by these two brilliant women, and early days helping to build the platform and recruit and um, make sure that the everything that we did at the company embraced technology, and at the same time they were obsessive about the customer, which is doctors, nurses, healthcare workers who are putting it on the line every day, and obsessive about their product. And when you have those two things come together, you get the result that we did at Figs. We have a company called Acasure, which its AI lab and base is down here in Austin, Texas. It was insurance, one of the largest insurance brokers in the world, and we did a deal with them and sold some of our insurance holdings. It was completely AI driven. And in that case, you basically put the team inside the company, right? Because it's a massive company with all, and we've gone into all kinds of things. So it just depends on the different situations. But the biggest thing was just to make sure whatever the company needed, they had access to the talent. Sometimes we build it, sometimes we help recruit for it. You know how in technology, it's whatever works, right? There's no one way to do things.
Well, Acrisure is really it's really interesting as an example of an insurance success in the space. It seems like very ripe still for disruption across the board. So how do you? It seems like a lot of the disruption has to do with like almost the first dumps that we've been using mostly paper. Like it's not digitized. You have to basically convert, create a infrastructure and a framework where like everybody's using the same digital system, like databases, and just organize the data. It seems like that's a huge leap that basically can revolutionize major industries that still hasn't been done. Insurance is obviously a great example of that.
And one of the things that struck me, the founder CEO of Acrisure is a guy named Greg Williams. They're out of Grand Rapids, Michigan. And as we were looking at expanding our footprint in insurance, I met with a lot of insurance executives. And they would talk about technology. Greg truly understood the power of what would happen across actuarial sciences, predictive analytics, and using machine learning to really run every aspect of your business, and then automating a lot of it, just the back office, tedious steps. As you said, one of the things that was great for us, they already had a data collection system and departments, and so it was much easier to pivot. And I'm very excited about the future of that company. It's they're doing some pretty innovative, groundbreaking things, and those are the things that I like doing. Right? Is that yes, I want to make money. That's what that is. But at the same time, what did you do with your time on Earth? Right? Did you do anything to leave any kind of mark that you did anything interesting? I can only speak for myself. There are many more ways to measure one's life, and I can only speak about how I think about things. I grew up poor in upstate New York with a single mom and watched her work a couple jobs, and had to, from a young age, to shovel snow and mow lawns and do all kinds of things to help her make sure the lights weren't turned off in our little place. And so that's just something that I've always been driven towards. And I have a really eclectic tastes and interests, and it's just been an interesting journey.
So help be part of and help enable some cool new creations across the board, like film, music, AI, manufacturing, just insurance, all the specific industries that are disrupted. Yeah, small tangent. Back to your childhood with your mom. Any memories kind of stand out, stick with you as something that helped define who you are as a man?
Yeah, even though university and college experience was not part of the family tree, and we had no connections. I didn't understand. I didn't know what a trust fund was or prep school. I didn't know what any of that was. But my mom, from a young age, would always say, you're going to go to college. There's no, if you choose to. And I think from a young age, that was just an expectation that I had and she instilled. And the work ethic. I watched her, and then my grandmother was a janitor, a cleaning lady in the hospital for 50 years. And then I remember there were times of, 10 years old, it's freezing cold out. If I don't go out and shovel 6 driveways, you don't have enough money to pay the bill. So I don't know I'm not a psychologist, so I don't know how that manifests itself in my life today. But I think the grit to say, I'm not in the mood to do this. I don't want to do this, but that's the work that needs to be done. And no excuses. Not I'm a victim and I'm going to sit around and talk about. No, it is what it is, and you have to get done what you need to get done. And again, I think it's you can never fully put yourself in someone else's shoes or experience. So I don't know what that is or feels like, but for me, those were two, I think, formative things that were important.
So that's pretty. The reality of life like that is pretty humbling. You've been so exceptionally successful that it's easy to get soft now. How do you get humbled these days?
Getting up. I think for me personally, trying to push the envelope and being weighed and measured. Right? That's why I always love sports too. There's a scoreboard. And, I'm a huge believer in opportunity, meritocracy, all those things that I think are ideals that we want to aspire to. And I think that there's a lot of things I'm involved with right now that I just want to see if I can do it. I want to see if my own little mantra is cause the outcome, right? As much as you can. And at the same time, have the humility and not to have the hubris or arrogance to say, I'm always going to cause the outcome. You'll get your ass kicked pretty quickly and humbled. The world and the universe is a big place with forces, beyond. But I think, I also think a lot about being intellectually honest, which when I do university talks and so forth, I think that's a superpower. Because if you find yourself making decisions based on other people's expectations, based on places you don't want to go, but you're either you feel like momentum is taking you there. I think that's a big problem. And there are people that go to our top universities and can't wait to get out and start their own company, and they want that pressure. They want to grind. And there are other people that are smart and talented that just say, look, I don't want to lay awake staring at the ceiling wondering how I'm going to pay payroll. I don't want that in my life. And I think if you can square that up and be okay with it, say what makes me tick, what makes me happy, what puts me in a bad headspace, because there's a difference between challenging yourself and going against your nature. So that's why I think that being intellectually honest and being able to really sit down and go inside your own head and say, what am I good at? What am I not good at? How am I going to put myself in a position to be successful? Because, I'm working on my weaknesses, but I'm not going to put myself career-wise in a position where I'm just fundamentally going to have a hard time being successful.
Yeah, intellectually honest is a tricky one. And it gets there's like levels to it too.
Sure.
Because like some of the things I think about when you dream of doing certain kinds of big things. A part of intellectual honesty is to say several things. One is like, hey, the thing you're dreaming about, like, one, the fact that nobody's done it probably shows that you're just a dreamer. This is not going to, like, think clearly. The fact that it hasn't been done probably shows that it may not be the right path. And two is like, if you're dreaming about stuff, there's a certain point where it's like, hey, you haven't done it. Like, why haven't you done it already then? Like, you have to be honest with yourself. Like, you have to be ambitious. Like, a lot of people work hard a long time for a dream, but you have to wake up and be like, all right, I've been at this for 10 years. Like with a startup, you launch a startup and you think, okay, 1 year, 2 years, 3 years, 4 years, pretty successful, but it hasn't exploded like your dream, and you have to shut it down. You have to be intellectually honest there. At the same time, you might want to be step it up, lean into it. Say almost like the flip side of like intellectual honesty is like maddening ambition. I'm just saying, fuck it, I'm gonna go on there. That is a kind of intellectual honesty, saying like, the big problem here is that they kind of doing too many things. Maybe with this dream to go on and all those kinds of things. I mean, this is human experience. It's complicated.
Yes, without all human things are complicated. And I think there's a difference between being reckless and making well thought out, informed decisions. If you're going to go all in, make sure you measure twice, cut once, as they say. And one of my other favorite, I forget, many years ago I heard this saying and it stayed with me. It was never mistake clear line of sight with distance. And so I think that the key, whether you're starting a business or you're thinking about leaving the company you're at, starting a business, or just leaving for another job, any of these things is as much as you can, right? And psychologists, I think, would tell us it's hard to be self-aware completely, right? That's the rub. That if we were all completely self-aware of everything we did, strengths and weaknesses, it'd be a different world. But I do think you can work on that and at least challenge yourself to think about it and not be in a position where I'm going to medical school because that's what you do in my family, and even though I'm miserable doing it, things like that.
So definitely you don't want to be sort of because you don't think fall victim to conformity, but just go on doing the same thing over and over again. Right. But at the same time, it's measured twice and cut once. It does feel like some of the biggest leaps taken are where you cut once and measure later. Because you leap in first.
Sure.
And it's almost like a gut. I suppose that is a measurement, but you build up a good gut instinct of like what to do, and then you just do it, and then you figure out. It's the building the airplane as you're flying it, right?
Well, and I think each one of those instances that you could probably cite has its own unique circumstances, right? I don't have a deep biotech background, so if I suddenly stood up and said, I'm going to put everything I have into this idea, those are, right, it's game theory, right? What are the odds of success? If, on the other hand, you're brilliant in your field, or you've seen some opportunity that you think is wide open, and you're going to go for it and break stuff, that's great. You just want to weigh, to me, always say, like, how crazy is this on the spectrum of, do I have any expertise? What is the downside if I fail? Right? If you're at a certain point in life with young children and you've got a mortgage or whatever else, that is one circumstance versus I just got out of Stanford or I just got out of whatever and I'm going to go for it. It's just the whole thing, right? It is complex, as you point out. And sometimes you just want to have the right matrix in your head of decision-making process to try to arrive at the right place. And even if you get close, that's where I think you say, you know what, the hell with it. I'm doing this.
Yeah. I do want to ask you about one specific idea that sounds super fascinating to get involved with recently. You led the $50 million seed round for a company called Colossal that is focused on deep extinction. This is funny relative to our conversation about Jurassic World. They're seeking to restore lost ecosystems and use gene editing to restore the woolly mammoth Arctic tundra. How are they going to do that?
Well, I met this fascinating guy at Harvard named George Church 5-6 years ago, and found him to be incredibly smart, have an imagination, and he partnered up with a guy named Ben Lamb, who's an entrepreneur. And basically, the press, and to me the imaginative, you're capturing my imagination by telling me you're going to bring back the woolly mammoth and other extinct animals, and we'll see where that road leads. I was more interested in an investor in the things that they're working through around understanding genes in proteins and CRISPR and all these other things, because being adjacent to George Church and his team as these things unfold over the next decade, I thought was the right thing to do.
People are important here, just like investing in people and seeing what the hell they come up with.
Absolutely. I mean, you can look through history, and great things are done by great people, right? And companies, they end up over time becoming a logo and immediately what you think of them. But they started out with a person, with an idea, and a team that cultivated that and made that happen. And I think there are certain folks that are just immensely talented that if you can be around them, and I also know his team's ethics in terms of spending time talking about where the lines are. People in other countries that may not have the same process, may not have the same checks and balances, are doing this and pursuing this regardless. So at least I felt like with George and Ben and their teams, they're also very responsible.
This is where the human side of things comes into play. I've interacted with a lot of really brilliant people in the technology space where you kind of, there's a lot of ways to feel this out. You can ask them literally kind of literature. You can feel out how much they really understand about human nature. Like whatever the technology is, when it actually starts to interact with society at scale, do they have an understanding or an intuition about how that happens? Some of that requires studying history, some of that requires just looking at the worst and best parts and events in human history to understand it doesn't always turn out like everybody hoped the technology turns out. If a person has a depth of understanding about history, about human nature, then I think that's the right person to mess with some of this cutting edge stuff.
Yeah, you want Marcus Aurelius with a PhD from MIT.
Exactly. You just a small tangent, but you mentioned having a conversation with Warren Buffett. You spoke really highly of him as an investor, as a human being. What about him do you admire? What from him? What insights have you drawn from him as a great investor yourself?
Well, the afternoon that I got to spend with him, which is something I'll treasure forever. But sometimes when you meet people, even that are immensely successful, you may decide that after 20 minutes or a half hour, you were in the right place at the right time, and that's fine. There are other people that are clearly different, special, and I don't care if you made them start from zero, would end up in a good place. And so it was an absolute privilege to spend the time with him. And a couple of things that stood out in the conversation. He is incredibly intellectually curious and well-read. And I like how simplistic he likes to keep his thought matrix. And then also, instead of trying to outsmart the market, it seems like a simple axiom, but just look, good companies that are led by talented managers that are good businesses over time are going to get there. So I'm not going to day trade. I'm looking for value. And then just on life stuff, and also his ability to take in and then use information is incredibly impressive. So I only spent I'd met him before, but I only spent one afternoon with him. But it's, pretty incredible. And one of the things that stuck out to me is we were in the middle of talking about Telco investing or how we thought about it. And I said, I'm trying to be smart about it. And he stopped me and said, Charlie Munger, he's a partner of many years. Charlie and I don't try to think of the smart thing. We try to think, what's the dumb thing we could do here? And I kind of laughed and he said, no, I'm dead serious. We think about it from the standpoint of what could we do in this situation that later we'd be like, that was a really dumb thing to do. And I actually thought that was, it got in my head. I still think a lot about that as I'm dissecting problems.
There is that's kind of long-term thinking if you just avoid the dumb things, or if you simplify it and you just focus on those simple steps. All it takes is just do that for a long period of time and be successful.
But it certainly worked for him. That's all I can say.
What about you? You've been a great investor yourself. How do you know when you judge people? So whenever I go to San Francisco, I was thinking of moving to San Francisco. That's why I decided to, after giving it some thought, talking to people, decided to move to Austin. Everybody's dreaming big and they have big plans. It's actually, I don't envy the job of an investor of any kind, because everybody has big dreams. And it's hard to know who exactly, what idea is going to materialize, what team is going to materialize into something great. How do you make those decisions about people, about ideas?
Well, if I had any kind of a lattice work on this, it absolutely starts with the people. And I think the reason for that is your business plan is going to change. Right? There's very few businesses I know of that say we're going to make a widget at this location, and 30 years later we're successful and we just make a widget, and that's what it is. Things happen, right? And today they happen with such velocity that you have to be able to make hard decisions based on imperfect information. And how are you going to calculate those answers? How self-interested are you going to be? What kind of ethics will you apply? What's your short-term versus long-term thinking? Are you able to give an honest assessment of the situation? Because the thing that you can count on is problems are going to happen. Things you didn't anticipate are going to happen. How pliable is it, right? How much elasticity is there in your ability to be successful? And I think it's important when you invest in something that you both see, you understand the roadmap ahead and agree to it, right? Doesn't mean there won't be twists and turns, but you're not like, well, wait a minute, what did we do here? This isn't what was in the thing I signed up for. And then I think honesty and communication is a huge thing to me. I always tell people, if bi-directionally, if there's something going on, start the conversation with, Lex, we have problems. Okay, now I'm sitting up, you have my full attention, and we're going to talk about whatever it is. Bad news should travel faster than good news. And because it's going to happen, being in business with someone that is going to shoot you straight and sometimes say, I don't know. I don't know what the answer is. I got to go figure it out. That I can process a lot better than, look, I don't want you mad at me or disappointed, or I can't handle not having success, so we're just going to kick the can. And I think, especially in today's business environment, that's very, very dangerous.
So that's a bad sign, not just because it's good to communicate and be honest, but if they're not willing to do that, then it goes back to the intellectual honesty. They're probably not also able to be brutally honest with themselves when they look in the mirror about the direction of the company.
Well, look, I wasn't there, so I don't know. But I think if you unpack many situations that turned out negatively, most of the people, whether you're faking lab results, right? You have a biotech company, everybody's staring at Theranos these days. Do I think in a lot of cases you're either the villain, like you started out saying I'm going to screw my shareholders over, and I'm going to be a liar. That isn't my experience. Most things are little incremental moves that say we're going to get this right next week, but today we got to make the presentation, so we're going to just tweak things a little bit. That's a slippery slope, right? And so that's why I think from the point of people, you want to go into the foxhole with folks that, understand things are going to happen, and I'm going to let you know about them, and we're going to try to solve them together. And then just in terms of the idea, I always ask, like, okay, if this company executed the way, that's the other thing that always cracks me up about financials. Whenever somebody pitches you, inevitably they'll say, our projections are really, really conservative. I'm still waiting for somebody to come in and say, look, my projections are wildly optimistic. We'll never hit these numbers, but anyway, it's, if this company did what it says and executes, and does it matter, right? Does it move the needle enough? And what are the things that uniquely position this company to be successful? And you just have to be able to answer, I think, a number of those questions pretty crisply.
But at the end of the day, it's still a big risk. So you just try to minimize the risk. Let me jump to another topic. You're an incredible human being. You're fun with this. Your band, Ghost Hounds, is touring with the Rolling Stones. So before we talk about your band, let me ask about that. What's that like, playing with the Rolling Stones?
For real. Just because they're my favorite band of all time. To me, the greatest rock and roll band, it's not even close of all time. And to share the same stage, to be on tour, and to go out and get that energy from the crowd, and every night come off stage, and later when they go on and you hear that iconic, ladies and gentlemen, the Rolling Stones, and then it's incredible. And what's amazing to me about the band, next year will be their 60th anniversary. 60 years. And it's hard to be around anything for that long, but making music and packing stadiums. And what's amazing to me, they can play a 2-hour set, and it's not just that, well, that's a hit or you recognize it. It's like every song is an anthem, right?
Yeah.
So it's been amazing. We got to play with them in 2019, and when they asked us to do this again, it's just an absolute privilege.
I asked you this offline, so I know you are a kind of rock star.
Yeah.
But just me, maybe I'm projecting, but do you get nervous? Such a large audience with the Rolling Stones. It feels like there would be a lot of pressure.
Yeah, I mean, you definitely don't want to screw it up. I think our band, is tight knit and all that stuff. And I think that the individual nervousness dissipates when you go out as a group and you're making music together, and you sort of, okay, we're all in this, and we're doing a thing. Which is why, even in sports, I always look at individual events like ice skating or anything where it's just you out there alone, and that's different than being with a team, nerve-wracking. So I'm sure if it was me with an acoustic guitar just coming out, it would feel different. But absolutely, you get the right kind of butterflies, I would call it, and just the energy of playing music and having it be this relationship. And look, I get it. I've been to a ton of concerts where I'm like, look, can we just get to the band, please? But what's been great is just an amazing reception. And we have this guy named Trey Nation as the lead singer, who's just incredibly talented. I mean, he's just not only an amazing voice, but just has that charismatic thing. So it's really fun.
What's it feel like playing in front of a huge audience? What's the, as a guitarist, like what's the feel? Are you lost in the music? Like you almost don't feel the audience? Does it add extra energy? Does it add extra anxiety? What is it? Like, what's it feel like?
No, stadiums are interesting just because it's so big and cavernous, and because you want to protect your ears. So we use an in-ear system so that you are a little disconnected from the crowd, because if you're playing that loud and you're standing in front of your amps without ear protection, that's bad.
How are you monitoring the sound? Like the in-ear stuff, is that producing the sound, or is it strictly earplay?
No, it's producing the sound. So it's like putting ear pods in and listening to a song and you're playing to it, right? It's just us playing. It protects your ears. But the energy from the crowd when they get going and get into it, which knock on wood so far has been amazing. There's nothing like it. I mean, it's just this bi-directional thing that happens, and I love music. Was kind of music and sports were kind of my first loves, and it's very difficult to describe, I think, accurately, because it's like no other feeling.
Musically, how is it different than playing in a garage with a band by yourself practicing? Like, is it, do you feel like you're creating something different when you got the guitar and the amp and just the sound dissipating out into everybody's listening? Is that?
Yeah, it's listen. The first time we did it, there's nobody in the stadium. First time I ever played in the stadium, and I'm just like, I'm out there in front and just hitting different chords and playing different licks, and I'm like, it's like I won a contest and I get to do this. But what's different about it, and each venue is different. So if you we went on the road with ZZ Top a few years ago, which was incredible. Love Billy Gibbons, he's a Texan, incredible person and guitar player. But when you're playing in like 5,000 to 7,000 seats, it's really, I mean, it's you're right there with them, with the crowd. And then when you play in an arena, we toured with Bob Seger on his last tour. We played some shows with him. And again, the arena, like they're all kind of packed on top of you, and it's super loud, which was cool. Being the crowd is. Stadiums is a completely different animal, and it's just a completely different experience.
Do you enjoy it versus like a smaller room? What's as a guitarist, as a musician, what's your favorite room to play?
Any rooms will have me. Look, I think arenas are the perfect blend, if I had to say, because it's loud and 20, 30,000 people, but like right up on you. The stadium, look, playing the stadiums with the Rolling Stones is going to go on the head marker somewhere. It's one of the more, I say this and I really mean it. My life is like a pump gun, so it just hasn't. No one's burst in yet.
Yeah.
But it's as cool as you think it is.
For 60 years, how do you think Mick Jagger still got it? How do you explain it?
I got to tell you something. I mean, the funny thing is, wherever there is excellence, people want to know, how'd you do it, right? What's the secret? Not only is Mick Jagger, and I think the songs that Keith Richards and Mick Jagger wrote together, you go back and listen to the lyrics, it's just incredibly poignant, and I'm just a huge Stones fan. So, but he works out like a maniac, right? And it's that 10,000 hours thing. It's that, hey, maybe I don't feel my best today, but I'm going to get up and do my routine and work out so that at his age, which, you know, I mean, you can look at people at different ages chronologically that are, you know, maybe we're both at this age, but I'm a lot older than you are, and vice versa. And he just, I think it's the combination of raw talent and the ability. He's very smart, right? Like he's understands how to have interaction with the crowd and hold them in the palm of his hand and be an entertainer. But then on top of that, the reason he can at this age run around stadiums and be just as energetic is he puts the work in. And that's one step that I think a lot of people miss sometimes. When they want that magic trick, they want to know what's the shortcut. Most of the time, the answer is there's no shortcut.
Yeah. You have to work hard on the way there and work hard to stay on top.
That's it.
And sometimes not even like work hard, it's just like be a professional, which that involves like in his case, at his age, with the amount of stuff you have to do on stage, and the way he does it, you have this is a professional athlete. A professional athlete that has to do things that are probably designed for 20-year-olds and 30-year-olds. Has to do at an older age, which means like what do you have to do? Well, he probably has like a whole physical routine he has to do.
Diet, the whole thing. And it's hard. Look, if you want to do great things, you probably have to do hard things to get there.
I'm not going to make you pick. Just stick on the stalls for one more minute. But what are some great Rolling Stones songs that were impactful to you? Lyrically, musically, maybe something you like playing, like air guitar? Or,
Sure.
I don't know.
Well, probably my favorites. I love Sympathy for the Devil. It's a very, I don't know, sort of Faustian. I love the lyrics. I love how almost a voodoo beat just kind of builds throughout the song. That's always been one of my favorites.
So in that song, he never mentions devil, does he? No, sorry. You know my name.
Yeah.
There's like a flirtation in the lyrics. It's kind of interesting.
Yeah, it's here's all the trouble I've caused along the way with you humans. And I just think it's really, really great.
And musically it builds really nicely.
Yeah.
It's like both fun and dark. It's cool. There's a playful nature to it. It's very stolen. Only they can pull it off. It's like playful, but it's also like dark and dangerous.
Yeah, and give me shelter. It's just, you know, and to this day, when I listen to the studio version, and Mary Clayton just comes on and sings that epic, iconic part, and there's a documentary that was done about backup singers. Phenomenal, and it tells the story of that moment, that song with Mary Clayton. It's just her voice and the way it unfolded. They got her out of bed at like 10 o'clock at night. And she's like, the Rolling Stones, and went in and just killed it. And I can't sing at all. I'm by ordinance not allowed around a microphone. So I'm always in awe when someone can sing like that. Those are my favorite Rolling Stone songs, and Painted Black's awesome. I mean, I could go on.
Yeah, guess what? Again, a song that builds that. I mean, it defines it for a generation. What made you pick up a guitar? What made you fall in love with guitar?
It's just the coolest instrument, right? I mean, when you watched back then, you know, and I was kind of an old soul. I was listening at a fairly young age to Muddy Waters, Robert Johnson, Mike Hopkins, King, and just the soulfulness.
Thrill is gone.
Oh, I mean, BB plays 5 notes, it just kills it. And the emotion that it evokes. So I just was just in awe of the instrument. And, you know, I also, there's always somebody around who's a musician who just picks the instrument up and can play, right? They're just so talented at it. They just listen to a record and play it That was never me. I never took formal lessons. I had to grind, to just make it sound like I wanted it to sound.
So both technically and ear, everything was hard work.
Yeah, I mean, I could hear it, and what they call, you play. So my right hand, the rhythm side of it is that's probably, if I have anything, my strength. But there's something pretty amazing that happens when you get together with other people and play a song. And that moment where it hits the pocket and you all kind of know it, and it's just such a cool feeling. And it was interesting growing up because I always had eclectic interests. So I loved math, physics, and science. So I had those friends, and I was an athlete, played football and baseball and basketball. So I had my jock friends. And then I had my music friends, and so it was just kind of that. And so when I was still living in Los Angeles and had Legendary, I just missed playing, and so I put this band together and called it the Ghost Hounds because, again, huge Robert Johnson fan, and that legend of Robert Johnson selling his soul at the crossroads in exchange for his musical talent.
You guys have that in one of the videos.
Yeah,
That's cool. Video.
Exactly. So I just thought like that's such cool lore. And I just love the blues. So Robert Johnson would talk about hellhounds on his trail, and so I always just thought, about ghost hounds. So I wish it were a more clever, deeper story, but that's about it for the name.
That's pretty deep, that's incredible. But you also talk about this, that you connected the storytelling of blues. So what makes a good story in a song? Like what aspect of storytelling connects with the song? So I'm a big lyrics guy too. I love like deep lyric people like Tom Waits and like people that are like Leonard Cohen, like Bob Dylan. They're like obviously poetry. Then there's some people like the Rolling Stones. It's like seemingly simpler, but it's still so much more to it. It's like less is often more. It still tells a strong story.
And there's certain people, and Mick Jagger and Keith Richards are in this boat. Billy Gibbons in this boat. They just say things in a certain way, which is just cool, right? Yeah. It's just, and so I write our music and lyrics. I have to tell a story. I have to know the characters in the song. I'm not good at just writing some rhymes and having it match up to the right key and the right music. I have to understand, like, that's just me. So I think that, look, if you have 3 or 4 minutes to tell a story, you have to be more efficient with your use of language, and you have to understand what you're building to, if anything, and evoke emotion, and hopefully for those 3 minutes get the listener kind of understand not only the point of the song but where you're coming from, and to make you feel a certain way. There's a song that the audience seemed to like a lot on the new album called Good Old Days, and I wrote that because, especially during COVID, reflecting on what normalcy looks like and what it happens when you're cut off. I just was kind of taken with this idea of that when you sit around and reminisce with friends, oftentimes it's not just like some big event happening. It's, remember that summer you go up to the lake all the time, and it's who you were with. And at the time, it probably seemed pretty pedestrian, right? It just seemed like kind of a normal day, but it was the company you were keeping. It was the time in your life. It was whatever it was. And I just kind of struck me that right now we're doing stuff that you're going to reminisce about later that seems kind of ordinary, and that was such a great time. So the idea is be in the moment, all that stuff. But these are the good old days, and enjoy it and soak it in, and kind of be present for it.
Yeah, it's a great perspective to take on the present, because we are in the thing that we sometimes the things we'll remember is the simple stuff, the little stuff.
Yeah.
Outside of Keith Richards, who is the greatest? Ridiculous question, but just indulge me. Who's the greatest blues guitarist of all time, rock guitarist of all time?
Well, you got a little bit of a hybrid with Jimi Hendrix, right? Because he played the blues and he played rock and roll. So I think most guitarists would say Jimi Hendrix is pretty ridiculous.
That probably for me.
You can't. I mean, even to this day, I don't care, technology, pedals, whatever. He just somehow fused with the instrument. I can't be sitting here in Austin, Texas, without mentioning one of the great guitar players of all time, Stevie Ray Vaughan.
See, that's how I remember on the Rothschild stepping up to the audience.
Well, no, listeners all over the place. But Stevie Ray Vaughan is another one of those that just blows me away. And then with the older guys, B.B. King, Hubert Sumlin, Clapton. I saw him on his last tour. He just walked out on just like unbelievable how he still sounds.
And both electric and acoustic.
Yeah,
He's
just master, absolute master.
And the greatest storyteller, Mr. Bob Seger. That's an interesting one. He almost doesn't get enough credit. I feel like for how great he is. Obviously, he's super famous, but
no, he's in his voice. I had the privilege of getting friendly with John Fogerty. John Fogerty and CCR fame, and he's another one that's just the way he phrases things. And you just look at the catalog of stuff he wrote. Amazing talent. I read Bruce Springsteen's book, and I'm a fan, but after reading the book, it was really, you go back and listen to his lyrics and the way he pours himself out is pretty incredible. And then again, with the old blues guys, I just think the emotion they could get out of playing, like staying on the one, right? Just playing the same rhythm. John Lee Hooker. You listen to Manish Boy by Muddy Waters, and it's just, there's something so, it just draws me in every time, and the emotion you're able to get out of things. I'm also a huge Chuck Berry fan. I just think that sound is,
do you know how to play Johnny B. Good?
I do. Yeah. Maybe, one of the great moments, at least of my childhood, was Back to the Future, and watching Michael J. Fox plug in and then at the end play at the dance to save his parents with Johnny B. Good. Awesome.
Yeah, the guitar is so much more than a musical instrument. It feels like it's like in the 20th century, it's like the car. Like it defines so much of Hollywood, so much of a generation of what it means to be. I don't know what it means to be a man, what it means to be a human in America. It's fascinating.
It's emblematic to me of a certain type of music. And that's I made a documentary years ago called Mike and Loud with Jimmy Page.
I highly recommend that everybody will document this incredible celebration of the guitar. Yeah, it says Jimmy Page, Jack White from the White Stripes,
The Edge,
and The Edge from U2. Okay, all right. Well, now you have to tell the story of that. How the heck did that all come together? Because it's so fascinating. Such different musicians all coming together, talking about their story, talking about how they approach the music, and also playing together a little bit in this casual kind of setting.
Well, look, one day I came downstairs and Rolling Stone magazine was sitting there. It was the 50th. It was the 50 top guitarists of all time, their list. And then I had some other financial report with video games, and the top video game at the time was Guitar Hero, right? Then there was a third thing I can't recall, but I said to myself, what is it about the guitar that is so central to the rock and roll, whatever you want to call it? Like, why is that the symbol? And I said to myself, I want to ask Jimmy Page why he picked up the guitar. This is Jimmy Page, right? And so I called a friend of mine, Davis Guggenheim, who had directed Inconvenient Truth, and I think still is, but at the time was the biggest documentary ever. And I called Davis and I said, look, I have this idea. I want to make this movie about the guitar, about different eras and styles and whatever, but I've never made a documentary. I don't know how to do that. So I was just looking for advice. And thankfully, because he's one of the best documentarians ever, Davis is like, you know what? I can't get this out of my head. I'll direct it, which was amazing. And we wrote 3 names down that represented different eras and different styles. Rarely do you get, you go 3 for 3, but it was those 3 guys, and it was just such an incredible experience to sit there and get to know Jimmy Page. I mean, it was like, and he was like Gandalf, man. He was like always Jimmy Page, and
that was so cool to see him. Gandalf was there's like a wisdom, there's a calmness to him compared to like the restlessness of Jack White. Like I mean, that combination is just fascinating.
It was one of the coolest experiences ever. And one of the things, there was a moment where Jimmy was going through his guitar case, and he had the double neck from Stairway to Heaven. He handed it to me, and I was like, mm-hmm. I mean, it's like somebody handing you Excaliburs.
Yeah.
Amazing experience. And The Edge, one of the kindest human beings you'll ever meet in your life. Just an amazing person. And I think you hit it right on the head with Jack. He's got that energy, and constantly pushing himself. But it's hard to believe it's been, I think, 10 or 11 or maybe even 12 years since it came out. But
after watching it, I realized like how much it was needed, and I was almost surprised it didn't already exist. I was like, yeah, because the guitar wasn't quite celebrated like explicitly. We almost didn't acknowledge it. How important it was culturally. It's kind of amazing. And the way it closed from the song, the Weight. It's called The Weight, by the band. Yeah.
That's because they didn't want to go home.
Yeah.
we were shooting on a Warner Brothers soundstage for 3 days. We called it the Summit, where the 3 of them came together. And the 2 things I'll never forget is when Jimmy starts to play the riff of Whole Lot of Love. Edge and Jack ceased to be rock gods or whatever, and had the same 15-year-old kid feeling that I did. You could see in their face. And then at the end, they're like, hey, can we play? Go. Can we just play something acoustically? Yeah. So we printed out the lyrics. That's what they wanted to play. And they just sat there and sat on those couches and just, incredible.
What's your guitar setup like? You have a few guitars. First of all, let's just put on why. So what's better? What's smaller Strat?
Well, I'm not going to get into what's better because I'm sure that'll start a flood of whatever. For me,
I'm going to say it's Strat.
All right.
Like
Well,
Strat.
I'm just going to put it. My main instrument is a Les Paul.
But okay, let me just put it on the table. I'm speaking as somebody who literally, I don't think I've ever actually strummed a chord of a Les Paul. So I can, maybe
I'm uninitiated.
Exactly. So I don't speak for experience, but it's probably because I'm Hendrix so deeply into it. Sure. I just kind of follow some steps and Clapton. So
the amazing thing to me is if you look back at Leo Fender and what the Gibson Guitar Company and Les Paul did in the 50s, those are still the shapes and the perfect thing today, right? The Strat, the Telecaster, the Les Paul, and they got it right way back then. So I have my main guitar. I've got a name for guitar. So my main guitar is named Hazel, and it's a '59 Les Paul. And there's something magical in that year, like a Stradivarius, and there's something different about it. So I play that, and then I play it through sort of my main rig is either a '59 Fender twin or a 65 Marshall. And then when we're on the road now, because when you use older vintage stuff, you just got to be super careful with tubes and everything. It has to be reliable. So very nicely, the guys from Two Rock sent me some of their amps, and they're really, because I don't use any new stuff, but the Two Rock stuff is pretty great. So that's actually what I'm
But it's close, like it's close to the sound that you like with the
Yeah.
one.
Yeah, it's new and reliable, and so that's what I'm using on the road.
Do people use like emulation? Do they use software? Is it still
They do. I personally don't. I go, I don't have many pedals. I use a Klon, an old, vintage Klon, straight into the amp, and go.
as old school as possible?
Yeah.
Is there other cool guitars you have that kind of stand out?
I have a bunch of what they call Blackguard Telecaster 50s, which are pretty great.
What are those Blackguard Telecasters?
Yeah, so they just, it's in
Oh,
the
they
50s,
actually
they
legit
used to
have Blackguard.
Blackguard.
Got it.
But they're incredible. So
What's the color of the Telecaster itself?
most of them are yellow with black, and then they got into different configurations. But there's something. I have a 51 Telecaster that I play in Open G on songs in Open G. It just, again, there's something, and I'll take all the help I can get for making it sound great. So I'll try to find the magic ones.
What's your writing process like for the music and the lyrics? Is there do you have to go to the mountains? Is there whiskey involved? What do you have to do? Or do you just write a little bit whenever you have a moment of free time?
I'm a boring guy because I don't drink. I don't. Just, I figure I can screw things up plenty on my own without adding anything. For me, it either starts with a riff, just something that I think is interesting, riff or tone that I can kind of sink my teeth into a little bit. And then a lot of times I'll write a title and love a title and then start to back.
So the title is almost like an idea.
Yeah, like this is where I want to be, and then start kind of writing it out. Again, I just have to know, am I writing from a character's point of view? Am I writing about someone or something? It's like a narrator, and what is this person? Are they happy? Are they sad? Where are they in life? I don't know if all that, like great writers, I'm sure would say, why don't you just write? You don't need all that. But for me, that's my process.
I'm not so sure about that. I bet you quite a lot of writers have create a world in their mind before they even put the simplest of words down. So yeah, there's quite a lot to that. What's your favorite song to play? Is there some favorite ones you go to? Both play and kind of. I'm sure you love singing.
No.
No,
I'm not. I'm neither talented nor do I have the desire. And I think, if you come see the show, you won't see a microphone anywhere near me.
But do you hear, like when you're thinking about lyrics, do you hear the idea of the words?
100%. And especially, what's great, with Trey is I write for his voice, and then we have these amazing backup singers that are just, and I can hear all of it. I just can't do it. And so I'd say of our stuff, there's a song called Half My Fault that I play in Open G. It just, I love playing the song. I love that energy. And then there's, we have a new blues album coming out, and there's a song called Baby We're Through, and it just stays on the one. And for non-musicians, that means, like in a lot of rock and roll and blues, it's what's called a 1-4-5 progression from your group out. You would hear, if you're a non-musician, if you heard it, you'd be like, oh yeah, that's a lot of songs. And this song just stays on the same group, like with Range or Shake Your Hips or any of those songs. And it's just got this unbelievable energy. It's fun to play, but I have to keep the same rhythmic thing going for the whole song.
With that simplicity, I mean, the personality of the song really shines. Trey's that guy, really cool. He just comes through. I guess guess you need that for bass singer. It's just
Got it.
just
You got to have that. And my other guitar player, Johnny Bob, he's a phenomenal. I mean, like a legitimate guitar slinger. We probably split the lead 70-30, and he is just. There's times sometimes I look over at him and I'm like, I'm being a fan right now because what you just laid down is pretty good.
from a lead perspective, what's the most fun thing to play? What kind of stuff do you like? Do you like slow? Do you like what? I mean, if you feel like drill is gone. There's so if you look at BB King, sometimes one note just bend all shit out of that. What do you call that? Vibrato.
Yeah. If I'm going to play the lead, it's a certain kind of feel. Slow blues is probably my favorite to play, or something that's got a little more of that Chuck Berry drive where you can be rhythmic in the lead. I can't, the shredding thing that those guys do, that's not.
Yeah. I was actually always able to do that really well. Like you mentioned, people that pick up that, like maybe it's the classical piano training. I can play super fast guitar, super technical. But to me, the hardest thing and my favorite thing is just probably less to do with the guitar, more living a life that's worth playing guitar for. It's like a certain kind of emotion that you can put it. It has to do with bending notes well, and bending notes is a whole other art form. I worked surprisingly a long time on Comfortably Numb. And so David Gilmour is there's a lot of bending, and they're simple. They sound simple, but the dynamics of them to express like a build up and the way it's held, and there's often a vibrato at the top for a bit. Just that it's almost like a sigh, a sigh of relief, and build up. I mean, it's just that's an art form on him. It's hard to get right. It's not just playing a note, playing a note, playing a note. It's in that like dynamic movement of how so much can happen. That's where the blues happens to.
It's like I'm a huge Freddie King fan too, right? And you listen to these guys, and you sit there and they're like, man, you're playing in a small range on the neck, but it's like I know the notes you're playing, and I'm playing them too, but not like that, right? I mean, Gilmour is certainly one of those guys that's incredible guitar player.
And yet another chapter of an amazing life. You love football. Like, you play football?
Yes.
What position you play?
Wide receiver.
Wide receiver. Awesome. So maybe we can talk a little bit about your love of football and the fact that you are part owner of the Pittsburgh Steelers.
Yeah.
So, I mean, where do we start? You start at the beginning, but let's start at the end. Why the Steelers? What attracts you to the, first of all, I think, not to be controversial, but one of the best uniforms in football, which is just called like black and gold. Just
decal only on one side.
Yeah, it's great.
Yeah, the helmet. Look, I've bled black and gold since I was a little boy. I grew up in upstate New York, and the first football game I ever saw was the Steelers in the Super Bowl. As a really little kid, and Jack Lambert, Joe Green, and Franco Harris, and those guys who came down from Mount Olympus or something, and I just was enamored with the team. And because we only had 3 channels, the only time I'd get to see them was occasionally when they were the game of the week or something. And I just loved, to me, what they stood for, the toughness, and they played football, the way that I thought was great. I was a huge Jack Lambert fan, our Hall of Fame linebacker who just intimidated everybody.
So that was the decade of the steel curtain. Arguably one of the greatest defensive in football history. And also one of the greatest football teams, period, in football history.
I've been a lifelong fan, and was very fortunate to meet Mr. Rooney. The Rooney family started the team in 1933, got to know him, and just was asked to be part of the ownership group. I think it was the end of 2007. First year as part of the group in 2008, we won the Super Bowl, and it was like beyond surreal. I mean, just beyond surreal. And you know, it's amazing to be able to do. I mean, the Rooney family is one of those most revered in sports for the way they conduct themselves. Mr. Rooney passed away, I think, 5 years ago now, and we lost him, but was a champion, helped build the league, I mean, put the league as we know it together. More importantly, was a civil rights champion who created what we now call the Rooney Rule to make sure that we're being fair about giving minority coaches the chance to get hired, and just is one of the most kind and amazing human beings I ever met.
It's incredible what sport does, like to bring out the best in people, to give people hope, to inspire people. There is something about football that has all the elements of a great sport. It's the teamwork, it's the sort of the combat aspect of it. It's like it's the purity of it. It's of like strength and power and speed, and all the elements of like last minute close calls required to win the game, and where referee decisions, of course, that's essential for sport, can screw up the whole thing. Just all of it together. I think, I don't know. It gives the drama and the triumphs. It's just beautiful. It's some of my favorite memories. I don't know if it's an accident or this is common with people. It's just with friends watching football, and connecting over that.
Yeah, well, it's an incredible game because there's nowhere to hide, right? You're out there on the field. It's a great game that requires not only all those attributes that you said, but it's an incredibly complex game. So if you don't know what you're looking at, you don't understand how complex defenses are trying to disguise what they're doing, offenses are trying to overcome that, and you can set up one play in the entire game. But a team that plays well together, right, knows their plays inside and out, knows their assignments inside and out, can overcome and beat a more physically gifted team because of that, that aspect of working together. One of the things that I always loved about sports is just you're out there, there's a set of rules, and there's a scorecard. So at the end of that game, it says, and you can make excuses about refs or this happened or that happened, but at the end of the day, did you go out and compete? And when you went out and were a competitor, how did it work out? Right? And the simplicity of that and the purity of that is something that I always have been drawn to.
What about the business of owning a team, or putting together a team, or trying to build up a team that's going to be a great team? What are some interesting aspects that people might not realize that you can carry over from all the other experience you have in business?
I think the hardest thing about professional sports right now, it's individuals getting paid money to play a sport, which is certainly different than amateur. And, the decisions that are hard is when you get to know somebody who's a player on the team, and either they're at the end of their career or you need to go in a different direction. And that person who's done everything that you've asked, whatever the coaches have asked of that person, then you get close to them. And then when they have to be traded, released, or whatever happens, it's, that's sad. And being able to stand back and in some ways be dispassionate and not be a fan, right? I'm on the Baseball Hall of Fame board, and one of the guys that's on the board is Jerry Reinsdorf, and I think it was Jerry who said, if you act like a fan, you'll be sitting with them. Which I thought was kind of funny.
Well, I got to put you back on that a little bit. But by way of a fan asking a dumb question, Okay, let me just give some examples. It's very common in sport. It's like this example of like certain great players going to another team right at the end of their career. And it always makes me sad. It always makes me want to wish they kind of retired right there. From a perspective of just like, do you ever, as an owner, but just in that space, think about like the Steelers in the full arc of human history. So not like as a business. Yeah,
The good news is I don't have to think about it as right.
You know,
I'm a minority owner, so I can think about it almost as a fan. But I'm sorry, go ahead.
Yeah, well, that's what I mean. I suppose it's a dumb question to think of, like of a business in that way, not just investment, but like legacy of like what footprint would you leave on this world, on this history?
That is one thing that I can say unequivocally, and I only have the experience that I have. But one of the things that I'm so proud of about the way the Steelers conduct themselves is, and that's the Rooney family. That's the legacy of the Rooney family. Is asking constantly about what's right for the league, what's right for the players. You know, what's the right thing to do here, and that's something I would hear Mr. Rooney say all the time. So I think that legacy is important because ultimately the team belongs to that city, right? Belongs to those fans, and you know the owners are the custodians of that. So I think you realize what sports teams mean to the fans, the memories it creates, the bonds that it creates. It's a responsibility. And I think that you do have to think beyond, certainly not just dollars and cents, but just sports is a very big deal in our society, and it has to be, I think, held to a standard that's not just, were we profitable this year, or what? There are other businesses for that. It is certainly business. I don't mean to romanticize to the point that it's not, but to me, it's more than that. Or at least my experience has been that it's more than that.
It's a source of meaning for millions of people. Like, and you see that most, like during COVID, for example, when there's so much desperation, so many people losing their jobs, so many people having to deal with the uncertainty with their future homes. Right. There's something about those sports that just unites us. That again, the tragedy and the triumphs of sport, of uniting, of gathering together with your friends, with family, shared experience over like this, over just team, over rooting for your team, for your city.
And the access, again, as I alluded to, we didn't have anything when I was growing up, but I would pour through the box scores. I was a huge Yankee fan and Steeler fan, and feeling some ownership of that, right? That I could read the box score and relive what they did and occasionally see them on TV and feel like I was part of that celebration when they won and everything. It's a very powerful thing.
You've been exceptionally successful in a bunch of avenues and a bunch of efforts. What advice would you give to a young person today, a high school student, college undergraduate that's thinking about career, maybe advice not about just career, but about how to live a life they can be proud of?
We talked earlier about intellectual honesty, and to me, that's the first step of just saying, to the best of your ability, who am I, and what's important to me, and what do I want to do and accomplish? If you can start with that and develop some sort of rules-based, philosophical, here's what I'll do, but I won't do. And that way, you can be flexible and pliable, and you're going to need to be. But if you still have a compass that tells you, hey, at least I know this is the path I'm going to take, I think that's very important.
The rules you're referring to, the principles, that's kind of like underlying integrity. So knowing what lines you don't cross on paths.
Exactly right. Because if you have those absolutes, there are many decisions that come into focus very quickly. right? Because hey, that's not for me. Or hey, I'm willing to do whatever it takes to do X, Y, and Z.
And it has to do with the thing you're talking about. It's kind of interesting. You mentioned it earlier in the conversation about slippery slope, and that's how often it happens. Like how the slipping into unethical behavior happens. It's a slippery slope of little adjustments you put stuff off, and that I found that to be. I've been fortunate to not have to fight very much in my life, but I still encounter them. That's what integrity, I think, looks like. Is as the slippery slope is happening, those little things is without drama, without making a show of it, making a decision that stands behind your principles and just walking away.
Yeah, and besides the big ideas, I'm going to change the world. I'm going to innovate. I'm going to do all those other things. I also start, if I'm giving any advice, which we can debate whether or not I should be giving advice, but just in terms of, well, let me start with this. Are you a good friend? Can you be counted on? Do you do what you say you're going to do?
Yeah.
Right? Are you accountable to what you sign up for, and do you hold others accountable? Right? What does all that look like? And then I think it's being as intellectually curious and well-read as you can be. We live in a world that is designed to distract you, right? And being able to sit with your thoughts or go on a walk and think deeply about something and not just surface area. You text me, I text you back, and we decide the fate of the world based on a couple of text messages or something. You don't want to lose touch, I think, with being well-read and understanding and standing on great thinkers' shoulders and learning from those works. And then I also think that there's resiliency, and then there's grit. And I heard someone say one time that those are slightly different. And I know that there are all kinds of challenges in life, right? That are tragic, that are unfair. There's no question that's the world we live in. But for me personally, to try as much as possible not to be in the victim mindset, because unfair things are gonna happen. And we all want to live in an idealistic, just world. That should be what we aspire to. I haven't seen that yet. I haven't experienced that yet. But yet you still have to function in that world. So, I think that resiliency thing is very important. And then putting yourself out there, right? Because if you play scared and you're always afraid to fail, this is probably a dumb way to get to the end of the podcast, but there are times, especially I'm out west, I love the big sky out in Montana, Idaho, places like that. When you look up at night, it's almost like I've never seen anything like this before, because there's no light pollution, so to speak. And sometimes when I look up, the most daunting problems that I'm experiencing, I'm like, those things have been there for a billion years or whatever, and I'll be gone, and it doesn't. The most famous person on Earth 200 years ago. So it's pretty fleeting, and so make sure you have a good journey, and especially coming out of COVID, I think telling people that you care about them, and maintaining and cultivating your friendships and relationships, and they're not just transactional, right? And making sure that someday when you're laying there, you can say, yeah, I was a good family member. I was a good friend. I was someone that could be counted on. I think all those things go into the mix of, however you want to take the journey.
So when you look up to the stars, do you think about that quickly approaching end of yours? Do you think about your own mortality? Do you think about your death? Are you afraid of it?
I'm a huge fan of Stoicism. Right? I read a lot of Stoicism. I think Ryan Holiday's done a great job of bringing some of that back into the forefront. It's just really thought-provoking. to me, and rings, a lot of it rings, just hits me. So I think that's right. And that memento mori thing, which is, hey, we're all going to die, so you should contemplate it. There's a finality to this thing. And so I think if you can rightly frame that between fretting about it every day and being afraid, and being so laissez-faire that you think, you're gonna live forever, it'll influence some of the decisions you make. It will influence the way you attack things, and hopefully the way that you live your life. So yes, I wouldn't say I obsess over it, and I wouldn't say it's omnipresent, but because I read a lot of Stoicism, and I think it's pause and say, who knows, right? There's going to be an expiration date, and if it happened tomorrow, have I done the things I wanted to do? Am I the person I wanted to be? And I think it's important along the way to check those things.
Yeah, I try to make sure that I actually visualize this. That I'm okay dying at the end of the day, at the end of each day. Like, if this is the last thing I do in my life is talking to you,
Oh, good Lord.
I'm happy.
You're
I know you're joking, but yeah, I'm happy I get to live the life I do, and I think memento mori, I think the Stoics have it right. So you have it right. So meditate on death enough to remember that this ride ends pretty quickly, to help you appreciate every day and the people you love, the people close to you, and the cool shit that you're doing in your life, the cool shit you're creating, and the fact that you, Mr. Thomas Tull, are playing with the motherfucking Rolling Stones. You are the man in so many disciplines, so respected, so successful. It's truly an honor to sit down and talk with me today. Thank you so much for showing up in Texas and for talking on this little podcast.
it's great, man. I'm a huge fan of the show and had a great time hanging with you, and I really appreciate it.
Thanks for listening to this conversation with Thomas Tull. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Mick Jagger and the Rolling Stones. You can't always get what you want. If you try sometimes, you might find you get what you need. Thank you for listening. I hope to see you next time. Humans are fascinated by bioevidence, and you've got to ask yourself, why? Is it the rash guard? Yes.
I talk so much shit that I'm like, man, if I lose, this is going to be rough.
You're literally just shut the fuck up. I got you, man. You were powered by McDonald's and Coca-Cola.
I want more. And then I smacked him, and he didn't want to fight anymore.
I'm not impressed by you. If George St. Pierre and Khabib Nurmagomedov face each other in their prime, who wins? I'm here with three individuals, each of whom are considered by many to be the greatest of all time in each of their respective disciplines. The greatest MMA fighter of all time, George St. Pierre. The greatest martial arts coach of all time, John Danaher. And the greatest submission grappler of all time, Gordon Ryan. So let me ask the first question. You guys can see the question on preparation here. What is the key to your success, each of you? One thing or multiple things that come to mind. John, go first. Is it the rash guard? Yes.
I like that you choose John right off the bat.
They seem the most nervous.
You inspire us to give the right answer.
For me, it's about finding a way to work in a world where most of the answers are already known. Okay, in any developed sport, by the time you enter that sport, most of the basic presets, the major techniques, the major mechanical understandings of the sport are long since worked out. And so, in a highly developed world, the key to success is to be able to identify some area of the industry that you're in, which is currently undervalued.
To do what the other people are not doing.
Deeper than that, everyone has a view of, okay, these are the main skills of the industry I work in. At any given time, some set of skills, attributes, will always be somewhat undervalued. They're underappreciated by the people in the game. You'll see that in any given industry, there are always trends which change the nature of the industry over time. So, fashion trends. In the clothing industry, you'll see at any given time there's a general wave of fashion which pushes most people in the industry in a given direction at a given time. What makes people stand out is the ability to look at the various possibilities out there and say, here is something which is genuinely useful, but which is currently being underused, underutilized. And I want to bring that back in and develop it. And because it's an inherently useful product, it will be very, very successful in its initial applications against people who aren't currently using it. If you can do this in whatever industry you're in, I believe you'll be highly successful.
This applies both for actual specific techniques and
Also tactics as well, in case of jiu-jitsu. So, for example, in my sport, leg locks have always been around. Okay, there's no shortage of people who can look back in history who are applying leg locks. Nonetheless, as in across the industry, leg locks were undervalued and underappreciated. There was a general sense in which most of the leading figures of the sport, for most of the history of the sport of jiu-jitsu, tended to de-emphasize leg locks. And when I looked at them, I said there was immense potential, but it wasn't being realized and needed to be changed. Since then, that has more or less occurred. Now, most people coming into the sport understand that leg locks are an important aspect, and they're no longer undervalued. If anything, it's gone too far the other way. Now they feel a little overvalued. And then this kind of fashion trend exists in every industry. And the job of anyone who wants to excel in a given industry is to be able to identify, okay, what are the things that are currently out of fashion and undervalued, and then look at what is their actual objective value, and then work to bring them back to the forefront.
John brought up fashion. George is wearing a really sexy shirt. So, assuming that's not the reason, is there something that comes to mind as the key to success?
Well, of course, everybody knows the famous that sort of every athlete saying, "Oh, it could be genetic. I was maybe gifted. I had sort of predisposition. I worked really hard." But I think something that people don't talk enough is when everybody sometimes go right, I was never afraid to try to go left. And I felt many times trying to do things that were not known to be things that would bring me success, but I tried it. Very often I was the first of trying new things, and I felt many times, but certain times it gives me a certain advantage. And for example, I was sometimes fighting guys that had much better wrestling background than me on paper, and nobody before that fought those guys. Nobody had dared to try to take them down because their wrestling pedigree was so good. And I didn't have on paper the wrestling pedigree to take these guys down to fight. But when everybody tried to go right, I was going left. I fought them in a different way. And that was the blueprint to beat some of these guys. You know what I mean? So,
Yeah, so we'll actually talk about a few fights that you did just that. That's fascinating. But let's stay at the higher level. Gordon, again, sticking on fashion, may I compliment your incredible badass hat.
Trying to fit in here.
We should say we're in Texas now, so he's become a Texan overnight. So, what is there something you could speak to that you would attribute to DT's success?
Yeah, so first of all, there has to be a rule where you don't ask us all the same questions because how am I supposed to compete with the answer John just gave? There's nothing I can do that's going to help that.
Yeah.
But I think it's there's many things, but I think the number one thing is John. When I came in, I was a blue belt and I was beating brown and black belts in competition already. But he really changed my way of thinking about the sport. I would just come in and if something wasn't working, I would just do it harder and faster and more aggressively, and that just degenerated into me spastically knee sliding into cross-hatching ground me against Eddie Cummings for 6 months and then just getting heel hooked repeatedly. And I'm like, this is not working. And Eddie, like when I met him, was like a chubby librarian looking guy. And I'm like 6'2", like jacked, 170. And I'm like, there's no way I'm losing a guy who looks like this. But he just kept heel hooking me. So I would just go harder and harder and it wouldn't work. And then John's like, well, if you learn to leg locks, you might have some more success. And then I was like, yeah, that probably makes sense. And from then on, I kind of just changed the way I thought about the sport. Instead of doing things harder, I would actually try to get better at jiu-jitsu.
Do you remember like a turning point where you became, as opposed to being mediocre, not just in technique but in approach to great?
I think it was somewhere around brown belt level when I was training consistently. I started training full time with John when I was purple belt, mid-level purple belt. And towards the end of my brown belt days, I was beating up like legitimate like ADCC champions in the gym. So I think like brown to black belt was a big thing for me. And then when I won my first EPI, I submitted Yuri, who won ADCC, and I beat Rothschild. So I think that was like my turning point as a competitor. But I think I started to reach world level a little bit before that. I think somewhere around brown belt, mid-level to late level brown belt.
Was some of that mental? Like, was there a moment when you, like after a training session, realized I could actually do this? I could be at the top of the world, world class.
The critical moment for me was when I think it was right when I got my black belt, maybe a few months before I got my black belt. We had a former ADCC champion come into the gym, and we did a hard round together. And I think I submitted him like 4 or 5 times, and no one knew who I was. I never won anything up to that point, and I was like, okay, like if this is like one of the best guys in the world, and I could submit him multiple times around, I think that this is like something that I actually could do professionally and make a career out of this.
Okay, so the actual performance was like you didn't need to believe before you perform. Like a lot of Olympic gold medalists, they have to believe before they can perform because like they're getting their ass kicked for a long time.
Yeah, I think the best way for me to believe in something is to have repeated success doing it against high-level guys. Like I'm not going to just believe I can do a double leg if I can't hit a double leg on anybody. So for me, the belief came from the repeated success in the gym.
Yeah, but to get to the point where you're submitting somebody like Yuri Simone is like one of the greatest grapplers ever, it's like a long journey.
Yeah, but I had the confidence, I had the belief in myself because of the success that I had in the gym prior to that event.
Even, and that's one step at a time. First it's the brown belt, then it's the black belt, then it's world class. Okay. George, was there a turning point for you when you thought, like, I can actually do this?
Yes, I always dreamed to become champion. And I think the turning point that there was 2 turning points, and they were my 2 losses. First, my losses to Matt Hughes. I went to that fight just to not lose. I was not fighting to win. And it's after the fight when I watched the replay of the fight, I realized I was doing pretty well, but during the fight in my own mind, I was not seeing it that way. I thought I was getting dominated by Hughes like 100%. When I watched the replay, I was like, man, I can beat this guy. I was beating him until I made that stupid mistake. So that was very frustrating, but that's what gave me the mental, the championship level mentality. And then I became a little bit overconfident because because I start beating everybody after that, and I start to believe the hype of people when they look at me. They were like, "Oh, he's the new up and coming superstar, and he's gonna be unstoppable." And then when I became champion, I lost to Matt Serra. So before I believe my first failure was because I had a lack of confidence, and my second failure was because I was overconfident. I think there's a per center of confidence. I mean, it's good to be confident because John taught me like confidence. It's like money in your bank account. If you can have all the skills in the world, right? And then if you don't have the confidence, it's like you can be a millionaire, but you don't have access to your bank account. So that's a little bit the analogy that John told me. So that's how I feel confidence plays for an athlete. But to be overconfident, I think it's always good to be aware, to be afraid of what can happen. So to have a perfect balance of confidence and fear, to me, that's what mentally gave me the edge to become, I believe, successful in my sport.
Playing off that, John gave me a speech one time, and he was like, "You have to be able to like flip a switch and turn it off." Where like a guy like Mayweather or someone who goes out who's super confident and he plays the character of someone. He's like, "No one can beat me. I'm the best that there ever was," and that's it. But if you look at me, actually train very hard. You can't play the persona of "no one can beat me" and have it translate into your life and just think that you're so good that you don't have to do anything and no one can ever beat you. You have to be able to play that public persona of "no one can beat me," but then you have to actually do the training to make that happen. You can't believe your own hype and say that I can just do whatever I want. No one's ever going to beat me. If you have to switch between the persona and the actual athlete, and that made a big difference for me.
It's tough because like you dominate such a large fraction of the world in grappling, and George too, just the perfect dominance after those two. It's hard for the confidence not to just like how do you avoid the confidence not becoming a thing that weighs you down, where you completely lose your mind.
For me, it's just number one, the guys in the gym are so tough. So the guys in the gym that I train with are always like nipping at my butt and always giving me new problems to solve. And for me, it's really just about trying to learn new stuff over time. So that keeps it interesting for me. And it's not really about, no one can beat me. I don't have to train. I have to do it. I can do whatever I want. It's more what keeps me in the gym is more about the fact that I'm learning new stuff all the time and working on something new and progressing to new levels at all times. I don't just come in and do the same thing over and over again, and that gets boring. You just come in and you don't learn anything new, and you just do the same stuff for years at a time, and you go, okay, this is boring. But when you have new stuff to work on and new goals, short-term and long-term goals reached, then it makes it interesting.
It's for me, it's a little bit like Gordon says, it's the fear. Because sometimes in the gym, even before I was competing, I was getting my butt kicked. But I don't care what happened in the gym. I mean, it hit my ego, of course, because I'm a proud person. I'm a competitor, even in the gym. But it's not a malicious competition. It's a competition between each other. When you fight, you have to be malicious. You go there to work together. But it hit me in terms of my pride when I got beat in the gym, of course. But that fear that I don't want it to happen in public, especially not during a fight. That what help me keeps the balance, confidence, and fear. You know what I mean? It's kind of weird. It's a mixture of both that I believe, to me, helped me succeed to have the right mindset to fight.
And I talk so much shit that I'm like, man, if I lose, this is going to be rough. So
Yeah, you put a lot of. I mean, that's the hard thing to do when you talk shit when you play the heel. It's so much the pressure is. I mean, you have to be good under pressure. It's the Conor McGregor thing.
the reason I actually started talking shit was actually like indirected because of George. because
I will become the opposite of George.
I won my first PBI, and I didn't talk shit, and everyone was like being like, oh, you only beat Yuri because he was tired, or this or that, and if they have a rematch or any other rules that he would have lost. I'm like trying to figure out what I'm going to do. So I'm scrolling through George's feed one day, and he posted a clip of him beating someone. And I look at the comments, and with this in mind, I'm like, George is the nicest person of all time. And if you look at the comments, it's like 10,000 comments, and like 9,900 are just people calling him like, all you do is lay and pray, you pussy, you suck, you can't finish anybody. And I'm looking at this, and I'm like, people are going to say what they're going to say regardless. They're going to talk shit regardless, so you may as well just say whatever you want and then just be yourself.
Is there some aspect, as I mentioned, Conor McGregor, he crossed the line with Khabib, well, at least in the eyes of Khabib. Was there something you ever regret about crossing the line, or do you ever feel like there's a line, or do you just keep pushing the line?
I basically play it per person. I basically fire back with like one step above what they do.
It's always plus one.
Yeah. So I usually go hard, like they fire a bullet, then I drop a nuke, and then after that initial shot, then we go back and forth, and I'll just keep one up and go.
So there's a lot of people that love you, but there's also a lot of people that love to hate you.
Yeah.
So, like, what do those people like energize you, or do you just, or is it funny to you? Like, what as an athlete, as a performer, you should not think about them. It's like a fun thing inside.
It's just like a fun thing that you see outside. Like because most of them that like talk shit, they like just say stuff that's factually incorrect. So then I just argue with like actual statistics. And it's just like you suck or you're not going to beat this person. I'm like I've already seen it that way. So it riles them up, and it's just a fun thing for me to do. Like my downtime.
Yeah, your responses are usually very factual, very scientific. I appreciate it. Like you start by talking trash, but then you respond with science.
Yeah,
it's great.
Okay, it's a good mix.
It's a good mix. I mean, on the topic of haters, or more specifically, sort of doubts within yourself or doubts around you as you're coming up. Maybe George, you can comment. I'm just ignoring John completely in this conversation. I was going to ask you another question, but let me just ask you on this topic. Are there times in your life that you were surrounded by people that doubted you all the time? And so, is there something you could say by way of advice how you overcome the doubt, either yourself or others around you?
The first time I manifest my desire to become a professional mixed martial art athlete, everybody doubted me. I'm not talking about UFC, just become a professional fighter, everybody doubted me. And I became a professional fighter. I had a few amateur fights. I won them all. Then I fought my first fight in Montreal. I won. I became a professional. Then I told people that I wanted to fight in UFC. Everybody doubted me again. So it's a normal thing. So I worked my way up, beat a few guys that at the time, Pete Spratt was just knocked out Robbie Lawler with leg kick. And the person who was my agent at the time did a great move for me. So he brought Pete Spratt in Montreal to fight me. Pete Spratt came to Montreal, and I believe he didn't know who I was, so he thought that he was coming to collect an easy paycheck, and I ended up beating him. So that gave me the opportunity to fight in UFC. And after I was in UFC, I wanted to become champion of the world, But Matt Hughes was there, and he seems invincible at the time. So everybody doubted me again. I became world champion. And after when I was world champion, I was competing against other world champion of other weight class for the title, for the legacy and everything. So I was no longer competing against my opponent. I was, as a competitor, you never want to be satisfied, because when satisfaction is the death, and when you're satisfied, you better retire. It's over. So always have to find motivation. What you can have more. I want more. Don't be satisfied. So I wanted to be like the best. As I was competing, like become the best. And of course, that people doubt you all the time. Every time you say something that is outside of the norm, of the normality. When I say there's nothing normal, but I'm talking about when you manifest your desire to do something that takes special attribute to succeed, or that is something that is hard to for sure. You can always have people that doubt.
It's so strange that people don't lean into supporting like people that love you too.
Yeah, even people that love you doubt me. And I believe you need to use that as a positive thing, as a motivation to prove them wrong. Yeah. So for me, that was the thing. When someone doubted me, nothing gave me there's more energy because I want to prove it wrong. I want to look at him in the face and say, "Hey, you see it? I got you, man. I did it."
So, John, do you ever use this one way or the other by saying, "I don't think you can do this," to motivate them to prove you wrong, or more general question of, the mental toughness required to achieve, or confidence required to achieve greatness? Like, what's your role as a coach when you have these two athletes?
With regards to your first question, would I ever say to someone, "You can't do this," as a kind of reverse psychology? I know. Uh, my job is to prepare people first and foremost with their skills. And as Gordon pointed out earlier, if you're in any way a rational human being and you are noticing that you're getting tremendous success with a given move in the gym against high-level opponents who give a good read on what your actual opponent in a competition is like, you would have to be a moron to not recognize that kind of success and say, "This is something I should be building in my game," and you will carry the confidence that you earned in the gym into the arena. So I never try to use reverse psychology. I feel that everything I do in terms of confidence is to give people physical skills. I know people say, "Oh, there's physicality on the one hand, there's mentality on the other," and confidence is squarely in the mental aspect of the game. But all the underpinnings and beginnings of confidence are physical. Okay, a rational human being will see where they're having success and where they're having failure, and confidence will surround those areas where they're having success and will degenerate in cases where they're having failure. So my job as a coach is to set them up for success in the gym with a given set of skills, and I don't have to do anything psychologically after that. If I can set you up to be highly successful with a given move or a set of tactics 10 times in a row against quality opposition in the gym, I don't have to do a damn thing when it comes to instilling confidence. I will tell people, "Hey, you're doing a really good job with it. It's working well for you." But when they nod in agreement, I'm not trying to force anything on them. They already recognize that harm before the words came out of my mouth. But on the other hand, intelligent, rational people will recognize when they're failing with given moves, and no amount of talk on my part can ever change that. If I teach Gordon a given arm lock, and 15 times in a row he tries it over a month, and all 15 failures, there's nothing I can say verbally to Gordon say, "Hey, you're really good at that move." He's going to say, "Bullshit, I'm terrible at it." And that will create a crisis of confidence where Gordon no longer believes the words coming out of my mouth. So we never compromise that.
But isn't there a line? You just said 15. You have to believe that doing this arm lock 15 times over a period of a month is worth it, because eventually you may get it.
And, that's a separate issue. That's a separate issue. But, there are times where I've more or less pushed athletes to go in a certain direction. For example, when I first met Gary Tonin, he never had a guillotine strangle. And I would say to him, "Gary, you're a scrambler. Like, one of the greatest weapons in scrambling you ever develop was a guillotine. It should be in your arsenal." And he was like, "Yeah, no, it's scramble from the back." I said, "Well, there's got to be a day you can't take someone's back. And it's always good to be able to strangle from front and back." Okay, of course, we all prefer strangles from the back. That makes sense. But there's going to come a day where it's going to be useful for you. And so that was one of the few times where I put my foot down and said, "You're learning this, shut the fuck up." And
He literally wouldn't teach him anything else until he got a guillotine. You know, if Gary would ask him a question, he's like, "Let's see your guillotine."
and for the first 3 months, as gifted as Gary Tonin is, most moves Gary gets it in minutes. There was something going on where Gary just couldn't get a And finally, after around 3 months, he started having some success until ultimately became one of his best weapons. We had to go through like 15 different variations of guillotine until he found one which actually worked reliably for him. And that was one of the few times where I put my foot down and said, no, you have to learn this.
So the long search had to do more with the physical characteristics. Like you had to figure out the right.
Like it made sense. It made sense in the case of Gary Jones because there were more opportunities per minute of his grappling or guillotines. The investment in time is worth it. For another athlete, I might have said, well, he hardly ever gets in a situation with front headlocks or guillotines. That's not even worth investing the training time.
Let me ask you a question on the competition side. You mentioned haters, and do you think about this aspect of the competition, the athletes?
This is a great question, and the answer is no. I'm. You can see that you couldn't find two more polar opposites psychologically than George St. Pierre and this one Cynthia on my left. And I've never said to my athletes, hey, I think this is the sort of demeanor you should carry yourself with. I'm myself a very flawed character, and I'm the last person on earth who should be delving out moral advice to other people. The only thing is that of course, I believe some things are off limits, but as long as it's done in the context of sport where no one's physically attacking people and doing anything crazy where it just goes completely over the top, then I give almost zero moral advice to my athletes. I'm a jiu-jitsu coach, not a preacher.
And next, if I may, we are entertainers. You know, we're athletes, we're professional athletes, but we make a living because of people want to see us perform. Same thing an actor, same thing a singer. And a lot of the time, especially in the fight game, an event is promoted. It needs to be with emotion. Love me, hate me, but do not ignore me. And you know, when it's authentic and it's done well, I think me, my favorite fighters to watch are the ones that have some sort of a bad persona. I really enjoy watching those guys because they bring an emotion into a fight, which is great. You know, I feel to me it's more interesting to watch when there is emotion involved, and I believe that's why some fighters make more money than others. You know what I mean? That's the reason why we can make a living.
Yeah, they're better entertainers, but you're right, the authenticity.
There's actually something very interesting there. It's time to break out some secrets. You know who, like you think of George St. Pierre, you think about the highly technical, polished martial artist. Do you know who his favorite fighters to watch were? You'd probably be thinking, oh, probably someone who's really technically advanced. And actually, it was Mark Coleman, Kevin Randleman, and Phil Baroni. He used to love watching them. That was a Hammer House. That was his favorite. He would love those guys. And whenever their fights were on, George would watch the Hammer House crew. And it's funny what you said about how those guys brought an intensity to MMA that was off the charts. If you ever met those guys in the prime, let me tell you, it was something to behold. And they had this crazy, larger than life personality. Most things they did make no sense whatsoever, but being technical, but that was their appeal. And these guys, and George loved to watch them.
You never knew what could happen with these guys. I remember when Mark Coleman won the Pride Grand Prix. I was in my living room. I was jumping. I was so happy. I was like, yeah! He beat Igor Borchevchin. I was like, to me, it was amazing. You know what I mean? Because of the emotion that they brought to the fight.
George is actually very interested by something he said there. Normally, when I ask what is the appeal of a given fighter and what makes me watch a fight, you talk about the idea that fighters are entertainers, and that's absolutely correct. They are. It's this weird industry where you're both an athlete and an entertainer. and you need to be successful in both regards to become financially successful. Insofar as your favorite athletes to watch, at least, the people who are almost like the polar opposite of who you are. I've always said that most people, if you look at, say, 1 million people watch a pay-per-view event, what percentage of those 1 million people have a genuine technical understanding of what's happening as they watch a fight? It's tiny. It's absolutely tiny. The vast majority of people who watch a professional fight have almost no technical understanding of what's going on in front of them. So how do they relate to the fight? What's the only way they can? It's through emotion. And so when they get a sense that these two don't like each other, then they can relate to the fight. But only a tiny percentage of people watching a given professional fight can relate to it on a technical level. The overwhelming majority will always form an emotional attachment to the fight. That's why when you see things, shows like UFC Prime Time, they never focus on tactics and the techniques of the fight. They focus on the emotional elements, the preparation, the view of their own family members as athletes get ready. It's always an emotional pull, because that's how 99% of the viewers relate to the fight. If I have, think about chess, okay? If I have minimal knowledge of two world champions coming to fight each other or match up against each other in a game of chess, I know so little about chess tactics, and I can't really form any kind of technical appreciation of what's going on the board. But if you tell me that these two chess players hate each other's guts, and they've got a rivalry which goes back 5 years, and they've said this and that about each other in public, then suddenly my ears pick up and I'm like, oh, okay, this sounds interesting. Because I just don't have the knowledge to appreciate what's going on the board in a chess game, to be able to appreciate the technical nuances of what they're doing. So any interest that I have in a chess match is going to have to come from some kind of emotional level, because I'm just not qualified to make technical assessments. And that's exactly how it is in the case of both grappling and mixed martial arts. That's why the ones who evoke the most attention are always the ones who can form some kind of emotional appeal. Conor McGregor was the all-time master of this.
I believe also emotion can be used as a weapon. For example, I've learned this from my favorite boxer, Sugar Ray Leonard. Sugar Ray Leonard, I remember, I was very young, so I watched his fight later when I was older, but I know that Sugar Ray Leonard was the best boxer of his era, to me personally. And I don't think nobody could beat him. I think it was skill-wise, it was the best. However, when he fought in Montreal, Roberto Duran made it in a way that Leonard became very emotional. He wanted to stand in front of Duran and fight a different fight that he normally does, because he wanted to show that he's a man. And he lost that fight, which was a mistake. So then later on, he beat Roberto Duran quite easy. Everybody remembered the no last thing. But my point is, emotion can be used in a way that it can derail your opponent out of his game plan. And I felt a lot of my opponent trying to do that. So that's why I never got involved. That was my way to defend myself against some kind of bully, to put like a shield in front. Some other guy like Gordon, he expressed himself differently. Of course, there's a language barrier, but for him, he's better at giving back. He's a better counter attacker. But that's the way he responds to the aggression of an emotional attack. I think everybody is different.
What's interesting that John said that he doesn't study the tactics of his game, or maybe you're not interested in the tactics of his game, because it seems like this is more than just being an entertainer. It seems like it could be an effective part of the match.
Yeah, I just feel like whatever investment you make in that it's going to get negligible rewards, because it's probably going to pertain to one match in front of you rather than the totality of your career. And whatever gains you get out of psychological trickery and play, typically don't last long. You've raised an excellent example with Sugar Ray Leonard. He did fight outside of his usual manner in that regard. But rather than me try to tell someone, hey, behave like this before a fight, I would have been probably more forceful between rounds with an athlete and saying, no, you're fighting this fight the wrong way. That would have a much more beneficial impact on my athlete than psychological trickery before a fight.
I believe another example of emotion that leads to failure is Jose Aldo against Conor McGregor. I think it was on purpose that Conor McGregor did this, tried to bait Aldo to become over aggressive to open himself because he's an excellent counter puncher. That's what I believe. He made a mistake.
There's another great one. My match against Cyborg, 2018 W Worlds, where he didn't even try to win. He just like wanted to smack me in the face the whole time because he was so angry. I was talking shit to him before the match, and it was like the finals of the Absolute. It was like the biggest match of the weekend, and he just didn't even try to pass my guard or do anything. He just wanted to hit me in the face, and I was like, sick. I just won.
It was incredibly frustrating.
Yeah.
It's fascinating to watch. It's like a grown man sort of lose composure.
And Gordon, one thing I've always been very impressed with you, and that's no matter how heated talk gets before a match with you, when you go out to grapple, you're absolutely cold. You've never gone into a match carrying anything other than just cold-blooded calculation, and you've always been able to separate very well the idea of words and deeds. And I think that's always been one of your strongest assets. The way I often measure this is when a match is over, I will ask the athlete questions about the match. And if they can't answer the question, what were you doing in the fourth minute? Okay, what was that setup you used in the third minute that got you into the Kimura lock? If they can't answer that, that tells me they were just fighting on instincts and emotions. But with Gordon, it's like a logbook. It's like, okay, the seventh minute you went for that duty time setup on the left side. What were you thinking? You can always give an answer. He's absolutely stone cold.
Speaking of emotion, Gordon, you will potentially, if you're healthy, face Andre Galbao in the ADCC Lebanon super fight. Who is Andre Galbao for people who don't know? Can you tell the story of your beef with the emotional interaction with the man?
Yeah. So Andre is he's considered the greatest ADCC competitor of all time, multiple-time black belt world champion, winningest ADCC champion ever. He has six gold medals, and I've been trying to compete against him pretty much forever. Like since I got my black belt in 2016, I've been trying to get matches with him. He was in the first EBI that I did, and he ended up pulling out. And then I've been trying to get matches with him, and he would always say no and give one reason or another. And then after the last ADCC, I was like, hey, Andre said he was retiring after this competition. So if he wants to retire, he's the greatest ADCC competitor of all time. And I think it's great. But if he wants to compete, then that's great. That was like super nice. And then he started like posting like past aggressive Instagram captions, and then we started going back and forth on the internet. And it was like one point where I saw him in person when he acknowledged, like, I understand like what you're doing, like I'm gonna pump this fight up, and he was like totally on board. But then there must have been something that happened where like he changed from like him like going along with it to being like actually pissed. And then there was the one night at Flow where I went to go shake his hand, and he flipped me off, and then he followed me backstage and started to try to fight me, and then I smacked him, and then he didn't want to fight anymore. And then we've been going back. He's actually blocked me on Instagram now, so he just won't engage. No one from Athos won't engage now, but it's going to be interesting how he shows up, if he can keep it under control or not.
Do you think, how do you explain that level of emotion? Is this fear of losing your throne? Is it just a human being like with Cyborg just becoming emotionally unstable?
It might just be me. I just have a way to get under people's skin and just, I don't know. He's he was cool for a while, and then I don't know. Then everyone gets like this. They're all so emotional by the time they actually step up to compete that it's pretty easy to read them. They're either so emotional that they want to actually come forward and beat me, like Tim Spriggs is a perfect example at ADCC. I posted on my story on Instagram 10 minutes before a match. I said what I'm going to do to Tim Spriggs is going to be criminal. And he's a very stolid guy, and he saw that, and he came out and actually tried to fight me. But he came and actually engaged my guard, and I ended up submitting him. So it either has that effect, or it has the effect where they know I've talked so much shit leading up to the match that they're so afraid to lose that they just get super stalled in and move away. So it either has one effect where they come forward and they want to beat me, or they're so afraid of getting submitted that they know if they engage, they're super cagey and they just back away and don't really do anything.
Do you think this match happens?
There's a lot of variables. One, I have to see how my stomach is. And two, if I'm actually going to show up and compete, my stomach's healthy, I doubt that Andre will actually show up to compete. I've been trying to compete against him for 6 years, and he hasn't done it, so there's no reason to think he would now.
Is it possible for you to speak to where your estimates are about your stomach, or is it not too unclear for that?
It's still too early to tell. I have this round of treatment that I'm doing until late February, and I'm pretty sure that I need to do the same test they did initially to retest all my levels, and then go from there. So I've been feeling a little bit better. It's not nearly as bad as it used to be. I was explaining to someone the other day, the last 4 years, I would be so nauseous that every time I would walk into a new room, I'd have to actively locate a garbage can in case I have to throw up. So I'm one step above that right now. I'm doing a little bit better than that. So it's definitely getting a little bit better, but it's not where it needs to be.
Can we talk about diet for just a second? Because both of you, George and Gordon, suffered from stomach issues of different kind, and have arrived for now at different places. Can you maybe, George, speak to the general question of what is the best diet for performance, for training? What have you learned through your career about this?
Well, I think everybody's different. To me, personally, I implement fasting, time restricted eating, and prolonged fasting.
What's the longest you've done so far?
The longest I've done is 5 days. I do it quite often. I do 4 times a year. I do 3 to 5 days water fast. And I liked it. It helps me with inflammation. I think it boosts the immune system. And that's about I read papers about this. And it helps me also feel good. It's kind of very therapeutic.
Physical and mental, or just mental?
Yeah, mental and physical, because when I break my fast and I sit at the table with other people, it doesn't matter what I eat. If we all eat the same thing, I always tell them, I said, my food right now tastes better than all of yours, because I have this thing that I believe sometimes you need to put yourself into suffering to realize how pleasurable something is. And I tend personally, diet wise, I eat whatever I want, whenever I want. I no longer have any problem with this. But if I would have a competition coming up, knowing that what I know now about my body, I would orient myself more towards an animal-based diet. That's because I tried different things, and that's the kind of diet that I believe helped me having less inflammation and feel better in terms of performance for doing something physical.
So high protein, high fat.
Well, it's different between animal-based diet and keto. I mean, there's carbs. There's a lot of fruit. I get a lot of the carbs from the fruit. A lot of organs. I know a little bit about paleontology and the past about prehistoric human, and I know that. And not only about that, I know because I've traveled certain places in the world. I went to visit the Maasai in Africa, the hunter-gatherer tribe. And I know that when they kill an animal, they go for the organs first. And I know most predatory animals, they do the same thing. So organs,
I believe is something that normally in our culture in the western part of the world we don't really eat, but it's something that is very nutritious.
Have you been able to convince Gordon to try fasting?
We always talk about diets.
It's a different situation. I think for Gordon because he's a heavyweight. He doesn't want to lose weight. When the heavyweight, the range of like my range was like I was a welterweight, but middleweight, but the heavyweight. It's like some of the guys you can compete against. It might be 300 pounds. So if you lose weight, it's a big problem. You know what I mean? So. And there's things that will work for me that might not work for Gordon, So we have to make his own experience. And I told Gordon, sometimes when everybody goes left, try to go right, see how he feels it, sort of thing.
Experiment. Not a topic that's part of your optimization, optimal performance formula.
Well, what I used to do before my stomach issues, and for those of you listening who don't know, I had recurring staph infections in 2018, and I took oral antibiotics, and I just completely wiped out my stomach. So I just was diagnosed. It was misdiagnosed as gastroparesis. So for those of you messaging me on Instagram, who are just watching Rogan, asking me about my gastroparesis, that's not what I have. They misdiagnosed it, and I did some other tests. And for 4 years, I didn't even know what it was. And then I got this, this doctor in California who diagnosed me with H. pylori, and then a fungal and a bacterial overgrowth in my small intestines. So the issues in the small intestines. So what I used to do was like seasons where I'd have a very clean season where I was competing. I would have a lower body weight. And I would do like an off season, kind of like a bodybuilder, where I would eat a lot more food and a little bit dirtier food. And I would have cheeseburgers and pizza at nighttime to have the extra calories. But now I can't eat those foods because they upset my stomach. So now I pretty much just try to eat whatever I can and maintain the weight the best I can based on how my stomach feels. So right now it's like rice, chicken, eggs, fish, vegetables, fruits, and pretty much nothing else. Like anything hard to digest, anything spicy, red meat, fast food, all that's hard for me.
Which sucks because it's
All best things. Barbecue.
And I mean, this diet is really important for you, John. I can tell. Like, is that something to think about for athletes at all? Again, this is part of it.
I've to be honest with you, I've never seen any measurable improvement in sports performance in jiu-jitsu by change of diet. I do believe that diet is important for longevity in human beings, and I do think it makes a difference, especially once you get past the age of 40, with regards to longevity. For older athletes, I do believe it makes some difference. But my observation is in athletes and in their youth and working up into their prime, I've seen athletes have the worst diets. God bless Travis Stevens, but that guy won an Olympic silver medal basically on McDonald's and candy. George St. Pierre, for 80% of your career, you were powered by McDonald's and Coca-Cola.
And Eugene Alfredo, that was my meal of choice before a championship fight.
Gordon, for him, his youth was just Five Guys, hamburgers. Gary Tonin, same thing. I've worked with Japanese judo players who smoked a pack of cigarettes a day and won Olympic gold medals. I've worked with Russian wrestlers who just ate whatever was put in front of them, and their athletic performance was outstanding. I've worked with other guys who did have what would be considered a very clean diet, and their performance was no better than anyone else on the mat. So I've never seen someone say, okay, I changed my diet, and because of that, there was a measurable improvement.
Another way to phrase it, though, is I have noticed with a lot of elite athletes, what they eat, they begin to believe that either it's not a hindrance or it's actually good. And Travis Stevens is an example of somebody who eats shitty because he believes it's like a power, because whenever he's traveling across the world, he can't rely on healthy, good food to be there. So I'm going to eat shitty so that my body knows how to perform under whatever Skittles or whatever. Everywhere's got McDonald's. So that makes, and they convince themselves. You talk about Russian athletes, a lot of them have very strong beliefs about this a particular food being good for them.
There's no agreement among them.
Exactly. There's no agreement.
Yeah.
So belief is more important than the actual diet.
Yeah.
but again, after after a night out, when you're hangover, I think the best thing, and I'm saying this with all sincerity, I think the best thing to eat to me was like a cheeseburgers with we call that a pizza tacos because it's very fat, it's greasy, so the next day when you wake up, I think you feel better. It absorbs the alcohol.
There you go. 100%. My mom told me the same story once, and then I tried. It was like I was hungover for some party, and I woke up. I was probably I don't know 19 or 20. I woke up, and my mom was like, "Yeah, just have a cheeseburger. Go eat something greasy." And I didn't. I was like, "Oh, I feel kind of better now."
I do not know the science, the exact science, but I always notice, and I don't know if it's placebo, but I always notice that if I party hard and I've been drinking a lot, if I don't eat before I go in, I don't eat shitty food, the next day I will wake up and feel worse than if I eat shitty food, I feel better. I know it sounds crazy. I don't know why, but it works for me.
Yeah, but it's also hard to decide on extreme performers. So the discussions we're having is amongst the very elite. This might not apply to a general recreational athlete, but for the elite, I've just seen champions in every kind of combat sport. I've never seen a correlation between dietary habit and performance in people under the age of 30. I do believe the diet is important for longevity, however, and for that alone, it may well be worth investing time in it. But with regards to sports performance, at least in jiu-jitsu, I've never seen any significant difference.
Well, we had a little bit of a difference of opinion on this, I think. What about strength training and muscle building? Or at least we had the discussion about this. So what do you believe is the value of training outside of the sport? So fitness, lifting heavy, lifting explosive, all kinds of lifting.
Personally, for me, I believe, and I heard that from John. I used to do to train like a bodybuilder before because I thought in my early days of competition that was the most efficient way to do things. Because it was like I was watching Jean-Claude Van Damme, Arnold Schwarzenegger. We thought back in the day that was the thing. That's how we should do it, to get ready for a fight. But I realized later on that it's all about efficiency. Some guys, they don't lift at all. They do it pretty well. So I do cross training mostly for longevity. It's mostly for like a therapy. It's more therapeutic than for performances to keep my body healthy, to do certain movements that are different than what I do every day in the gym and combat sport. Keep me healthy and athletic.
So all the interesting movement stuff that you've done outside the sport, that was
Therapeutic, mostly therapeutic. I think it could transcend to performance, but it's mostly therapeutic. I do not believe that squatting 5 plates or bench pressing 3 plates will make me a better fighter. I do not. I believe actually it could hurt me more. It could damage me more than benefit.
So, according to somebody who on Instagram posts a lot of pictures of you being shredded and huge, what's the value of strength?
So I do like a combination of John got us big into like gymnastic type movements, like toes to bar and muscle ups and things like that when we were young. Like toes to bar because that's like the exact motion you have to do when you're retaining guard, knees to chest. So I do a lot of that stuff in combination with I do a lot of opposite of George. I do a lot of bodybuilding workouts where I do like a basic split, like a chest and triceps, back and biceps day. And my idea is that weightlifting should always be a supplement to jiu-jitsu. So you should be missing a jiu-jitsu session to lift weights. So I do probably train jiu-jitsu every day, and I lift 3 to 4 times a week. I feel like lifting 7 days a week is too much. Lifting takes a lot of energy. I feel like hard lifts like that. But my idea is, if you want to get good at jiu-jitsu, do jiu-jitsu. And if you want to be bigger and stronger, lift weights and eat food. And I generally don't go super heavy when I lift. You start putting moderate weights with a very high rep range of 4 sets of 20 with a drop set at the end to fatigue muscles, break the fibers, and grow.
Okay, so 4 sets of 20. That's interesting. So that's more for endurance than raw strength.
Yeah, and also I think closer to competition, I'll pick the intensity up, and while there's no real way to get significant gains in VO2 max, I think that lifting and just getting used to mentally redlining gets me kind of in competition shape. Because a lot of times in jiu-jitsu, the guys I'm training with, they're not on a technical level where they can physically exhaust me to the point where I feel like I'm going to die. But I get most of that like when I'm wrestling, because I'm not as efficient in wrestling, so I get a lot more tired. And lifting, if you do like 4 sets of 20 leg press to squat, and you go back and forth, like you're like about to die at the end. And I feel like it gets me in the mental habit of redlining before competition.
But does muscle help you? It's like the actual mass of muscle, like this. So
I think being stronger will always help in a combat.
will always help.
Yeah, to some degree. It's not going to be to a degree where it overrides efficiency, but I think that it can't help being or can't hurt being stronger.
There's a bunch of people who believe, depending on the sport, that the strength can quickly become that have detrimental effects to efficiency.
Yeah,
like
I agree with that.
certain kind. I mean, if strength is like very cleanly, purely applied to the exact movements of the sport. So in judo, the explosiveness you need is very difficult to replicate in any kind of way except by doing judo.
I mean, for us, you always have to understand there's only so much technique that can overcome a certain amount of strength. Like if we all try to fight a silverback gorilla, it's going to kill us. But that being said, I do think that, like, for example, heavyweights, they're usually the least technical because they rely on their size and strength to beat smaller people. But I think that if you stay with the discipline of doing everything very precise, and I train with a lot of smaller people most of the time, so I get out of the habit of using my strength. I think if you're very precise the way that you train, I think the extra size and strength can help you.
Quick question: how would you fight a silverback gorilla? I mean, which animal do you think you can actually defeat that would be impressive? That most people would say you can't.
You know, I don't have an answer to this.
I thought you
But I want to say that me and John had like a 4-hour discussion on this one time. I'm like, what would win, bear or gorilla? And he went into like this whole dissertation about how like jaguars spin underneath like barrenboa silverbacks and kill them and like rip the artery in their legs out. It was amazing.
I guess so. Before we talk about strength, now let me ask: what do you think people would be surprised by if two animals faced? One of them would win, but people wouldn't predict that. So they would be surprised by the effectiveness of certain animal at fighting, whether it's in the forest, in the jungle. So let's slow down here. Okay. So there's two animals of different species fighting, and most people would pick. So, for example, the lion gets a lot of credit for some reason. I'm not exactly sure why it came in the jungle. Well, a lot of people told me that the lion, for example, the tiger can beat a lion. This is one of those age-old debates. Well, in grappling, in fighting, it feels like some animals use teeth and some use other parts of their body also. Like a bear, actually, I don't even know how they. I think they're extraordinarily powerful and long claws, and in addition, they have powerful biters as well. So I wonder, and the same with the silverback. I don't know how much they're. I love that we're having this discussion. We need your road discussion. I think so. Yeah, I think so. Your question is going in about 5 different. So it started with strength, and let's go back there, which is, do you think for an athlete in jiu-jitsu, let's stick to grappling. Do you think strength is helpful or detrimental? I've always believed that two things will create whatever effectiveness you have in grappling. Those are your skill set and your attributes. And the best athletes are those who excel in both. Don't kid yourself. If someone gets twice as strong by some kind of magic potion, they're going to be a more effective grappler. If someone gets
twice the level of endurance that they had previously, they would be a more effective grappler. These physical attributes have a very important outcome on the, sorry, a very important effect upon the outcome of matches. It's always a good thing to be stronger. It's always a good thing to have better endurance. It's always a good thing to have better balance or whatever other attribute you throw out there. Gordon's point was, okay, everyone agrees on that, but there's a problem. In order to build these things, you have to carve into other elements of your training regimen. And then it becomes, well, which becomes more important? Increases in strength or increases in skill? There comes a point where investing in strength training starts to get diminishing returns. I can't tell the difference between someone who bench presses 300 pounds on the mat versus someone who bench presses 400 pounds. But that's a big difference. That's a 100-pound difference. And for an athlete to go from bench pressing 300 pounds to 400 pounds, that would require a great deal of training effort and focus. But if I can't tell the difference when I grapple with them, why bother? Okay, once you get to a certain strength level, it doesn't really help that much to go from a 400-pound bench press to a 450-pound bench press. That's, let's say, you're really getting a diminishing returns on your training investment. Now, skills, on the other hand, have experienced far, far less in terms of diminishing returns. Every new skill you develop can translate very, very well into big increases in performance. Look at the example of Gary Tony that we talked about earlier. Investments in guillotine made significant improvement in his effectiveness in matches and led directly to some of his most important victories. But if he'd invested the same amount of training time in developing a bench press that was 25 pounds more than previously, that would have had no outcome, no focus on it in those matches. So the question always becomes, yeah, everyone acknowledges that these physical attributes are important, but everyone understands that becoming stronger or fitter is a desirable thing, and every athlete should work on it. The interesting question becomes, okay, at what point do you start to say, I'm not going to be helped by further increases in strength training or endurance training? And my point with my athletes is, in the overwhelming majority of cases, if there's any kind of doubt, invest more heavily in skill training than attribute training, especially once you get to a certain level on the attributes.
But the interesting thing that I think you should account for with strength training is there's Instagram. There's a world. It seems to be more fun to build muscle mass. It's like an addiction that people have.
But there's also economic elements too. Like most people, I hate to say this, but it's true. Most people are more concerned with image than function, and it's hard to sell a fighter or a jiu-jitsu athlete who doesn't look like one. It's like Vader. Yeah, it's a tough sell. Now, you can do it in fighting and jiu-jitsu because ultimately it's about whose hand is raised at the end of the match. And you can even use it as a selling point. You can be a guy that doesn't look like he should be winning, but he is winning. That is a selling point. But if you give most people a choice between looking like Arnold Schwarzenegger and winning matches versus looking like Fedor and winning matches, most people will select, I wish I looked like Arnold Schwarzenegger. And so most athletes feel almost like an economic compulsion to be in good shape and in order to advance their marketability.
Yeah, Nike's not going to sponsor Fedor or Tank Abbott.
Yeah, Tank Abbott, no, they go
We did, yeah. We at the very top. There's something about aesthetic, the image of strength. So it's also a personal thing. If you look at yourself in the mirror, you like what you see. You know what I mean? You find yourself attractive. You know, what can you do to make you look better? And I think to me, it was one of the reasons I work out. Was that. Well, I'm sure if Fedor looks in the mirror, he says, "I look damn good today."
It could be too, but it's also a genetic factor. Some people, it's harder for them.
All right, so question on training. You guys, John, Gordon, train often 3 times a day, every day. George had a different approach to training. So, what no, I don't mean that kind of the opposite or something. It's just not every single day. So, and obviously you are legitimately at the very top in terms of performance and accomplishment in the field. So what have you learned about what it takes to train to become not just the elite but the best? But a lot of people when you say train, they see training hard. I believe you need to be very constant and very disciplined. You need to train, but you don't need to train hard every day. That's what John taught me. Um, for me, the nervous system, sometimes I feel if I load it up too much, it comes to a point that it's too much. There is no more information that I can absorb. So, and I do believe that it's something that you can train to your capacity of being able to learn, of absorbing certain things. And I did a lot of volume of training, but when I was getting ready for a fight, especially during sparring day, I like to do it quick because when I fight, it's 5 rounds of 5 minutes. I don't like to spend an hour or 2 hours in the gym because I need to know how hard I can be going for 25 minutes. Like not for 2 hours, but 25 minutes. And my last fight, John and I were thinking of how could we make me more of a better finisher, or more opportunist. And John, I remember when we were training with Gordon, Jake Shilkane, Gary Toner, my round of grappling were different than be training for Abu Dhabi, for EBI or like in grappling the round are longer. In a mixed martial art fight, it's very rare that you're gonna spend more than 4 minutes or 4 minutes and a half on the ground. It's very unlikely. I mean, it can happen. But so you remember we did the round 3 minutes. We did all the round I was doing were 3 minutes round. So it gives a different rhythm to the training. It forced me to be more opportunist, to be more of a finisher, because I had only 3 minutes to do what I needed to do. So if I see something I need to go for the kill right away, I cannot be too over patient. You know what I mean? It served me well in my last fight, and I think that's a good blueprint to follow when you're a mixed martial art fighter. The result was great, and I think maybe I should have done that before. It was a great idea that we had. Not to do, be very careful and do too much volume.
Yes.
Just try to get out and then try to focus on finishing, getting out as
I mean,
quickly as possible.
to build up your foundation, I believe you need a lot of volume. But when you get ready for a competition, you need to be something that replicates what you're going to be facing.
What are we talking about? What do you think? Like, is there rest days, 5 days a week, twice a day, once a day? Is there any one formula like that?
I do not believe in overtraining. I believe in under rest. I believe you can be under rest, and people always link that immediately to the volume of how much volume they train, which it could be something else. How are you feeling emotionally? Are you having problems, personal problems? You have a hard time sleeping because that someone died, or I don't know, like you owe money, you're broke, or whatever. Like, you know what I mean? It could be anything. There's something that can affect you psychologically or emotionally that made it in a way that you cannot sleep well because you're stressed, your cortisol level is high. You know what I mean? All these factors need to be taken into consideration. It's not only about the volume of training. People always think the volume of the training is the only thing that can affect recuperation, which is not.
Yeah, you have to minimize the amount of stress from all kinds of factors.
It's a very stressful job to be a professional combat athlete, whether you're a grappler, a boxer, a kickboxer, a fighter, and you need to be taken into account.
Is it more or less stressful Next question. So I don't know how to ask this question, given what George just said, but training 3 times a day and finishing. What have you learned about what brings out the best in you as the grappler?
So over the recent years, I've actually changed it up a little bit. When I was coming up through from white to black belt, I felt that the volume was the most important. So it would be anywhere from like 3 to 7 sessions a day, going from school to school from New York to New Jersey. And I think the volume was very important to build the skills, where I just didn't know how to move my body and purple belt the way that I should. So I think that building the skills is super important. I think that early on, volume is very important. Now that I already have the skills built, I think that acquiring more knowledge is the most important. So I find that if I do so many sessions a day, if I do 3 sessions a day, I feel sometimes by the 3rd session, I'm just like so mentally, like there's so much information that's going through my head the first 2 sessions that I feel like I'm not even there mentally on the 3rd session. So I feel like doing less volume now, but having more mental clarity first session is more important because I already have the foundational skills acquired.
So a lot of your training is almost like just thinking, like learning.
A lot of it, yeah. So I'll do our schedule's been messed up since the pandemic because Tenzo's got shut down and they were using a French gym in Puerto Rico and now we're using a French gym in Austin. But once we have our own school, I have a set up schedule where I can pretty much just be there all day long. But right now I do like a lifting session in the morning and then I'll come in and help teach at Tenzo's. So I'm there mentally, I'm seeing what's going on and I'm playing around with ideas in my head. And then I'm there physically and very sharp mentally for the competition class during the 1 p.m. session. And then after that, I'll go home, I'll rest and get ready for the next day.
What have you learned seeing all these different athletes? Is there a universal rule that applies, or is it athlete specific?
First, one thing needs to be addressed is that George and Gordon play very different sports with very different athletic demands. Gordon can be in matches that range from anywhere from 6 minutes to literally hours long. As a result, the overall pacing and intensity of matches is massively different. Most obviously, there is no striking in Gordon's sport. Striking by its very nature is a much more explosive physical action than grappling is. Grappling is primarily isometric kind of sport based around isometric tension and endurance. George's sport does feature a significant amount of isometric tension, but the majority of it is based around explosion. So the physical demands of the 2 sports are radically different. In addition, the time of application is radically different. George raised a very interesting point. His matches seem long, 25 minutes for a championship match. I've always understand that the mixed martial arts fight at championship level, if it goes the distance, is really 5-minute matches. Each round is a match in itself, and that's exactly how you're scored. You're scored by who wins the most matches over 5 matches. As a result, the application of the techniques, especially the grappling techniques, has to be done at a certain pace. As George pointed out, realistically, the maximum application time you're going to get in most situations is somewhere between 15 seconds and 3 minutes. Even for a specialized grappler like Damian Maya, there's still a significant part of each round spent in setup time to actually get the match to the ground. It's very likely that at some point your opponent will stand up out of grappling and you'll have to reinitiate the entire process again. So that even for specialized grapplers, you might be spending only 3 minutes out of a 5-minute round on the ground. And as a result, you've got to get your work done in a very short time frame. Gordon Ryan, once it goes to the ground, and it can go to the ground because he chooses to sit to the ground, may spend the entire match in ground positions. As a result, the matches have completely different pacing, completely different physical demands, and the preparation that the 2 athletes go through
will reflect that. If George St. Pierre in training for mixed martial arts becomes fatigued to a point where he's no longer physically effective and able to do the consequences for that in animation can be very deep indeed. Okay, if you make a mistake in mixed martial arts because you're fatigued and tired, and you take a full power roundhouse kick to the head, that's some deep consequences. The grappler doesn't have to face that. You can be completely exhausted in grappling and just sit in the bottom of the mountain, just practice just survival skills. You just don't get submitted from bottom up. And that can still be an effective training session. Complete and utter physical breakdown of fatigue can end an athlete's career in mixed martial arts. The consequences of training through fatigue in MMA are potentially very deep and very disturbing. The consequences of training through complete physical exhaustion and grappling aren't really that severe. Okay, you just tap. Like if there's a problem, just tap. And so they're very, very different sports in the way you prepare for them. And a grappling athlete like Ryan can take many more liberties with physical exhaustion and the amount of hours a day you spend in training than you could with a mixed martial arts athlete. But it can actually be a benefit. Exhaustion as a framework of learning. So, like from a place of exhaustion, is there any benefit? You said being at the bottom of the mountain, sort of understanding jiu-jitsu, grappling somehow deeper, because you're excellent. Because then the only thing you have left in your favor is your technique, and then you'll see how technical you are. In addition, you'll get to explore realms inside your mind that we don't spend a lot of time in. And you'll learn a lot about yourself and your ability to endure, which will have potentially great benefits in similar situations and matches.
And there's, I mean, for me, for a recreational person, getting exhaustion allows you the great benefit to experience what it feels like to really get dominated at an even greater frequency than you otherwise would. And that there's something there. There's some animalistic thing that's very unpleasant. And then afterwards, it takes you to a place of like humility, and it forces you to rethink life in positive ways. There's something about dominance. If you get dominated a few times, you can rationalize it somehow, screw this up. But when you're exhausted and you have to do like 30 minutes or 40 minutes or an hour of just being dominated over and over and over, being submitted, I don't know. It's a very good process for other avenues of life. I find I can't explain why. I'm driving home, crying afterwards, listening to Bruce Springsteen, but afterwards, afterwards somehow you can think clear. You can see clear about what is the right path for life in all walks of life, like relationships, work, but also grappling. Actually, the grappling is the hardest one to see what you have to do. It clarifies other avenues, the humility. It removes the bullshit. It's like we see the world through some kind of fog and just removes it, and then you can see things clearly. I don't know what that is. I think it's important, like prevention, to push yourself, like something to see how far you can go, because sometimes you can go further than what you think. And it can boost your confidence. You can push yourself through a certain limit, and maybe you thought your limit was before that point, and you pushed through it. But like John just mentioned, it's a risky thing to do with striking, because if you're exhausted, you're gonna get brain damage. Grappling, you tap something, but you can do it also with strength conditioning. I like to run track. I do it all the time, track and field. It helps me to know myself better. I think it's important. It's a good point.
And it's like the scrimmage wrestling rounds we do. It's like, if you stop moving, that you're going to get scored on, and in your mind, like, there's no mechanical reason why I should give up the score here. But you're so exhausted that you're like, oh man, this is terrible. But if I stop moving, I'm supposed to. If I don't stop moving, I'm going to be twice as exhausted when we actually do stand up. So it's an interesting game you have to play inside your mind.
It's your pride very often that keep you
just want to lay down and beat it because we're completely exhausted.
What do you think is the connection, John, between this ego pride thing, martial arts, and actual violence with our ancestors? Do you think you ever plug into that? Do you think there's echoes of something going on there? Or like you mentioned you have flaws and demons. Is it deep in there somewhere? Do you think we're struggling with those demons?
Yeah, you'll need to patch up your question out with those kind of similar information.
Wow, that was not only am I being dominant in jiu-jitsu, I'm being dominant in interest.
I don't know, but I'm not that question.
It's that brother thing where they're like, okay, now we interview you.
But you went down the evolution.
Bob Lazar, what do you think? I mean, I don't mean just the line between what's martial arts and what is violence. I mean, there seems to be a gray area, and it connects us to the evolutionary ancestors.
Absolutely, yeah. I mean, I think there's deep recognition in all of us that, and this is the evidence for this is so easy to see in daily life. If you're walking down the street and suddenly hear a commotion, two people are fighting, you will see literally everyone on that street stop whatever they're doing and watch the fight. Humans are fascinated by violence, and you've got to ask yourself why. And of course, it's a recognition that for a significant part of our evolutionary history, violence was one of the most important elements in human existence. As much as we curse it, as much as we talk badly of it, the juxtaposition between humans' social nature and their need for each other to get along, to express love amongst the various members of the given community. There are disputes between humans that can't be resolved, and ultimately, throughout history, violence has been the number one method of conflict resolution, for better or for worse. And there's a recognition in all of us that this is where we come from, and there's a reason why combat sports have this thing where people will watch them and they might even be repulsed by them, but they find it difficult to take their eyes from it. And I do believe that most combat athletes carry that sense of their, even if it's on a subconscious level, this kind of belief that this is, you use the word pride, and I believe that's a big part of it. I believe that most humans have this sense of self-worth and pride, which they're willing to fight for. And if it gets crossed by someone else, they're willing to stand. And some people will stand more early, and some people will be pushed further back. But everyone's got that line beyond which they won't be pushed. And there's some kind of deep recognition in all of us that we have that somewhere within us, no matter how hard we try to bury it or what have you. And that's why I believe there will always be this eternal interest in combat sports. Now, I don't believe that most people today have any kind of respect for unrestricted violence or non-consensual violence. I think most good people are repulsed by that now. I'm sure that as humanity improves out into the future, that will become more and more widespread. But that's not to say we can't exercise these old evolutionary demons inside of us, and sometimes there are just disputes between different people, different cultures, different nations, where ultimately it's going to come into a shoving match, and that will degenerate further into violence. There's always going to be a need for humans to be able to express themselves through violent methods and to use physical force to get to their goals and objectives. Our need as humans is always to find a balance between the two forces of conflict and cooperation. We need cooperation because humans isolated from each other are more or less helpless and useless. In order to advance human communities need to build and grow. And so that sense of cooperation occurs in most of our daily lives. But there will also be irresolvable conflicts where physical force has to be used to form a resolution. And so most human beings find themselves swinging like a pendulum between conflict and cooperation. And that is something which really gives birth, I think, to combat sports. Because, sorry.
Well, I really have to ask you about this then. There's a guy from Harvard named Richard Brangham, and there's a lot of people that believe this. He wrote the book that basically there's a lot of people studying is what happened, how do we get from apes to humans, like what was the magic thing, right? A lot of people attribute it to fire and the ability to cook meat. There's a lot of different theories. So he actually, his theory, how do I describe this, is basically that the beta males won. That the apes that were able to cooperate. So the way you develop cooperation is that there's a big bad leader that the alpha male that you can only knock off their throne if you cooperate. And so we built big tribes that just excelled at cooperation by practicing the overthrowing the leader. And so, and anytime an alpha male would rise up, they would get we would develop our skill further and further of cooperation. And so we're all just beta males, the descendants of beta males. That's his kind of theory that cooperation is fundamental and it's so distinct to the rest of the neighboring animal kingdom. So I wonder what you think about this tension, violence, and cooperation. How important is this cooperation to the core?
Yeah. If you look at it in the different training room, jiu-jitsu and mixed martial arts, solo sports, a solo athlete steps into the cage or steps onto the mat. But all of your preparation is done in a cooperative training environment with many peers. And as much as it's an individual sport, all of your preparation is done as part of a group. There's a sense in which it's an interesting metaphor for humanity itself. Everything we do in life, we do alone, but we grow up in this given community and what have you. With regards to the whole alpha male, beta male thing, humans are, it's true, this spell is correct. Most primates do have very strongly defined alpha males who rule the roost and determine the entire direction of the community they build around themselves. Humans, on the other hand, don't have an alpha male in that strict biological sense of someone who's responsible for the next generation, dominates all the female population, etc.
Yeah, physically dominates.
But we do, on the other hand, have our own version of alpha males as far as we're political and sociological leaders who have a disproportionate impact on the direction of the community. So
was the cooperation allowed us to have a greater scale of hierarchy with the alpha male on top, with the alpha creature on top.
yeah, it's just fascinating theory.
In nature, we're very weak as a species, and we need to cooperate in order to evolve. That, I think, made us the top of the future.
If you look at humanity in nature, really the two things that seem to, more than anything else, determine whether or not a given human community will be successful in a predatory world are numbers and technology. Okay? The more your numbers increase, and the higher the technology for weapons and support systems you have around you, the more successful you'll be in a predatory world. So it's not clear that just killing off the idea of an alpha male is the single biggest thing. The rise of technology and the growth of community after the imposition of language, these are other things that would have been very, very important factors in humanity's rise. George, you made an interesting point. If you look at humans, just the raw material of humans would not be better. And a predatory kingdom, which is the absolute bottom of the food chain. We don't have a single effective weapon other than better than average endurance. That's about it. But you put us in a community who can talk to each other with language, give us the time to come up with technological advances such as metals. And suddenly a human will go from no combat effectiveness in the animal kingdom to a human arm with a simple metal tipped spear can kill damn near any animal in the animal kingdom working as a group.
I'll beat your silverback. I'll fight him in the deep water pool because he cannot swim. So I don't have to touch him. You're wrong. I'll get him into the pool. You know why? Because someone told me. Because I live in a community, someone told me that information. So I passed it on to
If he taught you, well, you have to convince him. You have to somehow convince him to join you in the pool, which is very difficult. It's very problem, very, very difficult. From a technical perspective, John, you've looked at mixed martial arts, fighting in general, and grappling. What's the difference between fighting and grappling? That's something I'd love to ask all of you. Maybe John, you can start.
When you talk about fighting, you mean unrestricted MMA type fighting.
Yeah, well, it's just like you said, unrestricted MMA type, but MMA type fighting. So there's street fighting, there's MMA fighting, and then there's grappling. It's really the sport of grappling.
You're saying the difference between MMA and grappling?
Yes.
Okay.
See, that would have been a much better question.
Yes. Well, the single, when you talk about grappling, you're talking about jiu-jitsu rules.
Yeah, I mean, you could maybe also mention different rule sets that somehow fundamentally change the sport.
In the sport of mixed martial arts, you've got two ways to inflict damage on the human body. You've got kinetic energy, which is done through striking, kicking, knees, elbows, fists, and you've got isometric tension used along the lines of lever and fulcrum, which can be used for strangulation and joint breaking. In grappling, you lose one of those. You're no longer allowed to hit your opponent with kinetic energy. You can do it accidentally, sort of throw, but you're not allowed to just knock someone out with a throw. Most grappling sports, it can happen, but it's relatively rare, and it's not encouraged by the rule set. So, you got close. So there's a sense in which in mixed martial arts you've got twice as many problems to deal with, and they occur in a much shorter time frame. The single biggest difference between grappling technique as a weapon in human combat versus striking technique is time. Grappling technique takes a huge amount of time to apply. Okay, the advantage of grappling technique is certainty of outcome. Once you get there, it takes a huge amount of time to set up a takedown, physically take them down, work your way towards a dominant position, culminating in your opponent's back, and then apply a stranglehold. That's a long chain of events, as opposed to a strong punch or kick, which can take a quarter of a second in application from start to finish, and the match is over. And so there's a sense in which grappling it's fighting for the patient and the calculating, whereas striking is much more for in this short time frame where everything gets done in the blink of an eye. There's a sense also that grappling is a much more forgiving sport. You can make a terrible mistake, end up in a terrible position, and still fight your way out and win. In mixed martial arts, it's much, much less forgiving. If you get hit and stunned, your chances of recovery are minimal. You're going to get swarmed on, and unless it's right at the end of the round, it's very, very hard to recover from getting hit and swarmed on. So there's a sense in which
biggest difference between is time for application of technique. In mixed martial arts, it's incredibly unforgiving in terms of time. Even the smallest error can have the deepest consequences. In grappling, you can make massive errors and still come back and win. Grappling will typically be won in a much higher percentage case by the more skilled and conditioned grappler, whereas there is much more of what they call punches in mixed martial arts, where there's a much higher likelihood of a lesser athlete defeating a greater athlete in MMA than there is in grappling, simply because of time of application of the techniques. Even the smallest period of inattention in MMA, and the match is over. Gordon Ryan can fall asleep for 30 seconds, have his opponent mounted on, wake up and finish him 5 minutes later. It's not going to happen in MMA.
Okay, so the stakes are much higher. You can do a lot of damage in first half of the time, and just the dynamic, temporal dynamics of others have
Everything you see will be a reflection of that. Then you go further into things like rule sets. In the sport of grappling, if Gordon Ryan comes out and sits down in the middle of the mat, his opponent must follow him to the ground and engage. In mixed martial arts, if you come to the center of the cage and sit down, the other guy can just walk away from you. They're completely oriented in different directions. Grappling is ground centered, MMA is standing centered. Again, every round you have to start standing again. If I disengage from a ground grappling situation, stand up and walk away from my opponent must follow me up to the feet. In grappling, it's the exact opposite. If I sit to the ground, my opponent must follow me to the ground. It's written into the rules there. So one is inherently ground oriented and one is inherently standing oriented.
So it's more difficult to dictate how the fight happens in mixed martial arts.
Yes, you have to go to a pose where the fight is, whereas in grappling you just choose it.
So, George, what is your sense of the difference in terms of how you approach between the two sports? You also are a student of wrestling and grappling. So, in preparing for fights, what parts of grappling purely the sport that you have to leave behind?
I'm very lucky. I had the opportunity. I train with, I consider the best mentor trainer I ever had. And I have some of the best grapplers that I can train with. They were there to help me in my career. So for my training is, of course, because I do not dedicate as much time one specific area, it's hard to be a world class athlete. That it only I always, for me, like the idea to be more well rounded, to be very competent in every of those areas, striking, grappling, takedowns, and all those areas, that being just very good at one and not as good as others. Because I like the idea that it gives me more option. When I fight someone, I can mold myself to become the perfect nemesis to that person better if I'm more well-rounded. If I do not have those well-rounded skills, I don't have that option.
You have less tools to work with, less technology. What about you, Gordon? What do you think is very distinct about grappling and the way you approach it versus fighting?
I think most of it was covered, but I think that the one of the big things is the fact that when you're looking at MMA, you have a pretty general, agreed upon, and unified rule set. Where if you look at UFC versus Bellator, they have slight differences in the rules, maybe, but it's pretty much the same thing. Whereas in grappling, you have EBI rules, and you have ADCC rules, you have IBJJF rules, you have no time limit rules, and each rule set will play to the skills of different athletes. If you do ADCC rules, it generally is slightly biased towards wrestlers, where they can stall to the overtime and then hit a takedown in the overtime and not really do any jiu-jitsu, but they score a takedown, they're going to win. Whereas if you have like an EBI, for example, you have to finish the guy in regulation, or you start in a jiu-jitsu position with your back taken, or in an armbar. So I think that you have certain rule sets that play in the favor of certain athletes. And certain athletes can win in one rule set, but then they just have no chance of winning in the other. Like when I fought Yuri the first time in EBI, I beat him in EBI. The chances of me beating him on that night under an ADCC rule set were probably pretty low. When I fought Leandro Lowe under an ADCC rule set, he beat me that day, but the chances of him beating me in the same day in an EBI rule set were like next to zero. So I think it's interesting that in MMA you have one unified rule set, which has small differences, but they're all generally the same. And in Jiu-Jitsu, you have a wide variety of different rule sets that have biases towards certain athletes' skill sets.
You mentioned Leandro Lowe. Got to ask you again about ADCC. You have lost very, very few times in your career. The same is true for George. And the only person who's ever submitted you is Felipe Pena.
Black belt, yeah.
At Black Belt. He is ADCC World Champion, multiple time IBJJF World Champion. You may face him at ADCC or elsewhere in the future. Will you beat him?
Yes. I have to say yes, right? But I fought him initially when I first got my black belt. Then I fought him a year later, so 2016 and 2017. And despite what people remember about the match, and whenever people talk about it, it's like, oh yeah, the guy recorded. But no one remembers that the first match was like a 45-minute war. And the second match with the full 20 minutes of ADCC. And if I didn't get my back taken in like the last minute and a half, 2 minutes, it would have went into an overtime. That could change the outcome of the match. I think that if you look at Felipe's performances, especially no-gi, specifically no-gi, since then, it looks like he's almost gotten worse. Whereas since that match, 2017, the only match I lost after that was against Vinny, Michael by points. And I'm on like a 55-match win streak over the course of 4 years, winning all the major tournaments no-gi. And Felipe, since that match, I think is like 5-2 no-gi. He's lost his last two matches. One was convincingly where he was dominated by Andre, and one was by submission. So I don't think that he's progressed nearly as fast. If anything, he looks like he's worse than he was when he beat me in 2017 based on his previous performances. That being said, I know he's going to come in training very hard for this one, and he's going to be prepared. But I just don't think that in terms of technical ability, he's anywhere near my level. And he was much bigger than me both times we fought. The first time, he was much bigger than me. The second time, he was 1 weight class above me. So now there's not going to be an advantage in technicality, and it's also not going to be a physicality advantage. So I think he's just going to be beat everywhere.
This is a good example of the scientific response to a comment, to a question. Yeah, so he's not. That's a match you're not deeply concerned with in terms of the set of opponents, because you have and you would be facing a lot of these.
Yeah, that's actually, in my opinion, one of the easier matches because of the fact that we're relatively the same size. If I show up at 230 pounds, like a lot of the guys are 260, 270 plus, so that extra weight does make a difference. I think out of that entire bracket, Felipe is probably going to be one of the easiest matches because of the fact that I can easily take him down. And if I take him down, I'm going to pass his guard. Whereas I feel like the other guys, because they're so much bigger and they're very cagey, it may take me a while to actually take them to the ground and get on top of them. I think they may be longer, drawn-out matches because of the fact that they're so much bigger and stally. It's hard to take them down. But Felipe is relatively my size, and his wrestling is atrocious. So I've already taken him down in the last ADCC match. So I'm pretty sure I could just easily put him down, pass him, and then finish him.
Well, I'm not sure what response I was expecting, but that was pretty beautiful. We talked about the Thiago Alves fight that George had, and John brought it up in class yesterday, I believe. But the point is, we're talking about wrestling, and I think that's a fascinating fight. That is an incredible display of strategy, of skill, of heart. George, can you maybe talk about that fight, John, maybe too? What lessons you gave from that fight? Okay, it was your fight, not mine. Well, maybe it also tell what happened.
Oh yeah. So I was fighting Thiago Alves, and in the third round, I tear my adductor muscle. It happened when I was on the bottom, and I think he pushed my knee down, tried to pass my guard, and I heard a pop. I didn't know what.
I think you were going for an armbar. You were on his back, you switched to armbar, and he cleared the leg by pushing on your leg. You went in with a pre-existing injury and tore.
Yes, and then it kept worse. And I heard a pop. I didn't know what it was, but I know it really hurt. So like, came back standing up, and there's a a famous video that goes on the internet about when I go back in the corner, and I tell my coach, I'm like, I don't know what it is. I think I tore my adductor muscle. Greg Jackson is like, I don't care. Hit him with your growing. But I was very worried because I was in pain. I didn't know what I had. So I didn't know the gravity of it. And it plays on your mind. So, but I had to bite down my mouthpiece and finish the fight. I know I was ahead on the scorecard, and I needed to finish strong.
So what was your strategy there in terms of strikes, in terms of wrestling? So he's an exceptionally difficult opponent to take down.
Yeah, well, at first I knew I had a good jab, a good, to stay always from the outside, fight him from the outside and use my footwork, because he was like a tank. He was much bigger and much stronger than me. And never wanted to stay in front of him. So it was all the way out or all the way in. And when I was coming all the way in, it was my proactive or reactive takedown, where I myself initiated the takedown by using a distraction, like a jab, like his head goes up, and then I go with a single or double leg, or to react, activating him for him to come hit me, and then while he's coming to hit me, I go change that on, and that's the way I like to take my opponent down. Some guys, for example, like Khabib, for example, he's very good at bringing his opponent to the fence and use chain wrestling to take his opponent down. I find that for myself, I specialize more into explosive takedown in the center of the octagon, because I found it more economical.
What did you see? You were commenting, John, about the wrestling. That was quite interesting. I mean, also, can you generally comment on the fact that George St. Pierre, I don't think you wrestled.
I started wrestling, I was 19 years old, but I wrestled some very good Russian guys, so they put me underneath their winning. But my ability to cover distance comes from karate. It does not come from wrestling. Wrestling is how I finish. Once I get the leg, how I finish the takedown.
So the timing and movement and the explosion required for this choreography. I think an important distinction to make here is one which George made throughout his career, and I believe, George, you were the greatest innovator in MMA history with regards to this. And this is the creation of what George calls shoot boxing, which is the amalgamation of striking technique, in George's case, mostly karate, because that was his martial arts background, into grappling, and in particular takedowns. When most people say so-and-so has better wrestling in mixed martial arts, you have to be very careful what they mean by this. There are many highly credentialed wrestlers in the early days of mixed martial arts who went in and truly struggled to hit a takedown. Now, these are very, very good wrestlers who, in a wrestling match, would easily put down their opponent. But in a striking situation where the ranges are completely different and the setups are entirely different, the stances are different, even the overall conditions are different. You're no longer wearing shoes. People underestimate just what an impact it is for a wrestler to take the shoes off. You lose like 20% of your forward drive the minute you take off the shoes. All of these make massive differences in whether or not you're going to be able to even make contact with a forward takedown. As George pointed out, the true value of wrestling in MMA is finishing the takedown once you've established contact. But that's only about 20% of the action of the mixed martial arts takedown. 80% of it is in understanding range, rhythm, setup,
opportunity, etc., etc. And that's not part of wrestling at all. Even the overall conditions are completely different. In the sport of wrestling, you start at very close range in a very bent over stance, and you're expected to wrestle for an international stars for 3 minutes at a time. Now suddenly you're completely upright, and you're not wearing shoes. All the conditions, the rhythm and speed of it is different. The counters are completely different. It's just an entirely different animal. And so George was an early recognizer of this and started to put the emphasis on direct training for shoot boxing in addition to wrestling. So he practiced with very good wrestlers in the Montreal Wrestling Club, just the sport of wrestling. And that's what made him very good at finishing takedowns. But it was in his shoot boxing training, which he himself largely developed. Remember, George started at a time when MMA was pretty damn young. And when you entered the sport of mixed martial arts, George, it wasn't even allowed on TV. Like, it was completely banned. It was in his country. It was physically banned. That he had to fight on Indian reservations. This is way back in the Wild West days of MMA. And so, as a young developing athlete, he had to more or less do this by himself. If you ever want to hear some incredible stories, talk about teenage George St. Pierre. They had a coach who used to make him put on boxing gloves. Now, he was 16, 17 years old, and just put him on a hardwood floor against a professional boxer who was in his late 20s, the peak of his career. And he said, George, you're not allowed to punch. You just got to take him down while he tries to knock you out. And it was crazy.
Darwinism. Yeah, he was like you're gonna adapt, or you're gonna
It
could have been very bad, but it turns out to be great.
But there's a sense here in which people think, what determines your takedown ability in MMA is your wrestling skill. That your wrestling skill will determine your finishing ability of takedowns. But there's so much more to it than that. Whenever people say, what are the broad elements that determine the outcome of a mixed martial arts fight? Okay, on the broadest possible level, I always get the same three things. The athlete who can dominate the pace of the match, the athlete who can dominate the direction of the match, and the athlete who can dominate the setups will win the vast majority of fights they're in. Those three things, the direction, the pace, and the setups. If you dominate all three of those, you're going to win 90% of the matches you're in. George could always dominate the direction of the fight because he could stop the other guy taking him down, and he could impose his own takedowns at any point in the match. So whether it went to ground or whether it stayed standing, it's always up to him. George had the most sophisticated array of setups and takedowns that I've personally ever witnessed. The whole distinction between reactive and proactive takedowns came very early in George's career, and he excelled in both. Most people tend to favor one or the other. Most athletes have a very hard time imposing their setups on the opponent, and as a result, they have to use the cage as a crutch for their setups, where they just bully someone towards the cage and then put them down on the cage. George is one of the very few people who was equally good against the cage or in the open. He could do so in both proactive and reactive situations. And the scary thing is that as good as all of you saw him look in the octagon, anyone who knows George as a coach will tell you he was twice as good as that in the gym, where he would often go against people several weight divisions above himself. I could sit here all day. I won't name names, but I always laugh when people say, "Oh, this is the greatest pound for pound guy of all time." And I've personally seen George take that guy down and crush him in the gym, and I can't say anything because it's rude to talk about that in public because it's just training. But I've seen George go with people all the way up to light heavyweight, some of the greatest names in the history of the sport, put them down, advanced position on the ground and dominate them in training. It's what he did during that time. George, I got to say, I deeply admire many of the things I saw you do, not just in the octagon, but in training as well. the impact that you had on the, the degree to which takedowns were used in sport was absolutely inspirational. That's why one of the reasons why I always say you're one of the only athlete I ever met who taught me more than I taught you. Is you opened my eyes to a whole new world of shoot boxing, and how I grew up in a time when I was laughing before when you talked about Sugar Ray Leonard. I was a kid watching that match, and I grew up in a time where there was boxing and there was kickboxing, and then I came to America and I learned grappling, and this young man here was the innovator when it came to the integration of the two.
Well, then I have to ask, because George sits here uncomfortably being complimented. If George St. Pierre and Khabib Nurmagomedov face each other in their prime, who wins?
It's a very, very loaded question.
How?
Yeah.
Like, what are the different trajectories you see? Oh, okay, how does each one win in your view? If one wins or the other one wins, what happens?
Interestingly, they're actually very similar in size, despite the fact that George fought at welterweight and Khabib fought at lightweight. If you actually see them stand next to each other, they're of similar height. Khabib's actually a little more thick set. Yeah, he's actually heavily walking around. George walked around most of his career between 188 and 191 pounds. And so Khabib actually would ironically have a kind of size and strength advantage, despite being in the lighter weight division. That's been the general trend as MMA has grown, is that athletes will come further down in weight to make weight divisions. I believe that George has the best takedowns in history in the open, in the cage. Khabib was his great strength was using the fence to facilitate takedowns. Khabib's other great strength was not only his ability to take people down, but to keep people down for extended periods of time. Both of them were powerful strikers on the ground and could do terrible damage to opponents on the floor. So they're both very similar in that regard. Khabib was mostly a puncher from the back. George is mostly an elbow from the front. But both of them could lay waste to opponents with strikes on the floor. Both of them were highly competent with submissions on the ground. They weren't submission specialists, in the sense of someone like Gordon Ryan, but they were certainly no slouches with submission holds. Yes, it's a fascinating idea.
So it's almost like who gets the first takedown?
Yeah, I do believe that they could probably stand up on each other. I don't think either one of them would be able to get down for a whole round. Both of them are notoriously difficult people to hold down. So I don't think that whoever won the first takedown wins the match. I don't think it's like that. I do believe that George would hold a decisive advantage in striking and distance management. The few times that Khabib did look shaky is when Khabib was either advancing forward menacingly, but when he had to fight moving backwards, there was a definite asymmetry between his ability to fight going forwards, which was very good, and his ability to fight going backwards, which was noticeably weaker. George would often fight both forwards and backwards. The Thiago Alves fight, most of the standing time, when he was going backwards. That's probably the single biggest difference between the two athletes at skill level would be in the standing position. On the ground, Khabib slight edge and takedowns on the fence, George slight edge and takedowns in the center. Ability to inflict damage on the floor, roughly equal. Ability to fight off the back, roughly equal. Ability to stand up from bottom, roughly equal. It's a very, very hard match. In terms of the biggest difference in skill level is going to be the standing position. And so it would come down to that doesn't necessarily mean that Khabib would lose in a standing position. He might just push it to the fence and just use match tactics where he kept the fight on the fence for significant periods of time. And you can win rounds in that fashion. So it's a match that could go either way. Both of them are absolutely the best you'll ever see. I've always believed the three greatest mixed martial arts I've ever seen in my life were George St. Pierre, Khabib Nurmagomedov, and John Jones. The three of them had some interesting similarities and differences. All three, beat every single person they ever faced. Um, I know John Jones officially has lost by DQ, but no one believes that was a loss. George does have two losses, but he defeated both athletes decisively in rematches. Khabib did it by having no losses. Interestingly, all three athletes have at least one match, which is controversial in terms of who won and who lost. John Jones has had several matches that could have gone either way on the judges' scorecard. Khabib's match against Preston Tebow could have gone either way. George's match with Hendricks could have gone either way. They all had matches that they won, which people would dispute the outcome. So that was a similarity between the three of them. All three of them have had the ability to dominate the direction of fights. When they want it to go down, it goes down. When they don't want it to go down, it doesn't. That's why I put such a heavy emphasis on that idea that the mixed martial arts champion must be able to determine the direction of the fight. It's the single most important attribute that they all must have. As to which of the three is the best, it's going to come down to criteria. You can't pull them apart. Which answer you give as to which of those three is the greatest of all time will come down to the criteria that you use. Really, is it being undefeated? Is it the amount of time? Was it the quality of the opponents that they had? If you do it by quality of opponents, I think you probably have to give it to George. If you do it by measured dominance for not being defeated, then it has to go to Khabib. Arguably, you could say the same with John Jones. His one loss is by DQ, but then you could also say the last 3 or 4 fights that Jones had haven't been the same measure of dominance as we saw previously. So ultimately, you've got those three guys, in my opinion, and which one you choose will come down to who. It says more about who you are as a viewer than it does about the respective level of the athletes. You could throw a blanket over them, the three of them, and they're just that good. And which one you select will probably say more about who you are as a viewer than it does about them and as athletes.
I believe that's fighter,
The GOAT.
he's not even born. Because the generation that is present benefit of a huge advantage. They have knowledge, technology that we didn't have before. And we had the knowledge that the other generation didn't have before. But I believe the GOAT is not even born yet. As good as they are today, I think with the sport where you can measure the performance, track and field, other things, someone is better than the other one because you can measure the performance. Fighting is all subjective. We always debate of who would win, but the tendency in sport is that the performance gets better. I don't think it's because the athlete necessarily get better. It's because they have access to better technology, knowledge, and they learn from their predecessor.
As long as that knowledge is transferred forward. So something tells me that the greatest of all time lived a few thousand years ago and has forgotten some of the greatest warriors. Like you imagine the kind of grapplers who just the history didn't record them. There could have been small tribes where they developed and made UFCs, and they've developed the kind of things you have to think of, like the Gracies. If the small family was able to develop so much so quickly.
I often, as this discussion with Johnny, I think it's very important that you mentioned. I asked him very several times, like, what would happen if we would take a fighter of modern days facing the champion of pancreation?
This is an interesting place.
And you brought some incredible good point, and people don't realize it.
Yeah, no, I think one of the great tragedies of martial arts history is our loss of the historical records of pancreation. Like most of what we know was, from what I'm told, is actually lost in the fires of the Library of Alexandria, and we're left with only a pitiful amount of information on pancreation matches. But what we do know is that there was a very
large participation in the sport, and that it was widely considered the most popular sport in the ancient Olympics, and that it was represented in the ancient Olympics for many hundreds of years, plus a long period of time before its introduction into the ancient Olympics. And so the development time that it may have had would have been very significant. It, as far as we know, most of the development would have been in the major Greek city-states for hundreds of years of development. Given its prestige as an Olympic sport, then the best athletes would have been doing some of the sharpest mind that we know of in human history were involved in the sport. Plato, the great philosopher, was a pancreationist in his youth. In fact, his name, Plato, is a nickname. Platos is like plate. That means broad, big guy, like the big guy. And he spoke often about pancreation in his written works. Imagine people with the intelligence of Plato thinking about grappling technique for hundreds of years in the most popular Olympic sport of that time. Significant numbers of people with financial backing as city-states put great prestige upon Olympic success. They would have funneled athletes in, brought in the best coaches, and they had that for many hundreds of years. Like, it's quite conceivable that the best pancreation athletes were of the absolute first quality. And it's so sad to think we'll never know what was their skill level.
It's interesting to think about what kind of techniques they developed, whether there's stuff we haven't discovered yet. In class, you're talking about the most effective takedown strategy in wrestling, in collegiate wrestling. So maybe let me ask first, because we offline talked about this too. What is the highest percentage submission? Correct.
Overall, you have to go with the rear naked strangles from the back. If you look at most tournaments, most rule sets, it has success across all rule sets, all weight divisions, all body types. It doesn't require any kind of specific physical advantage, such as height, in order to be effective. It works equally well in both fighting and grappling. It will work regardless of how physically and mentally tough your opponent is. Like a heel hook is a very high percentage technique in modern day competition. But if your opponent simply makes up his mind that he's just not going to tag and is willing to take the physical damage, it won't result in the end of a match. A stranglehold, by contrast, will always end the match, regardless of your opponent's mental toughness. So I believe it's good that at the end of the day, the single most high percentage method of submitting people in grappling is the rear naked strangles.
So when you look at an athlete, maybe Gordon, you can speak to this, like what's the best Gary with the guillotine? What's the best submission to really invest in? Is it the rear naked choke? To really invest in development, like understanding the entirety of the system that leads into that.
I think that you have to do them all, obviously. If I had like one submission only one submission I could pick for the rest of my life, it would definitely be rear naked.
Can you explain maybe some of the actual technical details of why that's the case?
Well, as John spoke about, they're different joint locks, whereas you don't have to tap. You can just let your leg break and then keep going with your strangle. There's none of that. And then it's just an inherent advantage you have being behind someone. Whereas if you go for an arm bar, you start from top mount and you're facing the guy, then you put him down and you're not directly behind them. With leg locks, you're facing the guy. Whereas when you're on someone's back, you have them in a pin where you can your chest to back, you have a body triangle in. You're pinning the guy in place. He can't explode out. He can't grease his way out most of the time. And there's an inherent advantage you have being behind them due to the fact that we're poorly set up to deal with threats behind us.
So would you say that's the most dominant position in jiu-jitsu, like more than mount, more than side control?
I think if you look at most matches historically, most guys who get stuck in positions for long amounts of time are guys with their back taken. You get an explosive guy from bottom mount, you can bridge, and you can off balance, you can lock half guard maybe and work back to guard. But someone locks a body triangle on your back, that's where you see most guys getting pinned in place for long amounts of time.
Was the body triangle like a well understood thing? Was that an invention at some point? Like as a system, as a
Control
yeah.
excellent. Your listeners can correct me on this, but I believe there was a technique banned in judo called doji, which involved crossing feet or locking a triangle around the abdominals from the back. It was banned in judo, I believe, because of intestinal injuries which occurred in the early developmental days of judo. And in the modern era, when I first began jiu-jitsu, body triangles were relatively rare. They were not the standard part of class. And sometime around the late 1990s, early 2000s, people started to realize, hey, this is a stronger method of control. It greatly increases the amount of control you have of your opponent's hips and torso over regular hooks. It's not for all athletes. It's difficult for most people who are of shorter, thicker stature to employ on big people. If your opponent's very broadly built through the stomach, it's almost impossible to apply. And so, because it can't be applied by all people, it tends not to be taught much at beginner level. And so, as a result, it was always seen as a kind of a specialist move for taller athletes at a higher level of competition rather than a broad-based move for everyone, or every body type, and every class to employ. So just to emphasize that much. But in top-level competition now, I think you would see that it's very apparent that the vast majority of athletes, whenever they have the opportunity or choice between body triangle and regular rear mounts, the majority of modern athletes would choose a body triangle.
So we also had this conversation about wrestling, and maybe George, you can comment on like what's the highest percentage, not statistically speaking. Perhaps that's also interesting. John talked about, but just for you, in terms of mastery of the takedown, what's the best way to take down a human being in wrestling?
Well, I personally, for me, it depends. For every fighter are different. They have a different set of skill. For me, when I look someone who want to bring down a tree, a big, strong, high tree, you cut it from the base. So the legs, that's what we stand on. So it was to attack the leg.
But is it single leg, double leg? Is it we talk about like there's also the John Smith low single.
Yeah,
I don't even know if that's applicable for jiu-jitsu at all.
You can use it, but it runs the problem with submission holds. It's not impossible to use, but without shoes, and in a situation where there's a whole place for submission holds and scoring, it's a lot more difficult to use.
It is interesting. Something being of a high percentage effectiveness tells a story. You're saying that every athlete is different, but if it's more effective for most people, I mean, it's interesting. It's interesting what John talked about is that the highest percentage thing is actually in collegiate wrestling that he was talking about is on the defensive side. So blocking a takedown and spinning around to the back. So that's an interesting idea. Then also there's all of these kind of going in for a single and switching to a double or wizard position and doing knee tap. Like there's all these kinds of combinations that seem to be effective when you look at the statistics. And it seems like there's maybe it's a scientific way of thinking, but it seems like there is some conclusion to be drawn there.
Oh yeah, I believe you need to. With the high percentage move, there's a reason why it works. I think it's made for a bigger amount of people. For example, I one of my main strength, athletic strength is I'm an explosive person. So I use techniques that are explosive. If I get a single leg, one of my things I like to do is to go for the double, power double. But for someone else, that, for example, in a single leg position, maybe he likes like body throw better. He's more a Greco guy, actually, or he's a judo guy. He's gonna go for something else. So, but there's moves that are, I would say, like just mentioned, are universal. Like statistically speaking, they're the highest percentage move that works for pretty much everybody. Everybody pretty much can do a dekajimi. You know, it's very easy, but it's not everybody that can knock a triangle with their legs. So those moves like rear naked choke, a dekajimi is the highest percentage move because
maybe more accessible. It's accessible for a bigger,
Yeah, based on the physical characteristics of people. Do you draw any wisdom from these high percentages, John, for like in terms of what to focus on?
Yeah, absolutely. Jiu-jitsu has an ocean of moves, and you can get lost on the edge. You can drift for a long period of time and end up with very little to show for it. So my whole thing is focus. We only live one lifetime, and your training lifetime is even shorter than your actual lifetime. So in that time, I was
Giant man.
that's exciting. Um, I put a very high value on choosing what I believe to be the most high percentage moves and putting an extraordinary amount of focus on them. The only problem is that in one generation, a move which can be considered low percentage might actually turn out to be high percentage in another generation. For example, we talked earlier about leg locks. When I was first started jiu-jitsu, they were considered the ultimate low percentage move. And a big part of my career has been convincing people that in fact that was incorrect, that they can be a high percentage move if we just change our approach to them. So we can't just follow tradition and say, oh, this is low percentage, this is high percentage. It has to be part of a fairly systematic study where you investigate what are the reasons why it's high percentage or low percentage. With regards to takedowns, if you look at what we could consider the most high percentage takedowns, if you're in front of someone, the single most high percentage way of taking them down is to get a hold of both of their legs and push them backwards. If you get a hold of one of their legs and put a force on them, they can use their other leg to defend themselves and hop around and funk their way out of takedowns and cause all kinds of problems for them. I don't care how athletic your opponent is, if you get a hold of firm grip of both of his legs and start pushing him backwards, he's going to fall down to his butt. Now, he might be able to recover from there, but he will fall down. Even easier than that is to be behind someone. Takedowns from in front of someone, difficult. You go right up to their hips, their head, their hands, and you go to all their defensive weapons. If you're already behind someone and you're doing what in America they refer to as a mat return, this is significantly easier than taking someone down from the front. If you have control of their head in a front headlock position, you've already closed distance on your opponent. You already have close contact. You don't have to worry about shooting anymore. There's no sprawl out of that. You don't have to worry about guillotines, claws, or standard defenses. Those will intrinsically be easier takedowns out of front headlock. So if we're going to talk about high percentage technique, I always go back to the mechanics of it rather than just historical tradition, because historical tradition can be wrong. It's wrong about leg locks. It's wrong about other things too. So my primary thing is, okay, talk to me about them. That's what ultimately is going to determine whether something is high percentage or not. Gordon pointed out earlier that when you're behind someone, innate physical advantages that you have the human body is set up entirely to defend threats from the front. We are poorly adapted to defend threats from the rear. We only have eyes in the back of our head. We can't apply pushing strength backwards. If you get behind someone, takedowns are 10 times easier from behind someone than they are when you're in front of someone. If you have to take someone down from the front, get a hold of both of their legs. You get a hold of both of their legs and apply a pushing force, you will almost knock them down. If you can get a hold of their head and work takedowns from there, again, it's much easier because most of their defensive apparatus is being taken away from them before the takedown even begins. And so, for me, high percentage takedowns will always be from the front, double legs. From any takedown from the back is going to be significantly easier than any takedown from the front. So all manner of mat return takedowns are going to be very high percentage. And takedowns start out of situations where the opponent is broken down in front of you and you have either front headlock or front chest wrap position are going to be significantly easier than takedowns from the open.
Of course, you have to consider the full spectrum of mechanics involved here. It's possible that an outside low single lead to a double leg is a much higher percentage. Like there's a lot of chain wrestling that needs to be considered as a possibility. Maybe straight on double. And part of this cultural too. Are people afraid of this kind of thing that they came to be the case with leg locks? Are people aware of this? Are they worried about this? Are they training for this to defend this? And then there's opponent specific, of course, that
Jordan Barros, people preparing for the double, which is why he had to develop a whole other kinds of different stuff. And then ahead to all the different controls, all the different ties within the rule set. And that's where it's so fascinating to see the effect of rule set on all of this. Judo, over the past, I think, 20 years, went through this every Olympics, different changes to the rule set, like fundamentally different in terms of what's allowed to grip, whether you're allowed to touch the legs at all. There was a big one in 2012, I think. And that changed the sport completely. It's so interesting. It's so interesting to watch how a tiny change in the rule can change the sport at the highest one when you're talking about people competing at the highest level. And the cool thing there is the rule change happens on a scale of every 4 years. So you get to see people that are at the top of their game have to like recompute. So it's not like you have a new generation of people coming up with the rule that have to figure, oh shit, you're not allowed to, like it's the equivalent of saying you're not allowed to kick anymore in MMA because you're not allowed to grab legs anymore.
Interestingly, if you look at the case of judo, if you look at the world rankings of athletes, when they went through one of the most significant rule changes in judo history, where they banned any form of grabbing legs, the ranking of athletes didn't change much.
Yeah, that tells you that there's a reason why those guys are top. Yeah. And it doesn't have to do with that they're specific to a rule set.
Think about that in terms of a measure, for example, in mixed martial arts. If they just said, hey, starting next week, instead of having 3 5-minute rounds, it's going to be 15 minutes straight. That would massively change the preparation of the athletes. It's a different game at that point. Judo literally was a different game before 2010 and after 2010. And yet, the international rankings didn't really change that much. The countries that were dominant before remain dominant. The athletes that remained before largely remain the same. You would think with such a massive change, all the rankings would be thrown upside down, but they weren't. And again, it goes back to this idea that there's a reason why the guys at the top are at the top.
And now for something completely different, we're talking about aliens. Say, George brought up Bob Lazar. I will likely probably talk to Bob Lazar on this podcast, and then John had a skeptical look on his face about aliens. So let me ask John and Gordon, do you think there's intelligent civilizations out there in the universe outside of our own?
The universe is unimaginably large. The idea that we are the only life forms in a cosmos as large as this is, I think, naive and foolish. There's a very high likelihood that if life could evolve on this planet, that it could have done so on many, many other planets around the cosmos. I think anyone who puts even a moment's thought into this would realize that there's almost certainly other forms of life out there. The real question with regards to the alien community is, have they got here and are they searching our planet in sulfur sources and making observations and periodically stealing people for experimentation purposes?
Doesn't have to be silver saucers, it can be different other color saucers.
And that question, I'm not good at. Recently, Navy footage has come out showing some very interesting phenomena. If you talk to almost any experienced pilot, they will tell you they've seen things in the upper atmosphere that are very difficult to explain. I'll be the first one to agree with you on this. There are some things out there that are extremely difficult to explain.
Literally UFOs, unidentified.
Yeah, we just don't know what they are. But to go from the idea that there's things out there that we don't understand to there's like little creatures running around and these somehow exist, I just reserve judgment. I just say I'm agnostic about these things. I think it's possible, but all the evidence that I've been shown so far was insufficient to come to any kind of definite conclusions until aliens land in Central Park on Tuesday afternoon at 3 p.m. and get out with their alien ray guns and start shooting people. I don't believe in many of the stories that get told.
Well, what about if it's not little aliens with ray guns, but something very different, very, very difficult to detect for us humans. And it's very human.
Which at that point, it's a fascinating idea, and it's certainly possible. But show me the evidence.
All right. What about you, Gordon? Do you look at the cosmos and ponder the stars often?
I think it's fair points John raised. Something really interesting I saw the other day was someone posted like if an alien organ or civilization 65 million light years away somehow managed to look at Earth, they would theoretically see the dinosaurs because they're 65 million light years away. So like imagine us looking at galaxies that are 100 million light years away. That's 100 million years ago. You have no idea what it looks like now. So that's just super interesting to be about it.
Yeah, the expanse is huge. So much cool stuff could be going out there. The scary thing, of course, is if they haven't visited us yet, there has to be a good reason for it. And the set of scary reasons involve the fact that they maybe once it gets sufficiently advanced in your development, you destroy yourself naturally, as humans seem to be approaching now. We more and more have the tools to destroy ourselves completely in terms of our weapon systems. And we're developing them more and more, and they're becoming better and better. And then we're starting to get angry and angrier on Twitter and Instagram with each other. That's a good point.
It's the risk that thing that is something that I will perish one day. Yeah,
But it's also just the sheer difficulty of travel through space. Like space is an unimaginably inhospitable environment, and to the best of our knowledge, this even the theoretical speeds that we can take in space, even if we could travel at the speed of light, we're not even remotely close to that. Still, the distances that need to be traveled to get to even relatively close solar systems are very, very long. If you look at astronauts who have spent significant amounts of time in space just orbiting the Earth, it has severe health effects on them. We're just not built for space. We're supposed to be in a gravitational environment.
But you're referring to your biological meat bag that's containing the essence of the mind that is John Danaher. Maybe we can transfer the mind alone. The bag, the meat bag is not designed for space, but maybe the God this is all that's in the mind.
It's possible. But
What do you think of you folks who like difficult things? What do you think about Elon Musk going to colonize Mars? Is this something you find interesting or a aimless pursuit?
I think it's a must or a salvation. We need to leave at some point the planet because historically in the past we know that we've been bombarded by asteroids, volcano, like crazy things happen here. It's very unstable. If you look at it through a lifetime of a human being, it's nothing. But just look 12,000 years ago what happened. So there's cataclysm that happen all the time. It's very unstable. So if we want to survive as a species, I think we need to get out to be able to get out, spread our seed.
So these are the early steps on a really long journey. But is there something about we don't get that exploration from most modern society. The kind of exploring that people did throughout the centuries of coming to North America, just throughout, and we're shrouded in physical uncertainty, what's out there. And now we get to do the same kind of exploration with Mars. Is there any aspect of you that wants to travel out to space, that wants to travel to Mars? The goal is to allow civilians to travel, perhaps in our lifetime, meaning affordably. You could do so now, unaffordably.
Traveling to space and traveling to Mars are two different things. I think I would like to travel into space. I don't know if I would like to travel all the way to Mars.
Because of the risks involved. It's boring. Is there some part of you that enjoys
I think that if I was like 14 at the end of my life, I would like to travel to Mars.
Because you'll
Just
just die at Mars.
the experience. Yeah. If I go to Mars, I'm not coming back. If it's a
One-way ticket. Hey, with the technology we have now, maybe in the future, maybe the children of our children will be able to
experience that.
Well, the
Weekend on Mars.
well, the whole design of the Starship that SpaceX is working on is supposed to come back. It's supposed to be reusable. So it's not a one-way ticket. That's the whole point. It's always going back and forth, back and forth.
What's the time frame between two planets that you travel from?
I think the current thing can be stuck on Mars for 2 years.
How long does it take to get from Earth to Mars?
Oh, it's pretty. I'm not exactly sure, but it's pretty quick. Like I don't know, on the scale of months, not scale of year.
You might not be healthy when you come back. You know, all the astronauts they experience health issues. You know, they lose a lot of muscle mass, bone density. So, yeah, I don't think the technology is good right now. I mean,
Let's say that
if it is, I would love to be doing it for a weekend. If it's safe, I would
you
love
are
to
also
be the
somebody
first one to do it.
for a professional fighter who sacrifices body, something. So there's some sacrifice we do. Right?
I would want to be the first. I wouldn't want to. I leave the other one, but when I know it's safe, okay, count me in.
So one of the things that people say, and this is something I wonder about, is it's like Henry Chillier or something. Once you're out in space and you look out and you see Earth, you look back at Earth, that's an experience. It's not like anything else. Like you can't replicate it here. It's to look back at that, but you die.
That nerve wracking. Like you see like Earth disappear into the distance.
Yeah, disappear into the distance. Then you get to actually stand on Mars and see, and just to look. You're standing on the ground and you're looking out, and you see the planet from which you came and where you might not be coming back. But there's a challenge to the whole thing. Where the risk is tremendous, and I don't know. I find that risk really compelling for some reason. But that could be just the exploration. I guess that's a genetic thing too. How much do you want to explore? There's a state film which, even in the best case scenario, where they did get the technology to whisk you to Mars in a fairly short period of time, it's kind of an inauthentic sense of exploration because your participation in it is no more exciting than your participation in an airline flight to a foreign country. You didn't have anything to do with the creation of the vessel. You're not commanding the vessel. You're not in any way, shape, or form important to the mission. You're just a person sitting in a passenger seat. You get off at a destination the same way you would if you flew to Singapore or London or someplace like that. Well, there's a hierarchy there's a leadership, and then there's a bunch of people, and they all have roles. You don't get to go to Mars without having a skill set.
You made it sound like space tourism.
Well, yeah, I think it's a long time before you have space tourism to Mars. You have nothing to contribute. Like you will have to go.
What you do, you go through a training program.
Training program, and there's technical things you can contribute. So they would bring people, in terms of agriculture. And
Okay, so this is better. This sounds like they're more like explorers. Like you talked before about explorers and human history, where Magellan sets off on his boat, and every person on the boat had a specific function. They were all into the mission in a very distinctive fashion. If they weren't on the boat, the performance of the crew would somehow suffer. So this sounds much better.
And with Magellan, I think most of the crew died.
A significant number did, yeah.
From bacteria, from things that are unexpected and so on. And if we discover life on Mars, who knows what that entails? Because that's like a manned mission to Mars would likely be very driven by the research to do all the kind of exploration required to find life.
Now, from Mr. Musk's point of view as a developer, presumably there has to be some kind of financial incentive here too. Is there some kind of financial benefit to Mars missions? Is presumably there wouldn't be that many people on Earth that could afford a ticket to pay for the kind of research and development that would require this. Is there some kind of mining on Mars of minerals that you use?
I think there's a lot of answers to this, but the only honest answer is the one that looks back at the human history where we did a lot of things just because we could. A lot of hard things just because we could, and that led to a lot of innovation that ultimately made our life better. So this is why you have NASA, this is why you have government organizations. Like, what's the purpose of NASA? NASA would answer that by saying, okay, well, we're helping launch satellites up there, all the they'll have a bunch of answers, but the reality is the programs were funded in large part by our desire to explore the unknown. And there's some aspect in which we have to all invest into that because, historically speaking, that has produced a lot of cool things along the way that were totally unexpected. Like NEST was funded by public funding, the taxpayer. How is Mr. Musk going to fund this? Well, currently, most of the funding for SpaceX is NASA giving money to, so they're making a competition. Who can get our satellites? We need to go to, for the space station to resupply the space station, or we need to launch satellites up. Who's going to carry those quote unquote payloads? They just need, so NASA's paying whoever the heck wants to get kilograms of thing up into space. This is NASA's specialty. Why did they just give up on that? Why they realized when Mr. Musk came along, those and others that said we can do it for 1/10 the price. So why should the taxpayers pay for it? Why don't you, NASA, do what you do well, which is like to test out cutting edge stuff, make sure they're safe. And now that we've developed a car, let us UPS and FedEx take care of doing this at scale, doing it cheaper, doing it better. I mean, that's the argument. And NASA what they realized is it took way, way too long to do stuff. But when you're investing millions, billions of dollars into a project, the bureaucracy builds up and the conservatism builds up to where you really have to test everything out. The projects take years. And then you have somebody like Elon Musk come along and says, well, let's do launches every week. And as opposed to just throwing away the rocket, we'll reuse the rocket. That was one of the sort of cutting edge inventions. It's a dumb, obvious idea. But like Elon says, why do you throw away the plane? It's the equivalent as if you flew a plane every time you threw it away. Why are we every time throwing away the plane?
But NASA tried that kind of thing with the space shuttles and some of these things.
Yes, but they did that with the space shuttle, but not at the scale here that the space shuttle was seen as this like majestic, amazing thing that requires a huge amount of investment. But Elon Musk is like, no, every basic rocket should be reusable and cut costs.
Do you think like the more technology we have, the more advanced we become, the more specialized we need to be? Like, is that for that reason that now there's different branch? Like you just explained now NASA they're specialized on this, but they're not, other branch.
Yeah, there's greater and greater specializations and build up more stuff, which is fascinating because is it making us more dumb in a way? Do you think yeah, I don't know, like
You know, but I use a cell phone, but I don't know how to build it up for that.
like I mean, it's that beta males building up this whole society because we're this collective intelligence. We rely on each other more and more, and I do also see sort of the rise of conspiracy theories and all those kinds of things because, like, I've been talking to a few folks about flat Earth recently. It's fascinating. There's a large community of people that believe the Earth is flat, and that idea takes hold. In this day and age, of all the ideas, that's the one that takes hold for a large number of people. And I think that's a consequence of this kind of specialization, where it's just a huge amount of experts. But if you look out into our world and try to reason simply about our existence, we are losing the skills to do that. Because more and more people are specialized, as opposed to general thinkers. We're like extremely good at specific things.
Are we capable now to do a robot that is self-aware?
That's one, the leggy one.
It's
No,
self-aware, like,
It's not self-aware. It's been listening. It's not self-aware.
but do you think a human being is self-aware?
That's a good question. I mean, I ask this question all the time. When the robots move, there's a sense of when they turn on, something entered that robot. Wow. And when it turns off, something left. If they move in a certain kind of way, and if they surprise you, there's certain elements that enable us to see the magic in a living being. And some of them, we can maybe list them, but
but it's the ability to surprise you. It's the ability to make mistakes and learn from them visibly. There's a bunch of things that you just, I don't know, it just feels like it has the magic of what is a living being, and which is what humans have. And I try to think about how do you replicate that into a machine.
So when you turn it on and after, you feel like it dies every time, and you
So for most machines, we don't feel that way. We don't, when we unplug things, we don't feel that way. I don't know why we don't feel that way. That's an interesting question. But I think when the robot has certain qualities, like memory, like ability to recognize you, yeah, you start to feel like you're turning off an organism. So whenever I have like the robots that recognize me and remember, this is important, that all the things we've experienced together, then it's like, holy shit, that's a living thing.
but
It feels like a living thing.
does he remember your robot? Does he remember things that happened before you unplugged it? Is it like he's sleeping? Like you wake up, or is he like
Yeah, so
or
right
you
now-
actually start to zero?
No, it doesn't start at zero. Remember that. That's the key.
Every time you unplug, wow.
It's storing the memories, but the memories are basic. They're like, okay, we walked around the kitchen, and then you looked at me. I mean, the memories, it's like data. It's not like we've experienced. It's able to actually experience anything deep like we humans can. But just the fact of memory, it's like the toaster or the microwave don't give a shit about me. They don't know me. They don't know me by name. They wouldn't recognize my face as being different from Gordon's. They wouldn't know the difference, and they wouldn't remember. The microwave currently doesn't remember, the times I've been sad or happy, like what food I put into it. It doesn't remember this. When I was being a fat ass or when I was being in good shape, and all just those memories are enough to make you feel when you turn the thing off. It's like, shit. That's a living. That's a living thing. Of course, that's kind of an anthropomorphism we do to each other, but that's something. You know, that makes me believe it's possible to create systems with which we can have a connection that are non-human, like similar to dogs and cats and so on. It just makes me, and that's what's interesting to me, because ultimately, I feel like that will help us understand ourselves and maybe practice crowd animation. Anyway, well, let me ask the advice question. Now that we're together, I spoke to Jazz, but I spoke to George. What advice would you give to young folks, whether we're talking about sport, excelling, becoming great at grappling, becoming great at fighting, becoming great at whatever sport they take on, or at life in general, whether that may be in high school or in college? What advice would you give them to excel at that thing they take on?
I don't know if I'm qualified to answer this because I'm only 26. So
You're at the top.
you said give advice to young people. For me, I think the two biggest things are find something that you're both talented in and you enjoy. I think that if you enjoy something but you're terrible at it, it's going to be hard for you to be successful in life in that given area. And it's going to be hard to do something for long amounts of time if you're talented at it but you don't enjoy doing it. It's easy to come in and train hard for a month or for 2 months or for a year. You can be very talented at it. But if you come in, it's a different story to come in every day for 5 years in a row, for 10 years in a row, for 15 years in a row. So I think finding something that you're both talented in and something you enjoy are probably the two biggest things for me.
How do you find the joy in it? So you've been training the same amount, a lot. You've been doing it for a long time. Is there ways to rediscover the joy in it?
Yeah, for me, initially, it was just learning new stuff. You come in as a white belt, and every day you see a different move, and you're like, oh man, that's awesome. And then when I started to compete more seriously towards my professional career, it was the joy of doing camps and seeing the result of those camps and meeting high-level athletes. And then it got to a point where I've beaten all the high-level athletes already, so who am I going to compete against? So now for me, the joy is just being the best athlete I can possibly be until I reach my prime, which I'm hoping is somewhere between 35 and 40. So instead of competing against the other athletes, that would be boring because I already beat all the rest of the guys. But I know that I can be better in a year from now or 2 years from now than I am today. And that for me is exciting.
By the way, is there some aspect of teaching that's exciting to you?
Yeah,
Because you become a better and better teacher over the years.
I definitely enjoy teaching. And I used to teach a lot before I met John. And then I met John, and I was like, I just have no idea how to teach. So that's like a completely different element of the sport. Doing things and being good at doing things or being good at winning, and actually being able to communicate those skills and knowledge to a vast amount of people is two completely different things.
George, advice for young people like yourself?
Well, first I would tell them, find what you want to become, what you want to do. And long term, use certain things maybe sometimes you don't love, but where you want to propel yourself in the future. Not what your parent, your friend wants you to become, what you want to become. Once you find it, you cannot doing it by yourself. Everything that is big achievement in life, we cannot be doing it by ourselves. So what I would say is, second thing is try to build up your team. Try to build up your team to be able to achieve your goal of people that are competent and people that you trust. You need both competency and trust. I see a lot of people sometimes in business, for example, they hire people that they trust, but they turns out to be incompetent. So now you have to fire a friend, or otherwise your business went down. The same problem if you do the opposite. You hire someone that is competent, but you cannot trust is gonna screw you, So it's very important to stay away from the negative. Build up your team, people you trust and that are competent. And I would say the third one is to work hard, to sacrifice yourself. Yeah, you got to go through hell sometimes. Yeah, you got to see the light at the end of it. To keep your dream in mind is going to give you the motivation to go through the tough times. It's nothing easy. To work is nothing you can accomplish without hard work. The fourth one, I would say, to invest on yourselves constantly. If you do not invest on yourself on whatever you are in, which business and sport, the game will catch up to you. For example, if you become champion at something, you stop and prove it. The other guys that are trying to be champion, they can catch up to you. So you need to invest on yourself. Most athletes, they make the mistake when they start to having money, they buy luxury stuff. That's one thing I didn't do. When I started making money, I was investing on traveling to New York, training with John, Gordon, and the guys to learn what is new in the game of jiu-jitsu. I used to go in Thailand, train Muay Thai, in Los Angeles to perfect my boxing skill. So instead of taking that money to buy jewelry, cars, to do what a lot of guys do, because it's a mistake, I invested in myself. I know there were people coming. They want my place, so I didn't want them to catch me. And the last one I would say, it seems weird, I would say, to give back. And it's not because I'm a nice guy. And it's not that I don't say that to look good. I say that when you make it, it creates opportunity where you can help a certain group of people. But when I say give back, not give back to everybody, give back only to the cause that you want. I give back not because I'm a nice guy. It's kind of selfish. I only give back to the people that I want to give back, because I give back to them, and I know that if I'm more successful, I'm going to be able to give back to people I love, to the cause that counts for me. So it brings me more motivation, because I don't compete for myself anymore. I compete to help people I love. So when you reach the top of your game, you need to find new motivation. If you're satisfied, it's the end of it. Your success will go down. So you need find new motivation. What can motivate you? What do you want? I want to help this. I need to be successful. I want, you need to find reason what you want to do with your success. So when I say get back, it's not because I'm necessarily, it's not to look like a nice guy. It's to keep the motivation to be able to keep climbing the ladder even more.
That's beautiful, George. John, first off, the two responses given so far covered, I think, the most important things already. Gordon talked about the need for an underlying passion and enjoyment. If you don't have that, you're not going to have the longevity that's required. In order to build skills, which is ultimately everything's going to come down to ability to build skills. You've got to have some kind of underlying passion and enjoyment which will keep you in the game long enough to build world championship skills. It's going to take a minimum of 5 years, and quite possibly considerably longer than that. George talked about the idea of community. You're not going to make it by yourself, so you've got to be able to build people around you and build a trusting environment around you to develop those skills. What I would add to the excellent points that both already raised alludes to what I said at the start of this podcast. You've got to be able to identify some kind of undervalued elements in whatever industry you're in and show the world what their true value is. In addition, you can't go through life doing the same things as everybody else and expecting to get different results. This is straightforwardly irrational, and worse, it's even arrogant. It's essentially the statement that I'm going to do the same thing as everyone else, but I believe I'm different. And so they'll work for me, but they didn't work for everyone else. That's like saying, no, I'm special. No, you're not special. We're all pretty much the same. And in order to be special, you're going to have to exhibit skills other people simply don't have. Thirdly, I would say if you want to become something truly impressive in life, you've got to be able to focus on one or two things that you do better than anyone else in your industry. You can't learn everything, but you can pick one or two skills, and the more innovative those skills are, the better. And you can truly excel at them. For example, at the peak of his career, no one in the world was better than George St. Pierre at integrating striking and takedowns. No one in the world was better at integrating grappling and striking on the ground. He had two things that he could confidently say he was the best in the world at. Was he the best at every MMA skill? No. But he was absolutely the best at those two skills. And those two skills were skills which he used throughout his career to win the vast majority of his matches. Gordon Ryan, at the onset of his career, could confidently say, there's no one in the world better than me at leg locks. He can also say, there's no one better in the world than me at late stage defense to submission holds across the board. As he went through his career, he started adding more and more elements. It's got to an extraordinary degree now where you can absolutely say he's the best at guard passing, the best at guard retention, and the list keeps going on. And that goes back to what Gordon said earlier about keeping things interesting over time, because we're always introducing new skill sets. The day you start saying, I'm satisfied with my skill set, is the day you get bored. And boredom to an athlete is a precursor to death by boredom. As long as you're still growing in those directions, you'll stay in the game for very long periods of time. So the main thing I would add to these statements by Gordon and George is this idea of finding something which is currently undervalued and showing the world what its true value is. Understanding that you can't just use the same training methodologies as everyone else and somehow expect to be different from everyone else. You've got to, almost every great rise in human civilization, whether it be groups of people or individuals, requires some kind of innovation. You've got to look for that new angle. Okay, George St. Pierre found it with shoot boxing early on in his career. Gordon Ryan found it with leg box early on in his career. And they branched out from that angle. Add to this the idea that you want to become the absolute best in the world in your industry. One or two things that make a difference find out what they are and focus on those things, and you'll go far. John, Gordon, George, this is an incredible conversation. Thank you so much for your extremely valuable time, George. As somebody who's become famous in part by commenting on people's performance, how do you think we did? How would you evaluate our performance today?
I'm not impressed by that.
Thank you, John.
That's it. I learn all the time. I talk to you guys. It's great. I love it. Yeah, it's very stimulated. I really enjoy it.
Yeah, it was something I really was looking forward to. I was hoping that we'd get together. So rare that at the same time in history there would be some of the greats together, and the fact that you guys would be willing to come together and talk like this is awesome. And that Gordon would even wear a cowboy hat. I mean, this is just historic. This is like Churchill getting together with whoever.
This is great and all, but the next one is just going to be us just quizzing John on which animal win in fights. Yes, for the whole 3 hours.
It'll be just we'll like Joe, and we'll make it a systematic.
It'll be a debate between Joe and John on which animal would win.
John and I, we have a thing that we send each other footage all the time of animal fight. We are very intrigued by that fight.
I get it like 3:30 a.m. on Instagram. It's like, check this out.
Like a rhino taking like a big like there.
It's not always fair.
No, it's never. But interesting stuff. If people would see what we send, the stuff that
They would judge you partially.
yeah.
All right. Thanks so much, guys. This was awesome. Thanks for listening to this conversation with George St. Pierre, John Donahar, and Gordon Ryan. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Miyamoto Musashi. There's nothing outside yourself that can ever enable you to get better, stronger, richer, quicker, or smarter. Everything's within. Everything exists. Seek nothing outside of yourself. Thank you for listening. Hope to see you next time.
I believe our official scientific worldview is incompatible with the reality of consciousness.
Do you think we're living in a simulation?
We could be in the Matrix. This could be a very vivid dream.
There's going to be a few people that are now visualizing a pink elephant,
A hamster has consciousness.
except for cats or evil automatons that are void of consciousness.
Consciousness is the basis of moral value, moral concern.
Do you think there'll be a time in like 20, 30, 50 years when we're not morally okay turning off the power to a robot? The following is a conversation with Philip Goff, philosopher specializing in the philosophy of mind and consciousness. He is a panpsychist, which means he believes that consciousness is a fundamental and ubiquitous feature of physical reality, of all matter in the universe. He is the author of Galileo's Error, Foundations for a New Science of Consciousness, and is the host of an excellent podcast called Mind Chat. This is the Let's Read My podcast. To support it, please check out our sponsors in the description. Now, here's my conversation with Philip Goff. I opened my second podcast conversation with Elon Musk with a question about consciousness and panpsychism. The question was, quote, does consciousness permeate all matter? I don't know why I opened the conversation this way. He looked at me like, what the hell is this guy talking about? So he said no, because we wouldn't be able to tell if it did or not. So it's outside the realm of the scientific method. Do you agree or disagree with Elon Musk's answer?
I disagree. I guess I do think consciousness pervades matter. In fact, I think consciousness is the ultimate nature of matter. So, as for whether it's outside of the scientific method, I think there's a fundamental challenge at the heart of the science of consciousness that we need to face up to, which is that consciousness is not publicly observable. Right? I can't look inside your head and see your feelings and experiences. We know about consciousness not from doing experiments or public observation. We just know about it from our immediate awareness of our feelings and experiences. So
Qualitative, not qualitative.
yeah, that's another aspect of it. So there are a couple of reasons consciousness, I think, is not susceptible to the standard, or not fully susceptible to the standard scientific approach. One reason you just raised is that it's qualitative rather than quantitative. Another reason is not publicly observable. So I mean, science is used to dealing with unobservables, right? You know, fundamental particles, quantum wave functions, other universes. None of these things are observable. But there's an important difference. With all these things, we postulate unobservables in order to explain what we can observe. Right? In the whole of science, that's how it works. In the case of consciousness, in the unique case of consciousness, the thing we are trying to explain is not publicly observable. And that is utterly unique. If we want to fully bring science into consciousness, we need a more expansive conception of the scientific method. So it doesn't mean we can't explain consciousness scientifically, but we need to rethink what science is.
What do you mean publicly? The word publicly observable. Is there something interesting you said about the word publicly? I suppose versus privately.
Yeah, it's tricky to define, but I suppose the data of physics are available to anybody. If if there were aliens who visited us from another planet, maybe they'd have very different sense organs. Maybe they'd struggle to understand our art or our music. But if they were intelligent enough to do mathematics, they could understand our physics. They could look at the data of our experiments. They could run the experiments themselves. Whereas consciousness, is it observable? Is it not observable? In a sense, it's observable. As you say, we could say it's privately observable. I am directly aware of my own feelings and experiences. If I'm in pain, it's just right there for me. My pain is just totally directly evident to me. But you from the outside cannot directly access my pain. You can access my pain behavior, or you can ask me, but you can't access my pain in the way that I can access my pain. So I think that's a distinction. It might be difficult to totally pin it down how we define those things, but I think there's a fairly clear and very important difference there.
So you think there's a kind of direct observation that you're able to do of your pain that I'm not. So my observation, all the ways in which I can sneak up to observing your pain, is indirect versus yours is direct. Can you play devil's advocate? Is it possible for me to get closer and closer and closer to being able to observe your pain, like all the subjective experiences, yours, in the way that you do?
Yeah, I mean, so it's, of course, it's not that we observe behavior and then we make an inference. We are hardwired to instinctively interpret smiles as happiness, crying as sadness. And as we get to know someone, we find it very easy to adopt their perspective, get into their shoes. But strictly speaking, all we have conceptual access to is someone's behavior. And if you were just, strictly speaking, if you were trying to explain someone's behavior, those aspects that are publicly observable, I don't think you'd ever have recourse to attribute consciousness. You could just postulate some kind of mechanism if you were just trying to explain the behavior. So someone like Daniel Dennett is very consistent on this. And so I think for most people, what science is in the business of is explaining the data of public observation experiments. If you religiously followed that, you would not postulate consciousness, because it's not a datum that's known about in that way. And Daniel Dennett is really consistent on this. He thinks my consciousness cannot be empirically verified, and therefore it doesn't exist. Dennett is consistent on this. I think I'm consistent on this, but I think a lot of people have a slightly confused middle way position on this. On the one hand, they think the business of science is just to account for public observation experiments, but on the other hand, they also believe in consciousness without appreciating, I think, that implies that there is another datum over and above the data of public observation experiments, namely just the reality of feelings and experience.
As we walk along this conversation, you keep opening doors that I want to walk into, and I will, but I want to try to stay kind of focused. You mentioned Daniel Dennett. Let's lay it out. So he sticks to his story, pun intended, and then you stick to yours. What is your story? What is your theory of consciousness versus his? Can you clarify his position?
So, my view, I defend the view known as panpsychism, which is the view that consciousness is a fundamental and ubiquitous feature of the physical world. So it doesn't literally mean that everything is conscious, despite the meaning of the word pan, everything, psyche, mind. So literally, that means everything has mind. But the typical commitment of the panpsychist is that the fundamental building blocks of reality, maybe fundamental particles like electrons and quarks, have incredibly simple forms of experience, and that the very complex experience of the human or animal brain is somehow rooted in or derived from this much more simple consciousness at the level of fundamental physics. So, I mean, that's a theory that I would justify on the grounds that it can account for this datum of consciousness that we are immediately aware of in our experience in a way that I don't think other theories can. If you ask me to contrast that to Daniel Dennett, I think he would just say there is no such datum. Dennett says the data for science of consciousness is what he calls heterophenomenology, which is specifically defined as what we can access from the third person perspective, including what people say, but crucially, we're not treating what they say, we're not relying on their testimony as evidence for some unobservable realm of feelings and experiences. We're just treating what they say as a datum of public observation experiment that we can account for in terms of underlying mechanisms.
But I feel like there's a deeper view of what consciousness is. So you have a very clear, we'll talk quite a bit about panpsychism. We have a clear view of what, almost like a physics view of consciousness. He, I think, has a kind of view that consciousness is almost a side effect of this massively parallel computation system going on in our brain. That the brain has a model of the world, and it's taking in perceptions, and it's constantly weaving multiple stories about that world. It's integrating new perceptions, and the multiple stories are somehow, it's like a Google Doc, collaborative editing, and that collaborative editing is the actual experience of what we think of as consciousness. Somehow, the editing is consciousness of this story. I mean, that's a theory of consciousness, isn't it? The narrative theory of consciousness, or the multiple versions editing, collaborative editing of a narrative theory of consciousness.
Yeah, he calls it the multiple drafts model. Incidentally, there's a very interesting paper just come out by very good philosopher Luke Roloff defending a panpsychist version of Dennett's multiple drafts model.
Like a deeper turtle that
just the difference being that this Luke Roloff's view, all of the drafts are conscious. I guess for Dennett, there's sort of no fact of the matter about which of these drafts is the correct one. On Roloff's view, maybe there's no fact of the matter about which of these drafts is my consciousness, but nonetheless, all the drafts correspond to some consciousness. And I mean, it's just like kind of funny. I guess he calls it Dennettian panpsychism, but this for Luke is one of the most rigorous serious philosophers alive at the moment, I think. And I hate having Lee Grolofs in an audience if I'm giving a talk, because he always cuts straight to the weakness in your position that you haven't thought of. And so it's nice, panpsychism is sometimes associated with fluffy thinking, but, contemporary panpsychists have come out of this tradition we call analytic philosophy, which is rooted in, detailed, rigorous argumentation, and it is defended in that manner.
Yeah, those analytic philosophers are sticklers for terminology. It's very fun group to talk here with us.
Yeah, well, I mean, it gets boring if you just start and end defining words, right?
Yeah.
I think starting with defining words is good. Actually, the philosopher Derek Parfit said when he first was thinking about philosophy, he went to a talk in analytic philosophy, and he went to a talk in continental philosophy, and he decided that the problem with the continental philosophy, if it was really unrigorous, really imprecise, the problem with the analytic philosophy is it was just not about anything important. And he thought there was more chance of working within analytic philosophy and asking some more meaningful, some more profound questions than there was in working in continental philosophy and making it more rigorous. Now, they're both horrific stereotypes, and I don't want to get nasty emails from either of these groups, but there's something to what you're saying.
I think just a tiny tangent on terminology. I do think that there's a lot of deep insight to be discovered by just asking questions. What do we mean by this word? I remember I was taking a course on algorithms and data structures in computer science, and the instructor, shout out to him, Ali Shekafande, amazing professor. And I remember he asked some basic questions like, what is an algorithm? The pressure of pushing students to answer, to think deeply. You just woke up, hungover in college or whatever, and you're tasked with answering some deep philosophical question about what is an algorithm. These basic questions, and they sound very simple, but they're actually very difficult. One of the things I really value in conversation is asking these dumb, simple questions of what is intelligence? And just continually asking that question over and over of some of the sort of biggest researchers in the artificial intelligence computer science space. It's actually very useful. At the same time, it should start at terminology and then progress where you kind of say, fuck it, we'll just assume we know what we mean by that. Otherwise, you get the Bill Clinton situation where it's like, what is the meaning of is whatever he said. It's like, hey man, did you do the sex stuff or not?
Yeah.
And so you have to both be able to talk about the sex stuff and the meaning of the word is. But with consciousness, because we don't currently understand, very much, terminology discussions are very important. It's like you're almost trying to sneak up to some deep insight by just discussing some basic terminology. Like what is consciousness, or even defining the different aspects of panpsychism is fascinating. But just to linger on the Daniel Dennett thing, what do you think about narrative? Sort of the mind constructing narratives for ourselves. So there's nothing special about consciousness deeply. It is some property of the human mind that's just is able to tell these pretty stories that we experience as consciousness, and that it's unique, perhaps, to the human mind, which is, I suppose, what Daniel Dennett would argue, that it's either deeply unique or mostly unique to the human mind.
It's just on the question of terminology before yes, I think it used to be the fashion among philosophers that we had to come up with utterly precise, necessary and sufficient conditions for each word. And then I think this has gone out of fashion a bit, partly because it's just been, such a failure. The word knowledge in particular, people used to define knowledge as true justified belief. And then this guy, Gettier, had this very short paper where he just produced some pretty conclusive counterexamples to that. I think, he wrote very few papers, but this is just, you have to teach this on an undergraduate philosophy course. And then after that, you had a huge literature of people trying to address this and propose a new definition, but then someone else would come out with counterexamples, and then you get a new definition of knowledge and counterexamples, and it just went on and never seemed to get anywhere. So I think the thought now is, let's work out how precise we need to be for what we're trying to do. And I think that's a healthier attitude. So precision is important, but you just need to work out how precise do we need to be for these purposes. Going to Dennett and narrative theories, I think narrative theories are a plausible contender for a theory of the self, theory of my identity over time. What makes me the same person in some sense today as I was 20 years ago, given that I changed so much physically and psychologically? One running contender is something like connected to the kind of stories we tell about ourselves, or maybe some story about the chains of psychological continuity. I'm not saying I accept such a theory, but it's plausible. I don't think these theories are good as theories of consciousness, at least if we're taking consciousness just to be subjective experience, pleasure, pain, seeing color, hearing sound. I think, a hamster has consciousness in that sense. There's something that it's like to be a hamster. It feels pain if you stand on it, if you're cruel enough to do it. I don't know why I gave that stand. People always give that, and I also think it's very violent examples to get across consciousness. And it's, I don't know why that's going to grab. But anyway,
say mean things to him. So let's go back. It experiences pain, it experiences pleasure and joy. But there's some limits to that experience with a hamster, but there is nevertheless the presence of a subjective experience.
Yeah, consciousness is just something, I think it's a very ambiguous word, but if we're just using it to mean some kind of experience, some kind of inner life, that is pretty widespread in the animal kingdom. A bit difficult to say where it stops, but you certainly don't need something as sophisticated as the capacity to self-consciously tell stories about yourself to just have experience.
Except for cats or evil automatons that are void of consciousness. They're the fingertips of the devil.
Oh, absolutely. Yeah. Well, I was taking that as read. I mean, Descartes thought animals were mechanisms.
And humans are unique. So animals are robots, essentially, in the formulation of Descartes, and humans are unique. So in which way would you say humans are unique versus even our closest ancestors? Like, is there something special about humans? What is, in your view, under the panpsychism? I guess we're walking backwards. We'll have the big picture conversation about what is panpsychism, but given your kind of broad theory of consciousness, what's unique about humans, do you think?
As a panpsychist, there is a great continuity between humans and the rest of the universe. There's nothing that special about human consciousness. It's just a highly evolved form of what exists throughout the universe. So we're very much continuous with the rest of the physical universe. What is unique about human beings? I suppose the capacity to reflect on our conscious experience, plan for the future, the capacity, I would say, to respond to reasons as well. Animals in some sense have motivations, but when a human being makes a decision, they're responding to what philosophers call normative considerations. If you say, should I take this job in the US? You weigh it up, say, well, I'll get more money, I'll maybe a better quality of life, but if I stay in the UK, I'll be closer to family, and you weigh up these considerations. I'm not sure any non-human animals quite respond to considerations of value in that way. I might be reflecting here that I'm something of an objectivist about value. I think there are objective facts about what we have reason to do and what we have reason to believe.
And humans have access to those.
And humans have access to them and can respond to them. That's a controversial claim, many of my panpsychist brethren might not.
They would say the hamster too can look up to the stars and ponder theoretical physics.
Maybe not, but I think it depends what you think about value. If you have a more Humean picture of value, by which I mean relating to the philosopher David Hume, who said reason is the slave of the passions, really we just have motivations, and what we have reason to do arises from our motivations. I'm not a human. I think there are objective facts about what we have a reason to do, and I think we have access to them. I don't think any non-human animal has access to objective facts about what they have reason to do, what they have reason to believe. They don't weigh up evidence.
Reason is the slave of the passions.
That was David Hume's view. Yeah. I mean, yeah. Do you want to know my problem with Hume? I had a radical conversion. This might not be connected. It's not connected to psychology, but I had a radical conversion. I used to have a more humane view when I was a graduate student, but I was persuaded by some professors at the University of Reading, where I was, that if you have a humane view, you have to say any basic life goals are equally valid. So, for example, let's take someone whose basic goal in life is counting blades of grass, right? And crucially, they don't enjoy it, right? But they get no pleasure from it. That's just their basic goal, to spend their life counting as many blades of grass as possible. Not for some greater goal, that's just their basic goal. I want to say that is objectively stupid. That is objectively pointless. I shouldn't say stupid, but it's objectively pointless in a way that pursuing pleasure or pursuing someone else's pleasure or pursuing scientific inquiry is not pointless. As soon as you make that admission, you're not a follower of David Hume anymore. You think there are objective facts about what goals are worth pursuing.
Is it possible to have a goal without pleasure? Is this kind of idea that you disjoint the two? So the David Foster Wallace idea of the key to life is to be unborable. Isn't it possible to discover the pleasure in everything in life? The counting of the blades of grass. Once you see the mastery, the skill of it, you can discover the pleasure. Therefore, I guess what I'm asking is why, when, and how did you lose the romance of grass of life? Is that what you're trying to say?
I think it may or may not be true that it's possible to find pleasure in everything, but I think it's also true that people don't act solely for pleasure, and they certainly don't act solely for their own pleasure. People will suffer for things they think are worthwhile. I might suffer for some scientific cause, for finding out a cure for the pandemic, or and in terms of my own pleasure, I might have less pleasure in doing that, but I think it's worthwhile. It's a worthwhile thing to do. I just don't think it's the case that everything we do is rooted in maximizing our own pleasure. I don't think that's even psychologically plausible.
But pleasure, then that's a narrow kind of view. That's like a short-term pleasure. But you see, pleasure is a kind of ability to hear the music in the distance. It's like, yes, it's difficult now, it's suffering now, but there is some greater thing beyond the mountain that will be joy. I mean, that's kind of even if it's not in this life, but the warriors will meet in Valhalla, right? The feeling that gives meaning and fulfillment to life is not necessarily grounded in pleasure of like the counting of the grass. It's something else. I don't know. The struggle is a source of deep fulfillment. So like, I think pleasure needs to be kind of thought of as a little bit more broadly. It just kind of gives you the sense that for a moment allows you to forget the terror of the fact that you're going to die. That's pleasure. Like that's the broader view of pleasure, that you get to kind of play in the little illusion that all of this has deep meaning. That's pleasure.
Yeah, well, but I mean, people sacrifice their lives. Atheists may sacrifice their lives for the sake of someone else or for the sake of something important enough, and clearly in that case they're not doing it for the sake of their own pleasure. That's a rather dramatic example, but there can be just trivial examples where I choose to be honest rather lie about something and I lose out a bit and I have a bit less pleasure, but it's worth doing the honest thing or something. I mean, I just think so. I mean, maybe you can use the word pleasure so broadly that you're just essentially meaning something worthwhile, but then I think the word pleasure maybe loses its meaning.
Sure. Well,
But what do you think about the blades of grass case? What do you think about someone who spends their life cutting blades of grass and doesn't enjoy it?
so I personally think it's impossible, or maybe I'm not understanding even like the philosophical formulation, but I think it's impossible to have a goal and not draw pleasure from it. Make it worthwhile, forget the word pleasure. I think the word goal loses meaning. If I say I'm going to count the number of pens on this table, if I'm actively involved in the task, I will find joy in it. I will find I think there's a lot of meaning and joy to be discovered in the skill of a task, in mastering of a skill, and taking pride in doing it well. I mean, I don't know what it's about the human mind, but there's some joy to be discovered in the mastering of a skill. So I think it's just impossible to count blades of grass and not have the geometries of sushi compelling, like draws you into the mastery of the simple task.
Yeah, I suppose. I mean, in a way, you might think it's just hard to imagine someone who would spend their lives doing that. But then maybe that's just because it's so evident that is a pointless task. Whereas if we take this David Hume view seriously, it ought to be, a totally possible life goal. Whereas, I guess I just find it hard to shake the idea that some ways of some life goals are more worthwhile than others. And it doesn't mean, that there's one single way you should lead your life, but pursuing knowledge, helping people, pursuing your own pleasure to an extent are worthwhile things to do in a way that, for example, I'm a little bit OCD. I still feel inclined to walk on cracks in the pavement or do it symmetrically, like if I or step on a crack with my left foot, I feel the need to do it with my right foot. I think that's kind of pointless. It's something I feel the urge to do, but it's pointless. Whereas other things I choose to do, I think it's worth doing. And it's hard to make sense of metaphysically. What could possibly ground that? How could we know about these facts? But that's the starting point for me.
I don't know. I think you walking on the sidewalk in a way that's symmetrical brings order to the world. Like if you weren't doing that, the world might fall apart. And
it feels like that.
And I think there's meaning in that. Like you embracing the full experience of that, you living the richness of that as if it has meaning will give meaning to it. And then whatever genius comes of that as you as a one little intelligent ant will make a better life for everybody else. Perhaps I'm defending the blades of grass example because I can literally imagine myself enjoying this task as somebody who's OCD in a certain kind of way and quantitative.
But now you've wrote this, you imagine someone enjoying it. I imagine someone who doesn't enjoy it. We don't want a life that's just full of pleasure, like we just sit there, having a big sugar high all the time. We want a life where we do things that are worthwhile. If for something to be worthwhile just is for it to be a basic life goal, then that mode of reflection doesn't really make sense. We can't really think, did I do things worthwhile? On the David Hume type picture, all it is for something to be worthwhile is it was a basic goal of yours or derived from a basic goal.
Yeah. I mean, I think goal worthwhile. I think goal is a boring word. I'm more sort of existentialist. Like, did you ride the roller coaster of life? Did you fully experience life? And in that sense, I mean, the blade of grass is something that can be deeply joyful. And that's in that way, I think suffering can be joyful in the whole context of life. It's the roller coaster. Like, without suffering, without struggle, without pain, without depression or sadness, there's not the highs. I mean, that's the fucked up thing about life is that the lows really make the highs that much richer, deeper, and like taste better, right? Like the like I tweeted this last night, sleep late at night, and I know it's like an obvious statement, but like every love story eventually, ends in loss, in tragedy. So like this feeling of love at the end, there's always going to be tragedy, even if it's the most amazing lifelong love with another human being. One of you is going to die, and I don't know which is worse, but both are not going to be pretty. And so that the sense that it's finite, the sense that it's going to end in a low, that gives like a richness to those kind of evenings when you realize this fucking thing ends. This thing ends. The feeling that it ends, that bad taste, that bad feeling that it ends, gives meaning, gives joy, gives, I don't know, pleasure is a loaded word, but gives some kind of deep pleasure to the experience when it's good. And I mean, and that's the blades of grass. They have that. But you're perhaps right that it's reducing it to some goals or something like that is kind of removing the magic of life. Because I think what makes counting the blades of grass joyful is just because it's life.
Okay, so it sounds like you reject the David Hume type picture anyway, because you're saying just because you have it as a goal, that's what it is to be worthwhile. But you're saying, it's because it's engaged in life, riding the roller coaster. So that does sound like, in some sense, there are facts independent of our personal goal choices about what it means to live a good life. And I mean, coming back full circle to the start of this, was what makes us different to animals. I don't think at the end of a hamster's life it thinks, did I ride the roller coaster? Did I really live life to the full? That is not a mode of reflection that's available to non-human animals. So,
what do you think is the role of death in all of this? The fear of death. Does that interplay with consciousness? Does this self-reflection? Do you think there's some deep connection between this ability to contemplate the fact that our flame of consciousness eventually goes out?
yeah, I don't think, unfortunately, panpsychism helps particularly with life after death, because for the panpsychist, there's nothing supernatural, there's nothing beyond the physical. All there is really is ultimately particles and fields. It's just that we think the ultimate nature of particles and fields is consciousness. But I guess when the matter in my brain ceases to be ordered in a way that sustains the particular kind of consciousness I enjoy in waking life, then in some sense I will cease to be. Although I do, the final chapter of my book, Galileo's Error, is more experimental. So the first 4 chapters are the cold-blooded case for the panpsychist view as the best solution to the hard problem of consciousness.
Yeah, the last chapter we talk about meaning.
Yeah, I talk about meaning, talk about free will, and I talk about mystical experiences. So I always want to emphasize that panpsychism is not necessarily connected to anything spiritual. A lot of people defending this view, like David Chalmers or Luke Roloffs, are just total atheist secularists, right? They don't believe in any kind of transcendent reality. They just believe in feelings, mundane consciousness, and think that needs explaining in our conventional scientific approach can't cut it. But if, for independent reasons, you are motivated to some spiritual picture of reality, then maybe a panpsychist view is more consonant with that. So if you have a mystical experience where it seems to you in this experience that there is this higher form of consciousness at the root of all things. If you're a materialist, you've got to think that's a delusion. That's just something in your brain making you think that it's not real. But if you're a panpsychist and you already think the fundamental nature of reality is constituted of consciousness, it's not that much of a leap to think that this higher form of consciousness you seem to apprehend in the mystical experience is part of that underlying reality. And, you know, in many different cultures, experienced meditators have claimed to have experiences in which it becomes apparent to them that there is an element of consciousness that is universal. That is sometimes called universal consciousness. So, on this view, your mind and my mind are not totally distinct. Each of our individual conscious minds is built on the foundations of universal consciousness, and universal consciousness as it exists in me is one and the same thing as universal consciousness as it exists in you. So I've never had one of these experiences, but if one is a panpsychist, I think one is more open to that possibility. I don't see why it shouldn't be the case that that is part of the nature of consciousness and maybe something that is apparent in certain deep states of meditation. And so what I explore in the experimental final chapter of my book is that could allow for a kind of impersonal life after death, because if that view is true, then even when the particular aspects of my conscious experience fall away, that element of universal consciousness at the core of my identity would continue to exist. So I'd sort of be, as it were, absorbed into universal consciousness. So, I mean, Buddhists and Hindu mystics try to meditate to get rid of all the bad karma, to be absorbed into universal consciousness. It could be that if there's no karma, if there's no rebirth, maybe everyone gets enlightened when they die. Maybe you just sink back into universal consciousness. So I also, coming back to morality, suggest this could provide some kind of basis for altruism or non-egotism, because if you think egotism implicitly assumes that we are utterly distinct individuals, whereas on this view, we're not. We overlap to an extent that something at the core of our being is.
Even in this life, we overlap.
That would be this view that some experienced meditators claim becomes apparent to them, that there is something at the core of my identity that is one and the same as the thing at the core of your identity. It's universal consciousness.
Yet there is something very, like you and I in this conversation, there's a few people listening to this, all of us are in a kind of single mind together. There's some small aspect of that, and or maybe a big aspect about us humans. So certainly in the space of ideas, we kind of meld together for a time, at least in a conversation, and kind of play with that idea. And then we're clearly all thinking, like if I say pink elephant, there's going to be a few people that are now visualizing a pink elephant. We're all thinking about that pink elephant together. We're all in the room together thinking about this pink elephant. We're like rotating it, like, you know, in our minds together. What is that? That pink elephant, is there a different instantiation of that pink elephant in everybody's mind? Or is it the same elephant? And we have the same mind to point that elephant. Now if we in our mind start petting that elephant, like touching it, that experience that we're now like thinking what that would feel like, what's that? Is that all of us experiencing that together? Or is that separate? So like there's some aspect of the togetherness. It almost seems fundamental to civilization, to society. Hopefully that's not too strong, but to like some of the fundamental properties of the human mind. It feels like the social aspect is really important. We call it social because we think of us as individual minds interacting. But if we're just like one collective mind with like fingertips that are like touching each other as it's trying to explore the elephant. But that could be just in the realm of ideas and intelligence and not in the realm of consciousness. And it's interesting to see maybe it is in the realm of consciousness.
Yeah, so it's obviously certainly true in some sense that there are these phenomena that you're talking about of collective consciousness. In some sense, I suppose the question is, how ontologically serious do we want to be about those things? By which I mean, are they just a construction of out of our minds and the fact that we interact in the standardly scientifically accepted ways? Or is, as someone like Rupert Sheldrake would think, that there is some metaphysical reality, there are some fields beyond the scientifically understood ones that are somehow communicating this? I mean, I think the view I was describing was that this element we're supposed to have in common is some sort of pure impersonal consciousness or something, rather than. So actually, I mean, an interesting figure is the Australian philosopher Miri al-Bahari, who defends a kind of mystical conception of reality rooted in a fight of Vedanta mysticism. But like me, she's from this tradition of analytic philosophy, and so she defends this in this, incredibly precise, rigorous way. She defends the idea that we should think of experienced meditators as providing expert testimony. So, I think humans causing climate breakdown. I have no idea the science behind it, but I trust the experts, or that the universe is 14 billion years old. Most of our knowledge is based on expert testimony, and she thinks we should think of experienced meditators, these people who are telling us about this universal consciousness of core our being, as a relevant kind of expert. So she wants to defend the rational acceptability of this mystical conception of reality. So it's what I think we shouldn't be ashamed, we shouldn't be worried about dealing with certain views as long as it's done with rigor and seriousness. I think sometimes terms like, I don't know, New Age or something can function a bit like racist terms. A racist term picks out a group of people, but then implies certain negative characteristics. So people use this term, to pick out a certain set of views, like mystical conception of reality, and imply it's kind of fluffy thinking. But you read Miri al-Bahari, you read Luke Ross. This is serious, rigorous thought, whether you agree with it or not. Obviously, it's hugely controversial. And so, the Enlightenment ideal is to follow the evidence and the arguments where they lead. But it's kind of very hard for human beings to do that. I think we get stuck in some conception of how we think science ought to look. People talk about religion as a crutch, but I think a certain kind of scientism, a certain conception of how science is supposed to be, gets into people's identity and their sense of themselves and their security, and make things hard if you're a panpsychist.
And even the word expert becomes a kind of crutch. You use the word expert, you have some kind of conception of what expertise means. Oftentimes that's connected with a degree at a particularly prestigious university or something like that, or expertise is a funny one. I've noticed that anybody sort of that claims they're an expert is usually not the expert. The biggest quote unquote expert that I've ever met are the ones that are truly humble. So the humility is a really good sign of somebody who's traveled a long road and been humbled by how little they know. So some of the best people in the world at whatever the thing they spent their life doing are the ones that are ultimately humble in the face of it all. So just being humble, how little we know, even if we travel a lifetime. I do like the idea. I mean, treating sort of like psychonauts like an expert witness, people who have traveled with the help of DMT to another place where they got some deep understanding of something, and their insight is perhaps as valuable as the insight of somebody who ran rigorous psychological studies at Princeton University or something. Like those psychonauts, they have wisdom if it's done rigorously, which you can also do rigorously within the university, within the studies now, with psilocybin and those kinds of things. Yeah, that's a kind of fascinating.
Still probably one of the best works on mystical experience is the chapter in William James's Varieties of Religious Experiences. And most of it is just a psychological study of trying to define the characteristics of mystical experience as a psychological type. But at the end, he considers the question: if you have a mystical experience, is it rational to trust it? To trust that it's telling you something about reality? And he makes an interesting argument. He says, if you say no, you're kind of applying a double standard, because we all think it's okay to trust our normal sensory experiences, but we have no way of getting outside of ourselves to prove that our sensory experiences correspond to external reality. We could be in the matrix. This could be a very vivid dream. You could say, oh, we do science, but a scientist only gets their data by experience the results of their experiments. And then the question arises again, how do you know that corresponds to a real world? So he thinks there's a sort of double standard in saying it's okay to trust our ordinary sensory experiences, but it's not okay for the person on DMT to trust those experiences. It's very philosophically difficult to say, why is it okay in the one case and not the other? So I think there's an interesting argument there, but I would like to just defend experts a little bit. I mean, I agree it's very difficult, but especially in an age, I guess, where there's so much information, I do think it's important to have some protection of sources of information, academic institutions that we can trust. And then that's difficult because, of course, there are non-academics who do know what they're talking about. But like, if I'm interested in knowing about biology, you can't research everything. So I think we have to have some sense of who are the experts we can trust, the people who spent a lot of time reading all the material that people have written, thinking about it, having their views torn apart by other people working in the field. I think that is very important. And also to protect that from conflicts of interest. There is a so-called think tank in the UK called the Institute of Economic Affairs, who are always on the BBC as experts on economic questions, and they do not declare who funds them, right? So we don't know who's paying the piper. I think you shouldn't be allowed to call yourself a think tank if you're not totally transparent about who's funding you. So I think that's it. And I mean, this connects to panpsychism, because I think the reason people, worry about unorthodox ideas is because they worry about, how do we know when we're just losing control or losing discipline? So I do think we need to somehow protect academic institutions as sources of information that we can trust. And in philosophy, there's not much consensus on everything, but you can at least know what people who have put the time in to read all the stuff, what they think about these issues. I think that is important.
To push back on your pushback, who are the experts on COVID?
Oh, they get into dangerous territory now.
Well, let me just speak to it, because I am walking through that dangerous territory. I'm allergic to the word expert, because in my simple mind, it kind of rhymes with ego. There's something about experts. If we allow too much to have a category expert and place certain people in them, those people sitting on the throne start to believe it. And they start to communicate with that energy, and the humility starts to dissipate. I think there is value in a lifelong mastery of a skill and the pursuit of knowledge within a very specific discipline. But the moment you have your name on an office, the moment you're an expert, I think you destroy the very aspect, the very value of that journey towards knowledge. So some of it probably just reduces to like skillful communication, like of communicating in a way that shows humility, that shows an open-mindedness, that shows an ability to really hear what a lot of people are saying. So in the case of COVID, what I've noticed, that this is true, this is probably true with panpsychism as well, is the so-called experts. And they are extremely knowledgeable, and many of them are colleagues of mine. They dismiss what millions of people are saying on the internet without having looked into it. with empathy and rigor, honestly, understand what are the arguments being made. They say like there's not enough time to explore all those things, like there's so much stuff out there. Yeah, I think that's intellectual laziness. If you don't have enough time, then don't speak so strongly in dismissal. Feel bad about it. Be apologetic about the fact that you don't have enough time to explore the evidence. For example, with the heat I got with Francis Collins, is that he kind of said that the lab leak, he kind of dismissed it, showing that he didn't really deeply explore all those sort of the huge amount of circumstantial evidence that's out there, the battles that are going on out there. There's a lot of people really intensely discussing this, and being showing humility in the face of that battle of ideas, I think is really important. And I just been very disappointed in so-called expertise in the space of science, and showing humility, and showing humanity, and kindness, and empathy towards other human beings. That's at the same time, obviously, I love Jurgen's sushi lifelong pursuit of like getting like in computer science, Don Canute. Like some of my biggest heroes are people that like when nobody else cares, they stay on one topic for their whole life, and they just find beautiful little things about their puzzles they keep solving. And yes, sometimes a virus happens or something happens with that person with their puzzles, because